Hello, everybody. Welcome to our series on programming in Objective-C.
Yes! Wibbit.net has taken you from the intro to programming in C to C++, now to its other object-oriented procedural component language, Objective-C.
Yeah.
What about the pronunciation of this language, Brian?
It looks like it would be called Objective-C.
Yes.
But it's actually, right.
Like, I object, Your Honor.
Yeah.
Well, this is my objective for this paper that I'm writing, yeah.
But really, you pronounce it objective because it's the C with the object-oriented bolted onto it.
Yes. So, let's kind of get started on the next step in our programming journey. Let's talk a little bit about the history of Objective-C.
Now, why was that not funny?
I thought it was hysterical. That's why I petitioned heavily to get that put in there. So the history, Brian. What is this? Where are we coming from?
It was created in the early 80s with Madonna.
Was she early or mid-80s? I guess she was early 80s.
She was created in the early 80s and she blossomed in the mid-80s.
There you go.
Just like Objective-C did.
Very nice.
As a material girl.
Yes, and that's why it's such a mystery.
Yeah.
Life is a mystery.
It was originally known as OOPC, or Object-Oriented Programming in C.
Right, which is why a lot of people like to call it Objective-C as opposed to Objective-C, because it comes from object-oriented programming in C.
C++ is also kind of object-oriented C.
Right, C with classes is what it was nicknamed.
Yep. So this is kind of like C++'s brother, in a sense.
Yes.
From another mother. If Steve Jobs was a woman.
Wow, so that means that C was she was around.
Yeah. So this is kind of a different offshoot from, so this is not built on C++, but it definitely took a lot of lesson learned from C++ and did its own thing, you know.
But it's still based on C, just like C++.
Absolutely, yeah.
So this is the other bolt-on language.
Yep. And it was really made to enhance code reusability.
There's a lot of aspects built into the language that allow you to expand things very seamlessly. That is one of the big advantages of using Objective-C. So the ability to take something that someone else has written, expand on it, and then use it for your purposes is where that reusability comes from.
Yeah.
Now, our buddy, the best friend of ours in the whole wide world, I'm not going to really say that with any seriousness, but Steve Jobs, who we all know from Apple, fell in love with this language. I mean, he was out at a bar, he saw Objective-C sitting across from him, and he was like, wow.
Dream.
Dream, 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 dream.
I was thinking more like the song from Wayne's World when he saw Cassandra.
Oh, what was that? Wasn't that Foxy Lady? Oh, yeah.
Yeah, okay. Okay, anyway.
So that's what Steve Jobs did when he saw Objective-C sitting across at the bar.
So he was like, guys, I gotta go, because she's waiting in the car, so I can't really do this whole Apple thing anymore. He took off with her and created a company called, maybe they kind of like pushed him out. They were like, she's Yoko. Yeah. Get out of here.
We're not going to get into the politics, but let's just say that Jobs left Apple.
Yes.
In the 1980s.
We'll be nice about it. We'll just say he left.
And when he left Apple, he created a company called Next.
Yes.
Capital N, lowercase e, capital XT.
Yeah. And the goal of creating that company was to make a new operating system called Next Step.
Right.
And in the process of doing that, him and the developers at his company created a series of development kits based on Objective-C to kind of give them the platform and the infrastructure with which to build their Next Step operating system. Which, as you know, maybe fast forwarding some years into the late 90s, ended up eventually turning into Mac OSX as we know it now.
The code base for Next Step was Mac OSX. So when Jobs came back to Apple
when they were begging for him to come back, like, please, for the love of God, come back to us.
He brought Objective-C into the Apple culture, which is why you see Objective-C pretty much exclusively for Mac, and you don't really see it for other platforms, because that's it.
Exactly.
She must have looked really hot at the bar that night.
I know.
But Objective-C, like we just mentioned, is most often referred to in the Apple context, although from a technical standpoint, it's not an exclusive Apple language.
Right. It's not that the Next company and Steve Jobs developed Objective-C. They really developed the Next framework that made Objective-C in a way that kind of put it on the main stage.
Exactly.
You know?
Right.
So Objective-C is around. It's a language. It's out there. Other people use it. They just adopted it and built a framework on it.
Now, just a word of warning, and Brian and I have, through our, trials,
Adventures.
going through adventures, learning the Objective-C language, we learned a few things. One, there's a ton of great references available. Even developer.apple.com has some fantastic documentation.
Yeah. But although it's good documentation, it just it shoves you in the deep end. The getting started things are too simple, and they're too geared towards, you want to make a button? Here's the 2 steps to make a button. See how easy it is? It's like their documentation is like a series of marketing commercials to convince you that Objective-C and their implementation of it is easy.
Right.
Without really explaining to you in a clear way. I mean, it goes from see how easy it is? Then you're like, oh, how does that functionally work? And then they're into craziness. Really quick,
Or they throw down that little ninja dust thing.
Yeah, and then
they're gone.
You're like, whoa, I'm back at the homepage for developer.apple.com. How'd that work?
But see, that's not the approach that Whippet.net's going to take.
Right, and that's why we're going through this.
Yes. So, now that we've kind of praised and kind of said Apple sucks at the same time,
yeah, kind of.
Let's keep an eye out for these Apple blanks.
Right. Exactly.
I can't imagine a circumstance, Brian, where you would not want to program an Objective-C.
This is something that you'll hear. You'll be reading the documentation, and you'll get frustrated.
The indoctrination.
Yeah, and you'll get frustrated and be like, how do I just... And you'll go to a forum. Inevitably, you'll go to a forum. And what you'll find is that a lot of people in the Apple developer community aren't really that friendly.
No, they're not.
Yeah, they're kind of shitty.
They're kind of assholes.
Yeah. And so one of the things that you might find when you go to a forum and you're like, hey, how do I instantiate an NS number object if I something? And the response that sometimes you'll get is,
I can't imagine a circumstance where you would do this.
Yeah, it's ridiculous.
Another answer is, why would you do that?
Right.
Or you should never do it.
Or, well, that's not the way you should do it.
Right.
Well, there's a lot of different ways to do a lot of different things.
Yes.
And we want you to be able to just, play jazz with it. We want you to, break it open and say, hey, these are parts of the framework that I like, and here's parts that I don't. So, it. I don't care if it's depreciated. I'm going to do it anyway.
Yeah, there you go. Yeah.
Do your thing, So the documentation is good, but the reason we're going through this is because we want to be able to kind of go through and say, okay, what the hell is this? What is the language and what isn't the language?
Yep.
How does this compile? How does it function? What are these?
Right.
What the hell is this parameter bullshit thing going on?
How do I use it best?
For?
How do I use it best for my purposes?
Exactly.
So now let's start talking about these Apple bleeps.
Right.
And why do they exist, Brian? Maybe you could help me understand these Apple people.
Right. One of the things that kept us away from getting into this language were these Apple and it's not the Apple company's fault that they exist.
Well, they do market to these folks. I mean, come on. They go to the Apple Store.
Yeah, the PC Mac things, and they're like, hey, we're cool kids.
Go to the Apple Store and talk and see who they hire.
Yeah,
that's who they market to.
That's true, yeah.
Yeah. They all drink too much Starbucks.
Yeah, and there's a chemical that Apple creates. It's called the eye gas, and they spray it into the steamer colonics that you get at Starbucks.
There you go.
They put the eye gas in them, and they blow them up their ass, and
they lure you in there to drink that coffee that's poisoned with Apple propaganda because they give you free Wi-Fi and Wi-Fi
and their free Wi-Fi only works on Mac devices.
And you'll also be able to see these folks because as they're sitting there at Starbucks doing whatever they're doing, usually it's nothing, they will sit towards the entrance with the logo on the back of their machine pointing towards the door. So
that's
as you walk
luminescent,
in, you can see it.
And generally speaking, they're a little pissy. And they're pissy because they just maxed out the daddy's credit card.
And they're grounded for the next week or so. What else? I
know, this is just such an easy target. Yes, we're on a roll here.
These guys, they hang out at Starbucks, and while they have their little logo pointing at the door, they spend 2 hours checking their email. That's an easy way to identify one of these people.
Sometimes because they're lonely and they think they're going to meet a girl at the Starbucks, but they don't. You can also tell if somebody's an Apple if they say, oh my god, yeah, and then I almost tripped over my Mac. It's like the same was oh yeah, I left my golf clubs to my Beamer.
Yeah, right.
Oh, my Benz is parked outside. Well, is it parked inside? Where the hell else would your Benz be parked? Or your car?
Why can't you say my car?
Yeah, right.
Why do you have to say my Benz?
Well, it's like when you buy a Mercedes at the dealership, the salesperson will even be like, this is a big deal. This is a life-changing thing. I'm going to give you the keys. And when I give you the keys, you have to realize that I'm not giving you the keys to a car. I'm giving you the keys to a Benz.
Have you bought a Benz before? Okay. And This next, you're going to start this next one, but I have a funny story about this next one.
Oh, I found something interesting. Anyway, yeah, for some reason they are convinced that they don't need to like understand security. They don't need to consider security considerations in their usage or in their development because they, for some reason, believe that Apples are just, or OS X's, don't have viruses.
Yep.
They're just totally immune.
It can't happen.
No.
No way.
Actually, I saw a website that exploited Chrome and installed malware on a Mac the other week.
No.
Yeah, it's pretty cool.
That can't happen.
I know.
That can't happen. Well, I can recall that when my wife and I were at the Apple Store getting the first gen iPad, one of the sales pitches that they were trying to get me to oh, you should get a Mac too.
Right.
We're like, no, thanks. She's like, they can't get viruses. Well, you know me, Brian.
Yeah, I know. You're going to get like lividly pissed off at that prospect.
Brian and I, we graduated with computer science degrees, but also computer security. So that we were a part of the security track, which is like an NSA certified program that we went through. So of course, I have a lot of knowledge about that, and I let this girl have it. I gave her like a 15-minute thing about like what viruses are, how you can exploit Macs, and all that kind of stuff, and she didn't know how to respond.
Yeah.
It was awesome.
She just cried.
It was beautiful.
She's like, I just have the swipe thing on my thing. And without provocation, they consistently make snarky comments about, it's like a PC. Yeah, that's like, whatever. I don't even have like a button on my mouse pad.
And they'll also say stuff like, oh, you can have Skype on a PC? That's crazy. I don't know. It's like, what?
Oh, is that possible? Huh.
Why would that shock you?
Yeah, right. But that said, the Apple devices are great. Like their user interfaces are like sexy as hell. They're very consistent. They're very well implemented.
Yep.
Like Apple makes some really nice products. Like their hardware is good. Their software is good. They just happen to accidentally produce a lot of I don't know. So we were kind of turned off by the Apple developer culture. Not the Apple company culture, but the Apple developer culture. And we kind of had to get over that by just kind of accepting the fact that, like, these people suck. Let's learn it and be like, here's why you suck, And now we know.
We had to learn in our own way because we couldn't really depend on the Apple community to help us.
And we would even try saying like, okay, well, that's, anyway.
And the Apple developer community, to its credit.
Yes.
Now now we're backtracking a little bit. The community itself pretty much values seasoned developers, but they don't really value newbies. And you can kind of think of that in many ways. Like one way you could think of it is they want things to be written only by smart and talented people.
So they don't want like a plug and play, off you go. So
Copy
you have
and
all
paste.
these, right.
Yep.
So you have all these like weird crap apps all over the place. That happened anyway. It's inevitable because people will build like programs that then pop them out, but they tried.
Yep. The language also kind of gears towards specific standards, naming conventions, method calling, and that is very, very different from the stuff that we've shown before.
And it's not, and you'll find using the framework and using the language, it's not necessarily intuitive of how it's laid out.
Yeah.
C++ in hindsight will look damn intuitive.
Yeah.
But they want all of their software to be written using that same standard and that kind of like Apple way of doing it. You know what I mean?
They even if there's another way to do it, you will be scoffed at. You will be told that
constantly
you suck because you didn't do it the way that you're supposed to do it.
And there's a reason that they do that because of other considerations that have been thought out in the design of the framework, but still, it's a weird way of trying to shepherd everybody into a certain way of writing the programs. We've also seen people asking questions about how to do certain things, and people will be like, well, just don't do that.
Yep.
There's a reason you should never have to do that. What the fuck, Like, it's crap, Like, if I want to do something, I want to make it like that's the device the Apple devices can do more than the templated things that the framework sets up for your convenience. It can do anything that you can possibly imagine.
Right. And isn't software development supposed to be expandable?
Yeah, that's exactly what it's for.
You shouldn't be
particularly
stuck.
This language.
Right.
Of all languages, the language meant to be so extendable and so flexible.
Right.
You should really be like, oh, you want to do something that I've never thought of? That's awesome. Let's extend it out and build our own little sub bullshit thing, and go at it, So that's what we want you to do. That's what we want you to come away with out of this.
Now, stop bashing Mac and Apple people. Let's get to the actual language itself.
All right.
Now let's talk about some of the prerequisites that are required in order for you to follow this course.
Yes.
The first one, Brian, are the previous Wibbit.net tutorials.
Right. Like C. Right. Intro to programming as well. Intro to object-oriented programming is crucial. C++, a definite.
Absolutely.
You also want to have a familiarity with the Mac operating system. It's a pretty intuitive operating system, so it won't take you long, but just make sure that you just put in some time with it and get familiar with it so you know how to like do the basics of navigating.
Right. A basic understanding of Unix is preferred because we're going to be doing some stuff on the back end in the beginning.
Yeah.
And if you don't know Unix very well, because as you guys know, well, as you developers know, Mac OS X is built on top of a variant of Unix called BSD Darwin, and we're going to be running stuff on the shell. And if you don't know it very well, you can pretty much just follow along with us. And there's also a syntactic thing that's kind of familiar to another language that we're familiar with, Brian.
Yeah, tool command language.
Yeah. So if you have any experience with TCL and its structure and the way that it, instantiates things,
it'll probably kind of help you.
It'll kind of feed into this because it's not the same at all as like C++.
Right. So fundamentally, this is based on the C language. Even if it looks a little different, just keep in mind that everything you've learned in that C series, it is based on C.
It's relevant, 100%.
It is. And just like we were saying before, just like C++, it's a bolt-on object-oriented programming language. So instead of C with classes, this is object-oriented C. And many of the data types are inherited from a master object. So, and these are all, so we were talking about how it's designed to be kind of extendable. And so in C++, for example, like a lot of the different data types are kind of their own thing.
Yeah.
In Objective-C, they all kind of come from this master object, this master generic object called NSObject.
Right.
And so any kind of object that you want to make, any kind of class you want to define and instantiate objects in, generally will come from an extension of an NSObject.
Yes, that's kind of how the lineage draws out.
Right. So you're always kind of doing this inheritance tree.
And for those of you that are proactive, NSObject.h and NSObject.m are open, so you can actually view the source code of these.
And see what that core...
Yes, you can see how it functions, and also you can see the reason why they designed this, so that when you create your own objects, you're bringing in all of the thought that was put into objects in general by the next group when they were putting together the next step library.
It's pretty sexy.
And as we progress through this, you're going to really appreciate the structure, and then as we move on to other languages that use this concept, like Java and C#, you're going to really start to see, wow, this is the way to go. This is it.
That's awesome.
So source code files in Objective-C usually have a .m extension. There's also a variant of Objective-C called Objective-C++, which we're not going to get into, but those use the .mm extension. That's how you would know the difference.
And the .m extension is often considered for the implementation files.
Right.
Also known as the
implementation files.
Yes.
Which we'll get into that. So we'll be using that for our base driver code and for our implementation code.
Yep. The objects use a header and an implementation, just like we've been doing over and over and over and over. Like old hat, you're used to that. No big deal.
Yes.
And memory management, for all intents and purposes, we're just going to say is pretty much manual.
Yes.
For as far as you're concerned, memory management is manual.
And that's the method that we're going to be teaching. But we're also going to be showing you other concepts such as Autorelease, which are going to be coming up later on.
But just kind of consider it to be a manual.
So some more of the fundamentals. Brian mentioned the NSObject. So this is the root class of the next step library, which is also from the GNU step, whatever. So like Brian said, all objects inherit from this, and it provides the basic functionality for the object's behavior within the execution of a program.
But then there's the foundation framework. And the framework is kind of like when we were in C++ and we were showing like the class that would wrap a string, or like the Wibbit string, or like the Wibbit integer and stuff like that. Those conveniently reusable classes all put together in a giant library, you can kind of think of as like a framework. It's just a well-organized series of reusable libraries and classes that kind of abstract your level of programming. So when we were doing it in C++ and we were kind of starting out at the lower level, by the end we were just saying like, oh, this dot that is that, and that's set to that, and it became very simple. So that's what that foundation framework is to do, is to kind of pop you up a layer of abstraction. And that just defines a layer on top of Objective-C that includes the primitive object class, which is classes that are all based on, everything is going to be based on the NSObjects.
Yeah, what Brian mentioned something that's important, but I'm going to add to it. Brian said that these classes are all reusable. I'm also going to add they are also extendable.
Right.
And they're designed to be extendable.
Particularly in this language, yes.
Yes. And there's also another aspect to this, and that's Coca, which is the most common native API, which we all know APIs are, for the Mac OS X, for Mac OS X development.
Right.
And we're going to be getting into that a little bit later on. We're going to kind of focus on the first two for the majority of this course.
Right.
And then Coca is going to be kind of added onto the end when we start building Mac OS X applications and even mobile applications as well.
Also, the reason you're probably here is because maybe you have an iPhone, maybe you saw somebody with an iPad, and you have a Mac. But the most common reason you're probably here is for mobile development.
Yes.
So Objective-C, as you probably assume, is the development language for the iOS. Mobile platform for the iPods, the iPhones, the iPads.
It's still the preferred language, even though you can do other languages. Objective-C is the preferred language. So this is very dominant in the iOS software development, the mobile development. And like Brian also mentioned, we can build standalone applications in Mac OS as well. But since this is so popular with mobile development guys, we do want to make sure that we get into some mobile development later on, where you can kind of get the fundamentals of how do you make an iPhone app? How do you make an iPad app? I'm sure that's of great interest to you.
Yeah. And the Cocoa API, it kind of changes when you go from the Mac OS X to the iOS.
Right, yeah.
And so
because Coca Touch is kind of a different variant. Right.
So when you make that transition, if you don't have a solid foundation, it can be a little tricky and cumbersome. So we really want to make sure that you've got that NSObject and that foundation framework just rock solid.
Absolutely.
So that from that point, you can just launch out and punch into any kind of API and use this, that, and connect the dots, and you're up and moving.
Could not agree with you more.
Our development environment's going to be one of kind of a combinational approach. And generally speaking, you're going to be using Xcode, the Xcode IDE. In this series, we're going to be using Xcode 4, and that's primarily what we're going to be using, but we don't really want to just jump you right into the IDE. We want to, as we always do, we want to start you with a minimalist approach so that you have a solid understanding of what you're getting into. And then we'll move you up into that Xcode IDE. And we're going to make that move pretty quickly, so we won't stay in the minimalist approach for very long, but just enough to kind of get your bearings and get your sense of like how things are running the Mac OS X.
Now, Brian also brought up something. We're going to be attempting to use the Xcode 4.
Right.
Those of you guys that are in the know, for lack of a better term, know that Xcode 3 and before are all free.
Yes.
Xcode 4 is charged.
At this point in time.
Since we are a legitimate business, Brian, we happen to have our development license for Mac OS.
Yes.
So we're going to be pulling in our purchase copy of Xcode 4. And for those of you that are interested in doing mobile development and Mac OS X development, we would strongly encourage you to go ahead and purchase your own development license. Maybe go watch these videos first. Make sure that's something that you actually want to do, because I think, you can still use version 3, right?
Oh, yeah. And for the most part, everything we do in this is going to be backwards compatible with Xcode 3. I mean, so whatever. So no excuses.
Right. So the minimalist approach that we will take is a text editor. We may be using Text Wrangler. We can also probably simplify that a little bit. We're also going to be using GCC, which is installed when we set up the Apple SDK. And like Brian said, the IDE that we're going to be using once we get past the minimalist portion is going to be Xcode.
Yeah, exciting.
Very exciting. So Brian, what the is this?
Text Wrangler.
But what's inside of Text Wrangler?
It's C.
But what is... Yes, it is pretty much C. Now, when you look at a basic Objective-C program, that just prints out "Welcome to Objective-C," it's just C code.
Nice, that's awesome.
Now that's insane.
It is in the membrane.
Yes. So let's take a look at how we can compile this.
Okay.
Right. So as we drop this little baby down, we're going to break this apart into different sections.
Okay.
Brian. What do we got?
So we've got our compiler.
Yes.
Just like we're used to.
Yes.
And then we have our output file, just like we're used to.
Yes.
But then we have our LOBJT, which is basically our parameter to say we want to include our Objective-C library.
Yes.
And then we want to include our foundation framework. And then we set the source code file, which is our .m file.
Not too shabby, right?
No, not at all.
That's pretty simple.
Very familiar with what we're used to.
Now, technically speaking, Brian, this course on Objective-C is not technically pure.
Right.
Why is that?
I don't know.
Oh. Okay, well then I will. We're gonna be discussing this language using NSObjects, which derive from the Coca Foundation, right? So this is technically an addition to the language.
Yes.
You don't have to use this to write an Objective-C.
Right.
And to see how all that functions, you can look at like I said, the NSObject.h, NSObject.m file to see how they instantiate things using the pure implementation of the language.
Absolutely. And because if we just stayed just on pure Objective-C, after a while, you kind of...
It would get very tedious.
Right. And you'd be like, when can I do the Mac stuff now?
It's not really relevant to what Objective-C is used commercially today.
Exactly.
Yeah.
And that's what we want to be for you is we want you to have relevant, useful, sellable, valuable knowledge.
And I don't think that I've seen, and this may be my ignorance, but I don't think I have seen another learning source that does not make this assumption.
Right.
You get a book on Objective-C, the first thing you learn is what is an NS string, what is an
exactly.
NS number.
Right. As if it's naturally part of the language.
Right, but technically it is not.
So this course is, we can't stress this enough, just so that you're clear, the course is aimed at Mac users, but you can follow along with the basics in Windows using some tools.
Yeah.
Just be aware that compilation syntax of Windows is not going to be quite the same, and not all code is cross-compatible, cross-platform compatible. But you could try it.
For those of you guys that are gung-ho about this, Brian, can you explain to them how they can attempt to try some of this in Windows?
Yeah, just go look for GNU Step, go download it, go to their website, check it out. Just install the MSys system, and then the core, and then just compile it, kind of like that you would do.
It's a little more complex than the way we're going to show, but this is an example of how you can compile a program here. But we're not going to be teaching Windows, but this is just for, hey, buddy, did you know?
Yeah.
Pointers!
So Objective-C is a maze of freaking pointers.
Yes! All over the
It's
place.
ridiculous.
Yeah.
So it can be complex, it can be overwhelming, and you can feel like you're upside down. Like a lot of times, like when you do somersaults in a swimming pool, or like in a river where you wash your clothes, depending on where you're coming from, it can kind of feel like that, because you can get kind of disoriented. You're like, oh, wait a minute, I thought I was calling that thing. I'm not calling it, I'm attaching to it, so this thing can consume it, and it sends it back over there. So it is a maze of pointers. It's a maze of memory management, but once you focus on the core elements, and once you really focus on how the language is functioning and operating, that maze starts to not look quite as much of a maze after a while.
Yes, if you are not fully comfortable with pointers, go back to C.
Right.
And then go back to the dynamic memory that we didn't see. Go to the dynamic memory in C++, because that is relevant, 100%.
Yeah, we can't stress that enough, how important it is to go through those intro to program. Just make sure you've got your foundation solid. That's our approach is always here, is that we always want to make sure that we have our historical context, we have our fundamental conceptual context, and then we can kind of advance from there with confidence.
So that's it, guys. We're going to start our Objective-C journey right now.
I'm excited. Hello, everybody. Welcome to our lab on setting up our environment for Objective-C. In this tutorial, we're going to show you basically how to go through the process of getting up and running an Xcode 4.
Yes.
Which is, at this point in time, the current recent version.
Yes, we're going to be installing the SDK, which also includes the Objective-C library, so that we can start coding and writing Objective-C applications, Brian. Exciting.
So the first thing we want to do is download Xcode 4. Xcode 4 is only available to Apple developers. So if you're not currently an Apple developer, you do need to sign up to become one. You have to do this anyway to deploy an app to the App Store. And the App Store is typically the way that you would distribute an application, unless you're going to do it through Cydia or some other like non-standard way of distributing an application.
Like selling you wares out of the back of your truck
in
some shady alley.
Pretty much. Some shady digital alley.
You know, it's kind of like in New York City how they had the people selling the illegal handbags walking around like, handbag, you want a handbag? You'd be like,
South Park, we got South Parks, we got Google Voice.
Yeah, right.
Nice. All the outcasted apps from the App Store you can get on the app black market, you know.
Nice.
Anyway, so you're probably not going to do that, I'm guessing. So we'll assume that that's the case, and we'll assume that you legitimately can get Xcode 4. We're going to get it through the iOS Dev Center, in this case, since these videos will be broad enough to where you can kind of get an understanding of developing for the Mac OS, but we're going to kind of tailor it sort of for the iOS operating system in particular.
Because we're awesome.
Yeah, and it seems to be what you guys would probably want to use it most likely for. So this is where you log in with your cool guy at coolemailaddress.com. And this is where I try to remember our password. Okay, so now that we're logged in as a developer, This is the Developer Center.
Mm-hmm.
And this Developer Center, you can see there's the Safari Dev Center, the Mac Dev Center, and the iOS Dev Center. And that's kind of how they segment out their development. There's a lot of really great resources for learning how to develop for these environments. You have getting started videos, developer libraries, coding how-tos, sample codes, all kinds of stuff. And you could jump straight to featured content like, how does AirPlay video support work? So for our case, we're just going to go straight to downloads. And we're going to get Xcode 4.02 and the iOS SDK 4.3.
Awesome, Brian.
Now, if for some reason you need the legacy Xcode 3, they still have it available as a link.
Right, and Xcode 3 is free, guys, so if you don't have the cash to put up for going through this tutorial, just download 3. Hopefully everything is, will work. If not, well, we'll just blame Brian. That's all.
And we're just going to download the Xcode 4 and the SDK 4.3.
What? That's craziness, Brian.
Yep. Okay, so now that we've downloaded Xcode, it's saved in our downloads folder, and it'll download as Xcode, whatever version is currently released at the time that you watch this, and iOS SDK, whatever version is currently released at the time that you watch this.
And also, whatever version of Mac OS you're running at the time that you watch. You may be using your brain to be doing this at this point. Who knows?
So to mount a DMG image in the Mac operating system, you just double-click on it.
Wait, I'm sorry. What? I gotta write this down. What do you do?
So you just double-click it, and it will open the DMG file as if you put a CD in, for example. So
yeah,
a DMG is kind of similar to an ISO. It's kind of similar to a BingQ file, whatever. But it's kind of Mac's way of it's like a cross between an ISO and a zip file, kind of.
It's a package. Yeah. You can Unix. Linux people are very familiar with the whole package concept. So we're verifying.
As you can tell, this is a very large package.
Yo, huge package. Huge package. I don't know if I've seen a package that big. Will you stop touching the package? Stop
playing with it.
Stop playing with the package.
Zip. Oh, that just finished very quickly.
Wow. Huh.
Nice.
I wonder if it's going to go that fast on your machine at home, folks.
So we have now this icon here, which says Xcode and iOS SDK, and it looks like a little drive. Do you remember those iOmega, zip drives and stuff?
Oh, yeah.
Whoa. So it kind of looks like one of those drives. It's just like a generic drive, so it's just mounted when it's available.
I'm sorry, you mounted the package? What?
Yes.
Okay, all right.
And then inside of this DMG file is the actual package that it's our installer package, which kind of looks like this box. And all we do is just double-click that, open it up, and it's going to say, this package will run a program to determine if the software can be used. So it's basically checking the prerequisites.
Wow, Brian, look at all this stuff.
Yeah, and it looks kind of like a normal install. Of course, I agree. You always want to agree.
Yeah, well, you have to agree
iOS
to all
SDK,
of Apple's demands.
Course, absolutely. So it's going to ask you where you want to put it, how you want to install it, which installation type. We're going to just leave all the defaults and just install it. Just kind of next your way through it. And it's going to prompt you for your admin password to say, am I allowed to make changes to your operating system?
And of course, my password is password. But don't try to break into my bank account with that password because it's password with a capital P and dollar signs instead of S's. So you can't possibly crack that.
It's like lead speak. So this installation works a lot like it would in Windows.
Yeah, well.
And it'll just you just throw the defaults on there, you're good to go. Don't worry about it too much.
Yes. So even though we're installing the Xcode IDE and interface builder, we're not going to be using that right out of the box. We're going to try to expose you to some of the command line functionality of GCC, which I know you guys have been doing before with C and C++ was kind of based on that concept. This is kind of the first step for us to abstract up out of that layer.
Yep.
But before we allow that to happen, and we're going to take the same approach with Java and C# as well, we're going to show you what it's like to live in that world, kind of get a little taste of it, and then boom, we're going to jump right out. Hey guys, welcome back to the Objective-C tutorial series. Kevin and Brian are here with you to do some badass
Yeah, we are.
Yes. So we set up the environment, Xcode is all installed, and what we're going to basically do here is just kind of just build a basic Hey Buddy program in Objective-C. We're going to compile it from the command line, and that's basically all we're going to do.
Just to kind of show you the walkthrough of opening up the IDE, seeing where everything is, compiling.
Well, I was
executing.
even thinking more primitive than that, just using a text editor.
Oh yeah, okay.
And so
absolutely.
That way we can do it from like the WIMP level.
Yeah, perfect.
So I don't know what text editors you guys prefer, but I like Text Wrangler. Brian,
it's pretty good.
Yeah.
Now, to be honest, I like Text Wrangler because of the lack of options. It's the best that's there.
Yeah.
But I think Notepad++
well, yeah,
just eclipses this thing.
Yeah. Well, we don't have that option.
But it's the best I've found. So if you guys know of better text editor, nothing against Text Wrangler, I think it's just sometimes we use it for more than it was intended for.
Maybe.
So if you guys know of any, like really great text editors out there for the OS X, let us know. We'd be excited to hear about it.
I wouldn't, because I already know what the greatest one. No, I'm just kidding. Okay.
It's VI and Terminal. That's the best text editor. Anybody else who doesn't use that's stupid.
We probably know quite a few people that have that point of view. So with our new text file, Brian, we can go ahead and save this as, and hopefully you guys know how to navigate. I mean, that was kind of a prerequisite to the course. I'm going to go to...
Because apparently Kevin does not.
Well, I just want to go to my desktop.
It's down here. It's on a share. We'll just cut that
all right,
out.
here we go. So I'm going to go to my desktop.
Under places, because it's a place.
And then once I get to my desktop, let's make a folder.
Yeah.
And we can just call it...
Objective-C Awesomeness.
Objective-C... Objective-C Awesomeness.
Or how about we just call it Whippet.net? Let's just call it Whippet.net.
All right.
Because actually our drive is called that, so...
Well, we'll have two things called Whippet.net on the desktop. And it will be your job to figure out which one is which. So inside of our Whippet.net folder, let's just do hey buddy, dot... Nice. Cool. So on our desktop here, ladies and gentlemen, we have a Whippet.net drive and a Whippet.net folder. So we can have fun seeing double right there. And you'll also see a Whippet.net logo right above that. So it's going to be great. It's going to be awesome. So Brian, if you were to make a basic hello buddy.
Hello Kitty.
Hello Kitty program. In Objective-C and also in C, we can use the import directive to pull in external files. Now, in some C implementations, Brian, this is considered appreciated, but Objective-C is its preferred method.
Yes.
You can use the include directive like we have been using in C and C++, but you won't see that across the Mac spectrum. So I would just make the recommendation not to do it.
Yep.
So we're just going to be pulling in the Foundation library.
Now these are installed when you install
the SDK.
Yes, the Xcode SDK. So
right.
Just so you know, you do have to have installed Xcode to get to this point.
But you watched that first tutorial, so you already knew that already.
There.
Right. And this is basically going to be set up exactly like a C program.
Because it is a C program.
Yeah, this is a C. This right here, Brian, is a functional C program.
Yeah.
And instead of, in the lessons, what we did is we kind of showed a regular C string. Let's call it NS string. My string equals, hey buddy. Now,
and if you remember, the NS strings always are preceded with an @ symbol. Otherwise, they're just a C string.
Well, yes, that's one way, which we haven't really gotten into the string stuff yet.
Oh yeah, that's right.
We haven't. We may have recorded it, but we haven't.
Anyway,
the Whippet.net style is to do.
So Vincent Van Gogh's ear is not something to worry about right now.
We do everything in a really up order. We don't even know what we record half the time.
I know what day it is, man.
So what we're doing is we're instantiating an instance of NS string, calling it my string, and this is just an object that comes along with the Coca Foundation framework, which is the base layer of the Coca framework. And we're setting it equal to a string called hey buddy. Now, like Brian said, there's this little @ symbol here that kind of separates this from a C string, and there's other technicalities that come along with it that we're not going to bombard you with for now. But
we want to print it to the console.
Yes. Now, Objective-C doesn't really have a natural native way to do printing. They have logging, but printing like how we use printf and that kind of thing. Objective-C doesn't really have like a C out.
And you could use printf. I mean, it would work.
Yeah. So what you could do, Brian?
Yeah. Okay. So
you could do, or you could even, if you're even cool like me.
I never used puts. I think it's lame.
Really?
Yeah.
I love puts.
I don't like puts.
So what I'm doing at this point is we have an instance of my string, and I'm going to call that instance, and I'm going to say, hey, my string, why don't you evoke your C string method and print that out to the console. So that's what we're going to be doing here. So we're going to print that out to the console. And in the beginning here, we're going to kind of just do this with a minimalist approach. We're going to be showing you guys compilation through the command terminal, right? So those of you guys that know all the fun shortcuts, do it. But I'm going to just go to my utilities, just the visual way. And then from that point on, we'll speed it up a little. And we're going to go to our terminal. And once the terminal is up, let's cd to our desktop. And then cd to wibbit.net. And then inside of this directory, Brian, what do we have?
Hey, buddy!
Hey, buddy!
It's our implementation file, or just .m file.
Well, our driver code file, maybe?
Driver code file,
whatever. So we're going to be evoking GCC, and we're going to ask GCC to include the library that is called Objective-C, right?
Nice.
And we don't have to do this, but in some implementations of command line compilations for Objective-C, it's good practice to call the framework switch. And the framework that we want to import is the foundation.
Right. So we've already imported this, but it just kind of lets it know that we did.
Yeah, there are some paradigms in the language where if you don't include this switch, certain things will not compile through the command line. I don't know. Whatever.
Just do it.
Just do it. So then at this point, we have all of the switches that we need to evoke the Objective-C compiler. So now we want to specify the input file. So heybuddy.m is the input file. And then we're going to specify the output file.
So you're obviously pretty familiar with the syntax from, C.
We have drilled this into your head. So we run this and we just do output file. And since this is Unix, we don't need to have any,
just a binary file.
Yeah, you can call it .exe if you want. You can call it .bin if you want. You can call it .as if you want. Or you can just call it nothing.
Yeah.
Right. So that's what we're going to do. And we're probably going to get some depreciated warnings. Because that C-string method that we called is technically depreciated, so if you guys don't want to deal with that, we can also add like a little -w at the end here to ignore warnings.
But our goal here is really to just to get this is just the most basic program we can think of.
Yeah,
it's 2 lines of code.
Brian and I don't know if we've talked about this already, but Brian likes to try to fix the warnings, and I like to say F you. I don't care how many warnings there are.
I like having 0 warnings, everything up to the current, because I understand the desire to try to shepherd the developers into some convention.
Getting on his high horse again.
But if it doesn't get the job done, it doesn't get the job done. So whatever.
So now, Brian, if we list this directory, we're going to see that we now have an executable file here and a text file here. Although this isn't really set to execute, but we can force it to execute, right? By doing // so execute in this directory. Hey buddy.
Hey,
there
buddy.
We go. Hey buddy.
So there's nothing freaky about the language. I mean, it's just
there is.
Okay, yeah, there is.
There's a lot of
something
freaky
about the language. That's true. But it functions just like you'd expect it. No, it doesn't. Okay.
No, it doesn't. No, that's not true either.
All right, well, you'll see.
I can't imagine a circumstance where we'd want to do this. I just can't. Welcome back to the Wibbit.net Programming and Objective-C course. Kevin and Brian are here to guide you on this amazing journey.
Yeah, this is like the beginning of the Lord of the Rings, except for instead of Mordor, you have a Starbucks.
Yeah, there you go. Yeah. So this is basically our lesson just to kind of introduce you to some of the common data types that Objective-C provides.
Yes.
Now, we're not going to be going over all or even a lot.
That many, right.
We're just going to go over a few so that you kind of see what they look like, and we'll start using them in a little while.
So what exactly is this NSObject, this next step object?
I have no idea.
Let's take a look. It's essentially a master class. It's a generic.
Also called a superclass.
Yeah, superclass, Champagne superclass. No.
Supernova? Champagne superclass Nova? I know where you're going with that little Oasis action going on. I get it.
So this master class is very generic, and it doesn't get into any specifics of any kind of specific functionality you would do. It's just a template of a idea of an object that many other objects inherit from. So all other objects come from this thing, and it has a lot of things that will manage how you use objects, how you interact with them. These objects are imported by the foundation library, which is the base framework that Cocoa is based on. And since they were originally developed for the Next Step operating system, or the NS operating system, they all start with the characters NS. So it kind of like we were doing with, instead of whippet string, we would say W string, like whippet integer or the W integer or whatever. It's kind of the same thing. So they would just kind of put that NS stamp on it because, maybe int is taken or integer is taken. So they say NS integer, you guarantee no conflict.
So we know it belongs to the NS series of classes. Right. Now this, as you guys recall, those of you that have seen the introduction to, object-oriented programming, and we had that, the inheritance structure where we began with life and got to you. NSObject is life. So we define everything that is an object. Every single object that can possibly exist needs to have this. And that's where the NSObject concept comes from.
Like the person or the chicken or the dolphin eventually work their way all the way back up to the NSObject.
Precisely. So it contains, I think Brian may have said this, but just to kind of reiterate, it contains basic memory construction and common members that inheriting classes can make use of, like, for example, allocating memory, deallocating memory, increasing and decreasing retain counts, which we'll discuss later with memory management, and all sorts of other things.
And this also creates a standard templates for all objects in the language.
Yes. Every object, same template. Which also kind of makes an interesting dynamic when you get into polymorphism and building interfaces between objects, too. Exactly. Now, Brian, what do we have here?
Okay, so these are actually the header and the implementation files for the NSObject class. So just like you wrote the WString class and you have your WString.h and .m, this is the one they did.
Yeah.
It's awesome.
Yeah.
So it was like, 20 guys roughly, give or take something like that.
Probably, who knows?
And this is what they came up with. So you can actually just go to these links, take a look at it. It's awesome. It's very cool.
If you really, really want to know the nuts and bolts of Objective-C, read those code files.
And now that you've gone through C and C++, you can actually kind of read them. Like, they're kind of readable.
Even if you can't read it exactly, you should kind of have a basic understanding of what it is. Right. Like maybe this thing doesn't make sense, but this thing, now this puts this in the proper context. Right. So it's really important. Now, we're going to be kind of referencing some code in this throughout this just to kind of show you how certain things work. But we want to give this as your homework assignment to review this code.
Yeah. And you won't find this approach anywhere else.
I don't think so. Now, Brian, what is the NSObject concept?
So the NSObject is the object that you always start with. So let's say I want some type of object. Step 1, get an NSObject.
Yep.
And it comes with, initialize, release, retain. And we can extend or override those things. So I first start with an NSObject. Those become things like NSNumber.
Ooh.
Or I extend the NSObject to become the NSString.
Yes. And everything that is common between those two come from its parents.
Right.
Its life node, NSObject.
Right. So now that NSNumber and the NSString, they both have the release, retain in it, all that kind of stuff.
Yeah.
Ready to go. So it's kind of like your Kickstarter your Kickstarter Firelog thing.
Yeah.
Sort of.
Sort of, maybe. Yeah.
I don't know. Really, that's a bad analogy.
That's horrible, but whatever. It works. I get it.
So what are the benefits of this NSObject design kind of setup? Well, it's that all classes and instances of the classes will respond to the same set of methods. And that sets up a really nice environment for polymorphism.
Absolutely.
Because it's not like, how did this class initialize this? And how did they do that with their other constructor? And how is this disposing of this? And you gotta wire it every which way. This kind of sets the stage for these things to be relatively consistent. So once you go from one type of extended object to another, it's a really nice, robust layer of getting between these two through dynamic binding.
Absolutely. Yeah. I
could
not have said
also
that
many
myself.
of the really difficult parts of object creation that you tend to nobody usually thinks to do this. Funny enough, like in C++ and stuff, like you don't usually find these like an object class. You know what I mean?
Right.
So it's so abstract. It's almost like really impressive that they thought of it. Because if you reuse the same code over and over every time you like calculate a string representation of a binary number, you would like put it in a library and reuse it.
Mm-hmm.
But all of these fundamental creation and destruction things with objects interactions, you reinvent the wheel every time you create a new class. But it's so abstract, you just never think to actually why don't we just abstract it out and just make it a class and have everything go. It's really clever.
Right, and Objective-C was kind of, although I'm sure some C++ developers did implement this concept, but it's the first time that it, like this kind of
massive.
Yeah, this started becoming viral because you start noticing that the more modern languages will use this same design. So let's take a look at NSObject and his friends, because not every single thing that we're going to be using in this language is an NSObject.
That's right,
but
kiddies.
But maybe it's some sort of a structure that contains values, or some kind of a wrapper, or like type def that's like built deep into to some code somewhere.
Yep.
So those are the three types that we're going to be talking about, and we're going to use NSObject to cloak all these around. Although in a technical sense, they are not all objects or interfaces, which is what Objective-C calls them. And there's also two different types of objects
this
that we can use.
This is important.
Yes.
And it's not tough once you kind of picture it.
Right.
So the two major uses is they're either not mutable or immutable or mutable.
Or not immutable. If we're working from the double, whatever.
So basically, if they're mutable, you can kind of think of it as like you can mute them, or like you can null them out, or you can change them.
Right.
If they're immutable, this kind of goes back to
the integer class
we made, where it's immutable, like it's disposable. So immutable is kind of like disposable. Like once you instantiate one, you can't change that value. It's static.
It's there for
and
there
so
for good.
If you want a different value, you have to throw it out and make a new one.
Exactly.
Whereas mutable, once you instantiate the object, you can change its value down the road.
Right. There are methods that will allow you to interact with the encapsulated values.
Right.
Immutable does not allow that to occur.
So immutable is like disposable, and mutable is like recyclable.
Yeah. So let's go over an example of interacting with a mutable object.
Okay.
So on the right-hand side, I have my Objective-C code, right?
And mutable is, just to reiterate, mutable is recyclable.
Yes. So here, I create my object. My object is called, my class is called NSMutableObject. And if you can see here on the left side, I have a value, which is acting as a field. So that's a private field not accessible to the client code or the driver code, whatever you call it.
Right.
But I have these two methods, setValue and getValue.
And now that's a dead giveaway right there.
Yeah, right.
Because you have a setter.
Exactly, yeah, there's a setter. So once this is then instantiated, I can set my value by calling the setValue method, which will interact with the private field on the back side of this class.
Right.
And then when I want to retrieve that data later on in the code, I can interact with that field by calling the getValue method.
Right.
And it will return to me back either a pointer to the value or a copy of that value.
Just like you're used to doing in the majority of what we went through in C++.
Yeah.
You know, that's usually how you would kind of naturally think to build a class.
And that's pretty much the method that Brian and I have been preaching, but there's a different way that we can live, Brian. We don't have to live this way. We can live this way.
Right. So this is a disposable or a non-mutable or immutable object.
Right.
And so this, like, NS immutable object, whatever that's going to be, and it doesn't have a set and a get. What it has is the value, and that value gets set through init only. And then you can get the value all you want, but there's no set. There's just init and release.
Right. So when we're interacting with this, Brian, when we create the instance, we will, just like you said, we're going to initialize the value by calling what they call an init method or an initialize method, which we'll go over later when we start talking about interfaces or classes, synonymous.
Yeah.
Then if I want to retrieve the value, I can call this. Now later on in my code, I want to change this value. Well, I can't. It's immutable.
And you don't want memory links either.
Right. So we're going to release this value, which we'll get into later when we get into memory management, but just get the concept down. The value is released and sent to whatever to die. But then I create a new instance. In that new instance, we'll call init, which will create a new value. And that's how it works.
Yeah. So not too bad.
No, it's actually quite simple when you get down to it.
It just kind of gets a little confusing when you just see immutable, immutable. So what's immutable? Immutable is disposable. Mutable means you can mute it, you can change the value.
There you go.
So all NSObject instances are pointers.
Yes. If they derive from NSObject, it's a pointer.
Yes. And so because it's a pointer, you have to think about memory management. And we'll just say there's no memory management that exists.
We're under the assumption, although we are technically
there's an asterisk there.
Technically wrong.
Right. For the sake of this introduction, let's just say no built-in memory management.
So be careful when managing your instances, particularly the non-mutable instances.
Because they're disposable. Like, you create them, they still just hang out there.
Right, yeah, you're right. If you just initialize, and you never properly release things, you are creating memory leak conditions.
Also known as a f***ing mess.
A big mess. No question. Now, Brian, let's start talking about some of the NSObjects and NSObject friends that we'll call them.
Right.
That we can just kind of get accustomed to.
So these are some of the ones that Next Step has made and comes from the framework. The first one is NSInteger, which most of these will work like an extension of the NSObject. In NSInteger's case, it's actually just a typedef.
Yeah, it functions like a typedef.
Right. So that's effectively just a primitive integer.
Yes, they're synonymous.
Right. It's kind of like an alias for integer.
Right.
Because they still wanted this to function like an integer and have all the advantages of being a relative, like a primitive data type, basically.
Right. You may get some compilation warnings when you're trying to, store an NSInteger as an int or vice versa.
But it works.
But it's technically correct.
Yeah.
So,
and then you have the NSNumber, and now that is an extension of the NSObject. The NSNumber is, because it's an extension of the NSObject, a pointer.
Exactly.
And the NSNumber just extended out functionality to. Now this is like the integer class we did, but this is not just tailored to an integer. It's more generically a number.
Right. It's for all numbers.
Right.
Anything numeric.
And inside of this class, the core data type, I think, is long as well in this. I'm not sure what it is, but it's...
Well, no, because it also allows for decimal points, so it'll probably be like
true.
a double.
Or probably something else bigger than that. Who knows? There's also the NS decimal, which is kind of similar to the number class, but it's kind of geared and tailored towards working with decimal numbers. So they kind of split them in those, and then from those types, from those object types, you can then move off and retrieve a value into a type of...
Right.
If you need to use whatever you need to use. If you need to use a float, if you need to use whatever, then you just kind of pull that float form almost as like a view of the number, which is whatever you want it to be. Anyway, I don't get hung up on how those work.
Those two in particular, and other ones we'll talk about, are the immutable type.
Right.
So when you make an NSNumber instance, you must dispose of it before you create a new one.
Yes, you can't, once you initialize the value of an NSNumber and NSDecimal, that's it.
Yep.
That's a one-shot thing, so that you can't change that value again. Another type is like NSRange,
which functions like a structure.
Right.
So inside of an NSRange, there's going to be two integers. It's like a start and length.
Right.
Kind of thing. Which we'll be using when we start doing string manipulation, because there's a lot of methods that will accept an NSRange to describe a range, like a substring, for example. I want to go here and take the parameters in NSRange. Yeah. So we also have
You have to admit, those guys are pretty out there.
Yeah.
Just think about the NSRange. We always pass in a pair of numbers. Why don't we just make a range object?
Yeah.
It's really cool. They really pushed it,
But here's where they f***ed up.
Oh, freaking bool. Yeah.
Now this is the worst part of the language.
It is. I'm not a fan of this.
And now, you know how we are accustomed to having a bool data type that will take true and false.
I like true and false.
Actually, you know what? There's two things that suck about the language, and I'll get to the other one in a second.
All right.
So
you mean three?
There we go. So then we have bool, and instead of making it true and false, it's yes and no.
All caps. Yeah.
That's so dumb.
Oh, I know what the other thing is.
You know what the other thing is?
Nil.
It's nil.
Oh.
Nil.
I know.
Oh, man, I hate it so much.
Null is good. Sometimes you're different just to be different. It's like art for the sake of art. Boolean is just trying to be different, just true, false.
True, false. Come on,
we know what that
man.
Yeah.
Come on.
Right.
This is not a Microsoft Access database, okay? This is a programming language.
Yeah, exactly. Right.
So when we start working with strings in the language, we're going to be using the NS string, which is the non-mutable version of the NS mutable string.
Right.
The NS mutable string's value, just like in the mutable objects, can be changed post-instantiation.
Right.
NS string must be destroyed.
Yep. And so those are also, again, they're pointers and they're extensions of the NS object.
Absolutely. Absolutely.
We also have some array objects, which is convenient.
Yes.
We have the NS array and the NS mutable array. So similarly, like we were just talking about with the string, the NS array based on the NS mutable array, the NS array is disposable, basically. It's immutable. We also have the NS enumerator for making enumerations, and we have the NS hash table, for example. So they really provide a lot of different they try to think of all the different use cases and not necessarily focus them categorized on the different ideas of the data types and what they could be, but more oriented on the functional use cases.
Very good description. by the way. We also have some other ones, like, for example, drawing. You'll see NS point. You'll see that when you do graphical
coordinates,
applications, right? Also, NS date for expressing date. And when we start talking about memory management, we're going to start talking about this very famous and controversial NS Autorelease pool.
Yep. But be aware that this is only like a few of the NS objects, like 3, you know?
This is like a nipple.
Not even close. Like, this framework is massive.
It's a drop of water in the ocean.
It's robust. They're always extending it. Like, every time they release a new version of, like, Xcode and the SDK and stuff, I mean, they pack, like, tons of shit in there. Like, they're just, like, pumping that thing with, like, whatever you want to do. It's really pretty good. Like, if they have new features for the devices, you know, you check out the framework and now they have, like, oh, here's an object for you to use the AirPlay and, like, wirelessly play to these speakers. And so, you know, it's nice.
I want them to make, like, an NS go take a object. That's what I want.
That way, have one. I don't have the auto-release pool.
Oh, yes!
So for more detailed information on this, look at their intro to their foundation.
Yeah.
It's a good reference. They have a lot of that developer site, the Apple developer site. Even though it gets a little overwhelming, they have a lot of documentation. I mean, there's so many languages and so many things that companies produce that are just like non-existent on documentation.
Yeah.
Nobody will ever say Apple didn't document the out of their It's good.
But they do have a specific audience for their literature. But I guess so does like Java and Windows.
It's better than MSDN, I think.
Yeah.
MSDN sucks a fatty.
It can.
But at least the people in the forums are helpful.
Hey guys, welcome back to Programming in Objective-C. Kevin and Brian here again, and in this lesson we're going to be talking about Introduction to Coca.
Yeah.
So Brian, maybe you can help me understand. What is Coca?
Cocoa is, it's a bean.
Right.
It comes from a cocoa tree.
Okay, right.
And, I don't know how, I always say cocoa, like hot cocoa.
Right.
Or like hot chocolate or hot cocoa.
Right.
But some people say like cacao.
Well, cacao, I think, is like the native way to say it. And I also think that's the name of the tree that it originates from, the cacao tree.
So people use it to make chocolate and stuff.
Right, yeah.
Yeah, so that's what we're going to be learning about today is how to make chocolate.
It's often used in milky beverages. It could be served hot, it could be served cold, which we all know is either chocolate milk.
It's robust and flexible.
Yeah. So we're going to learn how to make wait a minute. Hold on a second here.
What is this? Is this some sort of joke?
In 40 years, I've never seen anything like this. 40 years in this business. All right, so actually, we're not actually going to be talking about chocolate. Sorry.
It's just some other term like Java.
Yeah, it's like some cool little bean.
Yeah,
you know?
like that's a drink. We'll also use it as a language.
Yeah, we definitely have to come up with some technology term called like kidney bean or like black bean or pinto. Right? Yeah? No?
Like buttermilk or something, you know?
Yeah, buttermilk. So Coca, in relation to programming, is an object-oriented API used in the Mac development world. Basically a collection of frameworks that consist of a development and a runtime environment.
Cocoa in particular has deep integration with the Mac operating systems to give their applications a very powerful connection to all the aspects of the machine that it's running on.
Yeah.
So it's very much not generic. It's very tailored, just like .NET is tailored to Windows. Cocoa is very much tailored to like the Mac OS X and iOS.
Right, and even though the preferred language is Objective-C, you can hook into the Coca using other languages. So for example, we can use like Python, Perl, even C#, Java, Ruby, and Lisp.
Interesting.
Yeah, it's kind of crazy.
This is by far the most common development framework in Mac OS X, and it's purportedly the only one available for iOS
that we know of.
Well, yeah, there are other ones, but they weren't allowed, and now they're allowed, and I don't know. So we'll just kind of leave those off the shelf right now.
Yeah, a little controversy there. So Coca is not a part of Objective-C like we said before. It is an integrated part of the Mac OS X and iOS development. Right. So when we're using Objective-C, it's its own thing, and Coca is this layer that's kind of like thrown on top and below it.
So before we had made like a string class, and we made an integer class, and we made other things to kind of make things convenient. That layer is with the next step objects. So you have the next step number and the NS number and the NS other things. So this would be one layer on top of that. So leveraging those objects now into more convenient things like a UI button.
Right, yeah.
You know, for example. So you don't have to create a whole new button. You can just say like, oh, I need a button. Oh, well, you can just use it out of the Cocoa framework. Or I need to establish a socket. Or I need to whatever. You can just go grab it out of the Cocoa library of classes and methods.
Yeah. It's craziness, Brian.
For your convenience.
So where did this come from? It was basically developed in the 1980s through the 90s by Next. It was that company we talked about a little bit ago. And Apple acquired this later on in the 90s when Jobs made the swap from, Next back into Apple.
The original operating system this was developed for was, as we talked before, the Next Step operating system, which later became known as the Mac OS X. Mm-hmm. And this Cocoa framework became the Mac OS X's core framework.
Yep.
And because all of these classes are really for the Next Step OS, all the Cocoa classes begin with NS.
Right, which we talked about before, but it's worth mentioning again so that you don't confuse Objective-C with Cocoa, because they're different. They're really different, although they integrate so well that you don't know that they're different unless you know they're different.
Right.
So some of the core infrastructure. So Cocoa does have multiple libraries, tons and tons of stuff. I mean, we could have like a whole course on Cocoa. We're not. We're going to be talking about the two most integrated. So we're talking about the foundation, which contains the base classes and wrapper classes, the NSObjects,
like the NX number and NS whatever.
And we're also going to be talking about AppKit, and also for iOS UI Kit.
Right.
And this contains a framework for building graphical interfaces. Mm-hmm. And we're going to be not using these necessarily immediately, but by the time we get to the end of the Objective-C course, we will have built some graphical applications for macOS, hopefully as well, iPhone and iPad as well.
Because we really want to, at least in this initial series, to get you started, we don't want to, everybody gets so geared up and revved up to like, oh, I want to just like make a game right now, or I just want to like jump in and make an app that does something.
Right.
But the problem is you won't understand what you're doing. You're just going to kind of like parrot these tutorials that kind of say like, just type this line, type that line. You don't really understand what's happening, and it kind of does something. That's not really going to help you. So we really want to get you to have a solid, strong foundation so that when you start navigating the app kit, yeah, I know, no pun intended, right? Strong foundation. So by the time you get to the app kit, you're using the app kit, you're using the UI kit, you completely understand how they're functioning, how they're designed, how they're operating, and you're perfectly comfortable with it, which is not what you'll find many other places. And it's the problem that we ran into, which is why we're so excited about doing this lesson, this course.
The architecture of Cocoa, Brian, it does kind of drop through a hierarchy, starting with the lowest node, which is the operating system that Mac runs on.
Yes.
Now, a lot of people that don't really know, I mean...
Generically will say...
I don't want to say that because it sounds arrogant, but like a lot of people don't really know that Darwin is the base operating system.
People generally will say like BSD.
Well, no, I think generally people will just say, oh, it's Mac OS.
Oh. Yeah. True, probably.
I don't think that many people, at least folks that, again, you may have a different opinion than I, but folks that I know don't really know that, okay, this operating system is based on Unix, a variant of Unix called FreeBSD, and that variant that Next wrote was called Darwin.
It's the Darwin distribution.
Right. So we start our whole Mac hierarchy with Darwin. So this is an open source FreeBSD based operating system that sits at the core of Mac OS.
Right. And the newest current release of this that people generally are following, that's not the Mac OS X release, is the pure Darwin release. And one of the things that people like about this release, there's so many different Unix and Linux distributions. There's so many different ones.
Yeah. Go to, what is it, distrowatch.org?
Oh, yeah.
There's like 17 billion. Yeah.
So the thing that people like about this particular distribution is it is Unix. It has all the convenience of that, but also there's a Mac port. So some of the Mac apps can technically be ported over to it. So a lot of things people write, like core utilities for the Mac OS X, you can run in this free pure Darwin distribution. So some people like it anyway, but that's not... Pure Darwin is not what Mac is running on. It's just a offshoot of what it runs on. It's an offshoot distribution that's kind of like the currently maintained distribution of the equivalent of what Mac's running on. But Mac essentially is running on the Darwin distribution.
Kind of like a Windows 95 was running on DOS.
Yeah, exactly. So the core libraries are the base libraries. The base library layer that's kind of the lowest one-off layer. This is where the foundation layer sits, the foundation library sits. And this goes back to, again, when we showed you, like the string class and the integer class or the number class or whatever. Those wrapper classes and kind of some of those like core convenience libraries that we built in C++. That's where their equivalent of these are going to sit.
Right.
So one step off, just kind of, when we were writing those, we had to kind of write from the, we're going to copy a string, so we got to go character by character. It's that lowest layer, that first abstraction step off of the core language.
Right.
This is where that sits. So that's the first one. That's called the core libraries.
Right, and that also that's just a heartbeat away from the actual operating system layer itself.
Yeah, absolutely.
So this is where all the nitty gritty, and then the next layer up is the graphics and media layer, which is basically a service layer that allows, functionality for graphics, video, and audio. Two notable items that kind of rest at this level are OpenGL and QuickTime, which are relatively easy to integrate with your applications just through, just the framework allows that integration very easily.
And this isn't the ability to like slide a window around or show things painting in different weird ways. This is still a relatively base layer.
Yeah.
So this is core functionality of OpenGL and QuickTime. Right. This isn't, so this is what we're going to build on when we get to like the application frameworks.
Right.
And so those application frameworks, those start having the libraries and the APIs to kind of hook into the standard structure of Cocoa. And this has all the event handling. It has the standard application behavior. And that includes, the app kit and the UI kit. Now these things need not only the core libraries, but they also need the graphics and media layer to kind of have that presentation, that application level presentation.
Right.
So it's kind of a very logical building up on top of things.
Right. So it's like object inheritance.
Yeah, I know, exactly.
So lastly, we kind of sit at the user interface layer. Now this is where the user interacts with the application. So things like the desktop environment, like Aqua, sits at this layer.
Right.
So like me actually moving the mouse, moving the keys, that all sits at the hierarchy while everything else kind of just bottoms all the way down to the operating system.
Right. And in another way you can look at it, which is something that we'll get into later, is you can kind of look at these two, the core libraries and the graphic media, as the model.
Oh yeah, okay, I see where you're going.
This is the view layer, so the user interface is kind of the view layer on the outside, and the application framework is like the controller.
Yep, the model view controller.
So and that infrastructure, that MVC infrastructure, which we'll hear about later, is kind of pervasive throughout all of the development in Objective-C and in the Cocoa framework.
So, Brian, if I were to ask you a question, like, how do I build a Coca application?
I would probably watch a Objective-C course at Whippet.net.
That's great, but what if I was already watching the Whippet.net Objective-C video and they asked me this question? What do I do?
Well, I'd probably look for like an IDE, because that would be convenient.
An IDE? What is an IDE?
Integrated Development Environment. I don't know. So, the one that's most commonly used for Objective-C and Cocoa is Xcode.
Right. Not exclusive, but most common.
Yes. And it will come with the iOS SDK if you choose, or the OSX SDK. And, it will have all of the Cocoa libraries and frameworks kind of installed with it for convenience. So Xcode itself is used to develop, the foundational code. And then there's another application that it comes with called the Interface Builder, which is used to write like the GUI XML files, so to speak. So, and the GUI is at that point not integrated. You still have to then use Xcode to tie into the GUI, but we'll get into that later. But the two basic applications, the two predominant applications is Xcode and Interface Builder.
Yeah. So here's kind of a graphical representation of what Xcode may look like. So, we just have, you look on the left, we have code files. In our resources, we have, see where the zip file, XIB? That's our graphical component. That's our interface builder. So and again, we're going to be getting more into this later. This is more like just take a look, kind of be happy with it.
And if you remember in our introduction series, Introduction to Computer Programming, we had a lesson on IDEs where we kind of compare and contrast all the different IDEs.
Yeah.
So kind of if you remember back to that approach, this structure is very similar to what you'd find in Eclipse or Visual Studio or whatever you're using. Mm-hmm. So you have, just your file view, your text editor basically, and then your ability to run and compile.
Right. So here's where the base code would then be developed, and we would also be using hooks that hook into the zip file, which is the UI file basically, and that is designed using Interface Builder. Now, Interface Builder at first can be
a nuisance.
Well, yes, a nuisance. It can also be very intimidating.
Not intuitive.
It's not intuitive, and I think a lot of folks that first start looking at this go, "What the is going on?"
Yeah.
Because if you have a history of C#
Or like NetBeans.
Or NetBeans.
You know, or Visual Studio, like where you double click a button and start writing the code.
Yeah, and that's intuitive as hell.
Yeah, it is.
But this functions, I guess maybe if you started developing here, maybe like Visual Studio seems weird to you, although I think that you're weird if you think that.
Yeah.
But we're going to hopefully clear all this stuff up for you as we progress through this video series.
So I hope you're excited. We're now going to kind of launch into a lab to get you started on the development environment and getting Xcode installed and up and running.
Yep.
And thanks for watching. Welcome back to Programming in Objective-C. This video is going to be on object basics. So this is kind of just a first look at the objects and object instantiation and kind of how Objective-C works.
Yeah, and like the different types of ways that we can like interact and interface and create instances. And this can be fairly complex. You have to kind of pay close attention. And we're also going to be showing this to you without putting the memory management portion in context. So we'll kind of describe it, and then later on, these will kind of connect better with.
So this will be kind of your first exposure to the Objective-C syntax. Generally speaking, there are two ways to instantiate an object in Objective-C. The first is init. Init is a method that's built into the class, the NSObject class, to initialize an instance using a generic template. If you remember back in C++ when we template out a class.
Right. And you would use like the default constructor would be the equivalent, right?
Yes. This can be overridden,
of
course, and this is an instance level.
And you could also create your own init methods as well. You know, init is basically like what comes from NSObject, but I could make init with Kevin's fingers or something crazy.
And that's recommended.
Yeah.
You know, that's encouraged. There's also a class level way, a static method to instantiate an object. And these methods are built into the class. They do the same thing as init, but it just returns an Autorelease pointer.
Yes.
Some prefer to use this method. We'll get into the memory management aspects of it later, but it just makes it easier to deal with for memory management sake.
Right.
But you could generally just understand that one's on the instance side and one's on the class, static on the class side.
And it really depends on how you're going to use the object, and that kind of dictates how you would instantiate it. Now, we really can't go into the memory management stuff because it is fairly in-depth. So, like Brian said, just like ignore that for now and just make the assumption that we're 100% right. And then once we go over memory management, then you can formulate your opinion and fight against us. So let's talk about declaring an object, Brian, using init. How do we do this?
So the first thing is there's the object type. So just kind of like we would have before, if this was a person class, it would be person something. So this isn't too different from what we've seen in C and C++.
Or string or W string, W static.
So we have our object type, and then we have all NS objects are pointers.
Yes,
and
very important.
Every object that we instantiate are going to be either an NS object or something that is since inherited from an NS object. So we keep saying NS objects are pointers, and you're like, well, what about normal objects? Basically, everything we initialize in Objective-C essentially will be an NS object.
Yes, and please, take that very seriously because you are working with pointers, and you have to respect that and treat it that way.
Yes. Then we have the name of our variable, whatever we want to call it.
Right, like Brian is dumb. Sorry.
So now,
is that the object?
So here's where the syntax gets a little different from what you might be used to. You'll see that there's these open and closed bracket expressions.
TCO?
It's kind of like dual command language. This is kind of an evaluation block, we can call it. So you'll see like it goes inner to outer. So the innermost is first the object allocation. The language knows how much memory or how to kind of block out the allocation of an object. So we go from inner to outer. So we'll look at the inner block first, the inner evaluation bracket block first. And that's where it's the object allocation. So this is a class level method called alloc, and that creates a memory space for the object. Now when we pass it the object type, it will know how much or how to allocate that memory space. And it will return a pointer to that memory space. Just like we've kind of seen before when we say like new in C++, for example. And that will return back to us that pointer of that new memory space that's now been prepared. There's a class level method that's inherited from the NSObject class.
Right. So it's just a static method that says, go to this object, make me a new object, and send me back a pointer to where you have initialized, or where you created the space for this object.
Right. So that's the innermost and leftmost evaluation block. So that then returns, and then into this blue space is where that resulting pointer will now exist.
Yep. And now what we're going to do with init is now the instance level. So now that I've done object alloc, I've created an instance. So I'm going to be calling the init method against that instance that was just created.
So let's say if this is the person class, or in this case we'd call it like the NS person class, this would be sort of equivalent of saying like person.alloc, friend,
or person : alloc.
Yeah, or person : alloc.
C++.
Yep. And then let's say it's person P, this would be p.init, you know?
Right.
Or the person constructor, for example. In any event, so you can see that the word that follows the space after what you're trying to evaluate is the method that you're calling on it. So it's not a dot something or an arrow something.
Right.
It's evaluated, and then the next parameter is the method name that you're evaluating. So now we call init on the instance, and that's executed on the memory space that was returned. And this is the object's constructor.
Right.
This is the default constructor if it's just init with no parameters. And there are many types of init methods.
So let's go over an example of instantiating an NS string object using this method. So the first thing that we're going to do is we're going to identify what is the object that I'm working with. So you can see that on the right where the alloc portion is, we're just running against the NS string object class type, execute the alloc method. On the left side, we're saying NS string. Here's a pointer called myString, and that's what our variable is going to be called, myString. So just like I mentioned before, NSString alloc creates the new memory space. Now I'm going to execute init on that memory space, and again, don't be scared, init is just a method that belongs to NSString. And then once that's done, it's done. So Brian, how would I instantiate a class level?
So just the same way, very similar. We would declare the object type. All NSObjects are pointers, keep that in mind. And then we have the variable name.
Which is so different than the last time.
Yeah, I know,
Jeez.
right? So the difference here is we have our expression, which we have our object and our init method, and then we pass parameters by using the colon. So object init method is the static method to run in the class, just like we've seen.
Right.
And object is assuming the object instance, so that would be the allocated object.
No. This is the object name. That's like NSString and then calling on the NSString to init with.
Right. So this is the object's name, and the init method. And then you do a colon, and that separates to parameter.
Right.
So it's method, colon, parameter. And then in the order that these are delivered, this is the first parameter to send.
Right.
And so on. And then any additional parameters and so forth. So let's take a look to see what this would look like. Now this is not the instance level initialization. We kind of said there's two different ways. This is the class level, the static method, not the instance level. So we have our object type, then we have our variable name. Nothing new. We've seen that 100 times before. And now we call our init method.
Right.
So we can create different types of init methods for different types of circumstances. So in this case, we want to create and initialize an NS string object by using the method string with cstring. So we pass it as a parameter, a cstring. So the parameter, the separator to go over to the parameters, the first parameter that gets passed is, hey buddy, the cstring, because it's in quotes, just like in C, as you remember.
Right.
This is a C string being passed in, and the class level method will take in that parameter, will create a new NS string, and return back the pointer to it.
That's craziness, Brian.
Yeah. So this is the class level static method of initializing this.
Now, when you try to run this application exactly as coded, you're going to get this error. The error you see here is because, like we had stated before, we're using that static method of creating this instance, which is using an auto-release pointer, which again, we have not discussed. So this is basically saying, hey dude, you just made an auto-release pointer, but it's leaking because you're not actually handling this properly.
Right.
And that's fine. We're going to handle that properly later. Yeah. This is just a, hey, did you know, buddy?
So parameter passing in Objective-C is kind of interesting. Objective-C will attempts to make object declarations and method interfacing. Like, it's kind of like speaking like Yoda, sort of, sometimes.
Yeah.
They try to flow like a sentence, but sometimes they flow like a backward sentence because you're dealing with a lot of delegates.
Yeah.
So it's like, initialize the string we will, you know? It's
right.
It's sort of like that, but they try to make it very flowing, like sentence-like.
Yes.
So just kind of like, just sort of be aware of that as we kind of take a look at this.
And it is so different from what we have been teaching previously. Hopefully it's not too steep of a learning curve. And no matter how bad you may think this is, VB is still a billion, trillion, bajillion times worse.
Yeah.
So when you start thinking about how Objective-C calls methods, let's take a look at this first example here. Now my object is just the instance of the object that I'm working on. And I'm calling the method called clearValue. Well, this is just some hypothetical, it just executes that method.
Right.
And the second one, I'm executing a method and passing it a parameter. Okay. Now, new value, we're assuming is some, object or something that has previously been defined. So I'm saying My object, set value, colon, pass the parameter. And the next one, Brian, is kind of interesting. And I know that when I first saw this, when I was first learning Objective-C, I was like, what the hell is this?
I know, I was pissed too. I was like, this is the stupidest Starbucks-y thing I've ever heard about. This is crap.
So this, like, we have my object. Let's just say we're making a square, okay?
Right.
And we want to, and my object is a square. So I'm going to call the setWidth method. The method is called setWidth. And the first parameter, I guess we'll make an assumption, is a number, and it's just a variable called W. Now the second one, where it says and height, is strictly a label. That is not part of the method.
Right.
That's part of the method declaration, but that is not the method name. The method name is setWidth.
Right.
And height is a label that says the following parameter is going to be known as the height.
Right. And now you type that in.
Yeah.
Like when you call this, it's not just like an IntelliSense, it pops up and say, hey, do you know?
Right.
This is actually what it wants. It wants to, it's not the order of the parameters as much as it is the labeled parameter.
Yeah. And in a technical sense, according to the specs, you don't have to do this, but you're going to get on by people if you don't do this. Cause like, what the hell? This is the Apple way of doing it. Okay. Right. Don't just do like parameter colon, which would make sense to us because we're used to doing like commas to, you know, in C++. So read this out loud, Brian. My object set with 2W and height H.
Right.
That's that sentence structure that we're trying to talk about.
So I think the best way to name an object is instead of my, it should be I want my object to be.
Yeah, right. Every instance should,
So that's kind of the difference in this, as you'll kind of see the, the way that the wording of these methods go. Thanks for watching. I hope you're not too scared. Don't run for the hills yet.
I'm terrified, Brian.
It'll get better.
I'm terrified. Welcome back, everybody. We're going to continue our discussion on objects. Now, the progression that we have going here is kind of a little, we're trying to like gradually move into this thing because of how different it is from the stuff that we've talked about before.
So we just want to give you a few tips to start out with, and then we'll ease it in as you get more comfortable.
Yeah. So, Brian, let's start taking a look at, a subset of NSObjects that focuses on numerical values. The first group that we're going to take a look at here, I guess this is probably all the ones we're going to look at.
Yeah.
The NSInteger, which you mentioned before, which works kind of as a wrapper, like a typedef type of, then the super stupid, horrible, I hate this, bool.
Wrapper.
Yeah. NSNumber, which is a class that manages numerical data types, and NSRange, which is, acts as a structure that stores two integers, and is usually used to designate a start and an end point. Yeah. So, Mr. Brian, let's kind of go in depth here about what an NSInteger actually is.
An NSInteger is really just it's basically a typedef.
Yeah.
So it's just an alias for an int.
Yeah.
Effectively. That's all it is. So you can see when we do, like a printf and we just pass it a /n, like you don't have to, there's no like polymorphism going on there. That's just an integer.
Yeah.
You know what I mean? It's not, that's it.
And sometimes you'll actually, this may like throw a warning, not an error, but a warning. And you could also do like if you had, you have NSInteger I equals 124. If you have then after that int x equals I.
Right.
It'll throw a warning, but it actually functionally is fine.
So just so you know, like NSInteger is not one of the, it's not extended from an NSObject. In this case, it's just a typedef. Yeah. A wrapper, like Snow, Informer.
Informer. Then he's like, I lick your boom boom down or something stupid.
Yeah.
So here's that
gets up in that.
Here's that really horrible bool data type that Objective-C has implemented. So you can see here, of course, this is obviously not a practical application, but we're just kind of creating two little bool data types. We have to use all capital BOOL, and instead of true and false, Brian,
it's all capital yes and no.
That's kind of.
I guess I'm assuming what they were trying to do is, they wanted this to work like you'd speak, and this is an American language. It's an English language. It's a hardcore
America.
So in America, we don't say affirmative.
Affirmative. Well, unless you're Arnold.
Yeah, no, remember John Connor's like, don't say shit like affirmative or some bullshit like that, man. You gotta say, no problemo.
Yeah.
And so they basically wanted the Boolean data type to be like, no problemo.
Yeah, right.
Or, catch you later, wad. So like,
or hasta la vista, baby.
So this is basically trying to make the robot more human, is basically what Apple's doing. And so in doing so, people don't say like, do I take a left at that traffic intersection? True.
Well, I do.
So, okay, maybe.
But I've been developing for a long time, so.
So your object-oriented view of the world kind of bleeds in and out, doesn't it? So what they were basically just trying to do is make it a little more natural to say, like, yes and no and not true and false.
Yeah.
I know you're used to true and false, but that's how it is.
Yeah, it's not difficult to
really
get used to, but...
well, deal with it. I don't know.
Or you can just make your own, like...
Type def,
or like a define or whatever to kind of abstract your way out of it.
The NSNumber class is a class now. So this is not a wrapper. This is actually inherited from the NSObjects like we were talking about. And this is the class that manages numerical data. The developer library has a great reference documentation for this class.
Very extensive.
It's good.
Right.
It'll kind of walk you through everything.
Yeah.
And here's just kind of a basic example of it. So we're going to import our foundation header, and we're going to import stdio just for the sake of printf. And you'll see that we declare it with an NSNumber is the class, num is the name of our variable, and we do that alloc init like we showed before.
Yep.
But in this case, we're not going to use the default constructor, which it would have been init.
Right.
We're going to use another constructor, and this is called init with integer, and that takes in a parameter 100. We'll just pass it 100 for the value. So that will return back to us a pointer to the memory space that contains the space required for an NSNumber and initialized with the internal variable set to 100. And we can just print that out by calling the instance method integer value, which will return to us a primitive data type of an integer that we can then pass into printf. And then we release it from memory, just like delete in C++.
Very similar. Now, we did a number class, I think in C++, that's kind of similar to this. And also, one thing to keep in mind is that the NSNumber class is, it's immutable. So if you were to just call a init here, well, you just have an NSNumber that's just putting a memory space that you're not going to use. So when you do a init with something, you're then setting that value, and then if you have to change the value, you have to remove it and then create a new instance.
Right, so keep in mind, immutable means disposable.
Right, and that's what we were talking about earlier on in that lesson. We were trying to drill that in because that's kind of a big part of Objective-C.
Yeah, so that means this number is really one and done. So you can't change this number value. Like, that's it. You just...
Done. Over.
You use it, and then you release it, you instantiate a new one.
Yep, and there are positives and negatives to that approach, but I think there's more...
That's very different from what we've been seeing.
So as we were saying, there's a lot of initialization methods that we can use, and the documentation on the Apple developer site will kind of go over all of them, how to use them, and all that kind of stuff. But here's just kind of like a sampling of different ways that we could initialize an NSNumber. So
as you would imagine, any type of number data type that you have, whatever circumstance that you come across, just like in other languages, you could basically imagine that there's going to be a constructor overload to take whatever data type that you want to initialize it with. So if you have an unsigned integer, if you have a long, just know that it's always init with something. So it's init with long, init with a long, which is another data type. Init with whatever you want, Init
with a me love you long time?
Yeah. Now, what you won't see is init with string, because that's a little different.
Yeah, that's what like A2I is for, right?
Right.
Yeah.
Yep.
So here are some ways that we could instantiate an NSNumber using the class level methods.
Right.
Now you'll notice these don't start with init, right?
Right.
And it's kind of, that naming convention is consistent across Objective-C because this is not initialization, this is not a constructing method, this is a method that belongs to the class.
So this is the class level, not the instance level. So this isn't the alloc init, this is the calling it on the class.
Correct. And if you look at the symbol on the right, NSNumber star n equals NSNumber, which again is just the data type that we're working with, number with integer, :10, will effectively reproduce the code that we had just done, except with an auto-release pointer.
This would be similar in another language like C++ if it was NSNumber, : number with integer, paren, 10, paren, semicolon.
Exactly.
So that would be a C++ kind of equivalent of this syntax. Another example is, we have the initial one where you have, on the NSNumber class, you call number with integer and pass it 10. You could call a NSInteger I and set that equal to n, and then on the instance level call integer value. So the NSNumber class at the instance level has a bunch of different convenient methods, and it has way more than this, but here are some of the central getters. And you can get a Boolean value representation
which
of
is yes or no.
Yeah, so
stupid.
Right. And so that's basically if it's 0, it'll return you no, and if it's 1, it'll return you anything but 0, it'll return you yes. You can get the character value, you can get the short value, you can get the string value, you can get the whatever. So these are a lot of common getters that are on the number class. And so the sample is just an example of calling a getter to get the integer value in this case. Right. Or actually the NSInteger value, really.
Now, Brian, let's talk a little bit about NSRange. The NSRange is kind of a structure that's used in multiple situations in Objective-C. Now, if you take a look at this code sampling below, we're obviously taking in parameters from the command line, and we're just taking in two numbers, right? So as I make my NSRange R equals, and then there's a function that comes from the Foundation framework called NSMakeRange. And the NSMakeRange is a function that will accept two integers, a location and a length.
Right. So this is kind of this NSMakeRange function is sort of like a layer deeper. It's like a layer underneath. So this is kind of going back more to the C side, underneath the abstraction, and that's why you don't call it with the brackets. You call it like a function.
Exactly, right. Sort of like when you import string.h and you have strlen, a very similar type of thing
and
here.
And printf has the parentheses because that's coming from stdio.
The outcome of this application, if you look on the top, if we execute this program, I pass it 33 and 20, and this program is going to simply just tell you those two values. So the way that we access those internal values is exactly like we would in a structure in C, where we do the instance or the variable r dot and then the attribute that we're trying to access.
What's interesting about the NSRange is that a lot of methods commonly will require like a start and an end or a start and a length.
Like substring is very common, or like removing from an array, that kind of thing.
Right, and so the NSRange is really used for that purpose.
Yes.
And we'll get into this later, but instead of having substring and take start, substring take end as the two parameters, it just substring take an NSRange object. So it's a little, sometimes people argue it's a little more convoluted, some people just say it's more abstract, whatever.
And if you don't like it, later on we're going to show you how you can extend. So if you don't like this method, you can like make your own version of substring.
And that's really what this language is all about. It's really being extensible so that you can do what you want with it.
Do anything you want. Exactly. So I hope that this was, relatively high level, just talking about some of the basic number tools, I guess, that you'll be using in the Objective-C language.
Yeah. Hey everybody, we're now going to talk about NSObjects and arrays.
Holy monkey.
We're always going to be talking about NSObjects. That's kind of a given. But we're going to be focusing on arrays, the NS array, kind of how to use C arrays basically in Objective-C as well.
Now there are other types of objects like hash tables and that kind of thing. We're just going to be just focusing on the explicit array. And how would you make a list of objects in this language? And Brian is going to help us out by describing the two most prevalent.
So you know by now that we have our mutable and immutable.
Yes.
Which is our mutable means changeable, like you're able to mute it, it's editable. And our non-mutable, just the natural NS array, is immutable. It's a static array. It's disposable. It's kind of a one-time, you initialize it, get the stuff in there, and it's not going anywhere.
Yeah.
So the chances are you're probably going to use the NS mutable array more often, but maybe not. I don't know. It depends on the style that you end up liking. So the NS array, like I said, manages static arrays. There's a lot of documentation. You can look at the attachments, open up this presentation, click on the link if you want. The documentation's great. And the NS mutable array. So let's take a look to see how these operate. The NS array's initialization is, you're probably never going to call just the default constructor of init, if it even exists. It probably does because it inherits from the NS object, because you would create an immutable array with nothing in it.
Yeah.
Which you can't change. So that's not really going to do any good. So we're always going to be focused on the constructors, the non-default constructors. So like init with array. So this will take in another NS array and it'll initialize a new one. So you can do, basically, if you have an NS array object, like initialized, you can do some sort of operation on it, and that resulting array from that operation gets passed into this, which gets initialized. You can also initialize it with just a list of objects, which is init with objects. And you can also do init with objects, and you pass it an NS array, and it will take in a parameter of how many.
Right. So very different from what we've kind of been exposed to, right?
Right.
Now, we can also look at some of the class level. These kind of function the same way, but again, we're going to be getting a auto-release pointer, array with array, so same thing as before, we're setting an array with an object, passing in an object, array with objects, plural, setting multiple objects, and array with object count so that we can specify how much of the array that we want to take in.
So these methods are very similar to the instance level. They're just kind of like the brethren methods on the class level.
Exactly. The brethren. Now, retrieving data. What do we do, Brian?
There's some information we can get about an NS array from the instance. One is like the .count.
Not dot. What do you think this is? C++?
Yeah, whatever. The space count. So you can say if your array is called baseball bats array, it's baseball bats array count.
Right.
You can also get the object at instance and then you can also get object at index and pass it a number, which is kind of like get at,
right?
Basically.
Yeah. So here's an example of initializing an NS array and just setting it up with a pair of objects here. Now here's something that's really stupid, right? Now when we initialize an NS array, it has to end with nil. Sort of similar to how in C char stars end with a null character.
Right.
You know, so once I hit nil, I know that my list is complete.
Right. So that's like the array terminator.
Yes. And again, fellas, ladies and gentlemen, this is nil, not null.
Yes.
This is the
nil objective C.
This is the cool Apple way, man. Like nil. Like seriously? I like nil. Anyways, enough about my personal issues here.
It was the 80s. I mean,
yeah. That arrogance was still around in the 80s?
I guess
man,
so, yeah.
I would have thought, well, whatever. Anyways.
I don't know, whatever.
So here we go. We're creating an instance of NS array by doing NS array alloc. We're using an initialization method, which Brian, remember, that's an instance level.
Yes.
So now that I've created my memory space, execute on that memory space the method init with objects, colon, and here, and we're going to talk this a little bit more when we talk about the NS string, but the at quote, that is an NS string. That's the same thing as returning an Autorelease NS string.
Right. So the just quote without the at is the C string.
Yes. The constant char star. Exactly.
Right.
So we have A, comma, B, and then nil, end of my list. So now we're going to iterate through a loop, and since this is ANSI C, Brian, we're initializing I over top of the for loop. This ain't no C99. So we go for I equals 0. Well, I is less than ARR count, right? Brian said that the count method, and then I++. Now, what we're doing here is we're creating an NS string pointer, so we're not actually creating an instance here. We're saying NS string star S point at the memory address of the object at this index, which is ARR, which is again the name of the instance of the array. Object at index colon I. So go in there and go 0
get at
in 1 exactly. And then just print the NS string C string equivalent out to the terminal. And the ARR, we're not releasing it because we don't really want to put the focus on memory management at this point. And actually, if you really want to get technical, this program is so simple that when it ends, I mean, the operating system is going to clean that memory up anyway. Yes. So you could release it, but to what avail? You know? So when we talk about memory management, we're going to put a much stronger focus from that point going forward.
Right. So just keep that in mind. Now let's look at the NS mutable array.
Oh, wow.
Which is the one I like better personally.
Yeah, and because of the polymorphism and NSObject inheritance structure, if you have a method that accepts an NS array, it will accept an NS mutable array. Because all the methods are exactly the same.
Huh, nice. To add an object to the NS mutable array, these are the common methods that you would use. Add object, and then whatever that object is. Right. Doesn't matter what the object type is. It's just holding basically a pointer to that object.
And it basically appends to the bottom of the list, sort of like the linked list that we were talking about.
Yeah, exactly. Yeah. Actually, exactly like the linked list. You can also add objects from array, and you pass it an NS array, and it will just kind of consume those objects and put it in. So not adding the NS array as an object, it'll add all of the objects contained in the NS array to the NS mutable array. You can also insert an object at an index. Right. So you just pass it the object and then which index you want to insert it into. Removing objects is kind of a similar syntax where it's just that natural language again. Remove all objects is kind of like clear. It just clears all the objects out. And if you remember our linked list implementation, it's kind of similar in the way it operates. Mm-hmm. So you have all of those nodes that refer to each other, and it's just going to kind of wipe them out and clean them up. Remove the last object, removed object, and then you can pass it the object that it will look to see which object in the array equals this object and remove that one. Yep. Remove object at index, some number. Remove objects in range, and you pass it that NS range again. So anytime, like we said before, anytime that there's some common method that uses NS range or uses like a start and a length or start and an end.
Or a subset of something.
Exactly. Yeah. We're going to be using the NS range. That's what they want. So let's take a look at an example of the NS mutable array. So this is going to be of type NS mutable array, which mutable again, I want to just keep reiterating this over and over and over. Mutable is changeable. Immutable is not changeable. So this is a changeable array, and we'll call it MA. Meh.
Mutable array.
And we're going to call alloc init to just create our default constructed initialized object instance. So now we have MA. MA is empty. It's nothing to it. So now we're going to call add object, and we're going to pass as a parameter an NS string because of the at, just some text string, text to add, and then we're going to do it again, some more text to add. So now we have 2 objects that have been added to MA. And now, because we don't define the type of array that it is, we can pass any object type into this array. It's not just all of integers of all of whatevers. It's all of whatever object type we pass into it. So we can even pass into it MA itself.
Yeah, right.
So now the array contains itself after the 2 strings. So it contains MA dot to those 2 strings again, which is all pointing to the same memory locations.
Right.
So we can kind of make a weird, freaky little spider web of an array.
And you're also, like, you know, what this kind of demonstrates, Brian, is that we're not restricted by the data type. As long as that's, you know, an NS object of some kind, we can add that to this list.
Right, and that's something that we really need to consider when we're writing methods that use these arrays, because we won't have any guarantees that they're all NS integers or something.
Yeah.
So we want to be checking to see what we're working with, making sure we're dealing with them with certain ways, and having some of those evaluations before we just go in and start using things in array.
Yeah. So with freedom comes responsibility.
Exactly, yes.
So some other arrays. The next step, array objects are very convenient. Like I was saying before, that there are some other NS array type objects. We're just not going to bombard you with everything. But, Brian, if Objective-C is based on C, shouldn't we be able to use C arrays as well?
Of course. Now, they might be depreciated or non-appreciated
or just
unappreciated.
Unappreciated, yeah.
But
here we go, baby. Look at this.
Still work.
So I'm using a preprocessor macro. We're going to do define size as 5, which, you know, we've done this in C, int main. And then inside the main function, creating an NS string pointer, and then it's a string array of size. Holy monkey. And then for int I, which looks like we're using C99. Well, I is less than size, I++. And then at that index, sub I, look at this, Brian. We're doing NS string alloc, init with string, test, just because.
Right.
And then we're going a little for loop down here to print them out. And look what we're doing in this for loop. We're doing a release of each one of those string objects, although we didn't release well, actually, I don't have to do.
Yeah.
Because it's just those string objects.
Yep.
So I'm creating pulling out that pointer, printing it out, releasing it. It's kind of fun, right?
Yeah.
Yeah.
So just keep in mind that if, you can always, if you need to, punt back a step, drop down to just the C language.
Yep.
And rely on what you know when you need to, and just do what you gotta do.
You're gonna get for it, though.
But
I mean, Apple purists would look at this and be like, no, absolutely not.
Yeah.
I can't imagine a circumstance where you'd want to use this. Hey guys, welcome back. We're going to continue our little rampage here of NSObjects, and we're going to be discussing the famous string object. So what we're going to do is we're going to be discussing the NS string, which is, again, the static string and the NS mutable string. As Brian likes to say, it's mute. You can, punch it in the face and say, shut up, do whatever the hell I want because you're mutable. And the other one is like, no, I'm stat. You can't do to me.
Yeah, so just the normal ones are disposable. It's just there. You do it once and they're gone.
Remember that Marilyn Manson song, Disposable Teens? We're disposable teens. We're disposable. I got this. We're disposable strings.
Nice.
Yeah, Marilyn Manson was awesome back in the day.
I like him way better than Lady Gaga.
Well, Lady Gaga is, yeah.
She's like weird. She kind of is taking a lot of his things that he did and making it more palatable, I guess, but.
It's because she's a blonde girl.
Yeah.
Yeah.
But he was, Marilyn Manson had a pretty hot body too. So I don't know why
Marilyn Manson did not have a hot body at all. He was Brian Warner, is that his real name? He's an unattractive man, although very creative. You gotta give him credit for that.
NS strings are they're really the sort of, I like to think of them as the quintessential Objective-C NS object. They're kind of the proper, if this was a dog show, if we're doing a dog and pony show of all the different types of objects that is in Coco, NS string is kind of like the prize dog. That's sort of this is the one that's kind of the proper example example of how objects work in Objective-C.
And I think that in most languages, the string class that's implemented is kind of like, this is how it works.
Right.
Because the string is like always the base of creating objects. Yeah, I see what you're saying.
That said, once you get this, we've kind of exposed to you a few objects leading up to this point, a few classes. Once you kind of get to the NS string and get this under your belt, you'll really have a solid understanding of kind of how the next step objects look in Objective-C.
Absolutely. Now, one thing to take a look at the top here, Brian, we're importing the foundation NSObject.h instead of the foundation.h.
Yep.
Well, we're kind of flipping here back and forth as we do this. Just to give you an idea, typically you would use either foundation or coca.h.
Right. And when you get into working with Xcode, it will kind of manage all of these imports for you. It will manage all like the including of the libraries for you. You don't really have to think too much about that as far as everything Cocoa.
Yeah.
But we want to show you this just to get you familiar with the fact that these are just, header libraries. These are just classes that they implemented that you can go take a look at, and they're sitting there for you,
Right.
And that's where this stuff is coming from, just so you know.
So we have the NS string. We're creating an instance called str. We're making that equal to, and we're using the static, we're creating an auto-release pointer at, quote, quote. This is an NS string. So the at will designate that we are making this we're calling this against the class itself and returning an auto-release pointer.
Because if we didn't include this at, you would be trying to basically construct this with a C string.
And it wouldn't allow that to happen.
Right, because this pointer can't be equal to, it would be the wrong data type. It would get confused.
Yeah, incompatible.
Right. So having
Square
memory
peg around
space,
hole.
right. So having memory space with a C string is very different than having memory space that contains an NS string and all of the different types of data types that are contained inside of that object instance.
Precisely. And we're calling the NSLog function. Now, don't get hung up on this. We're going to talk about this in a little bit. I mean, there's really nothing to it. It's just going to write it to us with a log formatted date and crap.
Right.
I don't use NSLog. I know a lot of folks do. I'm not a big fan, but we're using it here.
It is what it is, yeah.
And then here on the NS string instance, Brian, we're calling the C string method. Now, didn't we do something very similar to this
I
in
think
C++?
we did.
Now, what are we doing here, Brian? We're using the puts function that comes from stdio, which accepts what?
A C string.
A C string.
Right.
Exactly.
So this is just like the W string had the C string method.
Yeah, right. So
or in C++, you had the C_str.
Exactly. So we're pulling back a char star, a constant char star that represents what this string is and just writing it out to the screen using the regular C functions.
And if you're lost, that means you probably haven't watched the C and C++ videos. So we strongly recommend, we can't emphasize it enough, that the introduction introduction to object-oriented and C++ are strongly prerequisite courses for this lesson, just so that you know.
You don't do yourself a favor by skipping ahead.
Yes.
You really don't. So, Brian, what are we doing here? This is craziness.
We're apparently just declaring that Wibbit.net is awesome.
That's the craziest thing I've ever seen. I declare from this day forth.
Yeah. So we're going to be looking at the NS string. NS string is not the mutable string.
Right.
NS string is the disposable one. NS string is the disposable one and done NS string.
We're disposable strings. If Marilyn Manson is watching, you're awesome.
So,
and don't
Marilyn Manson's so bored he just wants to get into Objective-C programming, apparently. I want to make the coolest app ever.
Well, he wants to make like the Marilyn Manson iPhone app, right?
I want to make an Apple app that will just totally gross you out. I don't know. So the first two examples, we're going to be doing the static class level instantiation methods. So we're going to call NS string, string with C string, and that passes in a without the at symbol, just the two quotes, Wibbit. And now our next string is going to be instantiated by calling string with string. Now, whenever they say string, they're assuming NS string.
Exactly.
So it's not NS string with NS string. They're assuming when you say string, it means an NS string. And that's why you pass in the parameter with the at, denoting the fact that it's an NS string instance. The next two examples are the instance level initialization, and that's the alloc init, but instead of just the default init, this is an NS string, so it's immutable. If we just call alloc init, it's not going to do us a lot of good. We're going to have this blank string that's stuck, whatever. So we're going to be calling it alloc init with C string, and again, that's the C string, the string with C string equivalent without the at because it's a C string.
Right.
And then our fourth example is init with string, assuming the NS string that has the at in it.
So just to also kind of further emphasize, the S1, S2, and S5 are auto-release objects.
Right.
S3 and S4 must be managed.
Right. Absolutely. The class level method has the kind of intelligence built in to add them to the Autorelease pool, basically.
Yeah.
And we won't talk about that much, but the instance level... We have
some great examples coming up. We're excited about that.
But the instance level does not. The instance level is kind of a dumb way of doing it. Not a bad way, it's just a dumb, simple way of doing it. A more manual way of doing it to give you that flexibility and make it more robust.
Some would argue it's more efficient.
Yeah.
Right. But... Again, it requires more work on the developer's side.
So when we just call that this is equal to @ is basically you could kind of replace the @ with the class level method to instantiate. So anytime you see the @ that's effectively what it's doing. It's just calling string with string, NS string with string. You could basically replace the @ every single time with it. So you get it.
Is it just me, or in this font, doesn't the @ symbol look like an ear?
Yeah, kind of does.
All right, I'm sorry. It's like I'm listening to exclamation points.
So now we're going to do printf since we imported stdio. And we're just going to do printf and just print the C string equivalents of it. And that's just going to print out wibbit.net is awesome.
Now here's one thing that's kind of dumb, right? Either the compiler or IDEs may throw you a warning when you call the C string method saying that it is depreciated.
Yes.
And,
because it's not the way they want you to do it.
Yeah, I don't agree with that philosophy, but you're right. It's more geared towards we don't want you to do it this way, and not that you should, well, I'm sorry, yeah.
It's alright. They're just trying to really, shepherd the developers into, a herd to kind of make it easier for them to standardize your development process.
And they want to abstract you out of C.
Yeah.
Is basically, I think, what that attempt
and that's a fair attempt. I mean, I can respect that.
But what I don't like is how, when I do compile, Objective-C apps, and I have 5,000 depreciated, like, screw you! I don't like you.
See, I'm more on the side of trying to not have so many warnings.
Yeah, well,
just for curiosity's sake, if nothing else.
I'll fight the compiler.
Yeah, which is good. So we kind of have two different approaches of how we like to. So some people do it different ways.
So in C, in ++, in whether it was the string class that we made or the string class that comes with C++, you want to know how long a string is sometimes, right?
Yeah.
So in this particular case, there is a length method.
Nice.
That's craziness.
Yeah.
That's how you can tell how long a string is. Now, you can also do other crazy stuff like setting case, right? So we're creating an instance of an NS string called str. Hello, how are you today? And if you look on the upper right, you can see hello, how are you today in the case that we designated.
And keep in mind that since this is just the NS string, it's immutable. Yep. And so you can't change it.
Yep.
You can't change just an NS string, only the NS mutable string. I can't stress that enough. So that's why we have to then call string, lowercase string, which returns a new instance.
Yeah, so now we have str lower, str upper, where we're calling the lowercase string methods in uppercase string method. And then when we put that's out to the screen, if you look on the upper right, the second output is all lowercase and the third output is all uppercase.
And here's an example of the substring method. So we're going to basically pass in a list of words, a list of strings as arguments, and we're just going to loop through those and print them out by using the substring. Just something as a way to show you an example of this. For I to arg count, so for however many arguments we pass in, however many parameters on the console prompt we pass in, we create a new NS string, a disposable string, and this is a string with C string, argv1. Because it's a constant char star, obviously they're C strings, not NS strings. Then we create a range object because, like we said before, anytime we have a starts and length, it wants the NS range. We jump down a layer and call the NSMakeRange function. We start at 0 and we go to the string, size of the string, -1. And then we create a new string. So we'll just call it ext, just an extra string. And we're going to call string substring with range and then pass it that range object.
Holy monkey.
So that's just going to kind of get the string and then we're going to print it.
Yeah, now what that's going to do is, if we look at the output of this, if we pass our program the parameters, this is a test string, quote, remember that's going to take that as one parameter, and so is this, it will remove the last character from each string. Craziness, Brian. Now how do we split a string? This is craziness. This is a very useful part of software development.
Yeah, so let's say we create an NS string, and that NS string is like a comma separated. That doesn't mean like parameter, just the string contains like tildes or commas or something. In this case, it's commas. And then we create an NS array, and that's an immutable array, and we'll call it list. then that's going to be the string instance. The instance has a method that we can call that the NS string comes with, and it's called components separated by string, and that will return us an NS array. And then we pass it an NS string that contains what we want the separator string to be. So we'll pass it a comma, and it will return back to us an NS array. And then we can just do a for loop. This is kind of like a for each loop, and then it'll just print out everything inside of that array. Similarly speaking, we also have a join string. We again create our NS array from the separated by string, and then we print out everything inside of it. But now we create another NS string, and we'll call it the joined string. And this is going to join it back together. So now we say on the NS array instance list, we have a method that it comes with. So this is an NS array method, components joined by string. And now we kind of do the opposite. We pass it. Now we could rejoin this back together on a tilde or whatever we want. Mm-hmm. We'll just join it back together on the comma and kind of put it back to how it was. And then we'll print that out.
Now, here's kind of an interesting thing here, Brian. There's a loop structure here that we haven't gone over.
Yeah.
Right? Now, what this is doing is this is for, and then NS string star S is going to be the current value, and then in, and then list is the NS array. So what it's saying is go from the first to the last item, and each time we iterate through this, the pointer S will represent that current value that we're looking at in that list.
And this is considered to be a for each loop.
Yes. And many languages implement this. It's also different in every language pretty much.
Yeah, it is.
So now NS mutable string, Brian, now we've discussed the NS string. Now the NS mutable string is the guy that we can change, right?
Yeah.
So in this very first line here, when we're creating an instance of NS mutable string, we're just calling the init method. We're not passing in any parameters. It's going to be a blank nothing. Now, when I call the setString method, I'm now changing the value that's encapsulated inside the mutable string. Yeah, this is craziness.
So you guys are used to this kind of stuff.
Yeah, and then append string. So now we're going to...
Just like we've seen in C++.
Right. We're going to go to that instance. We're going to append the string. This is more text. And then I'm going to insert a string. Holy crap. This is inserted text. Now remember, this is that sentence structure. On my object, insert string, this string, at index this, right? So at index 18, put this string in there. So the output of this program is just going to say this is the text, which is the first string as we said it. Appending, this is more text, so that just adds it to the end. Now I'm inserting this in the middle of the string, because if you look at that last output where it says this is more text is pushed out. So this is inserted text is kind of slid right there in the middle.
Very cool.
It's kind of cool, right?
Here's another example of a method in the NS mutable string called delete characters in range. And so in this example, we create an NS mutable string and we just allocate it. So that's just an empty string. And then we're going to set a string. This is the text. And we'll print it out and make sure it's set. And then we'll create a new NS range object R.
We told you you'd see these guys.
Yeah. And so we call that NS make range function. And we'll pass it like 4 and 3.
Right.
So that's
location 4.
Yep. And then length 3.
Yep.
And so we're going to call on the MS, that first string the mutable string that we created with this is the text. We're going to call on that object instance the method delete characters in range. And we're going to pass it that NS range object. So that's going to delete characters starting at position 4, and it's going to delete characters. So that should delete space IS.
Okay. Let's prove Brian's theory. Oh, damn it.
Right. So this is the text.
This is the text, fool. Now on the opposite spectrum, Brian, let's say I don't want to delete the text. You know, let's say you want to delete and insert text. Well, that's replacing text, right?
Yep.
So what we're going to do here is exactly the same example. This is the text, and we're going to be creating an NS range, but this time we're putting in different coordinates. So, our location is going to be 12, and the length is going to be 4. So inside of that string, this is the text. We're going to be replacing TEXT lowercase with capital TEXT by calling the replace characters in range method. So MS, replace characters in range, passing the parameter R. And then remember, Brian, with string is just a label.
Right.
It has nothing to do with anything except for
label.
It's readability.
Yes.
Just so that it's for the developer's benefit. So I want to go into this range and replace with this string, text. So the output should look something like a this.
Yeah. Like that.
Like a this. And a string, Brian.
Awesome.
Very awesome.
Dog and pony show.
Like Ryan was saying, this is kind of like the de facto is the wrong word. Is that right?
Yeah.
Like this is a lot of times when learning Objective-C or you get a book on Objective-C, what's on page 1, Brian?
NS string.
What's an NS string? Yeah, exactly. So, once you kind of figure out how that functions, that is part of that NSObject inheritance structure. Right. Once you get that, everything else is pretty easy.
And then the other half of that is to kind of get that, how there's mushrooms and toadstools, and for every mushroom there's like an equivalent toadstool that'll kill you.
Yeah.
It's like they're evil twins. Just like that, NSObjects have their immutable forms, and string is a perfect example of how those get implemented. Welcome back. We're now going to be talking about a big steaming pile of NSLog and its functions. Or methods, whatever you want to call them.
Well, this is actually focusing more on functions. And just to kind of show you how C and Objective-C are the same kind of thing. So we're just going to try to make this quick and painless because this isn't really an important lesson, but we're just going to throw this out there. So an NSLog is basically just a function that's used to write information to the command terminal in a log output format. So it kind of works like printf, and a common format is like, the time, the date, the executable that you're running, and some process identifier. So like, here's an example of some code where I just say, I'm running an NSLog. Okay, that's cool. And then if you look at the bottom, that's what the output is. And there's also different ways that you can use this. Very much like printf. So the first one is a format string, the first parameter. And just like in printf, if you don't specify any arguments, it'll just print that string out. But if you do specify arguments, you can then, insert values into your NS string.
So like Kevin was saying, we can use the format string just like we do in C and printf. And in this case, here's a list of common format sequences. The @ symbol gets replaced with an NSObject type.
Right, like if you wanted to do it, replace an NS string or insert an NS string, right?
A lot of these are kind of similar, like the %d, %i is a signed integer.
Yep.
%u is unsigned integer, f is a float, just like you'd expect. You can do lowercase or uppercase x for hexadecimal, and that's pretty similar. %p is the pointer value. %s is a C string,
right,
just like it normally would be. And %c is a character. So they really tried to keep this very similar to the way printf works, but it's the NSLog functions implementation of it. So here's an example of calling the NSLog and passing an NS string into it. So we create an NS string called error message, and this is the error message. And then we call the NSLog function, and we pass it first the NS string, that's our format string. So because it's an NS string, we have to put that @ in front of it. And then we do a %s, which will be replaced with the string, an NS string.
Yes, a C string.
A C string,
because the %at is the NS string.
Right. And ::error dash %at. So %at will be some sort of object, an NS object, and %s will be a C string. So the C string that we're going to pass it, which is the first parameter, is __func___, which passes it the function that we're currently in, that we're calling, and that's a preprocessor directive that we have access to.
Or macro, whatever.
Right. And the next parameter is going to be error message, which is our NS string, and that's going to be replaced with the %at.
Right.
To replace the NS object. So if we look at the output, we can see that the NSLog naturally will give it that format, the date-time format, NSLog test.
Which is the executable that we're running.
And then the process ID. Yep. So if we want to see like what process was running. And then main is the result of __func__, because we're in the main function. And then error, this is an error message, and that's our NS string. So pretty straightforward.
Yep.
If you're used to printf, this should be no big deal for you.
Oh, absolutely. That's why we said there's really not that much new information here. We're just throwing it out there. So this next example right here is we're going to be using the NS string with format method to format our own string, because really that's pretty much all that the NSLog is doing when I pass it a format string.
Right.
So here I have string, format string, whatever that's equals an instance level. So we're doing a NS string with format : and then the @ remember that just specifies this is a NS string, and then %c space %d, passing it 2 parameters, x and 20. So when I run this on the when I output this, the output is going to be the character x and space 20.
Yeah,
craziness.
Perfect. Because Objective-C is pretty much C, these functions are going to work the same way. You know, just like you can tell the similarities to printf and NSLog and how they kind of take things in. And when we call functions, it's just like calling a function in C. The only real difference is that in this case, now we have our NSObject layer, which is great.
Wait a second, Brian. So calling a function in Objective-C is exactly the same as
it is
C?
It effectively is running on C, so...
What the hell? I thought this was a different language. This is bullshit.
Yeah. So here in this case, we make a function just to kind of demonstrate this.
A function prototype? What? What?
So here's our function prototype. We declare it, convert string. It's going to return an NS string pointer type, because we can do that here.
Yeah.
And it's going to take in a constant char star. So our function implementation down below is NS string is a return type convert, just like we do in C. We pass in a parameter constant char star s, and we return, and now we're going to call it in our Objective-C manner, NS string, which is our static class instantiation of string with C string, and pass it the parameter s. And that's it. So that's a perfect, simple, smooth example of implementing a function in Objective-C, just like you would in C, just like you're used to already doing. And if you're not, go back and watch the C videos.
Right, so then the output of this would be this. Now, Brian, recall, we have no auto-release stuff in place, so we're going to see errors. Oh, you don't have an auto-release pool.
Right.
Again, ignore it. Ignore that.
We'll get there.
Yeah, we'll get there, but this is what the output of that would essentially be.
Yep.
So here's another cool one, Brian. So I'm going to make a function here for NSInteger and make that GCD. So this is going to be a recursive algorithm.
Right.
We're going to take in two NSIntegers. So NSInteger x is 90, y is 50, and z equals the greatest common divisor of those two. And this is like the same thing as the GCD function that we wrote in C.
Yeah, it's exactly the same. The only difference is we're using that NSInteger type def instead of int.
Yeah, now where this kind of gets a little crazy is when we want to use the NS number.
Right.
Because the NS number is a non-mutable, it's an immutable encapsulation of a value. So, in order for me to use this value, I have to like twist open the cap, pull out the value, and take those two values, do an operation, and jam it inside of another one, right? So this is the exact same thing, but we're using an NS number. So if you look at the top, NS number X, number with integer 90, and then Y, number with integer 50. GCD, so number Z. So those two, you see, those are instance level, so those do have the auto release, which is why we have the auto release errors in the top. So if B integer value instead of if B equals, right? Then return A, whatever. And then else, we're just setting a temporary integer equal to the integer value of A mod the integer value of B, making a new instance of NS number, calling the auto release. So this is going to be NS number with integer n, and then call that function again and again and again.
That's awesome.
Yeah,
Not too bad.
That's craziness. Oh, that's it?
Yeah.
Holy shit, that was easy.
So everything that you've already learned in C, in programming in C, really translates well and very rapidly, and stuff you learn in C++, obviously, of course, too, translates really well to Objective-C. So all of the things that you learned about functions and implementing functions and calling parameters and everything else, all is still applies because we're really running on top of the C language. Hey everybody.
Hey buddy!
Welcome to our next lab.
Yes, the next lab.
There's the one before the next one, but it's the one after the past one.
Sure, why not? So Brian, what are we going to do with this lab?
Well, we're going to just kind of get a brief and quick exposure to using an NS number. We're still going to be out of the console, but
in the console. This is the console.
We're still going to be in the terminal.
In the terminal.
And this is just going to be just like a really quick usage of NS number in some program. And so to play around with it and to demonstrate NS numbers, we're going to write a quick function C style. That will test to see whether it's prime or not.
Sounds fair.
Yeah.
All right. Do it. So open up your favorite ASCII text editor, which ours for the day is Text Wrangler. I'm gonna save as, and our Wibbit.net directory. We'll create what do you want? Is prime.m, right? Because we're basically just gonna create a program that will test for a prime number using using an NS number, but we're also gonna be like decrypting the NS number and weird craziness. Yeah. But that's Objective-C.
Extracting the fruit out of the NS number.
Objective-C is all about boxing shit up and then boxing it 5 seconds later. Foundation/fondation.
JaneFonda.h.
Foundation.h. So I'm pulling in the foundation and its main.
Yep. And we'll do some parameter passing from the command line. From
Okay.
the terminal line.
And you'll also notice that Brian and I, against our own instinct, are using the Unix style, or, you know, I guess the Unix style curly braces where we're kind of catting them up against the methods and stuff like that, or the functions, just because that's what they do in Objective-C. That's what you're going to be most exposed to. So.
Yeah. And that's what Kevin's mom likes to do.
She likes to just cat right up against Brian's main function.
And expose herself.
So we're also going to show you some other really dumb data type
Expose her entry point.
that Objective-C forces down your throat, and that is the capital bool. So the capital bool, we're going to just make a function prototype, and we're just going to call this is prime number.
You should say is an Optimus Prime number.
This will be taking in an NS number, object, pointer, whatever, and that's that. So just like in C and C++, when you're putting together your function prototypes, you just prototype that above the main function and then declare it below it. So in this case, we're just going to do a num, and that's that.
That's it.
So we can also just do some quick input checking. So if argument count does not equal 2, because remember, Brian, the first one's going to be the executable, the second one's going to be what we pass it. We can put to the user.
Error.
Error. Wrong number of args. Toll. Nice. Actually, I don't want my Mac to be that mean. Wrong number
Buddy.
of args. No. Can't imagine why you would do this.
To me.
Here we go.
Okay.
Fair enough. Fair enough.
Jenny.
Jenny. Return 1. Okay, Brian.
Return 1. I guess it's a problem.
Well, returning 1 because
Fair enough,
it's
yeah.
failed, right?
Okie dokie. So now we just say like if is prime number.
Okay.
Well, let's make a number first.
Let's do that.
Yeah. So we'll make an NS number.
Like this, right?
Yeah. Num.
My num.
And then we'll make it like 7.
All right, now the NS, we're going to be getting into like how these brackets and expressions work later. Don't get too hung up on it. But we're going to be calling, and this is stuff you guys already know, we're going to be calling the class, we're going to call a static method inside of the class. And the class is called NSNumber. And the static method that we're going to be calling is called, what is it, number?
Number from integer.
Number from integer. And we're going to be calling the ATOI, ASCII to integer,
No.
which we use in C.
Oh, we're going to go from string. That's right. I was going to say we could just go from a number.
We're pulling it, but it's coming in as a string.
Oh, yeah, I forget. Sorry.
And that's going to be
So it's not a number from integer.
argv0. Why not? It's an integer now, bro.
Oh, yeah. Good call.
What the f*** is wrong with
I don't
you,
know.
man?
I was blowing a zebra off the side.
I'm going to pull these brackets in so we can see it. So, for the NSNumber object, call the number from integer method and pass it an ASCII to integer conversion of argument sub 1.
So we need to include the library?
I think foundation.h has it. It already.
Okay.
I think it already does. Let's
Awesome. Well, that's convenient. Let's check
just
it out.
check. Return yes, no yes.
Yes.
Yeah. I like that better.
No, yeah.
No, yeah.
Yeah, I'm going to need you to...
I'm gonna need let's see, where am I? PWD. Okay, I'm already in the directory. So GCC dash library objc dash framework foundation, and then we're gonna do is Optimus Prime dash O is Optimus Prime, and cool number from inner. Is that right? Why is this so lame?
I don't know.
I think it might be number with integer. I think it's number with integer. So what this warning is saying is that we typed in the wrong method. It's saying that this may not respond. Here's the funny thing, Brian. This pops up as a warning.
All right, so it'll still let you do it. Yeah.
Not respond. So whatever.
Your program will probably crash and burn, but we don't want to say that that's the case. We're just kind of,
So we're going to be calling number with integer.
Yeah. Awesome.
That should be the end of that problem. Cool.
Yeah, cool. All right.
Very nice.
So now we just want to implement our method, our function in this case, sorry. We'll implement our function and then test the number and then print something out.
All right, so first we're going to check to see if it is a prime number. And we're going to be doing that by passing
my num
into this if statement. And if it is, we'll do like a little printf action, but we'll define this in a moment. If we scroll down here to the function, Brian.
Yeah.
we have to do what's called unboxing, right? Which is a very common thing you have to do in Objective-C no matter what the hell you're working with.
So we want to turn the NS number, just for convenience sake, into an NS integer. And
just for convenience sake?
And an NS integer, as you know, is basically a type def of an integer.
Right.
So we can do with this as we please.
Right, so we can just... Basically, this I believe this is what they call unboxing, and that's when you take a data type to extract the data type. So from here, we're going to do a num, and we're going to call the integer value method. So we unbox the integer value that's stored inside of that NS number.
Yep.
And we're also going to do NS integer I, because what are we going to do, Brian?
Do a for loop.
For loop.
Okay, so the first thing we want to test is if n mod 2 is 0, that means the number is even, and it cannot be a prime number. So we'll just kick out of here. No. It's like a French language.
No!
If n mod 2, I can't even do a French accent. All I can say is no.
No! Yours is way better than mine.
It should just be no and we.
Yeah, we. Like this we? Or this we?
Was it OUI?
Or
Howie?
that we? OHI?
Ohio? Howie?
Whatever.
Alright, anyway. So now let's run through our for loop, and we're just going to iterate from 3 to almost the length of n.
Right.
And we'll increment by 2 because we're not going to be testing the even numbers.
Okay. So since Brian has already ruled out that this number is not a even number, which means, a prime number by definition is a number that's only divisible by two numbers, 1 and itself. That's what a prime number is.
Right.
So if something is divisible by 2, well, that's not 1 and that's not itself. That's a divisible number.
Right.
So by starting at 3, we've already ruled out 1 because every number is divisible by 1.
And if some put 1 in here, it's not going to be 2. It's not going to be, an even number. It's not even going to go on the for loop, and it's going to return yes, and 1 is technically a prime number. So
yeah, right. Mm-hmm. Right. So when we start at 3,
so we're kosher.
We're good. We're kosher. So there's only going to be one condition.
Yep. So if the number mod I basically, so if is 0, right? So if it's divisible by anything, then it's not a prime.
Well, I think that's it.
Yep, that's pretty straightforward.
All right, let's go compile.
Not necessarily the most efficient algorithm for determining this.
No, this is the most efficient algorithm.
Just don't put any big numbers in there; you'll be fine.
I think we should do a number of 7 trillion billion.
Or if you put a large number in there, just don't be in a hurry.
So if we do is Optimus Prime with no arguments, we're going to get our error. Wrong number of arguments. I can't imagine why you would do this.
To
me. What do you want to do, Brian?
Let's do like 14, because that's not prime.
14.
So it just won't say anything. It'll just say that we're leaking all over the place.
Right. And we didn't print anything. Now
yeah, we didn't put in our auto release pool. Actually, let's print an else statement.
Yeah, let's pull the code up again real quick. So ignore that auto release.
No, we weren't printing anything anyway. Well, it worked.
All right, I'm gonna
just release it.
No, I'm gonna just do this to it so that we don't have to worry about auto release for right now. So we're gonna learn about this later, guys. Don't worry, okay? Just don't worry. Init with integer, and that should remove that issue.
Again, we don't want you to worry about memory management right yet.
Yeah, and we're going to discuss this in depth later. We just want you to hey, what is this whole weird thing? Okay.
Okay, so if it's a prime number, let's just print out your number is a prime number.
Or how about %d is a prime number?
Cool. I like it.
And we're going to have to kind of unbox this again and typecast this as an integer because printf doesn't know what an NS integer is. So we're going to do well, actually, no, we don't have to do that.
No, we can just say the integer value.
No, check this out. Watch, this is awesome.
No, this is printf.
Yeah, I know.
Yeah. Tricky.
Yeah.
That's funny.
So we can do that. That is a prime number.
Yeah, that works.
And
then else it is not.
Whoop. Else is a not
is a non prime number.
Is not a prime. Is not a prime. Okay. Whew. All right. Let's try this again.
Okay, cool.
Now, don't be scared of that NS Autorelease error that we got. Or
we'll get into it. Yeah. We'll get there.
Don't be scared.
We just want to...
See, Objective-C likes to go swimming, and I'm not sure why that popped up again.
Because we didn't rebuild.
I thought we did.
No.
No? Okay. Well, you know what, Brian?
No.
Yes. All right. So
how did I guess?
We recompiled it. Oh, 14 is not a prime number.
Hey, it works.
How about 11?
That's incorrect.
That is incorrect.
11 is, in fact, a prime number. Try 7.
Why is it failing every time?
Well, it looks like...
Oh, look at this. I think, don't we have to do this?
Oh, yeah, that's right.
If prime number equals yes.
Yep.
Without context, I'm sure that this is pretty freaking some of you guys out. So don't get scared. Don't be all like Brian and stuff. Fuck. Why is this happening?
Go down to the function.
All right, so there's something wrong with the algorithm, Brian.
Hooray! We get to debug a problem.
All right, so I guess we can just put this back, because that obviously was not the problem. Do you see something wrong with this algorithm, Brian?
Looks like we're incrementing and
we're incrementing.
So there's syntax issues that you can come across. There's compiler issues, linking issues, and logical issues. This would be a fatal case of a logical error.
Yeah, the logical errors are the worst kind.
Yep, or like basically a typo, but
yeah,
whatever.
So now let's try it again, Brian.
That's the problem with computers, is they do what you tell them to do, not what you want them to do.
So 7 is prime, but 7D is not prime.
Yeah.
How about 7 million?
It's probably not prime.
It's not. Wow, that was pretty fast.
Well, because it's an even number.
Oh.
Now do like...
But see that?
Do like...
1.
Yeah.
Well, that was insanely fast.
How is that a prime number? Do a different big one.
That is a prime number. That's divisible by 1 in itself.
Do like 9.
Well, that might be divisible by 3.
It is. That's still pretty damn fast.
Yeah.
Oh well.
9.
Anyway.
9. I don't know how far we can push this thing.
Anyway.
Nice.
Cool. Fun times.
Yeah. So there's your basic, and we'll just kind of scrub through the code one last time, Brian. Give me your input from top to bottom.
It's pretty straightforward, other than the fact that, I'll say this, without IntelliSense, navigating these objects is a pain.
Yeah.
Because you're likely not going to memorize every method of every object, probably because it changes every other month. You know, like, you'll memorize half of the methods and then they're depreciated the next month and you have to learn a whole new set of them. Oh, and then you go from iOS to iPhone and you gotta learn them all over again, and then they change the one by the time you get back to the other. So, you're probably not gonna memorize all of these, and they're gonna be a moving target. IntelliSense will kinda help you once you get familiar with the language that Apple tends to use for their method names. That said, don't put in the wrong number of arguments. We instantiate a number to a number pointer. We allocate the memory space. We initialize it with an integer. We're using the old school ATOI to convert the string to an integer. It's fast. It works. It's not the Apple-y way to do it, but it's perfectly effective. Then we just test to see if it's a prime number, then we print that or not print. In our prime number algorithm, it's very basic. We just unbox the integer value, store it, and then if it's an even number, we kick out. And then we iterate from 3 to almost the length of the number, skipping the integer numbers. If I versus n is divisible, and we increment I this time. If n and I is divisible, if n mod I is 0, then we return no, because it's divisible, it's not a prime number. And that's it. It's pretty straightforward. But anyway, that kind of gives you a very brief, quick sense of the NS number and NS integer.
Welcome back to Programming in Objective-C. Kevin and Brian are here again to talk about... Are you done sipping your coffee, Brian? Nice.
Interfaces.
To talk about interfaces. Now, Brian, interfaces is kind of like a different name in Objective-C for classes and objects, right?
So we're going to be creating interfaces.
Hooray!
Hooray, interfaces.
Just to kind of preface this, everything in Objective-C is supposed to be extendable, like very easily polymorphic, like everything comes from the NSObject, like everything is all very like connectable and connected and together. It's like hippie language, right? So just keep that in mind. Anyway, interfaces or classes are similar to a class declaration in C++. Mm-hmm. They're declared a little differently. The code files are kind of similar in nature, where you have the interface file, or like the header file, the .h file, which is the object template. Nothing new. You're used to this. Then you have the implementation file, which is the .m file.
Implementation file.
That would be like in C++, it would be the .cpp file.
Yep. Mm-hmm.
And these are like the object actions, the object implementation.
Yeah, the definitions of stuff.
And then you have the driver file, and that's also a .m file.
Wow.
So this is just like in C++, where you have the .h, the .cpp driver, just like we've shown a bunch of times. You know?
Yep.
And, obviously the driver is the program that evokes the object.
Sexy. Very nice, Brian. So, let's do kind of a basic example. Now, there's really nothing to kind of boast about with this example, because it's just kind of, I don't know, just getting you exposed to the concept. So we're just going to make a little interface that stores a number, and it allows us to retrieve that number.
Cool.
Right?
Yep.
So if you had this, if I asked you if this is immutable or immutable by that description, what would you say?
It's immutable.
No, it is not, because we are doing what? We're storing and
Well,
retrieving.
I guess it depends if storing is part of the constructor.
That's true. Well, let's take a look at the object. Now, if I asked you if that was mutable or
Okay,
immutable.
well, it's mutable.
All right, so now check this out, guys. We're going to do the classic Whippet.net line-by-line approach here, and let's take a look and dissect what we're looking at here. So if you look here in green, right, that's the interface declaration. That's just saying, I declare this interface! And then within that code block, after we declare the interface, and we'll get into the inheritance there in a second, we're declaring fields. And then below that, we're declaring methods, and then the @end terminates, basically says this is the end of the interface declaration.
Right.
So, the @interface keyword, Brian, let's pick it up right there.
So this is similar to declaring a class, where we'd say, I want a class called numbers, and numbers extends from NSObject. Instead of class, we're just going to be calling it @interface.
Right.
Because that's what this is considered to be. And what that really does is it kind of gives them the ability to leverage how they want to implement declaring and blueprinting out classes in their own way, and we're just going to call that interfaces.
Right, and this is the Objective-C component. So
Right.
this isn't the Coca component.
Right. So now here is the interface for the class name, and this is the class that we're extending.
Right.
So we're going to be extending the NSObject. This is probably the most common object that we'll be extending. So almost any time that you create a new interface, you're going to be creating an interface that extends an NSObject.
Right, or another object that had previously been extended by.
Right, exactly.
Yeah.
Right. So that's the object we're inheriting from.
And that is where the Coca component slides in there.
Yes. Here's the field declaration. So any kind of fields that are required, we're going to declare them here. And this is kind of similar like when we declare a class and we have like private and public, you know.
Right.
This is sort of that area. Now, where it's slightly different is our method declarations aren't inside of the interface curly brace block. They're outside of it, but in the same file and before the end indicator that ends the interface. So the fields go inside of the curly braces, but the method, kind of prototypes, the declarations, go between interface and end. And if they're instance level, you put a dash in the front to designate the fact that this is an instant level or it's a non-static. So we have the return type encased in parentheses. That's the return data type. So this is kind of similar to all the concepts that you know, like this method is going to return void. This is the method name, and then the parameter separator, just like we see when we call the method, and then the parameter data type, and then what we want that variable name to be. So now this is a little different, where we actually declare that variable name on this side in the declarations. Now here's another one that's also instance level. It returns an NS integer, and there's no parameters, so we don't need the colon. We just give it the method name, which is get number. And then end is the end to block out the entire area where we're declaring the interface as blueprint.
Wow, Brian. That was explained very, very well.
Sweet.
Now let's take a look at the implementation file.
Okay.
Now let's take a look at the implementation file.
Okay.
We're saying that jokingly. We actually think it's really stupid that a lot of Mac people call it implementation. Sorry. Implementation, folks. It's an I. Sorry. Anyways, so you can see this is broken up into basically two components. Using the import directive to pull in that header file that we just created.
Oh, yeah.
And the actual definition of the numbers interface.
So this isn't drastically different.
No, it's absolutely not. So you can kind of see that the implementations of these two methods directly relate back to their prototypes that were defined in the .h file,
Beautiful.
including the same exact text. So when you're defining this, you can literally copy that code, paste it here, and put little squirrely curly braces around it and start working on your definitions.
Like, do you remember in C++ when we would copy and paste out of the header, we'd have to change all those different things?
Yeah, and scope in, all that stuff. This, no, not the case.
Not in this case, we can just stick it in there.
So instead of the interface keyword, we're going to be using add implementation, and this is basically the same thing as interface. It marks the start of the implementation for the class, and then of course the numbers, which directly relates back to the interface name that was previously declared. Then here is my method for set number, and you can see that what we're doing here is back in the back here we had you can see up there NS integer global number. We're just going to set global number underscore global number equal to num.
Yep, that's it.
It's not too crazy. And then here's my getter. I'm just going to now give the user that. So we just encapsulated an NS integer.
Nice.
Hooray, hooray, hooray. This is probably what the NS integer class should have been, but whatever.
And then again, we also have the at end.
Right. So that further kind of, this is where the implementation begins. This is where the implementation ends. Now, Brian, just like in C++, the combination of these two give us the potential to create an object called numbers. Now, Brian, how do we drive and evoke this class?
So we create an instance of our numbers interface.
We also have to import the numbers.m file.
Right.
Yep.
Oh yeah, so we import numbers.m just like we would do in C or C++. There's nothing really new with this. And here we can just say numbers, my num, and that's going to be a pointer because it's coming from the NS object. And we just do an alloc init. And then once that happens, since this is mutable, we can say my num set number 1234, and that sets the number. And then we just print get number.
That's crazy.
And get number returns the NS number, and NS number is effectively an integer, so that gets passed into printf.
Doesn't this suspiciously look exactly the same as NS string and NS array?
Yeah, yeah.
Holy sh! So now we're actually working at that level now.
Yeah.
That's maddening, dude.
That's cool.
So here we go, guys. Now we're gonna kind of walk through this one at a time.
So first we import numbers.m, our implementation file that we just created, and then we declare a variable named mynum of type numbers, and that's going to create space and memory.
Well, that's going to declare the pointer.
Right.
Right.
So this declares the pointer, creates a pointer for the mynum object. Then we allocate the memory space of the size we need for a numbers object, which since it inheritance from an NS object, it's really an NS object memory blocking space with our internal number in there. And then we call init. And init instantiates and gets a global number in there, as you can see, because that was our internally defined variable.
Yeah, so now we have a functional pointer.
Yep. So now we have mynum, and we call the instance level method that we created called setNumber, and we pass it as a parameter 1234. So that sets our internal global number to be 1234. And then when we call printf, we call mynum getNumber, and getNumber returns the NS number, NS integer, which is effectively a type def of integer. So when we pass it into printf %d, it can print it out.
Very nice.
And it prints out the value is 1234.
That's crazy, Brian.
Yeah.
So something to kind of be aware of. This interface, just like we had mentioned before, is not written in pure Objective-C. We use the foundation library, which is a root part of the Apple Coca framework.
Right.
So we pulled in with the init method. That init method comes with NSObject. We didn't write that init method at all. It just kind of came along with it. So let's kind of do another example, because that one just was not sexy enough for me, Brian.
Yeah. We want to just beat this in there.
Why not? So let's do another example that kind of pushes this a little bit further. It's kind of like a real number, a classic example, which we also did this in C++ as well. So in mathematics, we know that a real number is a non-imaginary number. So they can also be expressed by a numerator divided by a denominator, which is also called a rational number.
Right.
But real number is also technically the same thing. Mm-hmm. So we want to store two integers, a numerator and a denominator, and we want to access each one of them individually and return the divided result.
Cool.
The non-imaginary number results.
Right.
So let's kind of dissect this code right here.
All right.
So Brian, maybe you could help dissect this code here.
So we import foundation because we're going to be extending from the NS object. So we declare our interface, which we're going to call real number, and that is inherited from NS object. So that will give us all of the init and alloc and whatever else. our internal fields are going to be NSInteger type underscore numerator and underscore denominator. We're going to have 3 instance level methods that are going to be setters. One is going to set the numerator, set the denominator, and then
set the numerator and denominator.
Right. So one takes in the numerator, one takes the denominator, and one takes in numerator, and then the text label called and denominator.
Yeah.
Denominator, so that, like we said before, where we want this to, their style of doing this is to make it kind of plain English. We can say set numerator 5 and denominator 10, or whatever. And then we have a couple getters. We just have a get numerator, get denominator, and get value, which will return a double, because that will be the result of the division.
Right. Excellent.
And then end.
Oh, yes, nice. So when we kind of bust this apart into different sections, you can see that we're importing the Coca Foundation library first.
Yep.
We're declaring the interface second, and also sneaking in our fields, yes. Then we're also going to define our method declarations next. Now these method declarations are broken apart as setters and getters.
Yep.
And then we just simply end the interface. So it just kind of breaks apart into these very logical chunks.
Cool.
Okay, now Brian, here since we went through C++, and we're assuming that you guys, took it seriously and rocked through it. This is the exact equivalent written in C++ on the left-hand side here. So you might be wondering, well, why are those protected and not private? And I don't think we've discussed this yet. And I think we will talk about access specifiers in a little bit, but in Objective-C, if you do not specify the protection level of a field, it is assumed to be protected.
Right.
Which, remember now, that means inheriting classes can access it, but calling code cannot access it. So in this case, in the C equivalent, we have protected numerator denominator, setting those, setters, setting the getters. So there is your template for those two.
Very cool.
Now, Brian, let's talk about some I'm going to stop saying that. Let's talk about some implementation.
So like we would normally do with our implementation file, we import the header, or the blueprint, the kind of like declaration of what's going to be in here. And then we start with our implementation tag, which is @implementation, and then we go down and end our implementation with the @end on the bottom.
Very nice.
So this is the implementation of real number, which is the same name we gave in our interface name. And we just start marching through. We don't have to do anything with the fields at this point. So those are just kind of declared in the header, just like they would be in C++ at this point. And we will go through and implement our methods. So these methods look exactly like they do in the header, but in this case, we just surround the code block and put in our implementation. So set numerator, we're going to go to our self, which we have access to, which is whatever this object instance is, because this is an instance level. It's got the dash. We can access self. And then because this is a pointer, we're going to use the arrow just like we would in C.
Right. Now, real quick, Brian, just to kind of extend on this, in C++, the open recursion keyword is this.
Right.
So this object. Now, Objective-C took the more Perl approach, which is self. So instead of, this is the same thing as this. So don't confuse that. So self is the pointer to the instance that it currently is. Right. Yes.
So self arrow underscore numerator to access the protected internal field. We'll set that equal to our parameter numerator. Same thing with denominator. And then when we implement set numerator and denominator, which is the one that takes both, we have the text label on this one as well. So it's set numerator, numerator, and denominator, denominator. And all we're basically going to be doing is calling the self instance and then the set numerator method and pass as a parameter numerator. So just like we would do in C++ where we start building on those lower level methods and leveraging those later, we're going to do the same thing here. It's no different. Programming's programming no matter what language you're in.
Yep.
Unless it's VB.
Yeah. In which case, yeah.
So get numerator, it returns an NSInteger, return self, point to our protected internal field underscore numerator. Same thing with the denominator. And then for get value, all we're going to be doing is returning typecast double, just like we would in C++ or C. And then self, call the method get numerator, divided by double typecast value of self get denominator. So it's pretty So once you start getting used to the syntax and kind of see how those evaluations happen within those brackets, and the fact that it's not self.get numerator, it's self-get numerator, and the way that the implementation wants the dash, the data type surrounded in the parens, once you start kind of getting used to that syntax, conceptually, there's no difference between this and C and C++, or C++ particularly.
Right.
And as you can see, the C++ equivalent to this is very similar. So in C++ on the left, you can see that we would have our void real number scope into set numerator, taking the parameter int numerator. In this case, we just have the dash void. We don't have to scope in because we're inside of that implementation real number block. So there's no scoping in real number to set numerator on each line. It just happens once, which kind of makes sense because real number : over and over and over and over in C++ is kind of redundant.
Yeah.
And then we've taken the parameter as value numerator, just like we did int numerator. This is going to be NS integer numerator. And then instead of this arrow numerator, it's going to be self arrow numerator. So it's really very similar.
Right. Absolutely. So now the real number driver, Brian. Now here is where everything kind of comes together. We're going to create an instance of our real number class called myRealNum, and we're just going to be calling alloc init, which you guys remember comes from NSObject. And we're going to evoke against that the setNumerator method, and we're going to set the numerator as 100 and setting the denominator as 51. And then we're just going to print f, %d, %d, %f, get numerator, get denominator, get value, and release, which don't focus on release yet, but
We're
releasing our object. Now, if we want to compare this to...
Releasing it into the wild.
Yes. Yes. The wild, yes.
I don't know.
Now, here is the C++ equivalent.
Wow, that looks very similar.
It's like exactly the same damn thing, pretty much.
So the biggest difference that you can see right away is instead of my real num arrow get numerator paren, it's just evaluation brackets of my real num get numerator.
Yeah. Here's an example of calling the set numerator and denominator method.
I still find those things funny. I don't know why. It's still tough for me to adjust to that.
It's its own thing.
Yeah, it is.
So here we go. We're going to evoke against myRealNum. We're going to call the set numerator method, and we're going to value that 100 and denominator, which is like an overload of the set numerator, :51. Mm-hmm. So remember, that and denominator is label text that has absolutely nothing to do other than uniquely identifying this particular method call.
Yep.
Right? And then the output's exactly the same. And if I were to try to do something similar in C++, which technically you cannot, we would just have a method called setNumerator and denominator and just pass two parameters.
Right. This is based on C, and this language does not support operator overloading. This concept doesn't exist in Objective-C. But it's common to use methods to kind of like get around this. Like, for example, you can say like, what we would want to do with operator overloading is like, you have a first object and a second object. And you want to be able to say first object plus second object stored as new object. But you can't do that. So what people will tend to do is they'll do like an add method on the instance level. So you can kind of say like new object equals first object add second object. You know what I mean? Mm-hmm. So it's kind of like it's another way to do it. But it's what we got.
And that's the end of the introduction to interfaces. Definitely try to mess around. Do as many examples as you can.
Yep, go through the labs.
Yeah, go through the labs, and please pay special attention to this, because this is where we start to like break off into the implementation of Objective-C that we're going to start doing. Everything is built on this concept. Enjoy, folks. We'll see you again real soon. Hey guys, Kevin here from Wibbit.net. What I want to do in this video is I'm going to kind of introduce you guys to the whole interface class concept, and we're just going to be doing a couple of examples. This first one that we're going to do is we're just going to kind of follow what we did in the lesson video and the lecture video, and we're just going to start getting used to writing classes, what that entails, compiling, and all that fun stuff. So the first thing we'll do is to get started here is I'm going to open up my applications, and I'm going to open up my text wrangler. You guys can open up whichever text editor you like the most, and then from here, for my utilities, fire up my terminal. And once I have these two applications ready to go, then we're ready to start coding. So the first one that we're going to do is the interface that we did in the lectures where we made a numbers interface. Now, I know that we kind of went over this code and we kind of described everything pretty well, but I want to kind of get used to writing it, compiling it, running it, and that sort of thing, instantiating it. So, as you guys recall, when we're building classes, we're going to need to have a pair of files here. So we're going to have a header file, an implementation file, and a driver file, which is what these three files here on the right is going to represent. So if I file save as this in my Wibbit.net directory, let's just call this numbers.h, and then the second one here, file save as, and the implementation is going to be numbers.m, and then the driver code file will also have a .m extension, so we'll just do file save as, we'll just call it numbers driver.m. And once we have all these code files up, we can jump up here to the numbers.h and we can start coding. So remember, to declare an interface, we're going to say @interface, and this is the same thing as calling it a class. The name of the class, so the class here is going to be called numbers.
And we're going to be inheriting from NSObjects, which we'll discuss in a little more detail later on. So when I open up this block here is where I'm going to store my fields. My public, my private, and my protected fields will go in this code block here. And then this end is going to mark where my interface or my class declaration ends. So this space down here after this code block is where I'm going to declare all of my methods. Now in Objective-C, we really have only one option for a method, and that's a public method, but we'll kind of discuss a little bit more of that as we go through these. Now in this numbers interface, we had a protected value called global number, and this was an NS integer, which is not an object type, so we don't have to do NS integer star, it's just going to be NS integer, and this variable is going to be called global number. And this is not instantiated, I'm just declaring that if this was a pointer, then I would have to init this later, but we'll go over that stuff later on. So keep in mind, and we'll discuss this later, but this is a protected type, so I could just call this protected right here, and that would be equivalent, but we'll discuss more of that later. I just want to make you aware that if we don't define what the protection level is, then it's going to be a protected type. Now let's build our setters and getters. So here I'm going to declare a return type of not vodka, of void. So this little dash here says that this is an instance or non-static method. The return type is going to be inside these parentheses. So I'm going to return an instance level method, was going to return void. Then I define the name of the method, set number, and then by putting this colon here, I'm then saying that after we've called the receiver of this, which is the instance, I'm going to send it a message. The message is going to be the method, and the method is going to say set the number, and then we're going to pass it some parameters, or in this case just a parameter. And the parameter is going to be of type NS integer, and the variable name is going to be called num. So now we've defined the set number prototype. So now when we come down here, we will define the getter. And the getter is also going to be an instance level, and it's going to be NS integer is going to be the return type. The method name is going to be called getNumber. And this will take no parameters because it's a getter. Getters don't take any parameters. So now that we've defined the interface declaration, we can then go into the implementation declaration, which is the .m file. So in here we're going to import a few things. I'm going to import foundation/foundation.h, and I'm also going to import the code file that we just wrote, numbers.h. And then we're going to define the implementation by doing @implementation, and then @end, which will end the implementations. Anything in between these two are going to define the methods that we had defined in the .h file. Now, an Objective-C is kind of cool. I can just go over here to the .h file. We can just go ahead and copy these exactly as they look. Come back into the implementation file and paste them here. Now, all I really have to do is then define my code blocks here, and I can just start writing the code for these methods. So now that we've got these blocked out, let's just define the code. In the setter up top here, all that we're going to be doing is we're going to be setting that protected member, which is the global number, equal to the parameter passed from the client code. So if I paste this here, that's going to equal num. And that's all that the setter is going to do. And as you can imagine, the getter is going to be just as simple. We're just going to return the private variable get or global number. So we've actually now defined this class. So in the numbers driver, all we have to do now is import the numbers.m and then set this up exactly as if it was a C program. So to test to make sure that this works, all we have to do now is try to compile this code. So inside of our command terminal, we can then cd to, I think it's on the desktop. Then once we're on the desktop, we'll go to the wibbit.net directory. So if you guys remember the syntax that we're using to compile this, we're going to run gcc-lobjc-framework foundation. And then the name of the input file, which as you guys remember, I think we called this numbers.driver.m, and then we'll do -o numbers driver. I got a wide screen, I might as well make use of it. There we go, numbers driver. Okay, so we have an error here on numbers line 6, unexpected identifier before dash. Numbers.m line 6. Numbers.m. And I made a typo here. I'm very sorry about this. At implementation is supposed to have the name of the class here. So it's at implementation and the name of the class. Sorry about that. Let's clear the screen and run that again. Okay, so that did work. So if I do ./numbers driver, it runs, but it doesn't do anything. So now let's make use of this class in the numbers driver here. So now let's make use of this class in the numbers driver here. We will make an instance. So as you learned in the object basis lesson, we will make an instance by calling we're calling it number, which is the name of our class, numbers, and this is going to be a pointer. And then we're going to have the name of our instance, which is num. We'll just call it num. And that's going to equal, and then one way that we can instantiate this is by calling the class level or static method numbers. Now this comes, Alec, this comes from the NSObject inheritance, so don't be confused about that. We didn't define a method called Alec, but NSObject did. So we're going to be using the NSObject method Alec. And then we're going to be calling init, which if you look back at our class here, we don't have a method called init. So what this is saying is create an instance in memory space for a numbers object. Then on that memory space, execute the method called init. Now, NSObject has a method called init, and that just kind of works kind of like a constructor, although technically it's not a constructor. It just kind of like runs post-instantiation instructions. Now, our class, we never defined an init method, but we're going to go over this a little bit later on. So we're just going to call init anyways, just so you kind of get used to this concept. But from a technical standpoint, we actually don't have to do this. So just for fun, we'll do it. And we're also going to be discussing another concept later on called, when we get into memory management and release, retain, and we start talking about reference counting. We're going to release our object here, and I'm just going to not explain what that is, just because. We'll learn a lot more about that later. So now let's interact with the object that we've created. So in the .m file, we can see that we have a set and get. So let's just simply set and get this value. So if we do a bracket, so we're going to call the receiver. The receiver is going to be the instance, which is num. And we're going to speak to the receiver and tell the receiver that we want to send it a message or interface with it. And the interface that we're going to be asking for is set number. So when I get into this num, I want to interface with you and I want you to set the number. Then I want to pass a parameter. And the parameter that I want to pass is 125. And then we will end that communication. Now let's get that and let's print that out to the user. So we can do then a printf, and then we'll just tell the user num equals, we'll do a good old-fashioned %d new line. And then inside here we're going to do the same thing. We want to interface with something. So I want to speak to the receiver, num, and when I'm communicating with the receiver, I want to get number. And since there's no parameters, I will pass no parameters. And that should be that. So when we save this, file save, which I've already done. It's Apple S for those of you guys that have Apple machines. And let's compile and run this, and we should see that we're going to be able to successfully set the value and retrieve the value. So now I have a warning here, and that's because an NS integer is technically not the same as an int. This code that we wrote will technically work, but to remove that warning, what we can do is just typecast this to an integer. So now that that's typecast as an integer, we should have no further problems. We should be able to run this with absolutely no problems. So we'll clear the screen, compile the code, run the code, and you can see num equals 125. So congratulations, you've written your first Objective-C class. Now that we've successfully written our first class in Objective-C, let's write another one. And we're going to write the other one that was from the lesson where we wrote a real number class. So let's write that. So inside of our text wrangler, I'm going to close out the numbers that we just wrote, and I'm going to make a new file, and we'll kind of start from here. Now, just like in the numbers class that we wrote, or the numbers interface that we wrote, we're going to have 3 files, right? We're going to have a .h file, which is the header file, implementation file, and the driver file. So we'll just kind of go through and save this as real number .h, real number .m, and real number driver .m. So we'll kind of start from the back to the front, just like we did last time. So we're going to create a interface. So we'll do @interface, and we'll call this one real number, just like we did in the presentation, inherits from NSObjects. And inside of this, the fields that we're going to be storing are going to be 2 protected values, NS integer, numerator, and then another one, NS integer, denominator. So those are the 2 fields that we're going to be storing, and then we're going to be defining some methods. The first method we're going to define is an instance level method that returns void. And we're going to call this one setNumerator, and the setNumerator is going to take in an NS integer, and the NS integer is going to be numerator. So we're going to be setting the numerator. Then the next one is going to be another setter, so we're going to set denominator, and the denominator is going to take in an NS integer, and this will be called denominator. And then the next one is going to be another setter, and this one is going to be the one that has the label text. So this is kind of an overload of set numerator. So we set the numerator, and this is going to be an NS integer called numerator. But we're also going to be setting the denominator. So let's define the label text and denominator and colon. So now we're going to be defining another variable. So and denominator, NS integer, denominator, and then a semicolon. So here's the set numerator and the numerator. And then the next label text here, and denominator, and the denominator. So now let's define the get methods. So we have a get method here, which is instance level, returning an NS integer, and this is going to be get numerator, and then another one, which we can probably just copy this and just do get denominator. And lastly, we're going to return a double, and this double is going to be get value, which will be the division between those 2. So here's the .h file for our real number interface. Now once we have this coded, let's go to the .m file, and let's import foundation/foundation.h, imports real number.h at implementation, and then real number, and then end the implementation. Now when we go back to our .h file, we should just be able to select and copy these methods, and then when we go here to the .m file, we should just be able to paste those in here. Now we can start defining what these methods are going to do. Now in the case of set numerator, you can pretty much simply guess what this is going to do, right? This is going to set our protected underscore numerator equal to numerator, which is the passed variable here. Our set denominator is going to be the exact same thing. We're going to set underscore denominator, which is our global protected member in this class, our field, to denominator. Then our set numerator and denominator. Now we could do this in a couple of ways, but the way I'm going to do this is I'm going to evoke self. So in the open recursion that we used in C++, we used this. So this refers to the instance of the object that I'm currently working within. In an Objective-C, we use self. So self represents the instance of the object that we're currently inside of. So now the receiver is going to be me. And I am going to set numerator. So I want to speak to myself, and I want to call set numerator, and I want to pass it the parameter of numerator. So that will set the numerator. And then we could do the exact same thing, self set denominator, and the denominator is going to be the pass parameter of denominator. Now later on, when we start looking at another implementation of this code, we do stuff like we protect the denominator from being equal to 0, because the division by 0 is illegal in mathematics. So you could, just have that logic in one spot, which is why we're calling these methods instead of directly interacting with the protected fields. So then we have our getters down here. So the get numerator, as you can imagine, return the protected numerator value. The get denominator, same thing. So we're going to return the protected denominator. Hopefully I have no spelling mistakes, but we'll find those in a little bit if there are. And then the get value is going to be a simple division. So when we get to get value, we are going to return. We're going to do a little bit of typecasting here. We're going to evoke self, and we're going to get numerator, which is one, we could interact with these directly, but I'm just going to be calling self, so we kind of get used to that, because you're going to use this a lot when you start writing applications. So get numerator divided by the typecasted value of self get denominator, and that should do that. Like I said, there may be a chance that I have some spelling mistakes, which we'll find out here in just a second. So now that the implementation file is coded, if we go to the real number driver code file, let's import real number.m, and we'll just make a C program. Now the skeleton's written, let's do a real number, and this will obviously be a pointer, right? We'll call this rnum, and this is going to equal a real num alloc, and we're going to call the init method from NSObject, and we're going to do rnum release for something that we will be describing later. Now let's see if we can get this to compile. So in the terminal here, we'll do a gcc-lobjc-framework foundation, and then we'll do real number driver.m-o real number driver, and what do we got? Cannot find interface declaration for NSObject superclass in real number.h. So let's go to text wrangler. If we go to real number.h, real number, real new num, real number.h. Sorry about that. I knew there was going to be spelling mistakes. I'm notorious for spelling mistakes for two reasons. I can't spell, and I also try to type as fast as I can. So if I run this again, I got the same error. Cannot find interface declaration for NSObject, real number.h, line 1. Let me go back here, though. Real number.h. Well, let's see. Real number.h should have the foundation framework here. This is a mistake here. Although I did have a spelling mistake here, I pulled in real number.h here, and it should be real number.m. Let me try that. Sorry about that. So in the real number driver, I pulled in the wrong code file. Now, I don't know if that's going to clear all of this up, but let's see. So if we compile this, all right, at least we're looking a little better. Real number.m, error, real num undeclared on line 4. Okay, real number.m, line 4. What does it say? Real num undeclared. Oh, this is the driver code. Sorry about that. So real number rnum. Oh, I have a mistake here. Instead of this should be real number. Sorry about that. So let me make sure that compiles before I start acting like I know what I'm talking about here. Cool. Now it does. So we had a few little baby spelling mistakes here in the .m file. I misspelled this. In the .driver file, I had the wrong import file, and I called the real number class something it wasn't. So here we go. Instantiate an instance of real number called rm, set to the response of calling the static real number method alloc, and then against that object that was just created, run the init method, and then store the complete result of this. So take the pointer, the result of that pointer, and store it here. And then at the end, we'll release it. So now let's start interacting with this. So we can do rnum set numerator to 100, rnum set denominator to 50, and then we should be able to do printf. Let's do a %f. So we'll just print this value. So then we'll do rnum get value. And that should be coming out as a double, so we shouldn't have to do any typecasting. So this should do what we expect it to do. So if we execute the compilation /real number driver, we get 2, right? Which is correct. Now let's interface or interact with the real, so we'll do a set numerator to 100, and now let's call that label text, and denominator, set that equal to 2. So what should we get here? We should hopefully get whatever that equals, which should be 50, right? So if I run that, and unexpected semicolon before printf, what did I do here? And sorry. I think I'm writing in TCL here or something. I gotta put my semicolon there. Sorry about that, folks. So let's run that, and now let's execute the program, and we get 50. So this interface acts exactly as we would expect it. So congratulations again, you've written your second interface, or your second class in Objective-C. And in this one, what we did was, we just defined the real number interface declaration, which just defines the protected fields, followed by the public methods. Then we went one step further by implementing. We actually put some code to these methods so that these would interact with the fields, and then everything else would interact with the methods that interact with the fields. So these interact with these methods. This interacts with the fields as well. And then this interacts with the methods that interact with the fields. Real number driver, just like we did in the last example, created an instance of real number. Then we set the numerator to 100 and the denominator to 2, and then we printed out the result, followed by a release of that instance.
Good morning, afternoon, or evening, everybody. Welcome to our lecture on moron interfaces.
Yeah, so we're not calling you a moron. We're actually saying that this is more stuff about interfaces. But Brian is a moron. So let's talk about some stuff first that sucks about interfaces and classes in Objective-C, Brian.
Like what?
There are no support for operator overloading,
What?
method overloading in the classical sense that we know. You can use the label text to circumvent that. And method interfacing does not allow dot syntax.
It's crazy.
Yeah, but there's semi-support, although it's not real support for private methods and static fields. So there's a lot of stuff that interfaces and classes lack in Objective-C that we are used to from C++.
Yeah, we're getting spoiled.
Yes, we have gotten spoiled.
Objective-C doesn't support private or protected methods, like in that sense, at least not right now. But I couldn't even imagine a situation where you'd want to do that.
Yeah.
I mean, whatever. Private methods can, you can sort of do that, but it supports field modifiers of, the public, private, and protected idea. So
here's an example of a interface numbers. I can't remember if we talked about this before, but we may have. In this example, you see that in our field declaration, we have an NS integer called global number. Now, by default, Brian, if I don't specify what the access level is, it is protected.
Right.
But if let's just say that I want to have unadulterated access to this value, well, then I can have an access modifier, and we can call this public. So then we could do something that we are already accustomed to in C++, and we use dynamic memory, is we can then create an instance of our object, numbers, n, alloc, init, and then n, arrow in, because it's a pointer, to underscore global number, because now we have public access to it.
Now, what about private methods?
We have private methods. Well, we talked about that before, Brian. Private methods are not natively supported, right?
Right.
But there's a way that you can sneak them into your code.
Okay.
Now, this is something that the only reason I know about this is because I ran into a situation where I was writing some code in Objective-C.
I couldn't imagine a situation where you'd even be doing that.
and I wanted to kind of sneak this in. So look at this little static void method in my implementation declaration here. This is not defined in my header file or in my interface code. And this is just, and it's not an instance level. It kind of hangs back. And I can call this by sending self, so I can evoke certain things on the self instance. So
that's funny.
That's kind of a cool little cute way of sneaking private methods into your code.
Which would probably make a lot of Apple developers have an aneurysm.
Oh, I can't wait.
So we have, also for fields, we have public, private, and protected. Kind of like we talked about with the public example, where you can just kind of label them as such, and that will be the access level of the field. The objects don't support conventional construct. It's more like calling a init than a constructor. And what that does is it returns a pointer to the new instance that was just created. So it's functionally constructor, but it's not a constructor. So what do you mean it's not a conventional? In a classic sense of the word constructor, the constructing method will naturally execute when you instantiate an object.
Right.
It doesn't really work that way. You actually call the initializer. So let's look at an example. It will make more sense that way.
Mm-hmm.
Let's say we allocate the memory space for a number. So we have our numbers class, our numbers object, my num, and we call numbers alloc. So that'll allocate the memory space.
Yeah, and then assign my num to point to that memory space.
Right. And then we call the set number method, and that will set the number and kind of like initialize it and get it going. Although it's not really init or a constructor.
Right, so we never called init.
Right. This is all perfectly legal code.
Huh. What the f***? You can do that?
So this is also legal code where you say my num init after you allocate it.
Right.
And that will call what would effectively be like the constructor.
Right, so that proves that init is not a constructor. Otherwise, it would already have executed when you created the instance of the object in the first line.
Right. So what's the kind of like proper way? Like, how do I make it work conventionally? The method new will call allocinit automatically as kind of like a interesting sort of like stylistic abstraction of allocinit, I guess you could say. And that kind of works like a constructor, but it just allows like just that one init method, like literally init,
right,
to be executed. Mm-hmm. And init is kind of extended down from the NSObject.
And if it's a non-mutable object, you don't want to use this way.
Right. Yeah. So the new method is kind of considered appreciated by a lot of Objective-C texts. So if you take a look at these two code files, the difference being when you say alloc init and see how it's nested, alloc is nested inside of the init call, so the result of alloc is then calls on init, then alloc is static. That's equivalent of just saying numbers new.
Right. Initializer. So what exactly is an initializer? I mean, really, all that initializer is, if you kind of think of it in the context of a constructor, although technically it's not, it's a method that returns a pointer of the type of the object that it is within. So for example, here, these are the initializer methods. So in this real number class that stores in as protected values or protected fields, we have a numerator and a denominator. And within this, as we initialize this, when we create this instance, or we can initialize this instance, we can init with the numerator, we can init with the denominator, or we can init with numerator and denominator. And when these are executed, it will return back an instance of a real number.
Kind of like a constructor.
Kind of like a constructor, but it's not, because it's a method that's executed after the instantiation of the object has taken place. So if we take a look here at the implementation code for this, let's kind of walk through how these initializers work. Now here are the definitions for my initializer. So I have my numerator, init with denominator, init with numerator and denominator, and you can kind of see how they work. You can see that they both create instances, they call other methods inside of them, and they return
Right. And what's up with that super init business?
I don't know. Let's go through this. So when we start talking about super init, Brian, super is a keyword in Objective-C that refers to the object type that is one level above it.
Right. So the class that this was inherited from.
Right.
Parent class.
Exactly. So what we're doing here is I'm saying go to the parent class and call the init method for the instance of the parent class.
Right.
And this cascades. If you have something that inherits 55, which we're going to go an example of this, but if it's like 55 inheritance, you're actually calling 55 init methods. Yeah, right.
Which is kind of cool.
That's kind of cool, yeah. So then right here, when we call self, right, we're calling the instance of this object. We're going to call the set numerator method, passing it the numerator.
We should make a method called righteous, and then we can call self-righteous.
Yeah, okay. Self-righteous, nice.
Anyway, sorry.
Self-serving, self-hating, whatever. Nah. So then the set numerator method is just going to evoke, the itself, and then call numerator, and then store that past value. So set denominator does the exact same thing. So you can see all that we're doing is we're creating a super instance. We're creating an instance. We're creating an instance after calling super init, and then we're just calling methods on our instance afterwards.
Yeah.
Yeah. And then right here, when we do set numerator and denominator, all that we're doing is we're calling the set numerator and denominator method that we've already built.
Yep.
And that's just going to be calling numerator and denominator.
So on, and so the world turns.
Right. So return self,
yes.
Brian. What does this mean?
It's not this, it's self.
Right.
So in this language, we're returning the instance that we are executing this from.
Yes, and this new instance will contain a retained count of 1, which we'll be talking about in a little bit when we get to memory management.
Right. So let's take a look at this real numbers driver, now that we kind of looked at the header and the implementation. So we call a real num, and we alloc, and then init with numerator 50. So we pass in 50 as the numerator, and then we separately call set denominator to 23. And then we'll just print out the numerator, denominator, and the value.
All right.
And so we compile that and we execute it, and we have 50 divided by 23 is 2 point blah 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 blah.
Holy crap!
Yeah, it's pretty cool, huh? Okay, and then in this case, we're going to call the alloc init, but at this time, we're going to do alloc init with numerator, 50, and then the parameter label and denominator, 23. Because that's how methods tend to read in this language. You know, like we had mentioned, they tend to read like full sentences. So, you know, you would read it, my real number, we would like to set to a new allocation where we initialize it with a numerator of 50 and a denominator of 23.
That's probably in a real Apple API somewhere.
Yeah, probably. Yeah, I know, right?
This init with numerator, guys. You notice that there is also an init with numerator that doesn't take a denominator. This is kind of a way of doing like method overloading, but not in the sense that we have taught it in C++.
Right. So what is this, really?
Oh.
Super is just a keyword that it just makes a reference up to the inherited class, or the class we inherited from.
Right, so for example, if the class numbers inherits from NSObject, then super refers to NSObject.
Right. So by calling super init in the numbers class, we're actually calling init on an instance of an NSObject, and the NSObject's implementation of the init method.
Yep.
So let's visually see what we're talking about. So numbers calls init, which calls super init first, which goes up to the NSObject and calls init. If we then extend numbers and create a subclass called numbers1, and then we call super init, it will call numbers, and numbers will call NSObject, and then we do numbers2, which calls number1, and then it's called numbers, and that calls NSObject. So every time we super init, and it super inits the parent, and that parent super inits the parent, and that parent super, it just kind of goes all the way up the chain.
Right, so if you need proof of you know, this action happening, in this code file here, you can see that we've done exactly what we just demonstrated. We have that numbers class that we talked about before that extended NSObject. Now we've created an interface called numbers1 that extends numbers, and inside of its init method, all that it does is it calls super init and then writes numbers1 init, returns self. Then we extend numbers1 again to an interface called numbers2 and do the exact same thing. So when we compile and execute the code on the right, you can see that numbers2 initialize numbers1 first, and then numbers2 it writes to the screen next and then returns itself. So you can see that those two init methods are ran independently.
And then somebody says, like, do we really need to do all this?
There's quite a few people that are kind of against this concept, although I'm going to go on the record as saying I am not, because it's a very, very common defensive coding practice.
Yeah.
Because if, like, let's just say...
Web.NET officially supports this due to potential problems.
Yes, exactly. There's the disclaimer right there. Because I'll tell you, like, if somebody creates some class where there's some, I don't know, let's say the init method makes sure that some value was not equal to nil, and then you try to access it later, but you never called super init, well, this protected value that you've now inherited will crash your program.
Right. Now, if we had constructors, it would be a different story.
Yeah.
But we don't, so it's not a different story. So we want to make sure everything is initialized all the way up the chain, you know, because they are part of us, you know, like if we're the smaller subclass, that parent superclass is part of us, you know? I mean, that's what we're extending.
And it all funnels down. It all funnels down to you. And if one link in the chain is broken, you're f***ed.
So this is like a best practice implementation where we first basically are attempting the super init, and then we check to make sure, like, if self is nil, then we do something.
Which is the Apple way of saying no.
Right. So we don't, like, double init, basically.
Yeah, and we also don't create a situation where if there was some failure initializing higher up the chain, we don't assume that our class is in good shape.
Right.
So that class real number star, like, you know how the initialize method that we just looked at, we had number star. Well, that is actually synonymous with a data type, Brian, called ID, which is a data type that basically specifies a generic NSObject type.
Yeah. So
it can kind of impersonate any NSObject. So if you look at the real number, Brian, how else can we represent this to be more generic?
Well, we could just return ID.
Holy shit.
Which just generically returns some sort of NS object.
It's pretty nice. And you'll see this implemented in code a lot.
You also see cases where people will interchange this with void for different memory management reasons, but we won't talk about that now. So let's talk about destructors. If there's no such thing as a constructor in a conventional sense, there's no such thing as a destructor in a conventional sense. Destructors are just simply overriding the native dealloc method. And dealloc is generally the way that you would deallocate something and destroy something in Objective-C. So in order to use that correctly, you should really just be doing super dealloc after another local memory cleanup, so that just like we went up the chain with super init, we're going up that chain with super dealloc to make sure all of our parents are also deallocated.
Right, because if your inheriting class creates dynamic memory during its time that it's aware of, it can clean up after itself. You might not be aware of everything that the class that you've inherited from does.
And you don't have to be.
Right, that's why you call super dealloc.
Yeah.
And it will call super dealloc, and it will call super dealloc, and then they'll tell two friends, and so on, and so on.
And so,
Wayne's World?
Oh, yeah.
Okay,
right.
asshole.
I remember. So here's a case where we declare a dealloc method that returns void, and then in our implementation, in this particular case, we're not really going to be doing any kind of cleanup because our internals are primitive, but we'll just kind of log something out and then call super dealloc.
Yep.
And that puts it up the chain.
Welcome back, guys. Objective-C programming. Kevin and Brian here.
You guys are still here?
Yeah.
Awesome. I'm always amazed. Good job, guys.
We're going to talk about static methods,
and
Brian.
gals.
Static members, actually, not just methods.
Yeah, static stuff.
Here's a static method. Now, reminder to everybody, a method that is static belongs to the object and not the instance. And Objective-C, static methods are prefixed with the plus character and not the minus character or the dash character that we've been using up to this point. So we have the instance level method. Here's an example. Dash, and then the data type, which in this case is void. The method name is instance level. And then our class level, which is plus, data type, which is void, and then class level.
Right, without the check marks.
Yeah, the check marks are there just because we're awesome.
Yeah. It's not like you got check minus on your 5th grade assignment and you got check plus.
I got a check plus, you got a check minus. check plus, check minus.
So the instance level again is once we have an instance like something x equals something, x has the instance level method, whereas its class, like numbers, has a class level method. You, I'm sure, know this because we've drilled it a million times now. Objective-C doesn't really support true static fields as far as fields go. A static field in Objective-C can kind of happen by declaring a field just in the implementation code and not in the interface code. Kind of like what you saw Kevin with his trickery in declaring the method implementation in methods implementation in the implementation file, but not in the header, as the weird little private workaround in an event. So going back to the numbers interface example, because it, kind of holds up well. We had instance level methods. And so we'll just add one, and we'll just say, get instance count.
Right, so we're going to count the population of instances.
Right. And we're going to have an NS integer global number.
Right, and that's going to be the number that we've encapsulated. But Brian, if we're going to have a get integer instance count, we're going to have to count this. Now, where would we store this value, since we're not obviously storing it here?
Right. We would store it in our implementation.
Wow, so we have a little secret thing over there.
Yeah, it's strange.
Yeah.
So in our implementation, we have an NS integer population 0. Now, that's not in our header.
Right.
That's only in our implementation. And we'll just start it at 0. And that's going to be our class level global variable.
Mm-hmm.
So when we get to init, every time we init, we'll increase our population by 1.
Holy crap.
Yeah. And when we dealloc, we'll reduce our population.
Holy crap.
So long as, we have something to deallocate. So if you take a look at this, where we print our population before ever instantiating anything, our population 0, and then we make a numbers instance n1, then we have population of 1, numbers instance n2, population of 2, and then we release n1, and it goes back to 1, we release n2, it goes back to 0.
Nice, not bad.
Yeah, so it's a pretty straightforward and quick and easy implementation of a static method.
Or, static method and a static field.
Yeah, both.
Yeah.
It's that easy. Hey everybody, we're gonna do our last lab in terminal mode. In terminal mode. I don't know. And this is just to demonstrate using classes or interfaces, extending an object, and static methods. So it'll be pretty basic. We're gonna make a very simple console class and have a couple static methods in it. We'll call them. It'll be fun times. You'll like it. We go back to our trusty text wrangler, and we want to create some files here. The first thing that we want to create, as always, is our header file. So we'll just save into our whippet.net folder on our desktop, and we'll call this console class.h.
Why not?
All right. And that will also have a brethren file, new text document. And we'll call this one, I don't know, something crazy like console class.implementation file.
Now hold on, Brian. Hold on. Whoa. 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 This looks really familiar. What is this all about?
So the structure is going to be just like we've been doing in C, but there's going to be a couple minor differences. As you know from the lecture, we will import foundation.h.
Well, yeah, we're going to ask, should we do this?
Do you want us to? I don't know. Okay, so whereas you might be used to something like this, console I can spell, or you might be used to something like this, instead, we're not going to call it a class, we're going to use the interface keyword.
Mm-hmm.
And it's going to be console, which is an extension of an NSObject. So we always want to be extending an NSObject, at least, or some other object that is since extended in an NSObject.
Yes.
And instead of the parentheses style, we're going to also have the end keyword, and everything in between those will be what we're dealing with.
And as we discussed in the lab, when you block out the interface, that's where you would be putting your field. But this particular class example we're going to write does not contain fields, so we're not going to waste the time.
Right. These will all be static. So as you recall, a dash is non-static or
instance level,
and plus means static.
Or class level.
Class level. This will return an NS string pointer. And the first method we want to declare will be, what do you think?
I don't know, read line. Kind of like you're reading a line of text from the command terminal.
All right. And then the other one, we'll do like write lines.
Right, so how about like a write with format, like a printf kind of thing?
Okay, and this will return NS integer?
Yeah, an NS integer. Kind of like how printf returns the length of the string that was printed, we'll do the same thing here.
Yeah, why not? And because we're not using NS number, we're using NS integer, which is a type def that's not a pointer.
Right. We don't specify that as a pointer.
And we'll call that write with format, so we can use like the format string this time.
Right. And a parameter colon.
Yeah. So okay. So sorry, I'm just laughing maniacally like a madman. So the first parameter is going to be an NS string.
Mm-hmm.
And the parameter will be the format string.
Right.
And then the second parameter will be the ... the repeatable other whatever parameters you want to pass.
Which we remember VA args from C.
Right.
Same thing.
So that should take care of a format string, and we don't want to use the additional parameter text label in this case because this is all kind of together with how we're going to package together the format. It's going to be that format NS string as well as the parameters that we pass.
How about next we do a write and a write line?
Okay. Those will also return an NS integer.
Right.
And this is just a write, plain old write, and then we're going to write like an NS string.
Mm-hmm.
Pointer, of course.
Mm-hmm.
We'll call that one text, and then we'll do an NS integer, was it write line?
Yeah, like write and then append the new line.
Okay. NS string pointer, and we'll also call that text.
And also do like a clear string, so like a void method that's just called clear. Now this is a very basic console class, but...
yeah, but you'll get the idea. At least we have some static methods. So now let's go over to our implementation file. And see how that's going to play out. One of the things that's kind of funny in Objective-C is, as you would expect, we're going to be importing the console class.h, right? Like perfectly normal. We're going to use a couple of other libraries to make our lives a little easier. And we're going to kick ST style with stdio.h. I mean, we are kind of doing like a terminal example, so whatever. String.h, stdlib.
Why not?
And stdarg.h. Cool. Okay, so our implementation starts with the implementation keyword and then the name of our interface or class. And we also end with the end keyword.
Nice, Brian.
Inside of here, the
I'm gonna steal the mouse for 1 second, Brian. I'm gonna move these because I think these probably should be up here since the H file is using the stdargs.
Okay.
There.
That's fine.
That's it.
While we're in the header file, let's grab these.
Oh.
The way that you implement is a very similar structure as the way that you declare them in the header.
You gotta put them inside the implementation declaration.
Oh, whoa, where am I?
You got lost.
Sorry.
You got lost, kid. You got lost.
I lost in the crowd. Lost in the crowd. 40 years, I ain't seen
40 years.
kids so lost. Okay, so all we basically have to do is just switch the semicolon with the parentheses. Okay, so let's do read line first. You want to talk me through this one?
Yeah, why not? So, I mean, obviously there's 1,000 billion ways you can do this. We're just going to kind of do a little basic one. So, we can just make an integer or an NS integer, whatever your poison is. And let's just call it like max string, and we could just make this equal 2048. So this will be like the longest output line you can do, right?
Okay.
That's fine. And then we can also just do one called I, because we're going to be iterating through a for loop. Let's also create, now I know that this isn't, and Brian's going to hate me for it, but this isn't very Objective-C, but let's make a char star using dynamic memory. So we'll call it buffer. Like Buffer the Vampire Slayer equals C-Alex, so we're going to be declaring a dynamic array of max string plus 1 length, and then we'll do of size for each 8 blocks.
Okay.
Right? So now we can do an fget, and an fget is going to, as you guys remember, that's like, we're going to be piping the data from the command terminal, which acts as a file, into this buffer.
Right.
So the maximum size of the buffer is going to be max string, and we could do max string plus 1. And then stdin is the file that we're going to be pulling from, which is not file, but stdin acts like a file, standard input. So once we pull that data in, we can do a for loop. And then this for loop is basically going to go through and remove any new line characters. So you can kind of think of it as a chomp, right? Because it will append new line characters. So for I equals strlen of buffer the Vampire Slayer. I'm not going to stop saying that.
It's fine.
Minus 1. So we're going to go to the last character.
Right.
And then while buffer sub I equals character _R, return carriage, or buffer the Vampire Slayer equals \n.
It definitely gets less funny the more times.
And then buffer the Vampire Slayer is I minus.
Okay, and then keeping with our convention.
Yeah, is there a way we can like make this not so? Yeah,
there we go. It'll fit.
Yeah, sweet. And then when we get here, all that we want to do, Brian, is just kind of like blank out that buffer. So buffer sub I.
Buffer
The vampire. All right, I'm gonna stop now.
No, you're not.
Equals null.
Because if you stop, I'll start.
So we've basically removed the new line characters that were at the end of the file.
Cool, fair enough.
Now that we've done that, Brian, let's create an instance of an NS string. And we can do this, we're going to do this using an autorelease pointer without having spoken about it, because we would probably get shit from people if we didn't do it this way. So NS string, return string equals, and we'll set that equal to calling against the NS string class, call the method string with C string, and pass it buffer. We've made a copy of that and encapsulated it into an NS string. And since we use dynamic memory, Brian, what would you do? What would you do? What would you... What song is that?
Oh, weird.
Isn't that a song?
What would I...
Who is that?
Oh, weird.
Why can't I think of that?
That was like a long time ago.
Yeah, well, whatever. So, we're gonna freebird, right?
We're gonna free the buffer. We're gonna free Buffy.
See, now you're starting. And then once we do that, all we have to do is return the return string.
Awesome.
Right?
Done deal.
Before we bounce... Maybe let's comment these lines out, Brian, and,
or we can just add that.
Whatever.
Yeah, we'll just keep moving.
Yeah, we'll just keep, we'll live dangerously. So in the write with format, and this is really the only bulk function that we have left, because the other two write methods you could imagine are going to just piggyback on that write with format method. I mean, why would you do that any other way? It just simplifies the whole thing.
Exactly.
So in here, Brian, we're going to be using the VA arg list that we had used in C, right?
Okay.
So let's create an instance of VA underscore list, which is basically a macro that's defined in the VA args header. Or the STD, or whatever they call it. In VA, people always call it VA.
All right.
So let's make an NS integer, and we'll call that L, or length, or len, or whatever you want.
Okay.
Yeah, cool. Let's call the VA_start function, and we'll pass it VA, which is that variable list that list that was instantiated above that, followed by the format string, which comes down from the NS string.
Yep. So the format string is a parameter, and the VA macro and the VA function are to support that ellipses.
Mm-hmm.
That gives us the variable number of parameters, variable number of arguments, in case you guys didn't know.
Right.
And if you did know, then go to hell.
Now let's create an instance of an NS string using alloc init, Brian. So we can do some crazy stuff like NS string equals NS string alloc, and then we can do init with format, and then colon, and then we can pass it the format string.
Yeah, we'll just pass it right along.
And then space arguments, it's colon VA, and then close that off.
Awesome.
Nice, not bad, huh?
Yeah.
At least hopefully, I don't know.
Yeah.
VA_end VA to kind of close the loop here. Nice, very nice, very nice. And then we can do next here, Brian, because in typical fashion with C, when you write something out, the user will get how many characters are written out. So we can just do length equals string, and then call str, and then call the length method on that NS string that we created.
Very cool.
And then from there, we want to release that string, obviously, which we'll talk about with memory management later on. And then return the length.
Beautiful.
Hopefully it works.
Okie dokie. So now we got a couple more. These are going to get very simple. So this is just going to return the result of kind of passing this along. So we're going to say self write with format, the one we just created, and say at, and then because this is a NS object, essentially, because it's an NS string, the type is a little %at.
Mm-hmm. Right, the format string %at.
And then we'll just pass it text.
Right.
That's it.
As opposed to like %d for integer, %s for string, %c for character.
The right line is going to be very similar to that, except the fact that we just add a new line character.
Huh.
So write with format. The format string text. This is exactly the same, except I don't know where my cursor is. Except we pass a \n to add the new line on there.
Wow.
That gives it the right line.
Now, a clear method, Brian, that's going to be hard, right?
So clear is going to call the system function, and it's going to pass it the clear string command.
Now we're in Unix, so clear is how we would clear the screen. Yep. Yeah.
And then we save this file, and now we have our class.
Cool. Now we got to build a driver.
Yeah. Okay, so now we're going to make a new file, and we're going to save this as our driver, and we'll call this console driver.
.m. No takers on that one.
Console class.
There you
driver.
go.
Yeah, that felt a little weird. So okay, so now I got our console class driver. No big deal. So we're going to import Foundation.
Which we actually don't have to do, Brian.
We don't.
Because console class.m does. But
Foundation can get imported until the sun goes down and it understands. And then we're also going to import, unintuitively, we're going to import console class.h. And that will probably bite me, but I'm pretty sure that that's fine when we're doing this on a console like this. And it will understand that the H file was referred to by an N file and go to the M file first and whatever, you'll see. Anyway, okay, so the first thing that we want to do is we want to call our clear function. So if we just...
Clear method.
Yes, sorry. Our clear static method. So if we call console clear, that calls our console class interface and then the static method in it with no arguments.
All right, so we've cleared the screen.
Yeah.
How about, Brian, why don't we just return Zippy and see if it runs at this point?
All right, sounds good. All right, so now let's switch back over to the terminal here. And Where are we? We're there. We got some files here. And just to
to be lazy.
Just to be lazy. We'll go back and we want Objective-C language. The language is Objective-C. We're using the foundation framework. And we're going to be calling the console class driver.m. Our output file is going to be console. I'm just going to call it console test.
Okay.
Console driver.
Nice.
Okay, and then we got an issue. Great. Undefined symbols for architecture x86. Well, let's do the most obvious thing to me, which is the thing that I'm... stop it. Not you. I don't want you right now. You can go away. Let's, for fun, make this an M.
Hey, all right.
Okay, so the calling the class from a .h, and I knew that was going to bite me. Seems like it only works when you're in the context of Xcode and it's managing it for you. So they must pass different parameters when they compile.
So we see some warnings which we don't care about, but we do have a few errors on line 42, Brian. So let's go to line 42 of consoleclass.m and see what the deal there is. Looks like we have some strange characters in the code.
Kidoki?
42.m. Line number should be down. Look at this, Brian. There was like a
control look at
character
that.
put in
That's
there.
funny.
Yeah.
Well then. Okay,
cool.
So stringless C string is depreciated. We don't really care about that. We can actually just whatever.
W means shut the f*** up.
And then we'll call console driver and execute it and see how it goes.
And it cleared the screen.
Nice.
Not bad.
Very cool. Okay. Let's have it do something else. Let's have it, which would just have it right to the line and then be done with it?
Yeah, we can write and read. Why not?
Okay.
Well, we might as well use what we got. Now, we're probably going to be getting some NS
pool leakage errors.
Pool leakage. So we're going to include an auto release pool just to prevent that from happening. But we're not going to tell you what this is yet. You're going to learn more about this later. But just know that sometimes, Brian, the objects like to go swimming, right?
Basically. Okay, so we're going to do an auto release pool, and then we're going to NS auto release pool alec, and then just init.
Yeah, why not? Okay.
Okay.
And then we could drain it.
Times, yep.
And then we'll write the code in between.
Yeah, and then we'll drain the pool.
Pay no attention to this, ladies and gentlemen. This is just to prevent
Pay no
errors.
attention to the man behind the auto release.
Yes. So why don't we do like a console write and just say like, what is your first name?
Okay.
Right? So, how about yourself? You first name?
Her first name. Your first name, perhaps?
Yeah, get rid of one of those. Put a space there
Whoa.
too.
Whoa.
Let's see if I can pull this thing out.
That's what she said.
So this should then write to the screen, tell me about yourself, blah.
Okay.
So
and now we want to store this in a string.
Why not?
So let's make an NS string.
Yeah.
Well, be a little more, less nondescript. Call this first name. We'll bundle these together. They'll be buddies. And then all we do is just call console and then readline.
Nice.
Because that's why we wrote it that way. And then we can do the same thing for last name. And say, in proper Apple fashion, we'll say, and your last name.
This is really starting to sound like a freaky program. I mean,
it is a freaky program.
Yeah.
I just brought it. Just brought the creepy. Okay, so then we'll do write with format, and the other ones just call that write with format. So that'll be a nice test. We'll just go right to the source. We'll say, hello, first name, last name.
This program makes me want to run and hide.
You didn't know I knew your name, did you?
I like how Brian finds it necessary to write as far off the screen as possible.
That's how I roll. Now we're going to pass first name and last name.
Oh my god.
Yay. Okay. I'm done. Alright, let's do it. Ah! Ooh! Okay, ready to try it out? Recompile and ignore all warnings, so... let's not ignore warnings. Okay, so we got depreciation. That's fine.
it.
Okay,
yeah,
cool.
that's okay.
So we'll just / console driver and then run it. Clears the screen and just kind of chillaxes. Shooby-doo-bop-doo-wop. Doo-be-doo-bop-boo.
So the console writes are not working. So let's go to the write with format method.
Okie dokie. Thank you.
So we go to
The write with format. Let's see what we got going on here.
Oh, we never actually wrote anything.
Is that so?
Yeah.
You don't say.
Yeah, we actually forgot the part that actually writes.
So we did everything that we were supposed to do but write it. So, Pranav, does that work?
Whoops. How about a little STR action?
Yeah. You are correct, sir.
All right, sorry about that, guys.
Yeah, wow. We're zony right now. We are not trained professionals at breathing and stuff. Okay, let's try it again. Yay, we got problems.
That's fine. They're just warnings.
It's just appreciated. I appreciate it.
I do. Oh, here we go.
Tell me about yourself. Your first name, perhaps?
Okay.
Name's Brian.
Okay.
And your last name? It's Lasterfield.
Smithson.
Hello,
Brian.
Brian Lasterfield. You didn't know I knew your name, did you? Yeah, I just told it to you.
But now the computer knows your name, and now it's going to come eat you in your sleep.
Yeah, anyway, that was fun.
Sort of.
Kind of.
Not really.
Hello, everybody.
Hello, Elaine.
Now
la. Sorry. Seinfeld fan here. This guy.
I don't understand.
That's because you're watching stupid shows.
I like Curb Your Enthusiasm better than Seinfeld.
No, that's blasphemy.
Really? I don't know. We're going to talk about...
That's like saying you like the spin-off show Joey more than Friends. And they're both terrible. Whoa. No, that's the other Joey. That's Joey Lawrence.
Oh, yeah, that's right.
Whoa, that was Blossom.
Oh, yeah, that was a Blossom spin-off.
Yeah.
Same rule applies. Whatever. Categories inheritance.
Wait, that was the Brothers show where it was like the Lawrence Brothers. What was that show called? The spin-off. The f*** was that show called?
Wait, so there was a spin-off of a spin-off?
I think there may have been. There was a Joey Lawrence Brothers show.
Weird.
Yeah.
Anyways. Yeah, there was like 50 brothers. That's
yeah,
right.
and they all
kind of look the same. And
they look exactly the same.
I forgot.
Weird. Man,
Whoa.
the fucking 90s, man.
Categories. So categories is kind of it's sort of a unique concept to Apple's take on Objective-C. So without further ado, we will just explain it as a method of extending classes, or a mechanism in which we can extend classes, maybe. It kind of allows you to create add-ons to existing classes. It's not necessarily a subclass of that class either.
Well, no, it's actually not a subclass.
Right. It's decidedly not a subclass.
Literally taking a class and you're taking
bolting
something
on.
and you're screwing something onto it,
Yes.
you're gluing it, and then boom, it's there.
We're bolting on a method to an existing class. It's kind of weird.
Mm-hmm.
Your custom additions will behave as if they're native to the parent class.
Yeah.
You know, obviously within the scope of this being imported.
Right, so if you were to write a category, this is a common syntax to use.
Right.
It's very common in Objective-C to name your code file the root class, the plus symbol, and then the extension. So we're literally saying this plus this. So this class plus this category.
Right.
Is how that's supposed to read. So we would obviously import the root class. So like, let's say we were extending NSString or NSNumber. You would import NS, foundation or whatever, NSObject or whatever, interface, the root class, and then in parentheses, Brian, the category the name that you're extending this as.
Right.
The implementation code is the same thing.
And you can decide what that category is going to be.
It's, yes, arbitrary text, so long as it doesn't contain like spaces and backslashes and weird shit.
And it's kind of like for namespacing reasons.
Yeah, I guess maybe you could say that. And the implementation code is very similar where we implement the root class, but we extend it by adding this category to it.
Right. That's pretty freaky. So let's set up a scenario in which we would need to do this. Because, why? What's in it for me? So let's say we work for a company.
Yes, Whippet.net,
right.
which is a multi-quadrillion, bajillion dollar industry.
So you mean like a
$15 a month industry. Okay, all right.
And with that $15 a month we saved for a long time, and we purchased a series of Objective-C libraries for $20 billion.
Well, with inflation, that I mean,
carry the one, and
it won't be too much longer where that's the minimum wage.
Yeah, right. But because of this investment, you have to use these libraries. You're the lead developer on this super secret project, so you got to do something with these things.
And your super secret project is to make a chop method.
Nice.
So shortly after you started this project, you as the lead developer, you were like, yeah, these libraries are neat, but like it's really missing some functionality that I really want.
Like a chomp.
Right, see, like a chop method, for example. So you go up to the whiteboard and you start drawing some code diagrams, and you're like, it would take a lot of time and money to rewrite this. There has to be a simpler way that I can extend functionality without using subclassing and without rewriting the code.
Well, thanks to Schmishdick, there is. Okay, so let's look at. I love this. I love your comments on this.
Well, remember we purchased this from the Supercomputer Company.
Right. So this is copyright 1998 from the Supercomputer Company. Usage license.
Even though you have purchased this code, you have no legal right to modify it.
If you do, horrible things will happen to you. Horrible things.
That's kind of it's like a lot of those APIs will have those types of warnings. To me, that's as dumb as like. You just bought a house, but you can't build, you can't do something. You can't put up a picture.
Or if you cut the tag off the mattress, like horrible things will happen to you.
Exactly, that kind of shit. Yeah.
Those warnings are scary as hell. You're like, for cutting off the label on a mattress? What? Weird.
So here's an example, Brian, of us actually, in our real life example, the $20 billion NS string code that we could have gotten for free, but our sales staff got duped into purchasing because they're a bunch of idiots. We need to add a chop method. Well, actually, I'm wrong. This is actually different. Forget I said that. We're just making an interface here, right?
Yeah.
And the super secret computer company in 1998 was not aware that you had to retrieve data. They only knew that you had to set data, right? I mean, it was the 90s. Right. The Joey show was on. Blossom was still blossoming.
They were confused.
And,
they just had a nit and Dialec. They were like, what else do you need? I can't imagine a situation where you possibly want to do more than a nit and Dialec.
They were probably watching the Saved by the Bell college years, and they were like, wow, Kelly Kapowski really got hot as she got older, even though she was hot too when she was younger. Anyways, back to reality, folks. Here, we're going to instantiate this, and we're going to call the initWithValue method and release it, but there's a problem here, fundamentally.
We can't get anything.
We can't get anything.
It's crazy.
So, what do we do?
Well, we just use a category to add a getter.
Holy monkey.
Yeah.
So we have in this category, so the at interface categories class, which is the class that we're extending, we're making our own category called manipulateValue, and look at the code file name is going to be category class plus manipulateValue.h.
Right.
And then here we're adding two methods, Brian. And what are we doing with these two methods?
A set and a get of the hidden value.
Precisely.
So we're exposing the privates of this class.
Yeah.
Forcedly.
Wait. Lisa Turtle, if you had to choose Lisa Turtle or Kelly Kapowski.
Lisa Turtle.
Yeah, I think I'd go with Lisa too. Did you know her and Zach Morris, like Mark, Paul, blah blah blah, they dated for a while?
Interesting.
Yeah.
That's kind of cool.
I say go Zach.
Yeah, nice. Okay, so we import our categories class, and then we import our category itself, which is our category class plus the manipulate value category. .m. And then standard IO for another reason. So we create an instance of our category class just like we did before.
Whoa. If we're going to extend this class, Brian, why are we creating an instance of the root class?
Because we extended the root class. We didn't subclass it into a new type of class. We're just extending the root. I know.
Whoa.
So everything else stays the same. It's great. Now, if we go to call the get hidden value, when we go to print it, we can just call that get hidden value on the class as if it came with it.
That's beautiful, Brian.
Yeah, it is.
That
is
awesome. Very beautiful. Now, this was not very practical. This was kind of a stupid example, which means that obviously I came up with it, but whatever. So, like, what if you had an NS string class, right? Which we do have with the Foundation framework.
Not so theoretically.
And it doesn't really have a chop method, but I want to chomp. So doesn't this sound like fun?
Yeah, I can't. Right. This is awesome.
So doesn't this sound like fun?
Yeah, I can't. Right. This is awesome.
All right, what do we do, Brian?
All right, very easy. So our header file for the category is the class we want to inherit in the category. So
no. The class we want to extend. It's important for that distinction.
The class we want to bolt onto in the category of the bolt on.
Yeah.
So this is going to be NSString plus chomp.h and NSString plus chomp.implementation. In the header, we just say interface, NSString, which is the class we're dealing with. Our category, we're just going to call chomp. And then our instance level method is going to be chompstring.
Holy monkey.
And then we implement it just like we would normally implement anything.
Right.
The only difference being our implementation is of the NSString with the chomp category in parentheses. It's very simple. And then we implement the methods just like we normally would. So we put in a chompstring method and it's a done deal.
And you look on the right side where we implement this code, we have a string 1, 2, 3, 4, and then return carriage n. And we print out before, and you see that there's new lines, and then after, there are none. So it works.
Yeah, very cool.
And we're just calling it against NSString.
Yeah. So now, instead of categories, let's talk about class inheritance.
Which we've already been exposed to.
Right.
But let's expose you more.
Yeah. So let's say we want to create a real number class, which is an extension of, or it inherits from, the NSObject class. So we do that by showing the colon interface our class colon the parent class that we're extending from. And in our implementation, you can see that when we declare our interface rational number, this is going to extend real number. So this will be a then extension of real number and so forth.
Right. So the real number class that we created before, this will extend that. And all that we're going to be doing with this implementation of it is having a string value, so that when we call that string value, it will just return a string with format, the float, and then the value of the string.
And you can see in the implementation of rational number, you don't declare your extension again. You only declare the extension of a class when you declare your interface. So, pretty straightforward. And you will be using class inheritance constantly. Right. If you want to draw something to a view on an iPhone app, you need to extend and create a subclass of like a UI view, for example, or a UI view controller in that case, and write your own drawRect method, for example. So it's very common in Apple development to be extending classes. It's like the nature of how everything will operate. You'll see more about it later. And but just know that these are very, very important concepts that are very specific to developing in an Apple universe.
And as we had talked about in the beginning, that Objective-C was designed to be very expandable. Well, this is one example of how that works. I mean, the whole concept of categories, Brian, is unique in Objective-C, and it really allows things to just grow very, very organically.
Right.
And the whole inheritance structure, although it can be kind of a pain in the ass, it's a necessary evil. It is what it is.
But it's also a nice design philosophy too, in its own respect.
Yeah.
You're like, no.
No, it's not. Hey guys, Kevin here from Whippet.net. What we're going to do in this lab is we're going to just kind of write that NSString categories extension that we went through in the lecture or in these slides, where we're going to be building a chomp method and just kind of attach it to NSString. So I'm going to start off by opening up my text editor and start coding. So now this, we're going to be dealing with categories. So we're going to have two files which will define the category, header, and implementation, and then one file to drive it. But in the driver file, we're just going to be pulling in the original class that this came from. which is kind of a different concept to what we've been discussing so far. So in the first code file, we're going to call this the, I guess, proper text for, or the proper name for an extension, or categories, which would be the name of the class that we're extending, NSString, then the plus symbol, and then the functionality that we're extending. So the name of the category, so we'll call this chomp.h. And now in the second file, which will be the implementation file, we'll save this as, and we'll do the same thing. We'll call this NSstring plus chomp.m. And then our driver file, it doesn't matter because this is arbitrary, because this can be used in multiple contexts. We'll just call this NSstring plus chomp driver.m. I won't put the plus there, that's kind of misleading. So we'll call it NSstring chomp driver.m. And that should be that. So in the driver code file, we will import the NSstring plus chomp.m int main return 0. And then in the .m file, we're going to import foundation/foundation.h import NSstring plus chomp.h. And we should be able to test to see if this imports this and this imports this. We'll just knock that out real quick. So we'll go to our utilities and your terminal. And once the terminal is open, we'll go to the desktop and we'll go to the Wibbit.net directory, gcc-lobjc-framework foundation. And then we'll do that's the wrong lab. NSstring chomp. Wow. NSstring chomp driver.m -o NSstring chomp driver, remove the .m, and I have a mistake. That's supposed to be dash, not equals. So instead of equals, we'll do a dash. Cool. Alright, so let me just run it again with a clear screen, and we're able to function. So in my text editor, I'm going to go back to my .h file to start defining my category. So the first thing that we'll do here is we'll define an interface, and this interface will have the same name as the class that we are putting a category on. So this will be NSstring. So in the NSstring class, I'm going to define a chomp category. And this is not going to have any fields, so I'm not going to define any fields. So in between here, I'm going to define my NSstring, and the method that we'll define is chomp string. And that's really all that we're going to have in our header file. So to kind of continue this on, I'm going to copy this entire thing and bring it over here to the .m file, where instead of interface, I'll change this to implementation. And the implementation will be of type NSstring, and it will be of chomp here. Okay, great. So inside of my block here, I'm going to define my chomp method. And as you guys know, throughout our entire experience programming together, we've probably written like 5 or so different chomp methods. Now, this isn't the greatest chomp method that you'll ever see, but it's just a version of how to perform this action, this process. So you want to make your own chomp algorithm, do it. This is just a little simple basic one that we kind of use to show off the functionality. And it's the same exact one that you guys saw in the slides. So we're going to call this int end of string. And we're also going to have an I. And just to keep this more Objective-C, we'll call this NS integer. So now we have 2 NS integer declarations here. Followed by, and now this is not Objective-C, we're going to make a char star, and we'll just call it S, and this is going to equal a typecast of a char star of the result of a calloc. So we're going to be making dynamic memory, or calloc, whatever you want to call it. And the calloc is going to be self, which is the instance of NSstring that we're currently working inside of, and the length. So we're going to be pulling in the length of the string and adding 1 to it. And we're going to make each of these, we'll just do size of char. So now we've created dynamic memory, just like we've done in C. It's the same, I mean, it's the same language. So char star S equals a typecast of calloc, and here's the size, the block size. So how many elements in the array that we want, and then how big we want each element to be. Now let's do an strcpy, which comes from string.h, which has already been implemented in the foundation.h, so we don't have to worry about pulling that in. We're going to copy into S, which is the dynamic memory that we just allocated, the value of the C string of self. So we're going to be interfacing with self, so the receiver of this is going to be self, and I want to retrieve my instance of a C, or my version of a C string. So now we've copied into S. So we have 2 copies of the string within memory right now. And we're just also going to be doing a setting end of string. And end of string is going to be equal to the result of str len of s minus 1. So this is going to be pointing at the very last character inside of the string. I mean, one character before the null character, that is. And once we do this, we're going to pop through a for loop. So we'll do for I equals end of string. And the condition for the for loop is going to be while I is greater than or equal to 0 decrement I, right? So in this case, we're going to the end of the string and we're going to be pulling back. So long as we don't hit the first character of the string, then we're going to keep iterating through this loop. Now, if we're going to look at S now, if S sub I equals the new line character, or S sub I equals the, sub I equals the, what do I got here? Equals the return carriage, then I want to change the value of F sub I equal to the null character. So we're just going to null it out if we find one. And the condition where we find a character that is not a new line character or a return carriage, we're going to break out of this for loop. So if every single character in the string is a new line or return carriage, they're all going to be blanked out. Else, the second we find one, we bail out. So now let's create a new instance of an NS string to return back to our user. So we're going to do an NS string, and the NS string is going to just be called, like we'll call it return string. And this is going to equal NS string, Alex. So we're going to be making a new instance of NS string. And I lied. We're not going to use Alec. We're going to be using NS string, string with C string, and we're going to be returning S. Now, for those of you guys that have been paying attention, this is going to return an Autorelease pointer, which we'll talk more about when we get into memory management. So this is going to be one that requires a release pool. So we'll discuss that later. Next, we're going to use the cFree function to free the memory of the dynamic memory that we just created here. And then we're going to return to the user the return string. And that hopefully is it. And that hopefully is it. Now let's do a quick compile to make sure that syntactically we have a code. We have compilable code here. So we'll do a. Okay, do we have any errors? Yes, we do. An include file NSString chomp line 2. Error, cannot use an object as a parameter to a method. So we got NSString chomp.h. What I think that this error is talking about is I made a boo-boo. And this is supposed to be an NSString pointer. And this should be an NSString pointer as well. So sorry about that, folks. Now let's try that again. Do we have any errors? I don't see any. If I do a -w, cool. So we have a compilable program, and the boo-boo was my fault, and I just declared the NSString as not a pointer. So, and that's what it has to be. So inside of the code here that will drive this, let's make an instance of NSString, str equals NSString, string, well, I can just do one of these things. And you know what? I almost made the same mistake again. Look at that. Let's do we'll do @ hey, buddy. So when we have this, and I'm also going to need an Autorelease pool, which we'll talk about later. And we're going to flush the pool. Let me just make sure that this compiles real quick before I get on my high horse. Invalid initializer, NS Autorelease pool, NS Autorelease pool star. Man, I'm really messing up on that today. That's usually not something that I do. Okay, so that functions. So now that we've created our object pool, which we'll discuss in memory management, so don't get all upset about that just yet. Let's do a printf, and the printf will go and then following line here. And then we'll do kind of like what we did in the slides, and we'll just do before %s new line. So what this will do is we'll do strc string. This should print us out showing that there are new line feeds in this string. So ./ns string chomp driver. Okay, so you see we have a before that has new lines here. Now let's evoke the chomp method. So let's do something like this. We'll do ns string chomped string will equal, and we'll do a str chomp string, which was the category. This was the method that we slapped onto this. So this is our own improvement to the NS string class. So now if I do a chomped string, C string, and we'll call this after, we should hopefully see a string that is chomped. So we'll have no new line characters at the end of the string. So we'll clear it, recompile this program, and then execute it. Now you'll see that Hey Buddy does not have any new line feeds after it. Now this is kind of a dumb little example, but I mean it's not that bad. Just to kind of one over the code, our interface declaration is very simple. All that we're really doing is we're adding the interface that we're adding the interface declaration for the method that we're going to be adding to the extension or the category of NSString called chomp. Then in the implementation file, we're going to pull in foundation, we're going to pull in the header file, then we're going to define the implementation in almost exactly the same way. We're just going to be calling implementation of NSString, and then we're adding to it our own piece, which is chomp. So this is different than inheritance. We're not inheriting the class. We're actually taking the class and we're throwing our own piece into it. Defining the method chomp string, and then this is just a chomp algorithm, and you can, if you have your own, do it. We're not saying our code is the best. It's just an example of how this algorithm works. And then in the code that implements this, or the driver code, throwing in an auto-release pool, which don't worry about that. Inside of the code that actually implements this, we're creating an instance of NS string using an auto-release pointer, which we'll discuss that later. So we have @HeyBuddy with a bunch of return characters and new line feeds at the end, followed by another instance of NS string called chomp string, which then wants to interface with str. So the receiver is str, and the message or the method that I'm passing it is chomp string. So then the response of this execution will return us a auto-release pointer of an NS string, and we'll assign that to chomp string. Then we'll print to the user, printf before, and then the format string after the format string, and the before we're going to be communicating with str, or interfacing with str. We're going to be asking for the C string method, and the same thing here with chomp C string. And as you guys saw, the result of the application is going to be one string that has new lines, and then another string that does not have new lines.
Hello everybody, welcome to our lab on Xcode and walking around the block in Xcode.
So just like Brian's mom, Xcode's been around the block.
So we've seen how to basically do the whole process through a text editor and terminal, compiling it. So now we're going to use it with the
Xcode IDE?
Yeah, the standard Apple distributed IDE. So
you guys, I'm sure, have had enough of doing GCCL, OBJC. Now we're going to do it the way that most developers would probably build projects. So we'll start by opening Xcode and doing a really quick gloss, maybe do a basic program so that you guys can see it, feel it, smell it, taste it, and then we'll start building applications using it. And I don't know if when we install Xcode, Brian, I don't think that it drops a link in your apps. I think you actually have to...
Right, it's in the developer folder on your hard drive.
It's in the root partition, developer applications, Xcode.
Absolutely.
Awesome. Can we make a shortcut to this? So let's make an alias.
And then you can
just call it, well, here we go. We'll just stick this on the desktop, right?
There you go. And you can rename it.
We're going to be using that, and when we get to Interface Builder, we'll do that then. Mm-hmm. So I think I can hit enter, right?
Yeah. There you go.
Okay, so now I've made my alias on the desktop for Xcode.
Then you double click it and it starts bouncing. It does the dance. So we'll create a new Xcode project.
Okay.
And the project type in this case, so we have a lot of different templates. We'll just kind of walk through this real quick. there's a separation on the left, as you see, between iOS and Mac OS X. So on the Mac OS X side, actually, we'll start on the iPhone side. On the iOS side, you have navigation-based, which is if you ever use an iPhone application, you kind of have like a view, and you click on something, and it slides you to that new view, and then you hit the back button on the top left, and it slides you back.
Like 99% of all iPhone apps, right?
So that's the navigation-based. And then you have OpenGL application, which is more like a game might be an OpenGL app. A split view-based application is kind of like a... maybe something like Dropbox would be like a split view. A tab bar application has the menu on the bottom, kind of like
iTunes.
Yeah, or iPod.
iPod
app.
Right? That's what I mean.
And then Unity and window based we'll kind of just leave for right now. And view based application is kind of like a very straightforward standard. You just kind of have a view, do something with it.
Right.
You have a framework library and other sections for static libraries and just to kind of do your own thing. Mm-hmm. And then on the Mac OS X side, you have the Cocoa application, Cocoa Apple scripts application, and for kind of macros in the operating system and stuff. And then the command line applications.
Which is where we're going to start.
Yep. We also have frameworks, libraries. We won't get too much into this, but just know that you can kind of write libraries that you'll bring in. You can write application plugins, and they give you a template for that, system plugins, and other stuff where you just kind of get an empty project and do your thing.
Nice.
Yep.
All kinds of crazy stuff, Brian.
Yep. So we'll go to Mac OS X application command line tool, and we'll create a project of that type.
Awesome.
Because this is just kind of a basic. We just kind of want to, show you how it's set up.
So I think we're going to want to select the foundation because we're going to be using Objective-C. So what do you want to call the project, Brian? Want to maybe do a Hey Buddy program?
Yeah, let's do that.
So we'll do Hey Buddy. Awesome.
The type is foundation, and then we select the parent directory for where we want the project to go.
Yeah, I'm going to put this on the Wibbit.net drive that we have on my desktop. So just hit create.
Yep.
Should be good.
That's right. And the create local grit repository for this directory, don't worry too much about it, but it's basically, you can see this letter M here in the project. As we edit stuff, because we have that grit repository, it's kind of like using Subversion or something else. As you edit and modify the files, it'll tell you which files need to be synced back up with where the files are stored.
Right.
In case you have multiple people working on the same project.
Now one thing, and I guess you don't really know, I guess you don't know this with the console. This directory structure here, guys, is actually like a virtual directory structure. So when we start getting into stuff like building GUI applications, you'll see this in more detail. But you have stuff like here, main.m, which we've been working with the M files, right? That's going to be our code file. And I think Hey Buddy 1, isn't this a documentation, like a man file?
Yeah. So if we just change Hello World to Hey Buddy, because Hello World is lame.
Right. Well, the first thing that we can kind of notice, now this is the code that was generated for us, right? Notice that all rights are reserved. Now that's important to notice because if you take this code and use it, you owe Wibbit.net $15 billion trillion. So keep that in mind. Anyways, you'll notice that we see things here that we recognize. We have a main function, we have import foundation.
Yep.
We have...
So it's the same thing we were doing before. They just kind of prepackage it.
Right. Autorelease pool, which we've seen. We've seen NSLog. We've drained the pool. This looks like a C program, Brian.
Yeah.
This looks just like the same stuff we've been building this whole time.
Yeah. Okay, well, now that the font's bigger and we have all the code here.
Brian and his little snappies.
Yeah. Hey, buddy.
Let's make this a little bit more Wibbit.net-y. All right, Brian, so if I wanted to execute and run this program, how could I do that?
Well, you can actually just click run.
Little play button here?
Let's do this step by step. We'll say file save.
Oh.
You could just hit the play button, but we'll say file save.
Okay, done.
And then we'll go to, we'll say product build. Usually I always do hotkeys, so I'm going to see if this works. Yeah, there we go. Product build.
Okay.
Yep, and this will build the project. It'll precompile the headers, compile it, link it, build it,
Hey, all right.
And now we can click on run to run it.
Can we go to product
we can do
run?
Product run, yeah, you can.
Do it the manual way? Which I think does the building and linking.
Yep. And you'll see this output console pop up on the bottom.
Holy monkey.
And it's not like a terminal window that opens. It actually just redirects it into this output.
So then the little terminal down here shows the output. So, and this uses that NSLog format, which we discussed.
So we could change that by changing how we call NSLog if we wanted to, but
Yep.
Or we could do like a printf or something. It'll probably tell us it's depreciated. Actually, that might be an interesting thing to see real quick.
So yeah, that's a good idea, Brian. So let's do an NS string. You'll also see that as we start to type this, Brian, what happens?
Yeah, there's it's like, I don't think they call it IntelliSense, but it's auto type ahead. And you can see how, you know, it's now saying that there's warnings and errors and stuff because we have like half typed code.
So look at this. So as I'm typing a nit with string, it's filling this out for me. Although it doesn't want to tell me how I'm supposed to type "Hey, buddy,"
Right.
which I can kind of appreciate. Now watch this, Brian. As I want to do "Hey, buddy," string, I can press enter.
Release.
It took 3 characters to get it. All right. So like Brian was saying, we can come down here and we could change this printf to an NSLog and see what happens. Or I'm sorry, this NSLog to a printf. And look at that! It even picks up the format for that, or it did.
Yep.
Nah, I lost it now.
Yeah, had it.
So if we do a %s new line and we passed it, hey,
buddy, string. There you
buddy,
go.
string. See those little lines through it?
Right. So it means it's a depreciated call method.
Right. So now if we try to build this,
so we get this yellow indicator on the left.
Yeah, right here.
And you also see it on the top. So if you click on that, you'll see it says C string is depreciated.
And then I'm going to say...
Nice. So let's build and run this. Let's save this, build it, and run it.
Okay. So we're doing it the manual way. If we hit save, build...
And running it will build it, obviously.
Right.
So even though it throws a warning, as you all know, a warning won't stop you.
Right.
You know, so it's just warning that it's depreciated. It's not actually seeing. So now if you look down on our output panel, you'll see that we don't have the NSLog formatting in front of it. We just printf. So it works perfectly fine. It's just, you know, using C strings in general is not necessarily the Apple-y way to do it. So get Xcode up and running and play around with it. Look at the user interface. We will we'll explore more later as we need to use the different elements. So, like, we're not going to show you the interface builder, obviously, right now, because it's just a command application, but hopefully this will give you at least, like, kind of the basic rundown of how to get a program running.
Right.
And test that your install is correct.
Hey guys, welcome back to the Programming and Objective-C course. Kevin and Brian are here again from Whitbit.net.
Oh, yeah.
And in this particular lesson, Brian, we're going to be talking about the basics of memory management in Objective-C.
So this is something that we've been eluding and dodging like the plague leading up to this point. All right, you see this like auto pool, and we're going to like drain it and fill it back up on Memorial Day or something. I don't know. Like just forget about it. We'll talk about it later. Like we've been procrastinating. Finally, the time has come. We're going to talk about it.
And this is going to be broken apart into a couple of different sections. This first one that we're going to go over now is just kind of the basics of what retain is, what release is, what deallocation, what that actually does. Then we're going to kind of jump into auto release in the next section because they are kind of like separate. They're not the same beasts.
And I'll say what we call basics would take you forever to read through the documentation to understand.
Probably. So let's do our best here, Brian.
Yeah, so we make advanced awesome things pretty basic. Let's see how this goes. So memory management in Objective-C is extremely important to understand. It changes depending on the type of device that you're programming for, the environment that you're writing for. If you're doing it for an OSX application versus an iPhone application, it starts getting more and more restrictive. So there's certain circumstances in Objective-C, especially with Apple, where you need to have, you're required to take a very like rigorous and manual control over the memory management of your application. And that's not necessarily a bad thing, as you'll find. This is very important to understand, and it's very critical on mobile devices because even though the devices are very fast, they're still a mobile device. It's still like a computer that would have blown your mind in the 90s in your freaking pocket, man. I mean, it's crazy, but it's still a mobile device nonetheless.
That same computer that you got when you first got Quake 2. That's probably what it is,
it's probably surpassed that now. You know,
okay, well, never mind.
I don't know.
I just really missed Quake 2. That was the best game ever.
I don't know. It's crazy.
They're no longer the computers from the 90s.
Anyway, Quake 2 is pretty fun. So some implementations of the language like I was saying, require like a very manual memory management. So we want to understand this all the way through for the circumstances that we run into that. And poorly managed memory will absolutely cause memory leaks and unstable code. And this doesn't just apply to Objective-C. This applies across the board. I mean, you have a junk collector and it automatically handles this, that, and the other. But like at the end of the day, poor memory management is poor memory management. And the more conveniences and luxuries you have in a language, the sloppier you get, the sloppier we get. I mean, I do it all the time. It sucks.
Yeah, I mean, but imagine like if you're writing stuff for like AI and like embedded programming, you don't have any wiggle room whatsoever. You know, you are running as lean as possible. So that's why this concept is crucially important, especially for the mobile device.
So we kind of recommend reviewing this like a few times over, like just really drill it in. We'll try to make it as least painful as possible. Try to make it enjoyable, but these are important concepts.
Absolutely, Brian. Let's take a quick second here to talk about a little bit more about memory management, and that memory management is not really native to the language. It's kind of something that was added onto it. Now, you guys recall in C, we would do malloc and calloc, but we would still have to free the memory that we've created.
Right.
So even though we have functionality to manage it, it's not built into the language. Like, for example, in C++, when you create a variable declaration inside, in C and Objective-C is the same way, but a variable declaration, not a pointer declaration, inside of a function, it gets jumped on the stack, and then once that removes itself, that memory gets deallocated. With NSObjects, you're creating memory in the heap.
Right.
Heap storage you need to manage that memory. So when we say it's not native to the language, it's because you actually have to take steps as a developer to clean up after yourself. So when Apple developed the Foundation framework, they put methods into the NSObject template that will help make memory management a little better.
And since everything inherits the NSObject, it's basically always available.
Right. And that's also one of the big concepts behind NSObject is make everything have the same memory structures and the same methods that they respond to. So, Brian, what is reference counting?
Reference counting is something where the memory management method uses a counter that keeps track of instance pointers. And basically, that counter just increments like 1, 2, 3, 4, 5, dealloc 5, 4, 3, 2, 1, 0. We're clear. It's not a form of garbage collection. It's just some sort of indicator that says we still have instance pointers out there.
Right. Yeah. Something is pointing at me.
Very basic.
And like Brian said,
not what is pointing at me, but something is pointing at me.
Something. Yes. Or something is pointing at me many times, which can happen. And like Brian stated, this is not a form of garbage collection. Okay. A garbage collection is an automatic form of managing managed memory. These are all unmanaged objects. So here's kind of like a high-level example of what reference counting is. On the right side, we have a list of pointers. On the left side, I have an instance of an object. Now, when this object is created, this pointer here says, I want to make a NS Brian object. Init, alloc init, boom. Now I'm pointing at this. Now, I pass this to a some other interface or some other class that stores this long term. So it will then increase the retain count and say, now I'm pointing at this. And then now I'm pointing at this. And then now I'm pointing at this. Now,
so
Brian,
we just created 4 different types of objects.
Well, 4 different pointers are pointing at the exact same object instance. So, So everybody's pointing at Brian. So when I go to any of these 4 people, any of these 4 pointers, they point me in Brian's direction. Now, as these pointers move off onto other objects. So if I set this new pointer equal to this new instance or this new memory address, I'm going to decrease this value, decrease this value, decrease this value. And then when the last person takes his hand off, the retain count becomes 0. And when the retain count becomes 0, dealloc is then called by the NSObject class, which destructs the object and all gone.
Right. So there's 2 different ways that this can be implemented. Obviously, like with the standard transmission or with an automatic transmission. The automatic way is to consistently scan all of these active pointers and match them to a particular object instance. And if an object instance has no more pointers, then it's removed. That's a lot of overhead, and you have to have something actively searching everything that you have, and that's pretty resource intensive.
Right, but you start to see this concept develop a little more when you move into like Java and C#, because that's what it pretty much uses in its runtime.
If you do it the manual way, which is used by Objective-C, the developer manually manipulates that retain count, and each instances that reaches a retain count of 0 are removed, which means nothing else is referring to me. I'm now effectively an orphaned instance.
Right, but the thing that's important to know, Brian, is It's not that nothing is pointing at you, but that nothing has written its name down on the piece of paper saying that it's pointed at you. Because things can be pointing at you without increasing your retain count.
Right. And what happens is it's deallocated and something tries to access you and it's bad memory access and it's a problem.
Yep.
That's why it's very important to manage your count, your retain count properly.
Yes. And we'll go over some rules to help you do that here in just a second.
One of the advantages though is there is like no overhead.
Yeah.
Because there's no garbage collection required.
Quick.
Yeah, so it conserves a lot of resources and it makes sure that memory management is like clean. We're cleaning up memory when we need to. Nothing's extra. Nothing's like hanging out there until it seems appropriate to get rid of it. It's like as soon as you don't need it anymore, that thing's gone.
Yeah, and anything that's performance based, I don't give a shit what language you're coding in. Anything that's performance based, manual memory management is always better.
Yes,
avoiding garbage collection is always the best way to go.
When and how you free up memory or manage memory changes based on the needs of the application and how your performance is going to be structured.
Yeah.
So absolutely.
So kind of think of reference counting, guys, as the same way that you would access like a file handle, right? So in a C program or C++ program, we have open files and then either written to it or read from it. And then when we're done, what do we always do?
We close that file handle.
We close the file handle. So when you're using instances or object instances in Objective-C, think of every single one of them as like a floating file. If you're using it, lock it. If you're no longer using it, close it.
Right.
That's that.
Yep.
It can literally be that simple.
Yeah. So let's take a look at a bad path. Like we were saying, improperly managed memory will cause memory leaks.
Absolutely.
Memory leaks. So let's see an example of how that happens. Okay, so here we have my var, which is we just created a new pointer instance that points to a memory space.
Right. So it just ran this code here.
Yep. So we just did an alloc and a init of my object, which inherits NSObjects.
And we do have a typo. There's supposed to be another left bracket here.
Oh yeah.
Let's just imagine that there is. I couldn't imagine a circumstance.
Actually,
how did you pull that off, Brian?
Magic.
Wow.
It's just like Penn and Teller.
Wait a minute. Which one am I again?
I don't know. So here we have alloc init, and that creates a pointer to an object.
And this object's retain count, by virtue of alloc init, is 1 automatically.
Right. So now this happens. Now we have a second line that says alloc init my var again, and that pointer now points to the newly allocated memory space. But nothing was done to reduce the retain count of the other one, so nothing's really pointing at it, and it's still kind of floating out there. This is what we call a leak.
A memory leak, yes.
A memory leak.
A memory.
Yeah.
So the retain count, Brian, that when we go back a slide, this number 1 is the retain count. So when I create an object using alloc init or new, I'm creating an object that has the retain count of 1.
Yep.
So inside of the actual NSObject code, with this is an excerpt from retain count. This is actual code when you call the retain count method, what it returns. So basically, this retain count method is an inherited property or inherited method from the NSObject. It's an integer that stores the number of references pointing to the instance. Now, the integer is manipulated manually, like I said before, with alloc new, but you can also increase it manually by saying retain. You could decrease it manually by saying release, and you can also deallocate or decrease it by calling dealloc. Mm-hmm. So those all have an effect on this number.
Right.
Holy crap, Brian. This is the actual, slightly modified for readability purposes, release method from NSObject.m.
Nice. That's awesome.
Now, this kind of looks kind of messy, but there is this little zombie enabled, which we are going to ignore because that's not really relevant to what we're going to be talking about here. That's kind of like a different implementation of this code. Mm-hmm. So let's walk through this, Brian. This is if the retain count is greater than 0, right? Because at the top you can see that the retain count equals 1, so, or equals 0, or minus 1 equals 0. Now, when we call release, what we're doing is we're just doing dot retained minus minus, which does what? Just decrements it, right?
And then if it comes back and that's 0, it keeps decrementing until we hit the condition where it's 0 up above.
Right.
Then that means that last reference pointer is released.
And then look what it calls. First off, it decrements because if you're doing a release and the retained count equals 1, well, 1 minus 1 is 0. So the retained equals 0.
Right.
Now, when we go down to the bottom in the else condition, which is what this code is gonna.
That's else zombie enabled.
Oh, else zombie enabled, right. After the zombie enabled crap, we decrease the retained count so that it equals 0. And then what did we call, Brian?
Dealloc.
From which object?
From ourselves.
From ourselves.
Yeah.
Which is the reference to the parent.
Right.
Holy crap.
I know, it's cool.
That's actually going to NSObject and is deallocating the method. And if this inherited from NSObject had an object that inherited from NSObject that had an object that inherited, then it goes deallocate all the way up until it eventually gets to NSObject, which will then actually perform the deallocation.
Right. Just like we talked about in class inheritance.
Yeah, it's beautiful.
So here's the appropriate way to manage it. So we created a new object, my object, and we create a pointer called O1, like object one, you know, whatever. So we do the alloc init, and as you know, that creates a an object and assigns a
pointer.
Yeah, it creates a pointer to a memory space, but also adds the retain count of 1.
Right, because alloc
naturally, right. So init ties these, and then we print it, we use it, do whatever we want, and then we call release on that object on O1, and O1 will release that.
Right, so now the retain count is zippy.
It's the same method we just looked at.
Right.
Yep. And so it decrements it, and then in this case it decremented to 0.
Right.
And so then it deallocates.
All gone.
Yeah, and deallocates all the way up the tree.
Yeah, cool. So what have we learned, Brian? In the retain count, the release method is used to decrement the value of instances that the object has pointing to it.
Yeah.
The new or alloc method will automatically set the retain count to 1.
Yep.
But Brian, there may be some questions that people
Because
have.
when you do alloc init, there's one that exists. Right. I mean, it makes perfect sense.
Yes, and you're creating a new non-auto release, which we'll get to later.
Right. So we have 2 questions.
Okay.
First is can we read this value? Like, can we find out what our retain count is?
I don't know.
And can we increment the retain count on an existing instance?
I don't know. Let's find out.
I would imagine, yeah.
So in this example, we have done the exact same thing with my object, object1, alloc init. So we all know at this point, O1, object1 is a pointer label pointing to an instance that has a retain count of 1. Now, Brian, the next line here, we're going to call retain. And retain increments that count. So what was 1 is now 2. So we can pull this value in, Brian, on this next line here by calling the retain count, which if you were to run this code, the value would be 2. Because we can see that alloc made 1, retain added 2. So we have one pointer pointing at an instance that has a retain count of 2.
Right.
So now what happens?
Then we release it and it decrements.
Okay.
So we'll print that out.
But
it's 1.
It didn't deallocate.
No, because it didn't go back to 0.
So don't think that release means deallocate.
Right.
Release just means remove one pointer or remove one reference.
It does mean deallocate if it's the last one.
In this particular case, this next line will actually set the retain count to 0, which you remember from the NSObject code that we looked at a second ago. This will actually run self-deallocate.
Yeah. Isn't that awesome?
All gone.
It's very cool.
It's like it never even existed. So never, ever, 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 ever do this, Brian.
Right. So it seems like this would be a good idea.
Yeah, right?
Not a good idea.
No, it's terrible. Yeah. Because what we're doing, Brian, is we have a pointer, a pointer OB1. And when we say OB2 equals OB1, you are not setting it equal to the value. You're setting it equal to the pointer.
Right. And that pointer and that what that's pointing to still in this case only has a retain count of 1.
Yes, even though there's 2 pointers.
Right.
Yes, exactly.
Problematic. So you could do this. You could then retain it, increase that count, and then point to it.
Yeah.
That's fair.
Right. So now we have a proper representation where the memory space that OB1 and OB2 are both pointing at has a retain count of 2, which reflects the environment that it's in.
Right. Or in a simpler, maybe more elegant way you could argue, is just make a reference to it and call retain, and it'll return back that object pointer.
Yeah. Right. Mm-hmm. So we promised earlier that we would go over some rules to help you understand when and how to manage these instances. And now this begins that journey. So let me just start off by saying, if you create an object using the following methods, you own that object.
Right.
I create one with alloc, which my object alloc init. Forget about init. Remember, init is just a method. It has nothing to do with creating an object.
It's kind of like the constructor, sort of.
But it's not. It's like a fake, I wish I was a constructor.
Right.
You know, so alloc creates the actual object, and init is a method I'm calling on that object.
Yes.
So forget about init. If you use alloc, you own it.
Yes.
If you use new, you own it. If you use copy, You own it.
Yep.
You created an object and you created an object with a retain count. And if you are the owner, you must release the memory by using release or auto release, which we'll discuss later.
Yeah. So if you're planning on using an instance outside of the context of the method it was received in, then you have to call retain. So if we take a look at this example of set string value, we have a pointer to some string in memory somewhere, and our internal value we'll call string value. So we want to set that to something else, and we have a pointer coming in a string. So we want to first release our internal value so that it can be deallocated if nothing else is pointing to it. And then we want to say that we retain that string coming in because somebody else might deallocate it outside of this method.
Right.
And we want to make sure that we're retaining it. So like we're now saying, oh yeah, we're also now going to be an owner of that memory space.
Yep.
We're going to make a retain on that. So we're retaining that pointer, and then we're setting our internal one to that pointer value.
Right.
So when we come out of here, if they go and release it, so long as they're not a total asshole and release it like 50 times for no reason, if they just kind of do what's appropriate for them, everything's fine. That instance in memory will still exist for us.
I've actually seen some Objective-C code where there was an instance that they were deallocating
It was
that was like while retain count is greater than 0, called
That's
release.
horrible.
Man, terrible.
Never do that.
So here's an example of how this works and why this works so beautifully. Now, as Brian was describing, this is kind of an excerpt from a class that doesn't really exist. So this is a method inside of a class. And inside of our class, we have a pointer, an NS string, called string value. And if you look on the bottom left, we're pointing to an instance of an NS string with a retain count of 1. Now, the code that is calling this class, be it the main function or some other class that is calling this, is going to be sending in a parameter of a string called str, which is a different memory space represented on the right with the retain count of 1. So with the string value, what I want to do is I want to call release. So now the retain count of my internal string is 0. I'm no longer using it. And if someone else has a reference to it, it will then just decrement. But in this case, it's going down to 0. And I'm going to retain the object on the right. So if you look on the right, now this has a reference number of 2. And in the next line, I'm going to assign my pointer to that value. And as my internal string value label is being deallocated, I have then set it to another instance. And as you can see, the retain count is 2, which properly represents the environment because we have 2 pointers looking at it.
And so outside of us, if the calling code deallocates str and that count goes back down to 1, we're still fine. So why do this? In this example, as you know, the parameter that was passed in was just a pointer. Mm-hmm. So we don't have any control over what they can do with that memory space.
We don't own it.
Right.
It was given to us.
Yes.
We didn't make it.
It was just somebody saying like, hey, there's some stuff over there.
Yeah.
But they could do something with that stuff over there. So by decrementing the retain count of the previous instance to clear it up, to be the proper owners of that, and then incrementing the retain count of the past parameter, that will protect that memory space from when the outside code releases that instance, so that it won't deallocate and we can still access it when we need to.
Exactly. Now let's take a look at this example, Brian. So this is kind of after we went through that method and we've assigned this value. Now str belongs to the code that called the code that to set this. Now that code, the calling code, the main function code, for example, then decides I want to release this and point to a new instance.
Right.
Now you can see these numbers properly represent the environment. Where string value, the pointer that the instance it's pointing at contains a retain of 1, while the new value that str just created has an instance of 1 as well.
Right. Otherwise, that gray object of the count 1 would be down to 0. String value would try to access it, and it would be bad memory access because that memory would be freed.
It'd be terrible, Brian.
Yeah, it would be a bad thing.
You're all gonna lose your pointers. Now, here's what you should never do in your life, Brian. Talk to me about this.
Unless you're suicidal.
Yeah.
You really don't want to, so now it's clear, like clearly you can see what's going on here. So we get a pointer in that has a string value passed in as a parameter. We don't know anything about its retain count. So you can see, str points to something with, 1 retain count. If we just set string value equal to str,
you have a loss.
So not only do we have a leak, and every time we call set string value, we're going to leak off another one.
Yeah.
But as soon as that calling code deallocates that str, we're screwed. So this is like a totally jacked up situation.
Right.
And even though it seems and that just leaks everywhere, it's just a mess. So then we run out of memory space and like the thing just goes all ape shit and it's just horrible.
Right. So Brian, this is what happens. str releases the instance and it points at its new object. String value is now pointing at a deallocated memory space. Crash!
So here we have a memory leak. Right. So let's say we have some string pointer that points to an object, and now it points to another object, now it points to another object. When those things never deallocate allocate, you just start getting like a whole big mess pile of them. So what we want to do is point to an object, release that, and then point to another one.
Yes.
Release it, point to another one, and keep it clean.
Absolutely. I could not have said it better myself.
Even though it seemed, going back to that string value equals str, the parameter value, that seems like it would make perfect sense. You just like, oh, that's what I want it to equal that. But now you can see, like, it doesn't even make sense now.
You're dealing with pointers, folks. Right. These are pointers, and they must be respected because you're pointing at memory addresses. Yep. You're not pointing at values. So this is kind of the continuation of the rules we were discussing before. If you did not create an instance, then you do not own it. Like in that example that we just saw, we were just passed the value. So assume that the instance that you don't own will automatically release.
Right, just assume worst case scenario.
Right. Assume that something else will handle deallocating it. And unless you're going to use something for an extended amount of time, don't worry about retaining. So like if you just have a method that just brings in an NS string and then prints out its C string equivalent, well, there's really no need to go through the whole, protecting it at that point.
And if you're writing the calling code, just release it.
Yeah.
Assume that object that you're passing it into is going to properly handle it.
Yes, and as long as you make those assumptions, you can have a nice, safe environment to work in.
And that kind of goes back to this whole like immutable concept. Mm-hmm. You just kind of like stick it there for when you need it there, get rid of it, move on.
Yeah.
Like just try to keep things out of memory. Don't like, fill up the whole space so you can just like wander around and access whatever you want whenever you want it, Like try to be a little more on the conservative side if you can.
So the instance that you're dealing with may be controlled by like, let's say another thread or some other instance. And by you interfering by, getting all like, this is my object, I do what I want, you could actually cause another class or another thread to fail and cause the entire program to become unstable and crash. So here's an example of like one pointer pointing at this. This is just to kind of like drill this concept in. Retain count of 1. Now I bring in this object for myself and I'm doing stuff to it. Now
hey, that's a cool object over there. Right. That's fun. Yeah.
Now I'm using it, but I didn't increase the retain count. But after I'm done, I didn't increase the retain count, but my code released it when I was done.
What a dick.
Well, I just completely fucked up this guy. So this guy who was obeying the rules got screwed because I wasn't.
And then bad things will happen.
It's all over.
So just use retain when it's necessary. A lot of developers that start off on Objective-C really struggle with memory management, and you can kind of see why. Like at first glance, when you're looking at the language, it's like, what the hell? What's going on? It seems kind of weird, but once you kind of get used to it, and once you like really see conceptually how it's structured, it can be a really good way to handle memory management. It's really not that bad.
Yeah.
It doesn't cause that many problems when it's implemented properly. So let's take a look at the following example for a situation that we want to look out for. So let's take a look at the following example for a situation that we want to look out for.
Right. Now this code has a bug in it, Brian. And what we're going to do is
Is it like a fly or just a bug?
No, it's a fly. It's that stone fly. That's getting a buzz on life. This code has a bug in it. And we're going to do a line-by-line review of this code, and we're going to find that bug. And hopefully this will teach you guys how you should best manage your instances when you're flowing through an Objective-C program.
Yeah.
So when I first create this program, we're making an NS string called value to pass.
Okay.
And Brian, we're using alloc and init. So when we call alloc, what does that mean?
That it starts off with 1, and that we own it.
We own it.
Yep.
That's what you got to understand. You call alloc, you call new, you call copy. You own that son of a bitch. And now, Brian, what do we do here?
Now it was kind of similar. Now test. Oh, sorry. Well, test object is now alloc initted, so we got another one out there.
Right, but look inside of the test object. What does it have?
It has an internal NS string value.
Okay, interesting.
Which is also a pointer.
Right, but
it's not alloc initted.
It has not been initialized.
Right.
But it still exists, so we have the potential to point at an NS string. So then when I call the TO, which is my test object, the set value method, I'm going to pass that NS string value to pass, which is what we initialized in the first line, the one that we own. Now my class does the proper thing, and it releases its NS string value, which if it's nil, this just doesn't do anything. It increases the retain count to 2, as you can see on the right-hand side, and then I set my pointer to it, and that perfectly reflects the environment.
Right.
We have two NS strings pointing at this instance, so not too bad. Now, Brian, what are we doing here?
Okay, so now we have a new NS string pointer we'll call stored value.
Okay.
And we're going to set this to be equal to the get value method.
Okay.
And the get value method just returns, basically, the pointer to its internal value.
Right.
So now, the stored value, unfortunately, and it's not necessarily the fault of the calling code.
No.
This is the fault.
It is the calling code's fault. It's not the class code. The class was obeying the rules in this situation.
Is it?
Yeah.
So now we have 3 objects that are pointing to that object.
Yeah, 3 pointers.
3 pointers pointing to that one object.
But we don't own this one because we didn't alloc init this one.
Right.
We didn't alloc this one. We didn't new this one. We didn't copy this one. So we actually just set this to the pointer. So now we have 3 pointers pointing at an object that thinks it has 2 pointers. This is dangerous.
Yes.
So now my value to pass, I'm done with it. So
Yeah,
I'm gonna
fair enough.
do this.
Gone.
Now, when I release the test object, Brian, inside of its dealloc method, it's gonna release it,
Yeah, that's problematic.
and then it's gonna call super dealloc
And now-
and destroy itself. And now, what happens if I try to print stored value?
It doesn't exist. It's bad memory access.
Well, then we're gonna get a crash. What happened, Brian?
So the instance was being used later on, and the developer failed to protect it. They didn't retain it. So in this case, the coder should have retained the value by an instance method to retain it. So the class performed correctly, but the driver contained a bug.
Yes. Mm-hmm.
So the calling class should have, when they got it, retained it.
Especially if they were going to be using it later.
This set of rules will kind of force developers into a circumstance where they have to be way more cautious about memory.
Yes, I agree. Now here is a fixed version of the code, Brian.
Right.
So what we're doing is on the to get value, we're calling retain on that memory.
Right. So we increment that count.
Yes, and at the end of the program, we release that memory.
Right. So this can be intimidating. It can be a little odd. Don't let it get the best of you. Be aware of it. Keep studying. Keep figuring it out. You'll find this all over the place. It's not just an Objective-C.
Yeah.
But usually it's just hidden from the developer. But there's a lot of cases where you will have to dig in and figure that out.
I can't tell you how many times I've inherited code that had nasty memory leaks.
Yeah.
And they were maybe like C++ code.
Yeah.
You know? Or it was some C# code that pulled in some DLL that had a nasty memory leak in it. You know, this paradigm exists everywhere.
Memory leaks. You probably find it all the time just running applications on your computer.
That's why you have to restart your computer like every week.
Right.
Right? It's because of poorly managed memory.
So later on, we'll kind of show you how to make this like a little more seamless.
Yeah.
But for now, let's just do it manually until you understand that concept. We'll walk and then we'll run.
Yep. So that's it, guys. Just to kind of summarize, like we just did in the last slide, but again, memory management can be kind of crazy, but hopefully we can make it easy for you.
Yeah.
For those of you guys that didn't believe us when we said that memory management is very important, this lab will show you how important it really is.
Yes. We'll try to show you. If we actually crash our computer, we will, not be able to show you.
But then you'll actually know then even more how important managing memory is. So what we're going to do in this lab is Brian and I are going to show you guys how to use some of the performance analyzers that Xcode provides to you. And what do they call it? The profiles?
Yep.
Is that what it's called? So let's make a new project so we kind of get practice going through this process. And we're going to make a Mac OSX application command line tool. And we'll call this, so the product name, we'll call this Memory Leak. And we're going to make a lot of money off of this because everybody needs a program that will leak their memory.
We'll sell it for billions.
Billions and trillions of dollars, Brian. All right. So if you were to make a memory leak program, Brian, how would you do this? I guess first thing would be to remove all the safeguards, right?
Yep. There you go.
So what would you do now?
Okay. Let's allocate and initialize an NSObjects
What?
a bunch of times.
What?
And not clean up after ourselves.
What?
Yeah.
We've never instantiated an NS object before, Brian. This is crazy. So let's make an infinite loop.
Right. So like yes.
1 equals 1.
Okay, that works.
So that'll be an infinite loop, and inside the infinite loop, we'll make an NS object.
Yep. And we'll call it leaky object. There you go.
Leaky like that.
Yep.
Object
Uh-huh.
equals, and remember now, Brian, in order for us to have a leaky object, we have to do what?
Allocate it.
We have to alloc.
NSObject alloc, and then we'll initialize it.
We don't have to call init, but we're going to do it just because. So if you look at this program, Brian, we have an infinite loop that's consistently running and creating instances of this object each time it iterates with absolutely nothing cleaning it up.
Right.
So we can expect this program to do what?
Leak.
Leak like crazy.
Yeah. So hopefully we'll try to run this. And because you all know that when you allocate something, you own it. Alloc means you own it.
Precisely.
And when you own it, you need to clean it up.
Yep.
And there's no release here. So
let's see what happens if you don't clean it up.
Yeah.
So under the products menu, Brian, we're going to go to profile, right?
Right. So this is just going to run an infinite loop and just keep on instantiating objects. All right, so we're going to use the... so there's a bunch of different profiles we can choose. Mm-hmm. You can look for zombie processes if you're doing multi-threading stuff. There's activity monitors, garbage collection if you're, using garbage collection. Timer profile, systems trace, threads. There's a lot of really nice profiles, and it's a pretty good user interface. In this case, we're just going to use the leaks profile. Mm-hmm. So that's what we're checking for. And the program starts running, and we should probably stop it right now because, as you can see, it's just going out of control. 10 megs, 11 megs, 12 megs. This thing's just gonna bomb.
This is memory leaking all over the our little.
All
right, we may have lost our program here. Hold on, let's see if we can stop it. But as you guys can see, that this program is very unstable. Unstable to a point that look what it's doing to our computer.
Right.
It's actually made our computer unusable.
Is it back? Is it back? Nope.
It's thinking. We're at 40 megs. 40.
It's trying to stop. Sometimes that little color wheel sometimes really gets on my nerves.
Yeah.
It was the best waiting cursor ever?
What?
It was the dinosaur in Windows 95 that would wag his tail.
What? They had a dinosaur
You don't remember that?
No, I don't.
Really?
No.
Yeah, in Windows 95 there was default cursor themes that you could come with. And you could make it black or white, and you could pick a dinosaur cursor. Crazy.
Well, as you can see that my fumbling and clicking around had run this thing 4 times, so the final numbers are not as drastic as the numbers that we were seeing. But Brian, you saw we had 40 plus megabytes of
and
memory.
Climbing with no end in sight.
Right. So there's why memory management is very important. Now, if we close out of here and we do the simple release, leaky object release, not retain.
So now, we're owning it, we're releasing it, we're cleaning up after ourselves. And those are the only 2 things that you really have to worry about when managing memory of an object.
So if we go to leaks profile, now the program is running, and it's running. You can see this little thing here is representing time. Represents the time, and you can also see the time incrementing here. But Brian, look.
Yeah, our memory's not increasing.
Our memory is very minimal.
Our total overall bytes is 52K. That's awesome.
This is the greatest program.
Yeah.
Most efficient program ever written.
And this while loop is just cranking as fast as possible.
Oh, yeah.
I mean, the number of cycles that this thing's moving through and
it's moving It's moving as fast as the CPU will allow it to happen.
Yes. Right. So it's pretty cool.
Yeah, that's awesome. So that's kind of an overview of why memory management is so important in this language.
Right. So once you really get into start writing more complex programs and you have objects kind of here, there, releasing, retaining, and all this kind of stuff, that is a great way. And once you do start finding leaks, that profile will help you trace down precisely which objects are leaking and when.
Right.
So it's a great tool to work those bugs out to make sure that your program's efficient and clean and doesn't leak memory. Welcome back, everybody. You now have a solid understanding of the basics of memory management and a manual approach to doing it. Now we're going to get into auto-release and how to drain your pool and winterize your backyard and stuff,
Well, Brian, one thing to kind of know about Objective-C objects is they like to go swimming. And you can give them a place to go swimming, but the problem is they will eventually drown and they will die.
So let's see what the hell we're talking about.
Okay.
So auto-release is essentially just a method of preventing memory leaks and managing memory. And it does this by using the idea of a pool of instances, like a bucket of instances that are created during runtime. And all of these instances are released at once when we call the release or drain methods.
Yep. Mm-hmm.
So it's pretty straightforward. It's kind of just, well, you'll see.
And believe it or not, you've already had exposure to this because we've already written auto-release pools. We just chose to not tell you what they were.
Yeah, we were like, oh, we'll save it for later.
So if you really want to look at it from a realistic standpoint, an auto-release pool is really nothing more than an array of instances.
Right.
And to manually add an instance to this array, you refer it or you call its auto-release method.
Right.
Now, you may notice if you start playing around with code, if you make an instance and call auto-release, you're going to get one of those warnings that says that just leaking error, there's no auto-release pool even though you called auto-release. Right. So that's what this is doing. This is taking that object instance and throwing it in the pool.
Exactly.
Go swimming. So here's an example, Brian. This is craziness.
Okay, wow. So let's take a look at this. So we have NS auto-release pool.
Uh-huh.
And we'll just call it P. Uh-huh. And we allocate it. Right. So it exists.
Right.
And I guess you could probably assume that auto-release pool itself has a retain count of 1.
Yes, you can. That's actually true.
Anyway, that's not important. Ignore that. Anyway, so we have an auto-release pool object out there. And now we create my object. So now we have a pointer, OB, which is alloc init. We own it. It's my object. And then we call auto-release on it. And what that does is it kind of associates it with this throws it in the pool.
Yeah. You ever go to like a party in high school and you're walking around the pool wearing like your regular clothes and some asshole walks over and knocks you in the pool?
Yeah, that's
what
basically
auto-release is.
So
Son
after
of a bitch, my mom just bought me those shoes.
So calling auto-release doesn't release it.
Yeah.
It sets the auto-release flag on the object. So, it really just adds it to that array so that it's within its domain, but still. Then you do stuff, blah, 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 and then later on, when you want to clean up, you just say drain on the pool P, and it'll clear everything out of the pool. It's like, calling drain is kind of like throwing a baby Ruth. And then, the auto-release pool itself will become deallocated, and because drain will set the retain count of the pool to 0.
Nice.
And it'll return
Very
0.
nice. So, Brian, here's the auto-release pool, right? And now I have my program running, and it's creating
It's a green pool.
It's a green pool. Well, I don't know if I want to go swimming in that water. It's like acid water.
Oh.
So here are my little...
It's like from Who Framed Roger Rabbit.
Was acid water in that movie? I haven't seen that movie in
Remember the ooze?
It's been like 15 years, man.
I know.
I don't know. I'm sorry. We have our object instances over here, and as my program is running, I'm just kind of throwing these objects in the pool. And then at the end of my program,
right,
I'm going to drain it, and then, oh no! The acid is burning us alive!
We flush the toilet.
They're all dead.
Yep. So why?
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 So
Why? Be more wait. No,
constructive with your feedback.
There you go.
Criticizing my thing. This is really just a way of trying to like tame this whole complex maze of pointers. Like as we saw in the manual method, you have to kind of like set this there and tie this back to that and release this one and do this every which way. Remember, Objective-C references objects using pointers all the time, always dealing with pointers. And if multiple pointers are pointing to an instance, then the retain count has to reflect this.
Yep.
So auto-release kind of takes on that responsibility, and it will figure out how to manage releasing these objects.
It's common in Objective-C for objects to contain a class-level method that returns a new instance of an object that's an auto-release. Now, we've actually seen this before.
Yeah, so and it kind of already like prepackaged, ready to go. You get that, and it's already flagged.
Yeah. Remember before we saw those errors when Brian and I were showing you how to instantiate an NS string example using like string with C string.
Right.
We got that auto-release error during runtime. Well, because we got an auto-release pointer with no auto-release pool. So these instances, when they're returned to you, are set with an auto-release flag. And now remember the rules from earlier, Brian. When you get a class-level instance pointer that's set to auto-release, you don't call alloc,
and
you don't call new, and you don't call copy, which means you don't own it.
Right.
The release pool owns it. Now that's kind of cool. You're getting something that you don't own, but you can use it and do whatever the f*** you want to it.
You can just like have a party with it.
Now here's an example, Brian. What is this method here in the middle? What is that?
It's a class level method because it has a plus sign on it.
Holy sugar.
So that means it's not from the object instance. You actually call like the person class and then person with first name.
Yeah, right.
And that kind of, and that's like it's just like init. It is effectively the same thing, except that it's on the class level. So init, you've already allocated the memory. Init on the instance level, you already allocated the memory and now we're going to initialize it. In this case, we're going to be doing the allocation, the init, and the auto-release flags all together on the class level and returning that back.
That's madness.
Yeah.
So here's some code on the left that we're going to scrutinize. In the first example, we're going to be calling these using alloc, which means that we the object.
Own it.
We own the object. So when I come through this code and I make some NS strings and I init with C string and I have two of these, now I have two objects that I own with the retain count of 1.
Right. So we got to release those later.
Yes.
So we got to remember to do that.
I create a person, and what do I call alloc? Which means what, Brian?
We own it.
I own this motherfucker. All right. So then I have a new person instance that has a retain count of 1, and I'm passing it to strings that have a retain count of 1.
Right.
Very cool, huh? So then here, if you look at this code, now I have a init with first name, and then first name, init with last name. And if you look at that code, if you look on the upper right, the two NS strings now have a retain count of 2. Because, Brian, the class that owns this, or the code that owns this, has its its mark on it.
Right.
But now my person class wants to own it as well. It wants to have access to it for a long extended period of time. So I'm going to retain it for myself.
Right.
Now, when I do person first name release, that person first name instance on the middle there, now retain count is 1. So the class still has access to it, but the code that created it no longer does. Same thing with last name, exact same thing.
Even
now,
though it was the owner.
Yes, the owner released it, but then, the code later on now has access to it because it's put its stamp on it. Now
now we're done with the person object.
Yep. And the person object, you see, calls release on the first name, the last name, and it deallocates itself.
Yep.
And then everything goes away. And there's the manual method of using this.
Right.
Now, what do we got here, Brian?
All right. So what does that have to do with Autorelease?
Nothing.
But it does juxtapose this example.
All right, Brian.
Okay, so here we have Autorelease pool. We allocate it.
The swampy acid water.
The frog swamp.
That's like the frog pee pool. The frog peed in there too much.
Oh, we're like in the swimming pool. The frogs always get stuck in the drains. You know, it's just
ew, man.
I don't know.
Don't talk about my frog.
Okay, so in this case, we're calling NSString a little differently. We're calling it on the class level, not on the instance level. So instead of saying alloc init with cstring, we're just saying instead NSString string with cstring. So that we don't own. We never set alloc. We don't own it.
Yep.
That's already set to auto-release. They're already in the pool. No big deal. We're just going to use them later. So now we go to create a person. And in this case, we also don't create a person with the alloc init. We call the class level method to create this person. So we call person with first name, and pass the parameters. And if you look at the class code, we do an alloc init, and the class owns this, and then we set the first name, we set the last name, which does the retaining and the releasing and everything, and then we flag the new person object instance with auto-release. We call that auto-release method and throw it in the pool, and then we return new person, which now is tied to the pool.
Right, so you've received an object that you don't own.
That's right. And so now when we're done, and within the scope of when we created the pool and threw everybody in the pool, we now say we're going to release the pool and drain everything in it. And then when everything's gone, the pool will deallocate and we'll return. Very nice. It's a beautiful thing. So that scary thing that we've been foreboding the whole time, which we thought was like, auto release is like the gates of Mordor. It really wasn't that bad, but it was too much to explain early on. So forgive us for taking the long walk to this point, but we hope that this really hammered the concept.
Yeah, no, but imagine if we did this on the first video, how many people would still be with us right now?
You'd be like, oh, this, I'm just gonna read a book.
You know what? I don't want to develop for app. Apple's stupid.
Where's my Android?
Yeah, right. Where's that Java course?
Welcome back, everybody. We've kind of walked around the block and we've seen everything from the different types of different types of objects that have inherited NSObjects, like the NSString and NSNumber and stuff. And we talked about interfaces. We've talked about instantiation. We've talked about memory management. So now that we kind of have a good sense of things, now we can kind of get into a little more of the implementation side of stuff. And the first thing that we want to talk about is properties, which are always a lot of fun.
Now, remember in C++, Brian, we had to make our own properties class because native, standard, regular, boring C++ does not have support for properties. But we were able to circumvent that very easily by using the delegate concept.
Which is cool.
And, all that kind of stuff. So the great thing about Objective-C is Objective-C, I think it's 2.0 or greater, supports the properties concept. So, oh, wow.
What do you know?
Objective-C 2.0 or greater will support this concept. Developers can basically assign a list of property enhancers to each property, which we'll go over in a little bit. That kind of gives each property its own uniqueness. You know how in our property class in C++ we have read-only, write-only, read-write. Well, those types of things are enhancers, but there's also things like I want to release, do the retain release stuff automatically and all that crazy stuff. So it can be implemented with or without setter and getter methods. And we'll go over both circumstances. And Brian, what the we can use dot syntax?
I love the dot syntax.
Oh, personally. Wow. That's craziness.
I really like dot syntax.
I do too. Now let's take a look, Brian. What do we got here?
Okay, it's implemented with two different keywords, and the first, they don't do the same thing. There's two different things. One is the @property keyword, and that declares something as a property. You'll see keywords for a bunch of different things. Like there's like the @interface keyword, and there's like the @outlet keyword and stuff.
Yeah, other things we haven't gotten to, like protocol and that stuff.
So there's all these different keywords that kind of allows Objective-C to kind of be its own thing and kind of break away from C.
Yeah.
And so we have this @property, which declares something as being a property, and then we also have @synthesize. And @synthesize is something we declare on the implementation side that says we want the language to generate the setters and getters for us automatically. And this isn't really required. If you're going to create your own setter and getter methods, you don't have to worry about synthesizing it. But if it's just kind of some property and all you're going to do is just kind of say like, I'm going to set this to be that and I'm going to get this to be that, then just synthesize it. No big deal.
Yeah, save yourself some time coding. So here's an example, Brian, of actually declaring a property in Objective-C. So here's just a class called myObject, and inside of it we have a setter and a getter, right? A set value, which returns a void, takes an NS string, and a get value, which returns an NS string, and a property, Brian, called value.
Yeah. Now, if we did our job right, when you ran through C++ and you went through making the property class and implementing properties and kind of our way of doing it, you should be really used to the idea of assigning, like, is it read only? Is it write only? Is it read write?
Yeah.
And pointing to the different methods that will do the setting and do the getting and things like that. So this structure should be very familiar to you now that you've gone through the C++ course.
I hope, anyways.
Yeah.
I hope. Now, here are the different sections of this program. We have the interface declaration, obviously.
Right.
Our property declaration. Our method declaration. And the N, which belongs to the interface declaration. Right. Now, if we scrutinize this property declaration, we see that we are declaring a property by using @property.
Keyword.
And inside of those parentheses, Brian, we have property enhancers.
Right.
And those property enhancers are followed by the data type that we're using, which in this case is an NS string, and the name of the property, which is going to be called value.
Right, which is the variable.
Right. Now, Brian, let's kind of dissect what each of these property enhancers do.
Okay, so the first parameter we're passing is the assign value. So this is assign, and that's assign value, which is default, if you don't put anything in there, if you just, And then we have readable and writable, and that can be like read only or write only. In this case, it's read write. And then the setter method, because it's read write, we're going to have to implement both the setter and the getter. So the setter method is going to be setter equals, and then the name of the method that we declare later, void set value. And then the getter equals the name of the method for the getter method that we want to assign for this property.
Holy monkey, Brian, that looks very simple. Now, if we look at the implementation code, right here, we have two methods, set value, which takes in an NS string, returns a void. And when we get that val coming in from the external code, what do?
Return the value.
We retain it. And then we release our private secret value that we're storing. And then we assign that pointer to the value that we just pulled in and retained. And the get value simply returns that pointer of the secret value that we're holding within our code. Now here's the driver code.
So here we create an instance of myObject and we allocate it. So we own it. Now we create myString, point it to the myString object, and we'll allocate it with CString and just call it tests,
Why not?
And we'll print this. So we're going to print the retain count, myString retain count, and then we have the value, which is really just a pointer that we're going to interpret as a pointer value. And then same thing for myString. So in this case, you can see that they're pointing at different memory spaces.
Right, because right now, underscore value is set to nil because we never instantiated it.
Right. And so now we're going to set the object O's value to be equal to myString. So that's accessing it through the property with that dot value now that we can use.
Okay.
And because we're saying equals myString, we're calling the setter. And that will jump over to the setter method, set value, and then that calls void set value and goes to the implementation file, calls it, passes the parameter, which is what we're setting it equal to, which is myString in this case. It'll take it in as val, retain, release our internal value, and set our internal value to be val. So to retain, release our internal value, and then set our internal value to be val now that we've retained it.
Awesome. So now we have two different pointers pointing at the same instance,
right,
which is what this line represents.
Yeah.
Retain count is 2, and the memory addresses are exactly the same.
Exactly. So they're both pointing to the same place. Very cool. And now we'll just put value out to the log. And when we call that with the dot value, we're not saying this is equal to something. We're just calling it. So we're reading from it. So that's going to be the getter. So that that goes over to our getter definition for that property, and that we've assigned to the getValue method. The getValue method declaration goes to the implementation file, which returns the value pointer, and that gets logged out as test.
Whoa.
It's pretty cool. And then we release our object's value, then we release the object, and it goes to sleep, and then that gets released and deallocated, that goes away, and then we release my string, and then we drain the pool, which in this case we didn't really have anything in the pool, so.
Yeah, who cares?
But we drain it anyway.
Yeah, now this code also was not really done well because you want your class to release its internal values, but we just did that here because...
For the sake of illustration.
Yeah. So those property enhancers, well, we have a few of them. Read write, which we've talked about before, makes a property readable and writable. Read only makes it, what does read only make it?
I think it just makes it read only.
You think so? Maybe we should pull up the documentation.
Or is it write only? I don't know.
I don't know. I'm going to call my mom after this and see what she thinks. Retain will increment the retain count when you set it. Assign will assign the value without retain.
Right.
Yeah?
Mm-hmm. Yeah.
So then you're responsible for retaining it and all that stuff. A setter will specify the setter method and a getter will specify the getter method.
Cool.
And then there's also this whole concept of atomic versus non-atomic. And then there's also this whole concept of atomic versus non-atomic. Now, we could have talked about this in C++ because it relates to multi-threading, but we did not. Atomic is the default. So when I make a property and I don't specify whether it's atomic or non-atomic, it's atomic.
It's assumed.
And why? What makes something atomic?
It's explosive. It's singular. I don't know. So if something's set to be atomic, you're allowing just unregulated access to properties between multiple threads. It's obviously less resource intensive, but you can have problems where you have like partial values being returned or crashing the program because you kind of like don't always have full exclusive control of what's going on. This is really useful when you're writing applications where you don't have multi-threading and you're not worried about different threads accessing the objects at different times and trying to manage what's going on here.
Right.
So we're basically saying that it's atomic. Everything is like kind of inside of that one unit. Nothing's outside of it. You don't have a whole bunch of different things all kind of accessing it. It's contained, and that we can just kind of have an unregulated access to the properties because there's only one point in time that one point in the code is going to be accessing that memory at any point in time.
Because we're running it as a strict procedural top-down approach, right?
But if we do multi-threading, it's quite different.
Very different.
So we need to declare it as being non-atomic.
Right, because you remember, Brian, when we do multi-threading, we have multiple instances of threads running at the same time. And if these both are trying to access something at the same time, or one's deallocating it while the other one's reading from it, we can cause serious problems. Serious problems.
And terrible things will happen.
It's like you're gonna lose your property.
So by calling, by declaring it non-atomic, what that does is it'll lock the property when it's being set. So when multiple threads are all trying to like set it at the same time or access that memory space at the same time, they have to wait until that property is not locked before they can access it.
Yep, so they queue up.
Right, exactly. Yep. And what that does is it ensures that if there's all these external components that are accessing the property all at once, that the setter must complete before some other getter tries to get it.
Right.
So you don't have that happening at the same time. So when it's like half written, the other thing's pulling from, like, it would just be crazy. So just make sure that all the getter calls will get the same reference.
So we talked about synthesizing before, and Brian, no, it's not 1985, and we're not talking about like electric, blah. We're talking about synthesizing properties. So earlier we talked about the fact that properties can be synthesized. Well, synthesizing a property in Objective-C creates a setter and a getter automatically.
Magically.
Yes, it's craziness. So here's an example of how we can do this. Now, in this particular example, we have an interface declaration where we have an at property assign read write. So we're saying that we're going to assign this, which means we're not going to be updating the retain count, but we're allowing read write access.
Right.
So at the end,
and it's going to be a NS string called value.
And we are also, in the implementation code, look at this, Brian, we have synthesize value. But we don't have any getter and setter methods defined.
Nope.
So how the hell is this possibly going to work? On the right-hand side, Brian, we have an NS string that we're creating an instance of my object, and then we're making an NS string, my string, alloc init test, and then wait a second. How does that work?
Oh, it just automatically stuck it in there.
Because we synthesized it. That means getters and setters are already... So when I
Isn't that crazy?
O.value...
It just sticks it in there for you like that.
But see, since we're using assign, Brian, we're not increasing the retain count and we're not releasing it. So what I'm doing is I'm setting O.value equal to my string retain.
That's extremely important.
Yes.
Because then we're increasing that count.
Yes, and we're hoping, in this case, that the class will release that memory.
Right.
which in this case we just happen to know that because we have the class code up on the screen. So when we do the NSLog 0.value, it retrieves the value. Enough. Right. Done. Beautiful. Very, very easy. Properties in Objective-C are so cool.
Yeah.
They're so awesome.
You use them all the time.
Yeah. I think the only other language that does it better is C#.
Oh, yeah. Yeah, that's just smooth.
So now we're going to talk about protocols in Objective-C.
Oh, yeah.
Now we're going to be throwing some code at you, and we don't want to scare anybody, but we want you guys to focus on what the protocol is and how it's used in the language. Now, for those of you guys that don't know, a protocol is an abstract class. But an abstract class is basically a class that's not designed to be instantiated, and it simply contains a template for a class that can be utilized in another class that implements it.
So you can kind of think of this as the abstract class factory design pattern, sort of. Maybe not really. Maybe we'll just cut that out.
Okay.
So you can kind of, and this template can enforce how this class is inherited. So if you go to extend this class and you inherit this class and you go to modify a little bit and instantiate it, this template, this abstract class template, can require that you implement certain types of methods and say certain ones are optional, and it kind of it just sets the stage for the guidelines of how to design the class. So
exactly.
You'll see.
So Objective-C's implementation of an abstract class is a protocol, and it's pretty much declared exactly the same as an interface. But instead of using like the interface declaration, we're going to use @protocol, which declares the protocol.
Yep.
@required will specify a list of required methods, and @optional will specify optional, and N will obviously declare the end of it.
Yep.
So we're going to make an example here, and we're going to be kind of showing some code and stuff, but stay focused on what the concept is and not exactly what the code is doing. The reason why we're throwing the code in there is because we just want to kind of show like an example of how you could implement this and stuff. So let's do this, Brian.
Okay. So we start off by just making a normal interface like we typically would, and we're going to be inheriting NSObjects, and we're going to make it like a Wibit contact, W contact, and it has a couple properties in it and a dealloc. And the properties are just, read write. We got first name, last name, and phone number. No big deal. So it's like a very basic, when you instantiate one of these contacts, you can set a first, last name, and phone number.
Yep.
And that's it. No big deal. And we look, go to the implementation file for this, and we're just going to be synthesizing those properties. So it automatically sets the setters and getters for us. And we just write out init and dealloc to kind of manage, releasing those and setting them, like clearing them out when we're in init.
Now, even though it's not generally good practice to do what we did here, but this class is designed to use Autorelease NS strings because we don't actually retain the NS strings. So keep that in mind. This isn't the greatest example in the world, but it does what it does.
But so this is our base class, which is has nothing to do with protocols. It's just a basic NS object extended to be a W contact, and it's got a couple properties.
Okay.
No big deal. Okay. So now we look at our protocol.
Interesting.
So we have this, it's a separate file. We have our header, and we import wcontact.h.
.m, which is what we just looked at.
.m.
This guy right here.
Therefore .h. So we import the wcontact, and we use that @protocol keyword, and we'll call this, in this case, contact proto.
Nice.
And then we'll use that required keyword to say that these methods that we're declaring in this header are the required ones, and then the shared contact and clear ones are just optional.
Yep.
So when you extend this class, you're only required to implement the required methods that are declared in this header. So that said, there's no contact proto implementation.
Right.
Because it's just a protocol. This is all it is. There's nothing else. It's just the protocol definition. It's just the template guidelines. So we look at an example that uses this. And so now we create another interface that's extending NSObject.
Yep.
But this time
it implements
the
contact protocol.
Yeah. Which then imports the wcontact class.
Right. It just kind of like, this is the template. Now, you can Here's the interesting thing about a lot of development language. I think Java is the same way, is you can inherit multiple classes at once, but you can implement multiple protocols or multiple abstract classes at once.
Right.
So in this particular case, if you had like 5 abstract classes that you wanted to implement, it would be inside of the less than greater than a comma separated list of the protocols.
Isn't that crazy?
Yeah.
That's awesome.
That's cool.
Yeah. So, and then in this implementation of contacts, we're going to have plural. We're going to have NS mutable array, which means it's changeable array. We'll call it contact list. And then we have an init dealloc. And then we'll have a class level access method that just says add contact to. We'll pass the reference to the contact list.
Right.
And we'll give it the first name, last name, and the phone number.
Right.
Because that's all we do in the header. Because we've made a reference to that protocol, there's certain requirements in our implementation. So now we get to the implementation, and we're required. So those required methods that we set up in that protocol, we have to implement those in here.
Right. So we do init because we want to, and our class needs to initialize that NS mutable array and super init. But Brian, this add contact.
Right.
That was not in the
header.
In the header. What
Right.
the fuck, man?
I know, isn't that cool?
Oh, that came from the
Protocol.
protocol that we're implementing.
And same with delete contact and count and get contacted index. Those are all methods that were required and stated as required in the header definition from the protocol.
Nice.
Yep.
Very nice.
And then we have dealloc. And
then we have dealloc.
Yeah. So But what that does though is every type of object that extends this protocol, we now have a known, which is that they've all been required to implement these methods. So anything that inherited that, we can kind of get all nice and polymorphic with. Between them, it's much easier to kind of like...
Although inherited is the wrong term, the proper term is implements.
Yes.
Inherits when you pull in a class, implements when you pull in a protocol.
Thank you. Yep.
Yeah.
Perfect.
So,
and then this is our class level method that we declared just on the contacts interface.
Yeah, and this just adds a new contact to that list. Now, when we implement this code, we're seeing that we're creating an instance of that contacts, which then in turn implements the contact proto,
right?
Which then utilizes that contact, the W contact class to store the single contact. Think of it kind of like a struct, but not really. Contacts, which is the class W, add contact to the list, the first name, the last time. So we've added a few people to our to our contact list, and we've gone through and we've just pulled them out, printed them out, and released the object. So add your own slant to this. I mean, first, write your own clear contacts and share contacts,
absolutely.
Which were the optional methods that we chose not to implement.
So you can implement those.
Yes.
And, rewrite the contacts class how you want it to work.
Yeah.
Because surely there's better ways to do that.
And the whole point of having a protocol is so that I give you need to make these methods. I don't tell you how to make them. I just tell you that you have to make them. It's kind of like, I guess, if you're a contractor, there's like codes to building a house. Like the toilet can't be this close to the sink, but you have the freedom to do whatever you want within those guidelines, and that's kind of what the protocol provides you.
Yeah. So that way, if you implement some sort of protocol, there may be another section of code that, because you've implemented that protocol, you can pass that object then off to that, and it can use it without really knowing what that object is.
Yep.
It's a new object type that you created with whatever you want to do inside of it.
Mm-hmm.
It's a really interesting idea for managing objects and object-oriented programming.
It's also rampant in language. I mean, you look at Java, you look at C#. This concept is exploded all over the spectrum. And like Brian was saying, it creates a very polymorphic environment. So now you can just kind of sit back and relax and enjoy the fact that you are a real Objective-C programmer. Hey guys, welcome back to Programming in Objective-C with Kevin and Brian from Webit.net, and we're going to take a look at exception handling. Oh no, a little letdown. So in NSC, in Objective-C, we have a class called an NS exception.
Oh, that would have been better. Yeah, actually, I kind of would have liked that NSC instead. Yeah, NS-C instead of objects. Anyway,
inside of this NS exception, we have two common methods. I think name and reason, where name contains the name of the exception, and reason contains the reason reason for the exception. Now,
makes sense.
We've gone over exception handling in C++. So the basics, you know it. And if you haven't gone through C++, for the love of God, man, go back and do it. Yeah. We're not here to babysit you, man. You gotta follow the curriculum. So Brian, look at this, look at this code example here. Okay?
Yeah, okay, so we got here,
we have a little main program here.
Right.
And inside of this program, I have an array. And this NS array has 3 objects, 0, 1, and 3. And these are all going to be auto-release NS strings, right?
And it's immutable.
Yes. And then when I want to print this out, what I'm doing is I'm asking the user to send me a parameter, and then I'm going to send that index.
Yeah.
So in this example, the user is calling the program sending 1, which returns 1. He calls it again with 2, which returns the number 3. Now when he sends 3, there's no index at 3.
Right.
So if you look on the right-hand side, you can see that an exception was caught.
Right.
And the exception type, the name is an NS range exception, and the reason is index 3 is beyond the bounds.
Nice.
Right? You see how
cool, yeah.
You see how that kind of works? So Brian, let's start talking about how we can implement try-catch. How we can implement exception handling.
Just like you saw in C++, we have the try and the catch. In this case, we also have the finally. So we use @try to begin a block that is going to attempt executing a code. And then once we begin with the @catch, that gets us into the block where we will be receiving the exception object, and we have the opportunity to act on that circumstance. And then the @finally keyword is if the try was successfully completed and everything is done, we can go to finally. So that means like the try and the catch are both completed, everything's done, and now after the execution, we're in the finally block.
Yep, beautiful, Brian.
So let's see this in action.
So Brian, these are the 3 different components.
Right. So the first thing that we do, we have our array, just like we know.
Right.
And we'll just have like a little Boolean value to kind of like flip whether or not an error occurred, just, you know, for the fun of it.
Could you tell me, is the set value, what is that? Error equals no!
I know, it's so...
No!
It's always like uppercase and like loud and yelling at you and stuff. Yes, it's error, alright, you know. It's like, chill, man, this is a hippie language. What the At least make them lowercase.
Well, it's like try and catch and finally lowercase. Why is it boo? Error equals no!
I swear, it was like the staple, like the guy with the red stapler was the one who did the Boolean implementation.
My stapler. The swing lines, whatever.
Burn
what was his name? Milton?
Milton, yeah. Anyway. So, okay. So let's look at the try block. So first we're going to use the try keyword and then, you know, kind of lay out like a little curly brace block. And what we're going to try to do, because as you remember the last time when we tried to do this and it was out of the range, it threw an exception. It was pissed off. So let's...
Yep, the program crashed.
Let's kind of like cast a little try net around it. And, we'll say like, well, we'll try this out. Like we know it might go freak out. And, if anything goes wrong and you throw an exception, we'll catch it. And, we'll take this exception in as a parameter and we'll just call it like EX will be the pointer to the exception object. And, just so that we can see it for, you know, just for the sake of showing we can interact with it, we'll just call NSLog and pass it the name and the reason separately. Mm-hmm. And we'll also switch the flag saying an error occurred.
Wait. Yes!
So now we go into the finally keyword block. And so that means the try or the catch finished. Like whatever we were trying to do, whatever was going on back there with the crazy kids, the try catch kids, they're done with what they're doing. So finally, we get into this block. So then we say like, if an error occurred, then we'll say like we caught an exception. Otherwise we'll say no exception detected.
Yeah.
And then, but what's great about this is this never like kicked us out of the code.
Right.
We're still now going down to release the pool, clean up our memory, wipe our ass, and return 0. Yeah. So what that prevents from happening is the code just like crooking out and exiting. We can take some sort of mitigative action.
Right. But also, Brian, for those that don't know, finally is not required. It's optional.
Right. Absolutely. Yeah. Absolutely. You don't have to do anything finally. You can just
do try catch and that's that. Yeah.
What you never want to do, ever, in any language, is use empty catch blocks. If I ever see that, I will...
I've done it before.
I will stab your mouse with a spoon. I don't know.
I've done it before. Not gonna lie.
Terrible. Oh.
Your face is terrible.
I can't tell you how many times I've just like going through somebody else's code. What the hell is going on?
It depends.
I'm like what the? I swear to God, like I'm trying to get this, and then I start looking through it, and I'm like, oh, there's an empty catch block. Oh, that's awesome. Great. Thanks. Bad things. Terrible things happen. Okay, so what the hell happens when we call this now? Okay, so what the hell happens when we call this now? So we have, we'll call it and we'll call 0. And 0 is perfectly within the array, it's bounds. So no exception was detected. It was perfectly fine. We tried it. We succeeded. We went to finally. The error was never flipped. Beautiful. Awesome. Then we call 1. 1 returns 1. Everything's fine. And then we call 2. Everything is also fine. That all is able to print it. Everything's successful. Everything's fine. And because of the error never being tripped, no exceptions were detected. Now, in the case where we call 3 now, that will fire that NSRange exception. So that exception object comes into the finally block. And because that Boolean was set to yes, we print out that we caught an exception, and in the catch block, before we printed that out, we put to the NSLog the name and the reason of the exception.
So we can also raise exceptions, Brian. Similar to in C++, we would throw an exception.
It's a little more Necromancer in Objective-C,
yeah,
so we just kind of erase them.
You can create an exception manually based on a specific situation in your program. An NSException allows programmers to create custom instances containing customized information about your specific exception.
Yes.
Now, if I were to do something like this, Brian, we're making a numerator, denominator, real number class here that are non-atomic. Those are read, write. That's read only. There's a getter. Blah, 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 blah.
I'm listening. Yep.
Crazy stuff. Well, Brian, if you look at this real number, right? There's a real number setter and getter. If we go to, there's a real number
property
getter. Yeah, property, right?
Okay, yeah.
Now, if you look at this code, Brian, that there is inherent danger in dividing by 0.
Yeah,
right?
that's true. Yep.
Because mathematically, that's not possible.
And it just freaks out.
You start falling into imagination land at that point, right? So what we want to do,
you have to make a distinction because you can't just say it's 0.
Yeah.
You have to distinguish the fact that you're
right.
Whatever.
So in this case, Brian, we're checking to see if denominator equals 0, NSException, throw this, equals NSException, and then we're calling the exception with name method.
Right.
The name is called real number exception.
Nice.
And the reason is denominator cannot be null, and the user info we're just passing as nil, and that's very, very common. And then we do the @throw, which then throws that exception.
Yeah, isn't that cool? So that'll bubble it back up. So when you call that @throw keyword, if any of this is happening instead of a try block, it'll jump over to catch.
Yeah, absolutely. And this gets thrown up. You're right. Yeah. Exactly. It's pretty awesome.
I tried to eat it, but and then I'll catch it. I don't know. Maybe not. Anyway, so let's see what happens. So in the driver side, here's our main function, and we kind of create a alloc init, a real number, and we set through the property the numerator to 1 and the denominator to 0, which, as we know, is the danger situation.
Yeah.
So we'll try to print out that real number's float value. We'll try to do that, but what will happen is we'll go back to that code we just showed you where it says if the denominator is 0, then throw the exception. Mm-hmm. So that'll get thrown, and we'll catch it like baseball, I guess. I don't know, or like cricket.
No, that's what it is.
Yeah.
Well, cricket. Sorry for those of you guys in India, but cricket's not really a sport. That's it's like croquet, sort of. I'm gonna get my ass kicked.
I know, right? So then we catch the.
I'm more of a ballet man myself,
Nice, right?
A real sport,
It always whenever I see cricket, it's kind of like they watch too much Dazed and Confused, the movie.
What?
Where they're running around with the paddles.
Oh, right.
I don't know.
No more, Mr. Nice Guy.
Yeah, exactly. Yeah. Anyway, so we catch the exception object, and then we act on it. In this case, we just do NSLog, and you can see that print out. So it's pretty straightforward. So when we throw, that will be caught by the catch block, and then we can do something with it. And we could have also put finally on there, but we chose not to. It's optional. We don't have to.
Yeah. So there's also a couple of ways that we can throw an exception. The first case you saw there, the real number exception, which is what we implemented just a moment ago.
Right.
We can one that we did, Brian, called a class level, which returned an Autorelease, right? So we're not calling alloc, right? Mm-hmm. This next one, we can call alloc and init with name,
right?
Instead of exception with name, and that's going to be the same parameters. But this should be released because you just created memory space.
That's true.
You can also just do an NSException, and instead of calling an exception, to set one, we can then just call raise
an object and everything,
right?
Yeah.
So NSException, just raise it, and then and then the format, same thing,
which is awesome. That's way better,
right? And then we could also do the format.
With a format string.
With a format string, and we could say the denominator cannot be, and then...
That's my favorite.
That's my favorite, too. Pretty sexy. Pretty sexy.
Thanks for watching.
Yeah.
Adios. See you in the next one.
Do svidaniya. That's Russian for goodbye. So, before, in the introduction to object-oriented programming, we introduced you to this concept of reflection. Reflection for men.
It sounds like a perfume.
It certainly does.
Like Bieber, like he has a perfume now.
Who?
Justin Bieber.
So reflection is not looking at yourself in the mirror, Brian. Actually, it kind of sort of is. See, yeah. Damn, we got Michael Jackson up just now. See, look at Whippet the Frog in there looking at us all scared. Although he is aware that he's inside of a box, that a Rubik's Cube is inside of.
He's like, what the f***?
He's also aware that he's stuck in the grass. So he's aware of his, and he's pretty frightened to be there because he's like, have you ever been somewhere with a giant Rubik's Cube?
He's kind of small, isn't he? He's like a little tiny frog, huh?
That's a big, he's normal sized frog. That's just huge grass. That's like Beetlejuice when they're inside the model, you know? It's like everything was like exaggerated.
Or, Honey, I Shrunk the Kids.
Oh, that's even better because like the grasshoppers were like the sides of houses.
That was creepy.
I like that movie.
Yeah.
Anyways, what the f*** are we talking about?
Oh, reflection.
Oh, okay.
Yeah, that totally I don't know. Anyway, whatever. So if you remember back to the object-oriented course, we mentioned reflection. And if you didn't go back and watch it, do it right now.
Yes. And the great thing is that might cause an infinite loop because every time you get to this, you'll go back, and you'll go back, then you'll go back.
Well, but we did put the if not condition in there.
Nice. We took care of this, man. Right?
So, and just to like jog your memory, that was the case where it was like, can you add two numbers? No. Can you add two numbers? Yeah. Okay, awesome. Add these numbers. Thanks. Here you go. Here's the two numbers you wanted.
Right.
Basically. Mm-hmm. Anyway. So you should know that. Go back, review. We're not going to explain it again.
So let's get to know our runtime environment.
All right.
With reflection, we can interact with the runtime itself.
Yeah.
We can see our ecosystem and dynamically interact with instances and objects that are inside our little bubble.
Very cool. So here's some NS functions for interacting with our runtime environment. So for example, we have like NS class from string, where we give it a string and it gives us, at least tries to look for the class based on the string name we give it. NS string from class, do the opposite. NS string from a selector, NS selector from string, NS string from a protocol, and a NS protocol from a string. So this basically deals with classes, selectors, and protocols.
Now, we have not discussed the selector concept, but we will discuss it here in just a minute. But the rest of these, you know what a class is. It's an interface. You know what a protocol is.
Abstract class.
Yes, right. So when we start to let's take a look at this first one, Brian. Now, Objective-C has a data type called class, and really it's not a data type, but it's like a data type that like acts like a data type, right? So
it's like a non-class type or something.
Yeah.
I don't know.
So it's like a data type that's a placeholder.
It's gross is what it is.
Yeah. So if you take a look at this example, here, we have a class instance of my NS string equals an NS class from string. Don't worry about this too much. We're going to go over this in just a second, but that makes a placeholder for an NS string. So now if I want to make an NS string, I can do ID str equals my NS string Alec, because my NS string is like a label for NS string.
Yeah, now it is.
So just like get that concept before we move forward, understand that concept. Class just replaces an instance of a class, replaces another class name. That's really all that it is. And if a class is not available, so if we were to do the NS class from string and we were to do butt cheese, and that class wasn't available, well then class would equal nil, and then you can handle that instance during the runtime flow of the program.
Right.
So here, Brian, here's an example of using this code in a sort of, kind of, but not really practical way.
So here we start off with class, my class is nil, and then we say if we got an argument, if our arg count is greater than 1, then what we'll do is we'll call getClass, the getClass function, which we'll see down below, and we'll pass it the argument vector 1, which is the parameter we pass in from the command line or the terminal console line or whatever the hell you want to call it. And then all we're going to do is we're just going to print out the string of the class we asked for, and then the memory location for my class, and then we'll just drain the pool. No big deal.
But if you look at the class declaration below, or the function declaration below, this creates a class instance called return class, and it stores the value of NS class from string set to class name. Now, the reason why Brian and I set this example up this way is look at this function, Brian. Without the context, that function has no idea what class is coming in.
Nor does it care.
Right. So remember before, right? When we had the bubble that asked the frog, I need an instance of a fly. That's exactly what this is. It's going to go in its little repository. And let's just say that little bubble asked the frog for an instance of a cheeseburger. Well, I don't have a cheeseburger. So then my class, return class will equal nil, and I can throw an exception. This is an unknown class.
Right. Can't do that.
Yes. But if I'm successful, I can return that back, and then I can just tell the user where in memory that class template resides.
Isn't that awesome?
Very, very nice.
So this is like a very reflective way of making an NS string.
Yeah, right.
Yeah, it's really cool, huh?
Yeah. So when we execute this program, Brian, we do reflection test, and I pass an NS string. NS string is located in memory at
right, and that's the instance.
Well,
cool?
that's the class. That's like the
right.
But then if I do an NS array, I get okay, that worked. But the NS array declaration is somewhere else in memory, naturally. Right? But now if I do an NS missing object,
nice.
I'm going to get an exception.
Clearly, it's not defined. Yeah.
So you can see that the program crashed.
Or didn't crash. It just threw an exception, I guess.
Well, throwing an exception crash. I mean, it aborts.
Yeah.
It's a crash.
All right, fair enough.
The name is an unknown class, and the reason is unable to locate class NS missing object.
Yeah, isn't that awesome?
Not bad.
Very cool. Now we're going to do the opposite. So this is the NS class from string. Oh, no, wait, hold on. That is the same thing. String from NS class. Ignore that. So this example allowed instances to be created without knowing if the type existed at compile time.
Exactly.
So we don't have to like presuppose all of the classes all the time. We can kind of like test the waters and then act if we think it's safe.
Right. So when you compile this, it can't tell you that this class does not exist because it has no idea what the class is.
And we're literally interacting with the runtime state of the program and allocating based on whether or not we have the that class available to us.
Yep. At that specific moment in time. Love it.
Yep.
I love it.
Now we have NS string from class. And what that does is it takes in a class instance of some type, and it declares this as class type, just an unknown class. And it will return an NS string containing the name of the class. Mm-hmm. So it kind of does exactly the opposite. So in this example, we have class my class, and we say NS class from string, passing the parameter, and then we'll create a new NS string object, and we'll call it class name.
Yeah.
And in this case, we'll say NS string from class. So assuming that the NS class from string was successful and we passed in a valid class, this will give us back the name. So you can say your class NS string or whatever you passed in, NS number, is located at and in the memory space. Isn't that awesome?
Very nice.
Yeah. So here in this case, we pass it NS string, and your NS string class is located at this memory space.
Nice. So Brian, the concept of a selector. Now, a selector is what you guys may remember from C++ as a method pointer. Right? So a selector kind of does that, although in effect it doesn't point to a specific method, but it encapsulates a method. So I can say that this cell, the data type is SEL, and we define a selector by doing @selector, and then within parentheses, then we define the template of the selector or method. So in the first example, we're encapsulating inside of a selector a method that takes no parameters. Mm-hmm. The next one, we have one that takes a single parameter.
Right.
And the last one, we have a method called method that takes in a parameter, and then it has a label text that takes in a second parameter.
Right. So what this is kind of doing is it's sort of saying, like, we want to talk about a method, but we don't actually want to execute it. We're just going to be, like, selecting a reference to that method, Right. We're talking about a method. We're not actually executing a method.
And the method does not have to exist for you to do this.
Right. And so here we have NS string from selector, and what that does is it takes in a selector instance, and it will return an NS string containing the name of that selector. So just like the NS string from class, this is NS string from selector. So let's take a look at an example of this. So here's we have a math class or interface math, which comes from NSObjects, and we have a instance level method which is add integer, and then we will just implement it right away and just x plus y.
But keep in mind, Brian, this is add integer, take in parameter to integer.
Yes.
Second parameter.
Very important.
Very important.
Yes. So this is, right, exactly. So in the driver section, we can see that we instantiated a selector called addSelector, and it's of type SEL, and that's going to be equal to the selector keyword making reference to the add integer to integer method.
Right. It's not making reference to a specific one, but it's just like wrapping up.
Right.
I want a method called add integer that takes in a parameter that has a label text called to integer that takes in another parameter.
Exactly. Yep. Right. So there's no reference, as you'll notice, to that math class.
Absolutely.
We're just generally talking about a reference to that particular method name and label. So now we're going to create a class. We'll say an NS class from string, and we'll take in the parameter, and now we have that as class. And if so long as that class is not null, we can
No. As long as it's not nil, Brian, don't say
all
null.
Right, yeah.
What language do you think
No,
this
I hate
is?
nil.
I hate it so much. Let's just call it null. You know what we should do? We should just do it. Define null as nil.
Yes, exactly.
That's what we should do.
So in this case, we're going to save the class name and then the selector name. And so the class name is going to be stored as the NS string from class. And we'll just pass it that class instance that we instantiated from
the NS class from string.
Right, exactly.
Nice. I'm paying attention.
And then the selector name, which is just, the string of the selector name, is going to be the NS string from selector, and we're going to be referring back to that add selector that we created in the beginning. And then we'll say ID, which is like some sort of NS object of unknown type, class instance, and we'll alloc init it.
Holy crap.
Yeah.
We're taking class and alloc initting it, so we don't know what the class is
Right,
at compile
it's unknown.
time. I love it.
It's very cool.
This is nice.
It's like reminiscence of like templates and generics and stuff. It's very cool. So if that, now this is really interesting. So now we say if the class instance that we just instantiated, the one that we just called alloc init, right? If it responds to selector.
Yes. I love it.
If we test for the add selector, which is, if you remember up above, is the add integer to integer. If we test it and it says that it can do that, then we will call it and we'll print out the result of calling the, the class C string, the selector name C string.
Well, we're actually just going to say whether it responds.
Oh, yeah, right. Okay, perfect example, I'm assuming.
Now, remember, in the introduction to object-oriented programming, we had an example where the frog had to add numbers.
Right.
And the frog asked the chick, who was talking about French fries or some crap, and she was like, "No, I don't know how to add two numbers." Well, then that's that.
Right.
If the else condition would be the chick. Now, when he goes to the fly and the fry says, "Yes, I can,"
right?
So that's that runtime component where a task is assigned to you, and I'm taking a specific instance and I'm testing it to see what it can do.
Right. So if the argument that we pass is math, it will respond to the selector. Now, if instead we pass NSString, obviously NSString never implemented like add numbers.
Yep.
With the label, with number, add number with number.
So NSString is the chick.
Right. So NSString does not respond to the selector add integer to integer.
Yep.
But if instead we call math, which is the class name that we implemented above with the method that it does respond to, it'll say, obviously math responds to selector add integer to integer, and we can actually call that.
Yep. Yeah. So in this example, we're calling the selector from string. So this will allow us to pass in a NS string and it will return us a selector. So in this particular example, we have a class instance that we're pulling in from the parameter, from the command line parameters. Then we have a selector, a cell we're calling a selector, equals NS string from selector. And this is taking in the second parameter that comes in from the command line. Now we're making an instance of ID, which is the generic NSObject type called class instance. This still cracks me up every time. We're doing the class alloc init, so
That's awesome.
The program has no idea what the class is going to be when you compile it. That's complete runtime.
It's awesome.
It's so cool. So when we create an instance of class blah, and then if the class responds to the selector that you have typed in with text, mind you, from the command line, if it responds to that, we'll just say responds and then release the class instance.
Isn't that awesome?
And here's an example, Brian.
Okay.
If we run this and we do NS string, which is the name of the class,
Nice.
and C string, which is the name of the method, which is encapsulated in the selector, it responds.
That's at runtime.
That's a runtime. It has no idea about NS string when we compile that. So cool. Gotta love it.
So we also have NS string from protocol, and big surprise, surprise, it will give you the string name, NS string name of a protocol that you pass, reference the protocol.
Yeah.
And NS protocol from string works the same. The NS class is the NS class functions. So we don't need to waste your time on this. You obviously get the idea.
Yeah.
It functions exactly the same, but with protocol. So boom, there you go. There you have it. It's
Reflections in a nutshell.
Yeah.
How did I get in this nutshell? How did I get in this Rubik's Cube?
Hey, buddy.
Hey, buddy.
Welcome to Delegates. We're going to talk about delegates in Objective-C, which is kind of like talking about fingers on people. It's an inseparable concept of, okay, well, maybe you can cut fingers off people, but, and some people are born with like little stubbies and stuff.
Well, it's like a mountain range, maybe. It's something that doesn't go, no, mountain range, a road.
Anyway.
It's like Olympus Mons on Mars, right? The largest volcano in the solar system. There we go, right?
Right.
Okay.
So delegates are an extremely important concept in Objective-C that's like, it's with everything in it, So you need to know this. And what we would emphatically and enthusiastically recommend is, if you haven't, go back to the Intro to Object-Oriented series and watch the video on delegates. I think it's a very good and clear way to explain delegates.
Yep.
And it's well worth going back and just kind of drilling in the concept before we really get into how it's implemented in Objective-C. And that's why we put that out there for you.
Yeah.
You know, so that you can kind of like base up before your party.
And for those of you guys that decided to skip C++, you did not do yourself a favor, because we're going to make the assumption that you've seen that material.
No, and C++ is awesome.
Yeah,
like, it's
right.
a really cool language. Like, seriously, if you go back and learn it, you'd be like, this language is f***ing awesome.
All right, Brian, let's kick this, all right? So a delegate, right? There's basically two parts to a delegate, which we know there's an instance and a method. And in Objective-C, we're going to encapsulate that method as a selector.
Right, because we're going to be referring to the method.
Precisely. Now, the delegate example here, we have my class. I'm going to send my delegate to you, and now my delegate points to you. So when I execute the function inside of my class, I'm actually executing it within the context of delegate class. That's the only review that you folks are going to get.
Okay, moving on. You should know that.
All right, Brian.
Okay, so let's. So here we're defining out in the delegate class header like a really basic class. We're just going to call it delegate class, and it's inheriting the NS object. We're going to have one method, like no init, alloc, anything, no whatever. Just, hey buddy, it's an instance level method, and all it's going to do is just call printf, hey buddy.
Hey buddy.
That's it. Nothing major. Just to kind of like, just because we just want some class, we don't really get bogged down in that.
And now we're going to have myClass.h. Now, if we go back to our little review here, myClass.h is this little guy here on the left. That's going to have a delegate that's going to call the code within the context of delegate class.
Right.
So we're going to create my class and then inherit from NSObject. In our private fields, Brian, we're going to have an ID sender.
Okay.
Now, ID means
we don't know.
Object. I don't give a flying shit what it is.
Right.
Just this is the object. And then a selector.
Right. Isn't that cool?
So wait a second. We instantaneously have a pointer to the object and a selector to the method within
That's
the
all we
object
need.
that we're going to call.
Like, this is pretty clean.
This is very nice. So then when the initialization method for this class, Brian, is going to be init with sender. The first parameter is going to be
of type
the
ID.
Sender.
Who knows what the type is?
The sender is going to be the instance of the class, and selector is going to be the selector that we're going to call inside of that class.
Cool.
Holy
and then we have delegate method. And
is that spelled wrong?
That doesn't matter.
Delegate.
Yeah, let's see. All right. Hold on, we got to fix that. Okay.
Wow, Brian.
Ta-da!
You and your snappy fingers.
I know.
You fix all problems.
So, I'm just so amazed at the magic, I just kind of lost my train of thought.
So that delegate method is going to represent, it doesn't really have to have an ID. It probably should be void. Can you fix that too?
Are you sure?
Snap.
We'll just...
And that method is going to execute the delegate inside of delegate class, which you can see on the right, Brian. Explain yourself.
So if you look at the implementation, we have init with sender, and that takes the sender and the selector, and we'll call super init on self, so the inheritance tree all initializes properly, and then we'll make a reference to the sender and ourself, and we'll say retain, so that while we're doing this, we'll release it in dealloc if you look down below, and then we'll also set the selector to be the selector that we take in, and then we'll just return self. And that's our init with our sender.
And we're gonna retain that value, Brian, because we don't own it, number one.
Right.
And we plan on keeping it for an extended period of time.
Exactly. Yep. And we'll clean up. And then we implement our delegate method. So our delegate method, what that's going to do is it's going to, actually, I should pronunciate that differently. Now we're going to implement our delegate method. It's not the delegate method, it's the delegate method.
Nice.
So we're saying we want to now delegate that method off. So if the sender that we initialized with responds to the selector, so if the selector is making a reference to some label of method that sender knows how to interact with, because we do want to test for that. Reflection. Right. Then we'll ask the sender to perform that selector of the selector that we passed in. And that delegates off the method.
Now, Brian, I was just kind of goofing on that, but we talked about reflection before. That is a pure runtime implementation right there.
Right.
Not only are we checking to see if it responds, but then we actually perform this selector against this instance.
It's crazy.
That's beautiful.
It is. And that comes with NSObjects. That's why NSObjects are pretty cool.
Yeah, it's pretty awesome. Reflection.
So here we create an instance of the delegate class. And if you remember in the delegate class, we implemented just one method, the instance level method of HeyBuddy, and we alloc init it. So now we have that object instance D. And so now we create a selector we'll call delegate. And that selector is going to make a reference to HeyBuddy.
Which is any method called Hey, doesn't have to be this one.
Right.
Any method called HeyBuddy that takes no parameters.
Exactly.
Right.
So it's not pointing at that instances method. It's pointing at the idea.
Right.
Which this instance happens to have, fortunately, of HeyBuddy.
And the interesting thing here, Brian, when you compare this to how C++ implements this, C++ requires you to scope into a specific class to identify a method.
Right.
This says any class type, anything
it's abstract,
can have this type of method.
Oh,
That's that. That's beautiful.
It is. So so here we create my class, whatever an instance M class, and we alloc, and then we init with sender, which we talked about a minute ago, and we're going to init with sender D, which is our delegate class, and selector delegate, which is HeyBuddy. And now, because as you follow this arrow up, we know that that instance has the ability to respond to the selector delegate in this case.
Right.
And so we set that up, and then here we init with sender, and we kind of like tie all this together now. So the object D points then to the internal ID sender, and that's going to retain. And then the selector gets stored as that delegate that we get passed, what we're calling, which is just a selector we're calling delegate, and that gets stored in our internal selector. So now we're kind of like all prepped and ready to go. We're all wired up and like set, right? So now that we're all set up, we're going to call the delegate method request, and if that sender responds to the selector. So if the sender, which is the instance D, responds to selector HeyBuddy, which it does have the method HeyBuddy in exactly the same label type, so this is all valid, then check, we're okay. So now we know we can perform the selector. And when that performs the selector, that goes off and calls HeyBuddy in the instance D.
Yep.
And
inside the context of the delegate class instance.
Isn't that awesome? So that goes off and says like, hey, print HeyBuddy, and HeyBuddy!
HeyBuddy!
Isn't that crazy?
That's beautiful,
yeah,
Brian.
it is. So it's as you'll now know from going through C and C++, this is a pretty smooth and clean, it's actually an extremely smooth and clean, kind of like well-baked implementation of delegates.
Yeah, very, very nice. So remember, Brian, we made a delegate class in C++ that encapsulated a delegate, and then we used that to send it off to a thread,
right.
the timer.
Yeah.
Well, we can do the same thing in Objective-C if we want to. So let's create an interface or class here called delegate that inherits from NSObject, and we'll just have the ID sender and selector as private. And then we're going to have an init method, init with sender, and selector, run delegate with a parameter, and run delegate with two parameters, and then a dealloc. So inside of the implementation file, the init with sender is going to just do the same thing that the other one did.
Right.
The first thing that we're going to do, though, is we're going to check ahead of time, Brian. If I'm going to make a delegate,
like right off the bat, as soon as we go to init,
does it respond to the selector?
Right.
If it does not, what are we going to do? We're going to raise an NS exception, so you have to try catch this. If you're sending me shit that's not going to fucking work, you. Okay? So, I don't want you to run. So then we can do a super init, self, retain, and then store the selector locally, and then return self.
Yeah.
Then when we run the delegate, it's going to run perform selector with sender, perform selector, and then the selector.
Right. And because when we init, it didn't raise an exception, now we're able to just kind of assume the best now when we go to run the delegate.
Well, we know it's going to work at this point. Right.
Cool.
So then we have the run delegate with the parameter. Now we're taking that in as an ID so that you can send me whatever you want. And then we can also call another extension or overload, if you want to call it this, of the perform selector method. So we do sender, perform selector, on selector, with object, and then the param. And that with object is kind of like a repeatable thing. So like here we have one where we have two parameters. So sender, perform selector, on the selector, with object param 1, with object param 2. And then dealloc will just release the sender, and then super dealloc.
Cool.
Not bad.
So here's a class that, we'll just use as an example. So we'll call this my class, and that imports a real number. And all this is basically going to do is we'll implement like print HeyBuddy, we'll print text, and we'll take in a parameter of some string, and then get a fraction between two integers. Just to kind of show as an example. So in our implementation, all we're going to say is call the self print text, and we'll pass it HeyBuddy, and then print text is just going to print whatever comes in the parameter as an NS string. Perfectly fine. And then when we implement get fraction, we'll take in the two parameters n and d, and we'll just kind of init with numerator and denominator and return an auto-release version of that real number object. So pretty straightforward. So this is just kind of like some example class that we can kind of use to show you an example of delegation.
So we're going to create an instance of Autorelease pool to manage our Autorelease objects. And now we're going to make an instance of my class called my class instance. So we're going to run alloc. Now we're going to have an array of delegate pointer. So we're doing it C style, baby. So we're going to do the my delegate of size 3. Now let's do some try catch blocks here.
Nice.
So delegate sub-0. My delegate sub-0 is going to be delegate class, which we've instantiated, alloc, init with sender, my class, and selector, and then we're making a selector called print hey buddy, which we know exists. Now, we're doing a second one, where we're doing the same thing, except for running the selector print text that takes a parameter. Then the next one, we're doing a get fraction that takes 2 parameters. So as you recall, Brian, if I slip back a slide, that init with numerator, that get fraction doesn't have a label text between the parameters. Now, an Objective-C person will say that is, I can imagine a circumstance where you will do that. But just to show you that you can do it, here we have get fraction : : which means it takes a parameter with no label text and it takes another parameter.
Pretty funny,
So if any of those do not exist, we raise the NS exception, give you the name, give you the reason, and return. So we're going to execute the delegate from sub-0 by saying run delegate, then do the same thing from sub-1, passing it a parameter because this one needs to have a parameter. And remember, we did the overload that will accept the parameter. And then the real number, num, equals run the delegate with 1:10, which will return 1/10, and then prints the float value.
Nice.
It's kind of cool.
Yeah, I like it.
So here's the output, Brian. So when we do the hey buddy, it just prints hey buddy. When we do the print this text, it will print this text. Now, again, this happens within the context of that class because this is being sent as a delegate.
And the important thing is that it actually functioned.
Yeah.
You know? Like, it did go off to those other classes and call those methods on those other classes.
Yeah, beautiful.
It's very cool. As you start exploring Objective-C, and as you start kind of like working with the different types of NS objects and the different types of things here and there, you're going to start to see this like all over the place, especially once you get into the Cocoa stuff and in the iPhone stuff. Like, you'll see this all over the place. So it's a very essential concept. Mm-hmm. And we are handedly putting this into the intro to Objective-C territory. I mean, this isn't advanced for Objective-C. This is kind of like par for the course. So,
but I think that the one thing that's kind of interesting to note about introduction to Objective-C is you do need to have a strong understanding of the concepts already.
Right.
So you need to be a C programmer. You need to have object-oriented understanding and C++ basic understanding. Then you can follow the introduction to Objective-C. So don't buy the sales pitch when they say this language is easy for beginners because it's actually quite not. Multithreading, Brian.
All right, let's do it.
So we're going to talk about multithreading in the Objective-C language. So in Objective-C, we are given an object called NSThread, which contains a couple of methods.
Very nice.
Init with target, and then that's the instance we're working with. Selector, the selector we're working with. An object, which is a parameter we pass. Cancel is canceled, is executing, is finished, name, set name, start. You can pretty much figure out what those do from the names. It's not rocket science here.
And so this object is what we're going to be using to create a thread that we can kind of call start on that will kick off that threaded method.
Yep.
It's very nice.
Exactly. So if we take a look at this code example here, we can break this apart in these two chunks. We have a class called test class that we've implemented up here, and then we have a main function below. And inside of this main function, we're going to create an instance of the test class using alloc and then calling init.
Right.
Then we're going to create an instance of the NS thread using alloc. Then we're going to call the init with target method, passing the instance that the thread method is inside of.
Right.
And then the selector, which is the method that we want to execute.
Cool.
Right.
And if you remember back, the selector is taking in the idea of the name of the method that we're looking for. Mm-hmm. And that selector is going to kind of just make a reference by it like that. So this init with target will go out to that class instance and kind of see if it responds to that selector.
Right. Just like we did with the delegates.
Exactly. Yeah. To see if we can thread it off and call off and start that thread.
And since this particular method takes no arguments, our object, which would be our parameters, will just be nil.
Right.
So now that we've instantiated this, we can run start inside of the thread, which will then in turn run that thread test method inside of the test class, which you can see that it runs, hey, I'm a thread and I'm running.
Right. So if you look at the implementation of that method, that thread test method, it'll print out like I'm running, and then it'll sleep for 3 seconds.
Yep. Well,
and then I'll say, and so, and then now it's time for me to die. Goodbye.
Yeah.
So what happens is, while that's happening, that thread object has a internal, like let's say a Boolean value.
Yep.
That's set to yes while this is executing.
I'm sorry. A Boolean value! Sorry.
So when that happens, this is executing property will kind of like tell you whether or not something's firing. While that thread is executing, we're just going to kind of like sit and chill.
Yep.
And as soon as it's done and it's dead, then we're going to continue on our way as if the thread is all like finished, and then we'll release our class and drain the pool.
We did almost the exact same thing in C++, so you guys should hopefully be accustomed to this by now.
Yeah.
So just to kind of finish this up, we're going to release, we're going to drain. Now, Brian, here's a modification of that last example.
Mm-hmm. So here, if you look at the test class, in the test thread method, we now are also passing in a parameter as an NS number of the number of seconds that we want to wait for. And if you look at the implementation of that method, whereas before we just had like sleep 3, now in this case we're going to sleep the seconds NS number object, and we're going to call integer value to get the integer value back and pass it into sleep. So then we're going to kind of say like, okay, it's been whatever number of seconds, and then now it's time for me to die goodbye. So just to kind of show that it's not like a fixed thing. So we create our pool, we create our test class, and we create our thread. And when we create our thread, we're also going to pass it, now this time, we pass it the target, the class instance, the selector, the test thread, the name of the method, and then the object parameter now, we're going to pass in this NS number thread lifespan. And we're going to create that number, or instantiate that with the number with integer class level method in the parameter 5. So it'll give it 5 seconds to sleep.
Yep.
Everything else works the same. So we call my thread start, it starts a thread, and while that thread's executing, it says, hey, I'm a thread and I'm running. Okay, it's been 5 seconds now. I'm going to die. Goodbye.
See you later, dude.
So this is a nice, clean, smooth implementation of threads. And take a look at the developer documentation on the NS thread objects, and it's pretty good. It's pretty robust.
Yeah, I mean, it's very basic. It's very simple, very seamless. It's even easier than the thread concept in C++.
That's true.
So it was put together quite well.
And with most things next step, the difficult concepts are made very easy, and the easy concepts are made very difficult. So thanks for watching.
And we will discuss those next. Coming up next on One Rivet to Live. Wait, what?
I don't know.
No.
One frog to step on.
One frog to step on.
Yes.
Is that really the name of like a soap opera?
Okay.
Hey!
So we've spent a lot of time talking about the Objective-C language, but in everything in Objective-C we've been dealing with like NSObjects and all that kind of stuff. Mm-hmm. We haven't really got that far into Cocoa. We haven't really kind of like talked about developing an application for Apple devices.
Right.
And the reason we haven't is, it's a little tricky to kind of tell you right off the bat. So we kind of had to set up all of these concepts of the Objective-C language before we jump into this. So now we're going to give you kind of an intro to looking into the Apple universe.
Universe.
So now you might be saying like, okay, I get the language, but these Apple apps are crazy and the developers are mean. Like, what the f gives, Well, like, I think that the type of people that tend to be self-motivated that will drive through the Apple documentation, like, are kind of socially awkward in the first place, and they're not very sympathetic. So, like, if you ask them, like,
I did it, why can't you?
You're right, exactly. Yeah. So, like, so when you ask them something like, well, I had a subclass of my UI view, and I tried to implement, like, the draw rect method, like, and it's not working, what the hell? They're like, well, that's because you implemented it on the wrong class, Read
the documentation.
Right, go refer to the documentation. It's the view controller, but you might not know what the view controller is, or like what the difference between the view controller and the view is.
Right.
Exactly. You're just like, I just want to see like the path to draw something on a view.
You see the same question on a C# forum, and you don't get that response.
Right.
At all.
You get like, yeah, exactly.
Here's my complete story. Actually, go to SourceForge, here's this project, and then go to
check it out.
the code project, and there's this.
Yeah.
Yeah.
So part of the problem in learning stuff for Apple is kind of twofold or more. The entire infrastructure.
To the power of 24.
So the entire infrastructure is kind of built on like this spin on the Gang of Fours design pattern, like their own kind of take on it. And because of that, these aren't like simple, straightforward concepts. So you kind of have to go through all of the like object-oriented knowledge. Like you have to understand those concepts like inside and out. You know, you have to understand like abstract class factories and
to an
blah, blah, blah.
explicit detail.
Yeah, exactly.
Yeah.
So that's like that immediately creates like a fairly advanced requirement of the understanding to even like interact with their objects, right? Also, like the documentation is great and it's extremely detailed and it's extremely extensive, but it is a bitch to read.
Yeah.
Like you have to block out days and just sit there while your eyes are bleeding reading through this shit. It's crazy. It should probably be like a little more. I don't want to get into that. The documentation organization is kind of like cumbersome and whatever. But then again, they don't want to like hold hands and they might want to weed people out. I don't know.
Yeah, but then there's also the whole thing about the explanations are built on top of concepts that have no references.
Right, exactly.
And that's really obnoxious. Yeah.
But that happens in schools. That happens in a lot of places too. But especially in their documentation. So what they'll say is like, they'll tell you to do something or they say, oh, the way you do this is to just like, you know, extend this and do this to the subclass. But if you don't know how to extend something, then you gotta like find that in the documentation somewhere else. And that's like a more basic language concept and not like a developing an Apple concept. It gets like really messy, you know?
Yeah.
So that's why we really wanted to like walk you through this process of like, you know, getting your foundation of the language really solid, getting your familiarity with the NSObject structure and a lot of NSObjects.
And the programming concepts like the delegation, that kind of stuff, right? So to be honest, the concepts are kind of difficult to explain in like plain English or plain Hindi or whatever language that you speak.
and that's something that usually like we're really good at. Like that's kind of our natural talent, I think, is our ability to communicate very complicated things in plain English.
Right. I pride. Well, that's why we have a whole fucking website dedicated to that.
That is kind of our skill.
That's what we do. So if you get through this, do us a favor, guys. Please, for the love of whatever deity you believe in, help this Apple community. Get involved. Be nice to people. When someone has a question, help them. Maybe give them a piece of source code or something.
If you're reading a forum and you see that the answer wasn't solved and you want to know it, all you have to do, it's really easy, just bookmark the page.
Yep.
Or like put it in like a to-do list or something so that if you later look through that to-do list and you're like, oh yeah, I know how to do that, tell them, please.
And if you see those smart-ass comments, why don't you respond with your own smart-ass comments? Because I want those people to just be shoved out. I hate these folks,
it's ridiculous. They're ruining the Apple development community.
Well, I think that what it does is it stains the development community in general because the development community is supposed to be an open educational forum. Like
it's not like exclusive and asshole.
We're supposed to help each other succeed. That's the way it's been since Richard Stallman and those guys in the GNU and the free software movement. When that was the idea. And if you know these guys, they get on these rants, but if it wasn't for those people, this would not exist.
Yeah,
they are working on top of an open source operating system using an open source version of a fucking programming language, and they get all like snooty about shit.
Yeah, right.
You know,
like,
so
oh, you're not like one of the cool kids. Like,
I mean, come on, guys. You know, let's help each other out here.
And it's not it's a really cool implementation of a language. It's pretty interesting, and the devices are awesome. I really like the Apple devices. I think they're amazing.
Yeah.
So a lot of times these responses to the questions are like short and unsympathetic at best. Let's see if we can turn that around. And that's what we're trying to do here. That's exactly why we do this. You know, for that exact reason is our motivation.
All right, so now we have to talk about the model view controller, or Apple's implementation of this concept anyway, which will kind of give you a high-level overview of what that is, because to this point, we really haven't gotten involved in much graphical interface stuff except for basics. So we've actually gone over this concept already. We just never described it.
Right, this way. Yeah.
And we're going to go over the class hierarchy and the delegations of actions and this other concept that Apple implements, or Objective-C's implementation of whatever, Apple's implementation of Objective-C, implement this concept called outlets, which we'll discuss as well.
And this is not conclusive for what you need to know, but this is like a pretty good starting point, I think.
Yeah.
So let's take a look at model view controller.
Yes, or the model controller view, as it should be called.
So yeah, exactly. We kind of like referring this to model controller view better because it makes more sense.
Yes,
and,
absolutely.
And so to give you kind of like a real world analogy, or like kind of a quasi real world analogy,
I think it's great. makes a lot of sense.
We'll say it's like this. The model's like a writer. The controller is like a director, and the view is like an actor.
Yeah.
And you're trying to build a movie. So in this case, the writer will do like the concept, the characters, all the stories, like what's going to happen, like this guy needs to do this, so that happens,
right.
And this, and da.
Then it's the director's job to then take the story and formulate it and then make it real and then tell the story in a way that the view or the actor will understand, so then the actor can then portray what the writer had intended.
Right. So like if your main actor is really good looking but he's not into women, and you're the director and he's like not responding to the female like lead that just died in the story, and you're like, screw, like what do you do? So the director can go to the actor and be like, just imagine like your dog died.
Right.
And the actor's like, oh my God, my dog died,
Right, yeah.
And so like he has to kind of figure out how to communicate it in a way the viewer will understand, so that he can get the story communicated out to the user or the audience.
But you see here, we start with somebody putting together the script, somebody interpreting the script, and then somebody then presenting. So it's like this goes up to this guy, goes up to this guy, where it eventually reaches the audience, which is you, the user of the application.
And the user is looking at and interacting with the view, which is the actor. It's the display of the idea. It's the display of the story.
Right. If you go to a play, you see the actors on stage. You don't see the director. I mean, at least not directly.
Right.
The writer, you'll be lucky if the writer even if he has a job after the play.
Okay, so now we can switch this around. It goes both ways. I don't know. So in this case, let's say it can go back and forth. So like in the views case, in reverse, the actor can start complaining and be like, the director's like, okay, I need you to jump out of this plane. And the actor's like, oh yeah, I'm not going to jump out of a plane, nor am I going to have like a stunt double jump out of a plane. Like, I'm not going to be in a movie where anybody's jumping out of any plane. F this, I'm out, find somebody else. So the director's like,
Tom Cruise, I guess?
Yeah, right. So the director's like, oh, what am I going to do? Like the actor wants this, and like we've already shot half the movie. I can't get like another budget approved. Like it's green light. Like got to do something. So he has to take this request back to the writer or the model and be like, "Do you have any way to deal with this? Like this is what the view is asking us for."
And then the writer has to kind of like rewrite it.
Right.
Or have like a backup plan available so that he can change the story to then make the actor happy.
So he's like, and that's how we have Under Siege 2.
Yeah.
So he's like, okay, how about you just jump out of a train instead?
Nice.
I don't know.
Very nice.
Anyway, okay, so another way to look at this and like so now we kind of step back into our, development realm. The model is kind of like the core classes and like the infrastructure and like the data and the
code base.
Right, exactly.
Frameworks, that kind of stuff.
The controller though is like the requests and updates that connects the view to the model and the model to the view. And the view is just the display and the user interface.
Right.
So then we have this idea of like views and class hierarchy. Now we've seen like subclassing like there's no tomorrow. I mean, we know how to like extend NSObject. Pretty much any object type that we created is an extension of NSObject. So the way views work is it's kind of this idea that it's not like a text box is something and a view is something else and a window is something else and they kind of like call each other. They actually like, it's like an inheritance line. So you have the UI window, and then inside of a UI window you can have one or many UI views that extend the UI window. And then inside of the UI view, you can have all these other extensions of the view, like the UI text field extends UI view, and so does a UI button. And so what it does is it looks for other things that have extended their parents. So when these things need to like update or whatever they do, it actually kind of like traces itself back to what needs to happen and redraws. So it's all kind of like this way of, it's not like these separate objects that are wired together. It's actually like it's like an ancestry tree branching inheritance structure of the view or the window that you're looking at.
Fascinating. Right.
So, and none of these are ever accessed from like where they reside. So we'll kind of see how that works. So no code is going to happen in here. This is just kind of like this is all on the view side, handedly on the view side. So instead, like all of these view objects, like a button, which is a view object, or like the view itself, they're all accessed by an outlet in a controller class. And so if you remember like our model view controller, so this controller class won't do like adding, or it won't do logic, it won't do whatever the case is, but what it does is it can go out and have the code base do stuff, and this controller then ties into the view. So here in this case, this controller will get like an outlet, and it has like the outlet keyword. And so we'll say like @outlet text field button, and we tie that outlet to the UI text field in the view.
Right, so we're plugging this one into this. So you can kind of look at the outlet as like a literal.
Right.
There's like a direct line between these two.
So now when we're in the controller class, we can just say we can just interact with text field outlet as if we've instantiated it. When we haven't really, it's just
it's just pointing at some UI. Yes, kind of weird.
Right, and so now this whole UI view thing in the Apple world, and we'll look at this later in the labs and stuff, but these all kind of get wrapped up in what they call an archive nib file. When that gets expanded and extracted, these instances exist, but they don't have variable names, they don't have instance names, they don't instantiate the way you'd normally think, but they exist. And by using this outlet idea, you can kind of tie a label and point over to them and access them, so that when you do something in the controller class to that field, that text field, it's updating instantly in that view. It's really cool. So now the controller class can access the text field, and this is most generally configured in the interface builder. But we'll take a look at that. And so there's also this idea of actions. So the outlet ties to an item, and action is is just what it seems. It's an event. So these can be set up for things like clicking a button or lifting your finger off of a button, and so that the clicking of a button can make a delegate call from the controller class. So in the controller class, we define an action, and we'll call it button action, and it takes in as a parameter a sender object. And we've seen in the other videos about sender objects and how that works and how we'd interact with them and stuff.
Right, the delegates passing around, so we're encapsulating an instance and passing it as a parameter.
So when we touch that button, we're really making a delegate call into the controller class. So the sender, when we receive in the controller class, is then a pointer back to the view. So that way we know what called us, or what its label was, or what the text field has, or whatever we need. So this is the rudimentary kind of fundamental concepts of how we're going to launch into starting to develop for the Mac devices.
Yeah.
And not all Mac devices are made equal, so we kind of have to take slightly different approaches for each device we're going to interact with, as you'll see. So from this point on, we're going to start getting into very intensely into the process of developing Apple applications, and we think this is really what you're after. We think this is the motivation for you to go through this
there really
at all,
isn't too many other motivations to learn Objective-C other than to develop for the Apple devices. I mean, you can make macOS applications, but that's not where the money is. Right now, the money is in the mobile market.
Right.
So
somebody sells an app for 99 cents and you make $1 billion.
So we want to kind of get you into that mindset. And the only way that we can really properly show this to you is to go through examples. And we're also going to be, we can cut this out if we don't actually do this. Whatever. We're actually going to be doing a project where we start from scratch and we take an app from a code base to a application, testing it in the iPhone application, and then sending it off to the App Store.
Right.
So we're going to go from 0 to 1,000.
And we'll also show another example where we go from code base to terminal, and then that same code base to Mac OSX application, the same code base to the iPhone, and then that same code base to the iPad. So we'll show you this, we'll create one model, and then we'll implement different views and controllers to be able to go off into all the different devices and areas of the Apple universe.
And then we'll take it to the App Store, and then you're going to make $1 billion off the greatest app ever. Hey, remember who to thank when you become rich, okay?
Right. Come back and find that little donation button.
And give us $5 trillion.
Billion.
No, trillion's better than billion.
Oh, yeah. No, trillion billion.
Oh, trillion billion. Okay,
yeah.
Got it. Makes sense.
Hello, everybody. Welcome to our next Objective-C lab. This one is going to be really interesting. You all have remembered in C and C++ when we generate a random number, you use the random function that's built into
C? The C pseudorandom number generator?
stdlib. That algorithm to generate that random number is a particular way of generating a random number. Now, it's not actually a random number.
Right.
It's a pseudo-random.
Pseudo-random.
Right.
But they tell you that going in. I mean, there's no mistake in the fact that the C random number generator is pseudo-random, calculatable, predictable.
Right. And then you pass it a seed value, and usually you pass it time or something like that, because it's changing and you don't know when the time ran. This isn't unique. There is no truly random number generator on a computer. It just doesn't exist. The only truly random number generation can come from like radiation. And you could have a sensor that detects a value from a radioactive something, and then that gets taken in as an input to the computer, and you could use that as a random number.
But we don't really have a nuclear lab at Wibbit.net Studios.
Right, except for my left testicle.
What?
Which glows.
Which glows.
So,
you should probably stop sleeping with your laptop on your
I know.
crotch.
Tell me about it. So there is no truly random number generator. A lot of people use the built-in random number generator in stdlib, and there's a couple problems with it. If you were to plot out a pseudo-random number generator on a graph, a scatter plot, you would see patterns starting to arise over time. Mm-hmm. So it's kind of repeatable. Different types of algorithms will generate different types of repeating patterns. There are some that are more uniformly distributed that are better suited for physics. So different types of random number generators that you would use in physics, such as like the Mersenne Twister, which is something that was developed by a couple Japanese guys in the late 90s. It's a really clever algorithm that uses bit shifting to generate the random number. It's also interesting to note on a security aspect too, because there are techniques to attempt to exploit algorithms that use the stdlib random number generator because it's predictable. So if you could figure out when something was executed or approximately, you could do a sweep of a small block of time and try to predict out what that random number would have been.
Right, because often those random numbers are used to generate like public or private keys,
right?
Like an instance that something is being encrypted.
Right.
Yeah.
So if you were to write your own random number generator algorithm and one that was a little less predictable, people wouldn't assume that you used any particular type. And the Mersenne Twister algorithm gives you some flexibility of how you do the bit shifting. Mm-hmm. So that's also something you can kind of use to sort of...
right. Well, you can also take this algorithm and customize it.
Exactly.
So the way that we present it is just one way of implementing it.
Right. It's kind of like the default you could think of.
Yeah. All right. So let's create a new project. Let's create a new project.
All right.
All right.
So we're going to build our own random number algorithm from scratch. It's going to be cool.
It's going to be awesome.
Command line tool, and we're just going to we'll call this,
like that?
Yep.
You know, you mentioned Twister, and for some reason I can't think of the word Twister without thinking of Bill Paxton. Things go wrong. You can't explain it. You can't predict it. Why did the tornadoes growl in that movie? Like when the tornadoes were like going around, they were like.
Well, I think it's the same reason that when it's the way that the news describes tornadoes too. It's like, you know, they'll describe a tornado as being like monstrous, vicious, vindictive, unsympathetic, like destructive, like, well, not naturally, but they'll kind of put like human villainous characteristics, you know.
Mm-hmm. So inside of here, Brian, we're going to want to create our own class, right?
Right, exactly.
Okay, Brian. So we have our code file here.
Yep.
And I'm assuming you want to build this encapsulated in some kind of a class, right?
Right. So let's add a new class. So we'll go to File, New, and there's a lot of ways to do this. File. So add a new file, and then it's going to ask us what type. So we're in a Mac OSX application, so we'll want to go to Mac OSX Coca, and then an Objective-C class. Now you can see there's a couple other options. We can also create a category, a protocol, or a test case class, and we'll explain those later.
But you know what a category and a protocol is.
Yep.
So no need to explain it.
So this is going to be a subclass of NSObjects.
Right.
Now you could subclass an NS number, you could subclass whatever else you want, just by typing it in, and it'll kind of auto-type for you. Mm-hmm. But this is going to be a subclass of an NSObject.
And we're going to call this what, Brian? The M Twister?
Yep, M Twister.
M Twister. And add targets?
Yep. We'll add to target.
And targets, I think, are the code files that you want to compile, right?
Right. Yep. Okay, so we'll start with a header file, and we'll start declaring our interface.
Yeah, see, look at this, guys. See, it's a good thing that you learned how to do this before you had the code generate this for you.
So now, if you walked into this blind, you'd be a little confused, you know?
Yeah.
But now you can see clearly that at interface is kind of like class. Mm-hmm. the name of our class and extends NSObjects. Like, this is like old news for you now. You're like, yeah, of course it is, whatever.
Here's where our fields are going to go.
Yep.
And are we storing fields, Brian?
Yep, so we're going to have 2, and they can be private.
Okay, you want them to be private?
Yeah, it doesn't matter.
Okay. What do we got?
So the first one is going to be an NS integer.
Okay.
And we'll say underscore capital MT.
Like that?
Yep, and then this is a fixed size array.
Okay.
Of size 624.
Okay, so this will be 624?
Yep.
Okay, nice.
And just for the sake of this example, this is the size of the field that we will populate and then generate through. And every pass of this entire array, we will clear and regenerate in bulk like this. And you'll see it as we go.
Okay.
And then we want another one of index, so also an NS integer. And we'll just call it underscore index.
Okay.
And there's only a few methods that we have, which is good. It's pretty straightforward. The first one is we're going to override a init.
Okay.
So it's going to return type
ID,
and then it's going to be a init.
Okay.
And then the next one is going to return void, and it'll be initialize generator.
Init.
Actually, we could probably call this init with seed.
The reason why you don't want to call it that, Brian, is because anything that starts with init is supposed to return an instance. Okay. Like that? Is that how you spell initialize? That's not how you spell
INITIAL. Initialize. Yep.
Like that?
Yep.
Generator?
Yep.
Okay.
And this is going to take an argument of an NS integer type.
Okay.
And we'll call it seed.
Okay.
And then the next one also is a void return type.
Okay.
And this will be generate numbers.
Generate numbers?
Yep.
And that's going to be no parameters?
No parameters.
Okay.
And then also the last one is going to return an NS integer.
Okay.
And it's going to be called extract number. And that will take no parameters.
Okay. Makes sense. So now to implement these, we'll copy the declarations here, and we'll go to the .m file, and it's sort of added some stuff here for us, so we'll just kind of maybe just keep those.
Yep, that's fine.
And just for continuity, let's do a dealloc here, because dealloc is defined here as well. Okay.
All right, so we already have init kind of prepackaged in the implementation file when we created the class, so we can get rid of our init declaration below.
Yeah, do it.
So where it says, so in init, you'll see it says self is super init, so that goes up the parent tree as we talked about before, and then if self, and then you have initialization code here. Inside of that initialization code, we're going to set the underscore index to 0.
Very nice, Brian. So we got index equals 0.
Yep, and then we return self.
And then return self. Okay, great.
So we also have a couple of static integers that we want to declare up above our implementation.
Okay.
It's going to be 3 of them. These are integers that will represent bit shift masks for when we do the bit shifting later. And these are just going to be static integers, and we'll use an integer to store these numbers. So they're all static, and they're all an NS integer. And the first one we'll call mask unity.
Mask unity?
Yep.
Like the mask with Jim Carrey?
Exactly, yeah. And that's going to be equal to 0x.
Now we're just using a hex value here.
Right. This is actually just represents 32 bits. So it's going to be all Fs. It's going to be 1, 2, 3, 4, 5, 6, 7, 8 Fs. And then capital UL. And the UL is represent...
Capital L?
L, yeah.
Like that?
And semicolon. And we can just put a comment in there that says basically FU.
I just want to make it clear that Ryan just said FU to everybody.
So we'll just put a little comment in there that says 32 bits.
Okay.
Because that's it. Basically, it's hex value of 8 Fs. That's all that means. And that 0x and the UL at the end just means that it's the hex representation.
And Brian, declaring these as static will prevent them from being reinitialized each time that we create an instance, because there's no need for a constant like this. There's absolutely no need for this to go along with each instance that's created.
Yep. The next static NS integer we're going to call mask highest bit. And that's going to be equal to 0x, 8, and then 7 zeros.
Okay.
UL, yep.
And you could
say a most significant bit. And then the last one not surprising, is going to be an NS integer called mask lower bits. Lower bits plural. Yep, equals. And this is going to be 7 and then 7 Fs. And then that's an equal.
No, it's not. It's a minus.
And then we can make a comment and just say this is the last 31 bits. And if I don't want to come off as sounding weird or like snotty or anything, but if you don't understand this and you're not interested in mathematics, don't worry too much. If you're not that interested in bit shift operations, but we'll basically just say that we can use these numbers in bit shift operations of representing. The first one is kind of like all ones. The next one is kind of like 1 and all zeros because it's just that one most significant bit. And the last one is 0 and then all ones. So you can kind of think of it that way if you were to imagine these in binary numbers.
Okay.
And so if we do like an exclusive OR against these, it would be like doing it against the most significant bit only, for example. You know what I mean?
Mm-hmm.
Okay, so let's look at the implementation for initialize generator.
Let's do it.
Okay, so let's look at the implementation for initialize generator.
Let's do it.
And this is where it starts to get interesting, and then the generation is really cool. So this is just like this is a sexy algorithm. Whoever the guys that came up with this they're crazy. They're like ninjas. They're like algorithm ninjas. So we'll kind of make some comments along the way, just so we have some way to kind of keep track and keep our place, because it can get a little confusing. So we'll make a comment and we'll say we'll set the first array value to be the seed.
Okay.
And so we'll say underscore MT and it's sub-0 equals the seed, which is the parameter that gets passed in. And then we'll declare int I, and we could use the NS integer, but I'd just use int.
Why not?
Because it doesn't matter. Then we're going to perform the shift twisting on each subsequent array element.
Okay.
So for int I equals 1, while I is less than 623, less than equal to 623, I'm sorry.
Okay.
I++. So we're just going to move through this array, and every iteration, we're going to say underscore MT sub I is equal to, the mask unity, ampersand, which is a bit shift for and.
Mm-hmm. It's a logical and operation,
and
which you learned in the introduction to computer programming,
exactly,
by the way. And you also learned this in C when we talked about bitwise.
Exactly. Left parenthesis, and this is going to be a constant number, and I'm going to read you the number. 1, 8, 1, 2, 4, 3, 3, 2, 5, 3.
Okay.
And these genius guys found this constant that just it works perfectly for a displacement variable in getting this pseudorandom to distribute properly. And then an ampersand, so times, and then another parenthesis.
You mean time, not ampersand.
Yeah, I'm sorry.
You meant asterisk.
Asterisk. And then left parenthesis, underscore MT, which is our twister array, and then I minus 1.
Okay.
And then the caret.
So that's going to be a logical OR operation.
Right, exactly. And then a left parenthesis, and then the underscore MT, I minus 1. And then we're going to do the shift to the right, which is a right arrow.
Bit shift right, correct.
And then 30.
Okay.
And then we'll close our 2 parentheses. And then
3 parentheses.
Wait, and then we're not done.
Okay.
Plus I.
Like that.
Yep.
And then close that off.
Yep.
So if you guys watch this, the mask unity that Brian declared as a static up here, that's going to be an AND operation against this entire chunk here.
Exactly.
And this entire chunk here from the most inner parentheses is going to take MT up 1, bit shift to the right 30 bits.
Right.
Right? Then from that, we're going to do an exclusive OR against its root value.
Right.
So we're going to, its root value, it's bit shifted 30 plus 1 times this cosmological constants.
Isn't that cool?
Yeah.
So that's all, okay. Right. So
for those of you that don't know astronomy, well, never mind, I'm not going to.
So that's all we do to initialize the generator. It's that simple. Yeah. It's really cool.
You know, cosmological constant was Einstein's theory of the force of gravity fighting against gravity, which he was dead wrong about.
Huh.
But that was his way of trying to say that the universe could not possibly be expanding.
Oh.
So his way of proving like why don't bodies fall into each other because the gravity's so strong? He said, well, there must be a force that's pushing against gravity that's the equal power of gravity.
Huh.
But then Hubble proved that it was the expansion of the universe that prevented that from happening.
Very cool.
Interesting. All right, sorry.
So this is...
You can tell that I don't really do much in my spare time. Besides read and do Whippet tutorials.
So it's a genius initializer, and then the other half we're going to implement is the generate numbers.
Okay, now this method initialize generator is complete, right?
That's complete. It's really straightforward. It's pretty smooth.
So now we have
generate numbers. So generate numbers is basically going to take an initialized array and scramble them randomly, kind of.
All right.
See. Okay, so we'll do int I, or NS integer I.
Okay.
And for I 0, while I is less than or equal to 623, I++. All
right.
So we're going to traverse the twister array. And then while this is happening, we'll say this. We'll declare a new NS integer.
Okay.
And I like to, this is stupid, but I like to call this piece of clay. Because this is kind of like, I think of this number as like a chunk of clay that we're going to like
You're
mold
just going to like
sculpt.
take it and you're going to just...
Yeah, exactly.
Yeah,
so I literally call this piece of clay.
Piece of clay, right?
Yep.
Like a this?
Like that.
Okay.
So that's going to be equal to, in parentheses, mask highest bit,
okay,
and underscore MT sub I.
Okay.
So we're gonna do the highest bit.
Mm-hmm.
And
do a logical and.
Yep. Mm-hmm. Against our current value, and parentheses plus parenthesis mask lower bits, so the rest of it.
Okay.
Logical and ampersand, and then in another set of parentheses underscore MT I plus 1 modulus 624, and that keeps it within our scope. And then semicolon. Okay, so that's the initial value of our piece of clay, and now we're going to create a another NS integer called temp index.
All right,
and that's going to be equal to, and then in parentheses I plus 397, specifically that number. End parenthesis modulus 624.
Okay,
so it's kind of like an offset index. Okay, so now underscore MT sub I is now going to be equal to underscore MT sub temp index.
Okay. Sub temp. Okay.
And then logical or a caret. So logical or, and then in parentheses piece of clay, bit shift to the right, 1.
Okay.
Close the parenthesis and semicolon. So that's going to be our value at this point in time. And then what we want to say after this is we want to do a test. We want to say, basically, if the piece of clay is an odd number, so if, and then in parentheses, piece of clay mod 2, not equal to 0.
Okay, so if it is not an even number.
Then this means that this piece of clay at this point in time is an oddball. So let's apply exclusive OR operation against this freaky constant of 2567483615. So we'll say underscore MT sub I is equal to underscore MT sub I caret, and then in parentheses 0 x 9908.
All right.
B 0 D F.
Okay, so
and
there's
then
your
uppercase UL.
There's your hex value. Okay.
And then end parentheses and semicolon. So that'll apply that exclusive OR operation against that.
Okay.
And that is it for the generation of the numbers.
Okay.
So it's really sexy. Like when you read the algorithm, when you read the mathematical approach to it, or you read their papers, it seems really overwhelming, because you have these kind of weird things flying all over the place. But once you kind of see it laid out in this algorithm like this, or if you look at, I think Wikipedia has a pseudocode demonstration of this Mersenne Twister. It's really elegant. It really boils down really well. So now we're going to do the extracting the number, and this is where we do like a little bit shift dance as we extract the number, right? So now we're going to do the extracting the number, and this is where we do like a little bit shift dance as we extract the number, right? So here's how this goes. Now this is like the finishing touch for making this thing freaky. And this is the part where you can really kind of customize for making this not default and kind of making this a little more secure, making your own take on it. So here's how this little twister dance goes. If the underscore index is 0, then we need to generate the numbers again.
Okay. Then we call generate numbers?
Yep.
So we're going to do self.
Generate numbers.
Generate numbers.
Yep, perfect. Okay, so other than that, and we don't return after that or anything, but that's fine because we just want to make sure that we're going to be having the index mod the size of our array. So every time we pass back to 0, we regenerate all the numbers. And it goes through that.
Or if generate numbers was never, well.
Right, exactly, yeah, if it were initialized, yeah. Okay, so let's create an NS integer, and we'll call this Tiny Dancer.
Tiny Dancer, awesome.
Yeah, Tony Dancer. We should call it Tony Dancer. Well, whatever. Anyway, it's equal to underscore MT subindex. So we're going to be dealing with the our twister array at this index location.
Okay.
Okay. So that's what the Tiny Dancer is going to start out to be. Now we're going to do this little bit shift dance, right?
All right.
So let's put a comment that says 11 steps to the right, and then another comment that says now 7 to the left and now jump. And then the next comment is and 15 more to the left and jump twice. And then back to the right, and 18 bits with a hand on the hip. And then repeat. So that's the Mersenne Twister dance.
Is that how you spell repeat?
Nope, it's like there you go. So that's the Mersenne Twister dance. It's like a little 50s doo-wop.
Or like the electric slide, the Macarena,
the electric boogaloo.
One like let's do the twist. What are some other big dance songs like
that?
The
alligator.
The mashed potato. The mashed potato.
Yeah.
And the electric slide. When we were like little kids, like everybody's mom was doing the electric slide.
Okay, so let's actually implement this dance.
Let's do it.
It's really easy, and this is all with kind of bit shift operations. So the first thing we're going to say is Tiny Dancer is equal to Tiny Dancer caret for exclusive.
Or
left parenthesis Tiny Dancer bit shift 11 to the right.
Okay. And
then the next one.
Okay.
Tiny Dancer equals.
Okay.
Tiny Dancer.
Tiny Dancer.
Caret. And then 2 parentheses. Tiny Dancer. Bit shift to the left 7.
Okay.
And then ampersand. And then in parentheses 0x. Okay, here we go. 9 D 2 C 5 6 8 0.
Okay.
And then UL. And then close it off, and semicolon. And you'll find these constants, these are the default constants. So even if you look at the pseudocode in Wikipedia, you'll find these. If you look at their paper, you'll find these. This is the ones that they kind of use for their example. So we're just going to kind of stick with that. And then 15 more to the left and jump twice. So Tiny Dancer equals Tiny Dancer, caret, and then kind of similar structure. So 2 left parentheses. Tiny Dancer bit shift left 15.
Okay.
Close parenthesis and then in parentheses 0x. Okay. E F C 6 0 0 0 0 UL. And then close it off.
All right.
And semicolon. Okay, so now we go back to the right 18 bits with the hand on the hip. So Tiny Dancer equals. You probably put it under the comment, but it doesn't really matter.
Wait, is it not right? What is in back to the right? Isn't that where we are?
It's all the same thing. And back to the right in 18 bits.
Oh, so this one goes up here?
No, these go together.
Oh, wow. Right. Like a these.
Like that, yep. And then we put that line underneath it.
So let me ask you a question.
Uh-huh.
Is this Tiny Dancer attractive?
From a distance.
Aren't they all? Anyways.
Tiny Dancer or, and then in parentheses, Tiny Dancer, bit shift to the right, 18. And then close off the parenthesis and semicolon. Okay.
Actually, the caret is exclusive or, isn't it?
Yeah, I think
because the single bar is
exactly.
Yep. All right, so these are exclusive or. Sorry about that.
Sorry, I was kind of doubting myself, to be honest. So okay, so now we want to repeat and get ourselves into the next position. So the way we do that, is by setting index, to be equal to, in parentheses, index plus 1, and then mod 624.
Okay.
And that'll do it.
That's it?
That's it.
That's not so bad.
No, it's not bad at all.
Let's see if we can get a build.
Okay.
All right. So
let's include the header and main, and then we'll try to build it. So you can see how these files are like dark gray. So we'll click on the header file, and we'll save this one.
Mm-hmm.
And now it's brighter. And then we'll click on main, and we'll save this one. And that'll become brighter. So that shows you that there's pending changes. Kind of like some programs will have like the asterisk in the title bar.
Mm-hmm.
Okay, so let's go to product and build and see what happens if we try to build this thing. Oh, we got a parsing issue. Expected expression. Okay, so we'll click on the build there, and
oh, geez.
we got plus plus.
Oh, geez.
Oh, how embarrassing. Oh
no.
All right, so then
I swear, Brian, if
so
we
we'll
just
go back to this.
if I just do build, it should save everything, right? Yeah. So you don't have to go through the whole issue of like save. So
let's see what our semantic issue is.
Before, well, it worked just then.
Okay.
Let me just real quick just double check to make sure that the build worked, and it did.
Mm-hmm.
Now let me show you guys something. So let's import the
Twister
Twister.m,
and then we build this magically. See, Xcode does some trickery. So Xcode will kind of like whatever. Xcode has it bound to the target. It'll include the header file, and then it will allow you to give the IntelliSense. So even though that's counterintuitive to how we've been showing you in C and C++, this is the Apple-y, Xcode-y way to do it. I'll just put it that way. Okay, so we'll try this out. So we have we'll create a new.
Okay.
We'll basically allocate a new Twister.
Okay. So what do you want to call it?
Rand.
Okay. How about not rand?
How about randy?
There is a rand function. So
okay.
How about like rand
twist?
Rand twist. Okay. Equals twist alloc init.
Yep. And then close that off.
And then we'll do a rand
initialize
release. Okay.
Okay. So now we'll initialize rand twist init.
Initialize generator.
Yep. And we'll give it a seed. So for the sake of this, normally we would pass time. For the sake of this, we'll just give it some number.
All right.
Give it like 579er.
579er. Like that?
Yep. So close that off. And then, so now we will do like an NSLog.
Okay.
And we'll say your random number is for an NS string.
Mm-hmm. Your random number is...
Yep, perfect.
That's okay.
And then we'll call rand twist and then extract number, and then close that off. And that'll return us an NS number. All right. So because it's an NS number, this is actually an...
That's syntactically correct.
Is that LD for NS number? Yeah, LD. There we go. Okay. So let's try it out and see if we get some random number or crash and burn.
Products. Build. All right.
And then we run this, and we should see our output window pop up on the bottom. And your random number is blah, 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 blah.
All right, so what if we ran this in a for loop?
Okay.
Would we get the same number?
Nope.
Okay, so if you ran this a second time, you would get the same number?
Not necessarily, no.
Let's try that. I don't think that it will.
Yeah,
it doesn't. Right.
Cool.
So if we were to do something like a for loop, where we did like for ns integer I equals 0, while I is less than 10, I plus plus, and we don't need to have
the
brackets.
Right, yep, we'll just take that out.
Just run this, see what happens.
We'll run it. There you go.
All right.
Hey! Same number.
It is the same number. So it's one number, and then the number swaps on its second iteration.
Right.
So if we were to take this...
Well, we could just change
it to I.
Yep, exactly.
So instead of that, we'll do I.
And we can take out the one above.
Mm-hmm. Okay, let's try that.
All right.
Same number.
And the number that's coming back is looking a little strange. So let's take a look to see if we may have missed something, which sometimes happens. When you write a method that returns a number...
Oh, yeah. You got to return the number.
You got to return the number. So Tiny Dancer never came home. So that may help a little bit here. Let's see if we can wrap this up quickly. Okay, now we'll execute that again. And as we'll find, our random number is all random all over the place. Anyway, so thanks for watching. Don't take anything for, don't assume that one way is the best way to do it. Don't assume that the default's the best way to do it.
But our way is the best way to do it.
Right, but this is just one out of a ton of different pseudo-random number generators you can get into. So if you have a need for it, go check a look at some of the other random number generators.
And it's probably still better than the C pseudo-random generator.
Probably, yeah.
All right.
Thanks for watching. Hello, everybody. Welcome to our next lab. This lab is really interesting. I'm really excited to show you. And this is going to be the Levenstein algorithm.
Say it properly. Levenstein.
So this is basically a fuzzy string matching. So you know when you're in Google and you start typing and it has like the auto type ahead. Well, that auto type ahead is based on like other words starting with what you've typed so far. But if you search for something and it's spelled incorrectly, Google will say, "Did you mean this?"
Mm-hmm.
That "did you mean" algorithm is what we're going to be looking at. And we're kind of using this because it's a fun algorithm, but also just to kind of give us a chance to take a look at static classes in Xcode in the process of writing in Objective-C.
Yeah.
So it's fun, it's interesting, so we should be able to take two words and kind of like screw up one of the words, and it will tell us the number of operations it'll take to get from the string that we typed to the string that we desire.
Cool.
Yeah.
Awesome.
So we'll take a look.
Let's make a new project. Yeah.
And this is going to be just another command line tool.
Command line. And we'll call it what? Fuzzy string?
Yeah.
Like a dice?
Right?
Awesome.
Cool.
Gorgeous, baby. Gorgeous. All right. So
the first thing we want to do is add a class.
All right. So we know how to do this, right, guys? New file. And Coca, Mac OSX, Objective-C class. Next, inherits from NSObject. Next, and our class is going to be called
Levenstein.
Spell, please.
Levenstein.
Like a dice.
Levenstein.
That sounds like a electric rock band, doesn't it? No? All right.
Okay. So we'll kind of just block out our header file for this class, and it's really simple. There's not much going on.
I'm going to move these in this. I meant to add the new file here.
Sounds good?
Yeah.
Okay, so let's go to our Levenstein header file.
Let's do that.
And we're going to make this just basically one static method.
Okay, so do we have any private fields or any fields at all?
Not at all.
So I'm going to just remove a dice. We're going to be working with static methods.
Okay, so so there's a plus for a static method, and it's going to return an NS integer.
Okay.
And the name of the method is going to be getDistanceFromString.
Okay.
And it just returns basically the number of operations from one string to another.
Okay.
So we'll do a colon, and then our first parameter is going to be an NS string pointer. And then that's going to be our base string.
Okay.
And then toString is going to be the label of our second parameter.
Okay.
And then an NS string. And we'll call this dest string.
Okay.
So the way that'll read in our NS style is Levenstein, get distance from string this to the string that.
Okay.
So that's it for our header file. So now
we're getting from to.
Right.
Right. Nice. Very nice, Brian. Well done.
Cool. So now we'll go to our implementation file.
That's all we're doing?
That's all we're doing.
Holy monkey.
Yep. It's that easy.
Holy.
This will be it. This one will be straightforward. This is just fun. It's just a fun one.
Okay.
Init and dealloc can be left as default. And so for the get distance, here's how it's going to go. The first thing that we want to do is we want to check for empty strings. So basically, if either of them are empty, then the length of the other string will be the distance of number of operations to get to the other one. So what we want to say is Right. So if the base string length is 0,
Okay.
then we want to return the dest string length. Because the number of operations from getting from empty to destination string is just however long it takes to type that.
Mm-hmm. Right.
Okay, so that'll return the number of operations. So then we just want to say the opposite. If the destination string's length is 0, then we want to return the base string's length.
All right. Base string length. Nice.
So we don't necessarily have to do this, but why move through our relatively expensive iteration when we don't have to?
Exactly, right.
Okay, so the first thing that we want to do is we want to create an array with the size that represents a Cartesian product of the two strings. So however many strings in one and however many strings in another, we want all of the possible intersections between every possible character of those two strings.
All right, so we're making a two-dimensional array, right?
Right. Okay. So it's going to be of type NS integer.
Okay.
And we'll call this distance array.
Okay.
And the first is going to be the base string length plus 1.
Wow, that looks weird to me.
There you go.
Sorry, I just...
Yeah. Length. And plus 1.
So the brackets inside the brackets got me.
So then we have another one of those for the destination length, plus 1.
Okay.
Destiny's Child? No. Plus 1.
Okay.
Perfect. All right.
Nice.
All right. Okay. So so that initializes the array. That creates the array. Now we need to initialize the array with the distance along the base edges.
All right.
So we're going to do a for loop for integer I 0, while I is less than or equal to the base string length, and then we'll increment I 1.
Okay.
Okay. So inside of this, we don't need to block it out necessarily, but we can if we want to. We're just going to say the distance array sub I 0. So we're kind of running along the edge, is going to be equal to I. Because, we know that in that case the length is 0, basically.
Right.
So then we're going to do the same thing, but for the destination string length. And we're going to run along the other edge.
So doing another for loop?
So we're going to do another separate for loop.
Okay.
Yep, so we can just copy and paste that. And instead of the base string, we're going to do the destination string.
So the destination string length
But then this time it's going to be 0i. Exactly.
Okay.
Yep, cool. Okay, so now we're going to have a nested for loop that's going to just start calculating these intersections. Okay, so now we're going to have a nested for loop that's going to just start calculating these intersections.
Okay.
So for int I is 1.
Okay.
Because we already have that base edge. I think you need an I in there.
Oh, yeah.
So while I is less than or equal to the base string length, increment I.
Okay.
And then inside of this, we'll want to say for int j equals 1. And then we'll do it to the destination string length and increment j.
All right, no biggie. So we'll do ns integer j equals 1. And instead of that string, we'll do that string. And instead of I, we'll do Jibby. Instead of I, we'll do Jibby. Nice, huh?
Yep.
Whoops. Sorry about that, folks. All right, there we go.
Okay. So now we got our nested for loop. So far, so good. So in this iteration, we actually only do one thing, but it's a relatively complicated one thing. So what we want to do is we're going to use the min macro that comes with Objective-C runtime for convenience, which is just the uppercase min. It operates like a function. And also, we could have used the destination string C string and pull the characters out of the subindex and stuff, but it's a depreciated approach. So we're going to try to be proper and use the substring with range on an NS string.
The next time that you stand up to go somewhere, I'm going to say, the way you stood up is depreciated.
Yeah, exactly. I don't appreciate the way you just called that NS string. So here it goes. So this right now is the meat and potatoes of the Levenstein algorithm.
The Rammstein algorithm.
So distance array sub ij. Whoa! Or
wow!
We dispatch a token. You got some extra little giblets in there.
Yeah, I'll get to them.
Sometimes there's something to be said about just typing in Notepad++, you know?
Yeah, see, sometimes you get victimized by autocomplete so easily.
It's madness.
Okay.
Okay, so this equals, and then the min macro, which is all uppercase min, and then open parentheses, and then space, and then another min, and we'll go through this as well. So then in this submin, we want to say it's distance array I-1 and j.
Okay.
Plus 1.
Inside min?
Yep, all inside min.
Okay.
Plus 1, and then comma, distance array I sub j-1 plus 1.
Okay.
Okay, so this is going to take the minimum of either one of those.
All right.
So that's the inner min right there, right?
Right, okay, I get it.
Okay, so then...
we do a comma here, right?
Right.
And then we have another min.
Exactly. So this is going to be, not necessarily another min, but this is going to be distance array I sub I-1 sub j-1
Okay.
plus, and then maybe on a new line and in parentheses and tabbed in a little bit. So this is going to be the base string, and it's going to be a substring of this.
Okay.
So we'll kind of bracket evaluate the base string and then substring with range. So it's going to be substring with range and then NS make range. And then in parentheses, and then in sub parentheses, I-1, comma, 1.
Okay.
And then close the bracket for the end of the substring.
Okay.
And then that double equals, because we're actually going to be taking we're going to do the inline conditional. So we're going to evaluate an operator and then do the question mark, something colon something else. So it's going to be that evaluated against the operator equal to the same thing, but for the destination string in J. Right. So one of the things that this shows is that no matter what language you're in, whatever it is that you need to do, you can accomplish it. So even though Objective-C is one of the more, I would argue, like painful to navigate, you can still do what you need to do. So at the end, before we close the parentheses off, we then say question mark, and then if it's true, we'll say 0, so just 0, and then a colon, and space, 1. So what this is it's this is an inline evaluation of an operator that says, depending on the condition, if it's true, you do the first, if it's false, you do the second. Okay, and then we, so that's it.
All right.
So what that does is it takes the minimum between the distance array on the angle on J and the angle on I, or if it's less than that, the distance array I-1, J-1 plus either 1 or 0 depending on the substring intersection. And that basically determines whether or not it's an insertion or a replace operation. So once we're complete with the for loop, we just return so once we're complete with our nested for loop, we're going to return the distance array sub base string length, dest string length.
Sub what?
The first one is going to be the base string length, and then one more. Yep. And then the dest string length. Sometimes the brackets and brackets do get crazy.
Yeah, it does.
Dest string length. Yep. Bracket. Cool. So the two concepts that we haven't talked about that we'll just kind of reiterate is the min macro and the inline evaluation. And so we can kind of show that is if we'll just do this in a comment real quick just to describe this. If we said min, and you'll see with the auto type, you get the little pound as if it's a
defined somewhere.
Preprocessor directive defined somewhere. So you have min A and B. And so if you say min 4 3 comma, just like it would in a function, 3 comma 4, it will replace this with the lesser of these two once they're evaluated. So this will just basically substitute itself for the number 3, and that's the min macro. And then the inline operation will say like 1 equals 2 question mark at yes. No. So this will give you an NS string no if it's false, and it's an inline way of having a very short conditional operation that basically, instead of having a separate if and then if this condition this, then store it off as a variable, you can kind of do it inline and just say evaluate the previous operation and return this or that, depending on if it's true or false. So this is, it's just kind of so this is more just to get used to seeing IntelliSense and getting used to seeing kind of like typing in Objective-C and compiling and seeing a static class and stuff like that. So let's go to our driver code file and we'll test this out and hope we didn't screw anything up too bad.
We still should be able to build.
Yep.
Okay.
Okay, so so let's import the Levenstein header. Cool. Awesome. All right, so the first thing that we want to do after the auto-release pool is where we can just get rid of the pools.
We'll just leave it. Why not? It's fine.
So the first thing is, let's just define like 3 different strings. So the first thing is, let's just define like 3 different strings.
Okay.
We'll say an NS string, string 1, string 2, string 3. And the first one is going to be equal to Wibbit.net with a capital B.
Okay, string 1.
Yep. And then the second, and then string 2 is going to be Wibbit.net with a lowercase b, because this will see a difference.
Oh, lowercase
or
b.
Lowercase n, whatever.
Okay.
And then at for NS string.
Mm-hmm.
And then the third one is NS string, string 3. And we'll do something like a little more messed up than the other two. So we'll say like capital W, lowercase o, s, d, t, .net.
Capital?
Yeah. So it's like a little more jacked up.
Okay.
And so let's make 2 NS integers now. And the first NS integer we'll call distance from 1 to 2.
Like this?
Sure. And that'll be equal to. And then, so now we're going to call our static method on the Levenstein class, and it's called getDistanceFromString, and then we pass it string 1, and then pass it string 2, and that'll be the distance from 1 to 2. And then, and we'll close it off, and so we'll copy and paste this, and do the same thing, but from 1 to 3, so we can compare this difference.
Alright, so distance from 1 to 3.
And that way you can kind of see, like, which one would it try to kind of, be closer to autocorrect you towards. And so what would happen is if you, so we could say like, the distance between something and something is something.
Okay.
Yep. And that'll be distance from 1 to 2.
Okay.
Yep. And then we can do the same thing from 1 to 3. And so what you could imagine is if you had a dictionary and you were to evaluate something against everything in the dictionary, you could say if the threshold of closeness, of distance, is less than, 4 operations, then we'll just assume that's like a hit. And that you probably meant that word,
Or you could have meant that word.
Right, you could have meant that word.
Want to give it a shot?
Yeah, let's give it a shot. So we'll just run it.
Yay!
And then our output should come up on the bottom. And so look at that. So the distance between 1 and 2 is 1, because the only difference is the B was uppercase, so it only took 1 replace operation. And then the distance between 1 and 3 is 3, because it took 3 operations. So we can also like delete the dot on the third string, for example.
Like this one?
Yep. And delete the T.
Okay.
So that should be now 5 operations. And hopefully this thing is correct, and it is.
Yay!
So that takes 5 operations to transform string 3 into string 1.
Give yourself a golf clap, Brian. Nice.
Isn't that cool? So it's a really neat algorithm. So the way that it's implemented in the Levenstein class is a little, it's a little tricky. It's a little advanced, but this just gets you used to the idea of like how simple it is to just extend an NSObject, even if it's just something we're going to put static methods in, and then to call it when you need it, and take it from there.
Awesome.
Hello, everybody, and welcome to our first lab in getting you into building a user interface. And so first we're going to do a very simple user interface for OS X.
Nice.
And then in the next lab, we'll do a simple user interface for the iPhone.
Cool.
Because they are very different worlds. Like the classes that you use, the objects that you use are very different in how you interact with it. So without further ado, we will create a Mac OS X GUI application. So we're going to create a new Xcode project. And we have been using the command line tool. Now we're going to use the Cocoa application.
Snap.
So we're going to call this, let's see, Simple OSX
Application.
App.
Nice.
Okay. We can select an App Store category, but we won't worry about that right now because obviously we're not going to submit a Simple OSX app to the App Store.
Or we could. And we could charge $5,000 for it.
Similar to like it used to be with the old MVC and Visual Studio, you can create a document-based application versus a single window app. Use core data and include unit tests. We're not going to do that for right now, so just don't worry about that. We're just going to make very simple, keep it default. And we're going to use our trusty Wibbit.net hard drive.
Nice. Holy crap.
Yep. So right off the bat, you can see that we have a place to put the application icon if we wanted to. And again, we can redefine the application category or define it. And we have version, deployment target. We're running on Mac OS X 10.6 at this time. And the main interface is going to be the main menu. So this is the interface file that will initially launch. So this will be like the parent interface, so to speak. And that's just called the main menu. So we start off with this application delegate. The iPhone is a little more handedly in the model view controller realm, where this is a little more on the application delegate, but they're similar in structure. So what this is a delegate call from the main menu that says application did finish launching. So like once something did happen, this will fire as a result of after the fact. And if it is before or if it's going to, it'll say application will be launching. Application will launch, but this is application did finish launching. Sometimes it gets a little confusing to get used to those delegate names, but. So for our simple application, we're going to beeline for the interface builder. Now, if you're used to earlier versions of Xcode, the interface builder was a separate application that you would launch.
Yeah, it was very different.
Yeah, and I feel this is a lot easier to use. The other one before was a little more painful. It was a little more convoluted to tie together the pieces between the code and the interface. And so
that's what I got accustomed to. So when I first saw this one, I thought this one was crazy. But that's just because I got used to doing it the crazy way.
So here we go. So,
it's like a Visual Basic programmer. Yeah. They can't do anything else.
So this is, so I'll just kind of try to walk you through this just so you can kind of get like your base exposure to it. So we have we click here for the main menu, we click here for the window, so now we expose the window. And this is our Simple OSX app. If we just run this, actually let's just run it. You'll see that it'll compile, it'll launch, and we'll have our.
Wow.
So this is basically the main menu that has a UI window object in it. So it's really simple, and this main menu is actually what's kind of like the driving root of it. So we have these panels here. We have this lower panel, which is our output window, which you're used to seeing pop up from time to time. And now we have this right panel. Now the right panel is our like inspector panel. So this has things like the identity information and what we are and who we are. Then we have a help, which obviously there's never any help because we're doing Apple development. Just kidding. So we have our class. So this as a whole is our NS window class. So that's what this is. So we could in turn say like, no, this isn't NS color panel class and like really jack the thing up. So we're just going to leave it as a NS window because that's actually what we want it to be. And then you can see we have the title, attributes, if it can be minimized, if it's textured, if it's blah, 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 blah. And you can, kind of move your way through here and see if you want to adjust the size, you can do this through the GUI as well. Just by dragging it around, you see these. You can constrain the minimum size, the maximum size, like what position on the screen is it going to initialize on. So you have a lot of different options there, just like you would in a lot of graphical user interface development tools. And these are our outlets and actions. Now we briefly touched on the idea of these outlets and actions, and that's what's going to tie everything together. So let's put a couple objects on the window, and we'll tie an outlet to one and an action to another. So maybe like a button, when you click the button, it fills out a text field. Something like that. Okay, so let's do a push button. We could do a rounded rect button. Let's do a rounded rect button, and we'll use these like center guidelines to kind of center it, so it's all pretty. And we'll double click on this and say click for action. Why not? All right, and then we'll have a text box. So this object library here down below, you can do different filters and constraints. We're going to do it for the object library. And this has rectangles and buttons and triangles and you name it. Labels, text fields, so we can put a label on here. Say Wibbit.net, why not? So we got our label here, and now let's add like a text field underneath the label. And the text field, we won't have like an initial default value or anything. We'll just kind of make a text field. And so what we'll want to do is we'll click a button and fill out the text field. Right? Okay. Sounds good?
Sounds great.
Okay, so we'll hide this little editor here for the moment, and we'll click on this penguin suit, little tuxedo. So what the tuxedo does is it brings in a view of the application delegate declarations, the app delegate header file that's associated, that's the file owner of this main menu. So you can see like this NS window, like that is this window, this NS window object. So this is the, you can't really say the calling class, but it's the associated delegate class to this window. So
right, because this is ran, and then your code kind of works with like the instantiated values that were created when the GUI came up.
Right.
Which is very different than a lot of other graphical concepts out there.
So we talked about outlets and actions. So an outlet, if you remember, is a reference point for the code to refer to the instance of an object or view in your view, right?
Mm-hmm.
And so if we right-click and drag on the text field, we right-click and drag right into the code, and you see how it's like it's trying to automatically stick something. You want to insert the outlet like privately in here? Do you want to insert it here? Do you want to connect the binding so that the outlet is bound to the... Should have held it for too long. Let's go back. So it says, do you want to connect it to this outlet so that this is also connected? Like, do you want to do crazy stuff? So what we're going to do is we're going to right-click and drag into our code, into where we would declare, like methods and stuff. And we're going to declare an outlet. So this drop-down, we can either declare an outlet or an action. And so we want to make a reference point that points back to the instance of this text field when it's launched. And so we'll call this our just text field.
Okay.
And the type is going to be an NS text field object because that's what it is. That's what we want to declare it as. So we're going to hit connect. And that now has connected our interface to our header class and declared it. But not only that, it will also, if we go to our implementation file, we'll switch to our central view and go to our implementation file. You also see that it automatically synthesizes the things that we connect the outlet for too. So now we go back to our tuxedo, and we'll right drag now our button. And so this says insert outlet action just like it did before, but this time our connection is going to be that of an action. And so we'll call this click action just for the sake of keeping it simple and getting to the point. And the type is going to be ID because it's basically an undefined type. And so what this should do is it should create an action, define an action that takes in a sender of some unknown type. And so the sender is the object that the
instance of that button.
Right, exactly.
That came from the zip file?
Yes.
Yeah.
In the zip file or the nib file, depending on how you want to pronounce it, the zip file is basically like a compressed archive class. And when the program gets launched, it like unarchives and instantiates objects. And then we make these outlets to refer back to those instances.
Yeah.
So we'll save our interface file. And we'll go to our delegate, and we'll just make sure everything's saved. And actually, let's just run this. It shouldn't do anything. We should basically have a button that... This button is going to be firing that action, but we haven't told it to do anything.
Action's not doing anything.
We got a field, we got a button, the program runs, it's our simple app. Hey, cool.
Yeah, make sure that you actually close the app, too, because if you just hit the X, it'll stay running.
Yeah, so you need to go up to the menu and quit. So you can go down to your menu and make sure that you don't see that simple app running anywhere.
Yeah, because if you don't do that, then I think that when you try to run it again, it's going to say the app is already running or something.
Exactly, yep.
Yeah.
So all we want to say here is that our so we have our text field, NS text field object. So all we want to say is that so our text field object, which is text field.
It's our NS text field.
NS text field.
And this is our property that refers back to the zip file text field. Is it set text? Attributed text title? Attributed title text? I think that's it. It's something that's very unintuitive.
Okay, so we'll set the attributed string value. Perfectly intuitive, right?
Right, yeah, it makes a lot of sense.
Hey, buddy.
God, wait till we get to C#. It's gonna put this
I
to
know.
shame.
You guys are going to like cry at the fact of how easy C# is. Give me a warning. Incompatible NS string. Hey, buddy.
Hey, buddy.
So, we got a warning, but it worked. And the warning is that it's incompatible pointer type sending an NS string to a parameter of type NS attributed string. So what this wants you to do, because, you know, whatever, it wants you to create an NS attributed string value and use this. And then, but we're just going to put up with the warning for the sake of this example. We don't want to like
Brian's putting up with a warning?
I know. So we don't want to like overly confuse you. There's a reason that they do that, but we won't get into it. So another thing too that I think is good to learn when you're doing just starting out with user interfaces and stuff is it's also good to learn how to fire an alert. And this is like a little hidden, and it's not necessarily recommended that you do this. But I'd say for testing purposes, I think this is perfectly fair game. So there's a NS function called NSRunAlertPanel, and we'll pass it wibit.net. And then we'll pass it, our message format. We'll say, we'll just pass it some, hey, buddy. Hey, buddy.
Hey, buddy.
And then the next value is going to be the name on the default button. And since we don't really have like a OK versus a close, I mean, it's just an alert, we're just going to say close. And then the alternate button, we're not really worried about, so we'll just nil. And then the other button and other parameters, so just nil. It's fine. So this will give us a little hey buddy alert pop-up as well as set the text field.
Nice.
And sometimes I find it's useful, especially if you're like, is this firing? Did I actually wire it correctly? Right. Like, why is it when I'm clicking on this image?
Is this method executing?
Yeah, exactly.
Right.
So sometimes when you're like working with views and overriding views and trying to figure out what's firing what, sometimes it's convenient to just have like a little alert pop up and be like, I don't know, say something like, hey, buddy!
Hey, buddy!
So I think it's a useful little trick. I hope you like it. That's a very quick, down and dirty rundown of how to... actually, let me just show you this too. If we just close this, like Kevin was saying, this simple app is still running.
Mm-hmm.
So if we go down to our dock, we'll see the simple app is still running. We have to right-click and quit it. So just to review, we went to the interface builder. We dragged some objects on here, a label, a text field, and a button. And then we wired it up with our header with using an outlet and an action, which is the IB outlet and IB action keywords. And in our implementation, on our click action implementation, which had automatically kind of like blocked this out for us and gave us our text field setters and getters if we wanted to use it that way, we called text field set attributed string value to change the contents of the text field. And then we've called this NS run alert panel. And the reason we have this is because we called outlet on it.
Mm-hmm.
If we didn't do the outlet connection, we wouldn't have access to text field this way. And we can call this anything that we want. So I hope you enjoyed that. I hope that gave you a pretty clear and straightforward run up into, okay, I've got some objects wired up and I can do some things. And now from here, you can just start kind of exploring the objects and that are available to you. And you can start implementing your own, model classes, however you want, and whatever you want it to do. And, the world is your Rockefeller oyster.
Welcome back, guys. So, we've been kind of hitting the Objective-C stuff, Xcode stuff kind of hard. Kind of graduating from a hey buddy to the memory leak, to the random number, to the fuzzy, to the Simple OSX App. Now, we're going to take you guys on a journey of building a basic iPhone application.
So our condolences, and hopefully this won't be too painful.
Hopefully.
The thing with building an iPhone user interface is its default structure is a little more complicated than the default structure of, like, let's say a C# graphical user interface application. So we saw the process of the Simple OSX app. If you haven't, look at it. This is not exactly the same, but kind of along the same vein. But the structure is a little different, as we'll see. So we're going to create a new project.
Let's do it.
We'll just, why talk about it anymore? We'll just jump in there.
What? Oh!
Application.
What kind of application are we going to build, Brian?
For this first simple one, let's just do a view-based application.
A view-based?
Yep. So it's basically just a program that has a view.
All right.
And we'll see that.
I can handle that. Okay.
All right, so let's call it a simple iPhone app.
Like a this?
Yep.
Awesome.
So the device family is the iPhone, and if you drop that selection down, you can do the iPad.
Right.
At least that's the base device family. Like, you obviously can have the same application run on both, but that's kind of a different approach.
All right, we'll save it in our hard drive.
Oh yeah, and then we'll just run this default application and see what it gives us. Now you can see that right off the bat, the supported device orientations is just portrait, landscape left, and landscape right, which is fine. And you also have the app icons, one the normal one, and then the retina display one. And so, and then you have launch images down below for like splash screens and stuff like that. So just like in the OSX application, you kind of have this summary view to be able to set up, that type of information.
Right. Some of the basic stuff, right?
And you can get to that when you click on the project on the top of the folder view. So let's run this and see what it looks like.
All right, let's do it.
So this should be just a blank view as the application.
Hey, I got to get a taller screen. We have carrier here.
Yeah.
And my battery is full, which is unlike my real iPhone right now. So this is it.
So this is the gray default view. So you could like drag it up and down, and you're dragging the thing.
I can hit the home button, and it goes back here. Then I can get on Safari.
Yep.
And I can go to porn sites.
Exactly.
All that kind of.
Yep.
Sorry. Anyways, this is the iPhone simulator for those of you guys that don't know what this is.
So this is where our programs will run out of.
Nice. Yep. Okay.
Isn't that cool?
All right, let's get out of here.
So also, if, before we quit out of here, if you go to the hardware menu,
okay,
let's go to device.
Alrighty.
And iPad, iPhone, or iPhone Retina, we have the option of.
All right. What does iPad do?
So iPad will bring up like a little iPad.
Wow. Ooh.
Isn't that crazy?
It disappeared.
Oh, maybe we just clicked. There we go.
Nice.
So, isn't that funny?
That is funny.
So we can also run even our iPhone apps on the iPad if we choose to.
And we could also go to Game Center, and we can play. I'm sorry, what? Wait, there's no like. There we go. Cool. There are games. Nice.
All right. So let's break out of here, and we'll.
Are you sure you don't want to play a game real quick?
Angry Birds is pretty feeling.
Okay, I'm sorry. All right. No. That was a joke. The internet works and it doesn't work.
Well, I can't launch the App Store like that.
All right. Quit the simulator. Nice. Okay. Sorry about that little tangent there. All right.
Okay, so we'll go back to our folder view, and you'll see here right off the bat, we have our app delegate like we had before. But now we have our view controller and the view controller's zip file. So this contains the view itself, as you can see. And on the top right, when you see the breadcrumbs, this goes simple iPhone, zip file, English language, and then view. So now we're looking at the view, and this is also highlighted on the left with this view indicator. Mm-hmm. So this is the view. We're going to add objects to the view and set properties on the view. And then this is the view controller. So this is the controller now. And then our model would be whatever we bring in to be the model class. So this is where we, right off the bat, instantly see that the structure of even the default product templates are incorporated with this model view controller view. And then obviously you still have the main window and the app delegate as like the root class, but we won't worry about that quite yet. So let's just make a simple application. So we're going to go down to the so you can see here the main window contains the view, the simple iPhone app view controller. Mm-hmm. So we go down to that other view, the simple app view controller zip file, and we're going to click on the reveal the right panel for our inspector tools. And now we got some stuff. So let's drag a label on there.
All right, we'll drag a label.
And we'll call it like Wibbit.net.
Oh, nice.
And we can just double click it to go to the editing mode. Wibbit.net.
All right.
Okay, we'll click off of there. And then click on the view itself.
All right.
And then go to the attributes. And then see where the background drop down is. We'll select that background drop down.
Right here?
Yep.
All right.
And say like other.
Other. I can do that.
And let's do like a light green, like a wibbity light green. Maybe closer to the center. A little closer, up a little bit, a little more towards yellow. A little to the yellow, a little down, a little down, a little down, a little down. Keep going. Right there. Beautiful.
Right there?
Yep.
That's a whipped green?
That's a whipped green.
Nice.
There we go. I don't know.
Cool, so we have a whipped
Now
green.
it is. Sweet. Anyway, we just changed the background color.
Oh, hey.
Okay, so now let's add let's do the same kind of thing we did before. Let's just add a text field.
All right.
So we'll scroll down in this objects list and we'll drag this text field on there.
Right, now these text fields are different, I think, right? These aren't the same.
Right, so in OS X we have the NS text field.
Mm-hmm.
In iPhone and iPad, it's like the UI text field.
Right. Different object.
Yep. Maybe just drag the right side of that in a little bit.
Yeah,
so
I
it's
didn't quite see that. All right.
Okay, so now let's add a button. So if we scroll down, we'll have like a little. There's probably a little.
I think there were some up here.
Round
right?
and direct button. Perfect.
This guy here.
Yep. Let's drag that in.
All right.
And just put that maybe in the centered.
In the center.
Let's actually center all these because it's going to be iPhone-y. So keep going to the right a little bit, and then you probably want that button to be a little wider too.
I will. Hold on, I'm getting there. So you want this center too?
Yep.
What kind of a lame app are you making me make here, dude?
And the label should be centered. Should all be centered. There we go. We'll center that thing.
All right, now this guy, we're going to make him a little wider. Maybe too wide.
Cool.
But that's fine. Okay.
All right. So we'll double click on the button and say, click for action. Sweet.
Very nice.
Okay, so now we have our label, we have our text field, and we have our button. And let's drag the button up a little bit because in case we click on that field, the keyboard's going to slide up from the bottom.
All right.
Okay. So let's...
Hold on. I got to see this real quick.
Okay, cool. Sounds good.
Simple is already running. Stop it. Here it comes. Here comes the $1 billion iPhone app. Oh, look at that. Click for action. Awesome. Okay, I'm sorry. I had to see it. All right, what's next, Brian?
Okay. So let's have it where we can basically, we'll type something in the text box, and then we'll click the button, and a little alert pop up will have the contents of the text field.
Okay,
How's that
sounds
sound?
great.
Cool. Okay, so let's hide our inspector panel on the right,
All right, goodbye.
and let's go to tuxedo mode,
Tuxedo mode.
or penguin mode, whatever
Penguin.
you want to call it. Okay, so this now connects us to the header file of our view controller.
Yes.
So now we want to right drag the text field.
Okay, hold on. Let me get my little... All right, so the text field.
So we're going to right drag the text field, and poof,
Nice. Okay. Right click on the text field.
and drag it
Yep.
into there. Right,
Right there?
exactly. Yep. And we're going to insert an outlet, and we'll call it simple text field.
That's called text field.
We'll just call it text field. And that's a UI text field. So we'll hit connect. That connects that up, and now we'll right drag our button.
To here.
Yep. And then that's going to be an action
Okay,
instead of an outlet. Button action.
how about button click?
Okay.
Because we're doing a click event.
Or it's actually a touch up event, but whatever.
Touch what?
Button touch up, because we don't click on an iPhone, you know.
Oh.
So the event is touch up inside. So if you click on the event drop down,
Mm-hmm.
you can see we have some other options.
Right.
If you want to do different kind of gestures or whatever
Mhm.
the case is.
Right.
So anyway, we'll just touch up inside, and the arguments is going to be the sender. Okay, so that'll all automatically go and build out the framework and our implementation file as well.
Keep in mind that when we dragged this guy over here, we made an outlet for him that was treated like a property. But then the actions, which is common in almost every single graphical framework you'll use, comes in as a method. So this will be acting as when the action occurs, we execute this method right here.
Right. So let's go to our implementation file and just wire up some functionality. So let's go to our implementation file and just wire up some functionality.
I'm going to get rid of penguin mode.
Yep, absolutely.
Sorry.
So just click on the one on the left, like the standard view. Yep.
Here we go.
Sometimes it makes you feel dumb using it.
So here's the touch-up method here.
Okay, so inside of that,
and the text field synthesize is put here.
Okay, so let's create a NS string inside of our click button action.
All right, we can do that. I'm gonna make some space.
Button touch-up action. I mean, sorry.
Our button feel up. Our button grope.
Yeah, there we go. That's what we should have called it.
Oh, you said NS string?
Yep, and we'll just call it like str or something.
Okay.
And then we'll alloc and then init with format.
You want to alloc it?
Yep.
All right. Which means we what, Brian?
Have to release it because we own it.
I own you.
Init with format, and then we'll do NS string, and then we'll just say like message : and then %@. Yep.
Oh, why did I do that? All right.
And then our next parameter will be text message.text, so without brackets. So in the iPhone world, which hopefully this won't like blow your mind, .text. Yep. So in the iPhone world, you have properties like this on the UI text field object. So they kind of NS text field was built beforehand, right? Before this was. So as they improved, they also kind of improved on usability a little bit as well. So you have access to properties like this, which I find way more convenient.
Right.
Okay, so now we're going to create a new view, and it's going to be a UI alert view. So we'll do UI alert view, and it's going to be a pointer to, we'll just call it alert view.
All right.
Okay, and that's going to be equal to, and we're going to alloc and init it as well. View, alloc, and then init with title.
Okay.
And then our title is going to be and we'll say like wibbit.net alert.
All right.
And then the message text label, and then we're going to pass it string as the message.
All right, so it's going to be
like
str, right?
Yep. Mm-hmm. Okay. And then our delegate is just going to be self. So then our cancel button title will just be like @close, NS string close.
All right.
And then other button titles we'll just put to nil.
Nil. Right.
Close that off, and then perfect. Beautiful. Okay, so now we have this UI alert view, and then, of course, because we init it, we need to release it.
Otherwise, 45 megabytes later, your system will explode.
So in between that, all we have to do now is just say alert view show. And that will do the, you'll recognize the alert right away. A lot of applications use the alert view. So when we run this and click it, you'll see it like instantly.
Okay.
So let's just run it, and then we'll type something into the text field.
Okay. It rocks. Right?
Yep.
So then we touch this?
Yep.
Hey!
Isn't that cool? So you recognize these alerts. I'm sure you've seen these modal pop-ups all the time. So that's the UI alert view.
Nice.
Yeah, and so showing that brings that to the screen. So that's a very
So I gotta treat it like it's my own iPhone. I gotta keep my processes closed. Sorry, it's instinct at this point. They have me brainwashed. What the fuck am I doing here?
I think you just changed the language to Japanese.
I did?
I don't know.
What did I just do?
Who knows? So that's a basic, straightforward example of just like quickly having the view instantiate, add some objects, making the outlet and the action, tying them together, doing something.
Right.
And that's it.
Is that it?
That's it.
All right.
See you guys.
So, Brian, we've gone through this progression here. We've built a simple iPhone app. Now, what's the next progression?
Okay, so the first one was just a UI view. Just like you launch an app, it has a view. We put a couple things in it. So the next one after that, we should probably look at is the navigation app with the navigation view. This is really predominant in a lot of like utility applications for the iPhone.
Yeah.
So like if you use like the IMDb app or like Fandango or something, like you click something, it slides you to the next view.
Right.
You do whatever, you can hit the back button on the top left, it'll slide you back to the first view. So we'll show you how to kind of work within that infrastructure and swap the views out.
Okay.
Because it seems like it would be a very simple thing to do, but it's not only is it not self-evident, it's not clearly described for somebody new on the internet that I found in a very simple way. Just like with the user interface stuff in the last one, that's not so clearly articulated on the internet. People like overcomplicate things, I should say. So we want to just take a very clean and simple view of the navigation view.
All right. Let's do it.
So let's create a new project. In this project type, instead of a view-based application, will be a navigation-based application.
Holy monkey.
And you can see the little icon that they use has that back button on it with like a little table grid underneath. So they're kind of showing you that structure anyway.
All right. So next, then what do you want to call this app, Brian?
iPhone Navigator. I don't know.
This sounds like a drama movie. The iPhone Navigator. Friday in theaters.
Yeah, I don't like that name, but it doesn't really matter.
Well, then by all means, what do you want to
Let's
call
call it Navi.
Navi?
Navi app.
No way. iPhone Navigator is better than Navi. All right. Well,
How about Navigator View?
Navigator.
No, see, because calling it View gets confusing because then you have the controller view.
Navigator app.
Yeah, there we go.
All right.
Yay!
Boy, sometimes half the battle is choosing a name.
Just like if you're in a band.
Yeah, I was gonna say, those of you that have friends in bands have this issue all the time.
So what we're started with is we have our main window like we had before, and now we have our root view controller, and that's what we get started with. So if we go to our root view controller, it looks just like the one that we had before, except that it's not in a view that's sized for the phone. It's in a grid view or a table view.
Mm-hmm.
So what's interesting about this is you would never see the data that you will use in the interface builder.
Right.
So the interface builder is always just going to have this kind of like representative data in it. And so we'll show you a basic example of how to add data to a cell and how to display it and how to have an on-click event on this. So that's the root view controller. So in order to go to another view, we need to create a second view as well.
Okay.
So let's add a second view controller, and we'll actually just call it second view controller. So we'll do file, new
file?
New file, yep. And this is going to be in iOS Cocoa Touch, and it's going to be a UI view controller subclass.
This fella here.
Yep. Because
iOS Cocoa Touch.
Yep. So it'll effectively be a UI view. So it is a subclass of a UI view controller.
Mm-hmm.
It's not targeted for the iPad.
Right.
And we will want it with a zip file for the user interface.
Nice.
So we'll hit next. So we'll call this second view controller.
It describes perfectly what it is.
Okay. So let's go to our zip file.
All right, so the second zip file?
Yep.
All
and
right.
we'll throw a label on here that says, like, view 2.
All right, so on the right guy here, this fella here, we're going to scroll down here to the label text, and we'll throw this in the middle, because Brian likes things centered. Is it going to hook in the middle, or do I have to, like, guess? Ooh, I did hit it. I got to change anyways.
Yeah.
What's it? Second
view.
Second view.
There we go.
Now that sounds like the name of a drama, like a teen drama on like FX or something.
View. Lifetime.
Yeah, Lifetime. Yeah.
It's like somebody had a near-death experience or something. Okay. So that's all we're going to use this view for, is just as like a placeholder to show that we loaded a second view. So that's all we're going to do with this. So if we go back to our root view,
All right, the root view zib.
we know that this is basically a, just this table view. And our implementation for the root view controller,
it's rootviewcontroller.m, right?
Yep. We'll go to view did load.
Okay, view did load.
Now, this is going to blow your mind. Not in a good way. Okay, let's run this application.
All right, run it.
Yep. Okay, so this is all we have, basically, right? And if you drag up and down on that table view, you'll kind of see that you're like scrolling and bouncing and moving up and down. Okay, so that's all we have. We never show any path of or loading the second view controller. It's just our main window loads, and then inside of it loads the root view controller. So let's quit the simulator. And the first thing that we want to do is we want to, if you go to the header of the root view controller, you'll see that we're subclassing the UI table view controller. So keep in mind that we're extending that. So let's go back to the implementation file, and we will override a method.
Okay.
And let's make sure that we don't already have it declared or anything. It's called number of sections in table view method.
Number of sections in table view. So
this will return 1 because we only want one section. And then we have number of rows in section, and this returns 0. Scroll up right there. Stop. Yep. Number of rows in section.
Okay.
Yep. So now we want to change this to return 1 instead. And this is for the table. It's part of the controller, and that will mean that we'll actually have 1 row returned.
Okay.
So it's a little weird, but that'll actually create 1 cell for this table.
So I say 1 here.
Yep, exactly.
Okay.
Now we go to cell for row at index path.
Cell for row at index path with is a overload of the table view method here.
Right. This returns an index path, and it does something for that cell. So generally speaking, we always have this cell identifier as a cell, and then we create a new UI table view cell, and it's called cell. Now this is all default, comes with the project. And then we call the table view and DQ reusable cell with identifier, the cell identifier as a cell, right? And so that creates, basically it just instantiates a cell. And if the cell is null, then we alloc and init it with a style, and I'll release it. So all this is basically doing is just creating a cell and then returning the cell at some index. And we can do something on the index based on how we want to interact with this. So here's what we'll do. So we know that we return numbers of rows in section. For every row, we're going to generate a cell and return a cell. So we're only doing this once. So what we'll say is right before it says configure the cell, we'll just set the cell text to something.
Okay.
So it's going to be cell.textLabel, because we're in iPhone land, we can use the properties, and we can do this inside brackets, because we're actually going to call something on the text label.
Okay. All right. So cell.textLabel,
Yep.
so we're
calling
the property.
Right, so we're revoking the property and then calling something on that, what that property returns, and that's going to be setText. So we're going to call setText, and then we're going to just do like, hey, buddy.
Hey, buddy.
Cool. All right. So that's going to set the text of one of the cells, and we're only returning one, to some text, right? So let's run that and see how that looks.
Okay. Hey, buddy.
Awesome.
Hey, buddy.
Awesome. So now we go to did select row at index path. So that was cell for row at index path. And now this view already has baked into it the did select, here we are, did select row at index path. So this is kind of like the action saying that we did select a row. And then it passes us the index, right? So what we want to say here is we can actually just delete this auto stuff that we don't need any of that. We'll just cut that.
Okay.
When we select this, we want to instantiate a view, our second view, and we want to push that view and move to it, right? So we need to be able to instantiate that view in this root viewer controller class. So let's jump back to the header file. And inside of our interface definition, we'll create an object, second view controller. So we'll create an instance of our second view controller. Okay, so in order to create that, we need to import our second view controller class.
Okay.
And then we'll declare that as a field, second view controller, and we'll just do a pointer view second view controller.
Okay.
All right, and then we're going to make a property.
Okay.
So we're going to make this as a property. We'll property non-atomic retain, and this is of type second view control. That's yep. And then of type second view controller. And then we'll just do same name, the pointer view second view controller. View second view controller. Okay.
You actually don't have to do this.
There you go. I think you're right.
So since we're synthesizing that, we shouldn't have to define that inside of our fields. So
Okay.
let's see where this goes. So in the M file, we're going to synthesize that, right?
Yep. So at the top, we'll just synthesize.
So scroll
that second.
through inside of the implementation declaration.
Yep. Synthesize.
Synthesize, and the property was
View second view controller.
view second view controller.
Oh, we spelled the second row. Maybe we can fix that.
I spelled it wrong here then.
Yeah.
Second. I literally said second.
Hooked on phonics works for somebody.
Yeah. Not me. All right, so we synthesized this.
All right. Cool. So now we go back to our.
Let me just double check to make sure that works. I think yeah. Okay. Cool.
All right. So let's go down to where we selected a row. So it's did select row. At
Did select
path.
row at index path.
Yep. All right. So let's go down to where we selected a row. So it's did select row. At
Did
index
select
path.
row at index path.
Yep. So we'll say if, and then because this is a property, self dot, probably redundant, but
Yeah,
we'll
we
just
don't
say
have to do that,
self
but-
dot view second view controller.
Yeah.
equals null, equal null, nil. Sorry.
Mm-hmm.
And then, so if that's the case, and then we'll open a block, and we'll instantiate this.
Which it will when we first start it. So,
so we'll create a new second view controller, and we'll call it pointer to view. Second view controller.
Okay.
And then we'll make a pointer. We'll just call PTR to view.
PTR view?
To view.
Okay.
Equals, and then we'll alloc init it.
Okay.
And then instead of init, we'll do init with nib name.
Okay.
And then it's an NS string that will be second view controller, all uppercase first letters.
Which is the name of this nib file right here.
Is that Pascal case or camel case? I can't remember.
By definition, it's camel case.
Okay, so,
anyone
bundle,
that tells you differently is just trying to be an asshole.
So the bundle is going to be the bundle we'll call in brackets NS bundle main bundle. The NS bundle main bundle is the central project path bundle location, basically.
So it like points to where the resources for the application are, like the directory, I guess, of where everything is.
Right.
Yeah. Okay, Brian. Are we gonna set this equal to that?
So now we're gonna set the our self after. Yep. Exactly. We're gonna set that to the pointer. Yep.
You know, we could just put that there.
Okay, let's do that then.
We could do one of these jobbies. Save ourselves the extra work.
Fair enough.
Fair enough, Jenny.
Okay, and then so after this if statement, we want to just push this view, right?
Sure.
So if it's not nil, it'll
make one
exist,
right?
And if it is nil, it'll make one, right?
Mm-hmm.
So what we want to say is in brackets, we want to pass a selected object to the new view controller. So we say self dot navigation controller. So the navigation controller is the actual navigation bar that comes with this project.
Okay.
So the navigation bar on the top of the screen that has the back button and everything,
mm-hmm.
That's this object.
Okay.
So we're going to call the method push view controller.
Okay.
And that'll be self.view second view controller.
Okay.
And animated is yes.
Okay.
And we'll close
animated is what? It's
yes.
Yes.
And that's it. So that will push our view. So let's run this application and see what happens.
Okay. So I have Hey Buddy.
Yep. So now if we click Hey Buddy, it will go to the second view. Now, what's interesting is there's no back button.
I can't go back.
Okay, now this is going to make you angry. I can promise you this will make you angry. So let's quit the iPhone simulator and let's add the back button.
Okay.
All right, so let's scroll to the top.
All the way to the top?
Yeah.
Okay.
You're going to like this. I'm excited for you to see this. So we go to View Did Load.
View Did Load.
Yep, pretty normal place to add a back button, wouldn't you say?
Sure, why not?
Okay. So let's add a title.
So this is after super?
Yeah, so after super.
Okay.
So we'll just add a title.
Okay.
So we'll say self.title without the brackets.
That's right.
Self.title equals, and then an NS string wibbit.net.
Okay.
All right. Now run it.
I don't like the look on your face, Brian.
Okay, now click Hey Buddy.
All right.
And we have a back button.
Okay.
That's how you add a back button.
Yeah,
yeah, exactly.
That doesn't make any sense.
Yeah.
That's kind of dumb.
Kind of.
I mean, it's easy. It's just not like intuitive.
And I guess the argument is you need a title for it to say what you're going back to. I don't know. But what if you just want it to say back? We'll find out about that later.
All right. Now what?
So that's it. That's basically, in a nutshell, a to the bones, basic, one cell on the default table, click it does something, and you can go back, it has a title.
Yep.
So that's basically the structure of how you interact with the navigation view application. All right, so when I started learning this, I found myself in a circumstance where I just wanted to draw something on a view, basically, long story short.
Right.
Let's say like you have a sparkline or like a graph or a, I don't know, like a dot or something, just anything.
A circle, a square, yeah.
Whatever.
Yeah.
I basically just I needed to draw something on a view, and it was not clear. People were saying how to show the objects and how to like interact with visor objects and rectangles and stuff. That's all fine. Like I had no problem with that, but I was like, how do I actually like get it on the view, you know? So I want to show you how to do that in like a clear straight shot path as best as I can explain it so that you don't have the same kind of headache that I had. Because I don't think that it's an intuitive approach. And I don't know if it's supposed to be an intuitive approach either. But it is what it is, and documentation tends to assume that you know what I'm going to show you first. So once you go through this and you figure this piece out, then once you get into documentation about like the mechanics of drawing, you'll be golden. But without knowing this little link piece that we're going to show you, you'll be a little lost. So let's create a project.
All right.
We'll just create like a view-based iPhone application.
Okay.
And we'll call this iPhone Draw on View.
Okay.
Okay. Create it there. It's perfect. Okay. So the way this works is, so you know we have our UI view, and that comes with the application. What we need to have is we actually need to extend the UI view object and overload a method called drawRect.
Okay.
Okay. So let's create a new class.
Make a new class?
Yep.
All right.
And this is going to be an Objective-C class.
Okay.
Right next. And this is going to be a subclass of UI view. Right.
Okay.
So, right. And then we're going to call this like my custom view.
All right.
So now we're extending the UI view.
Here we go. Down here.
Okay. We're going to keep this as simple as humanly possible. So here we have init with frame, and then the dealloc. And in between those, we have this commented out section called only override drawRect if performing custom drawing. So let's override that to perform custom drawing.
All right, so we'll pull these out.
Yep. And so this drawRect method, when this view is drawn, this will fire, and the rect is the size of the view. So here's what we're going to do. All we're going to do is create a UI Bezier path object, and we'll call it a circle. All drawing objects on the iPhone are Bezier. Sorry, I'm probably saying that wrong. Bezier paths. A Bezier path is like if you've ever used Illustrator and used the pen tool, and you kind of like click a point and then drag, and it makes like the little handle for the curved line. And you click another point and the handle for the curved line, and it makes like the lines and drawings and stuff. Or like if you're using like Visio, and you have like a circle, and you have like you have the circle, and you have like the little dot on the top, bottom, left, and right, and you can kind of drag them to like stretch it out or stretch it tall ways. That's essentially like a Bezier path. So that's what we're going to be using to draw anything in iPhone.
Okay.
So the type of object is a UI Bezier path object, and it's obviously extends NSObjects. So we'll just call it like UI Bezier is how you spell Bezier. So if you want to look up about Bezier paths, you can, and then path.
Like that?
Yep. So that's the object, and it's going to be, we'll just do a pointer circle. And that's going to be equal to...
It autocomplete didn't catch that, so...
Yeah, so we'll build this as soon as we're done to make sure that's okay.
Well, actually, we can just do this.
Let me actually go to my custom view.h, the header file, and let's make sure, we got the UI kit, so we should be okay. So let's see if that builds. Just unused, but that's okay.
Huh, interesting.
Yeah, it is.
All right.
Okay, so that's going to be equal to, and not, instead of alloc init, this is going to be on the class level. It's a UI Bezier path.
I'm not going to mess it. Okay.
And then we'll call it the method is Bezier path with oval in rect. So Bezier path with oval in rect colon. And now this is a built-in function called CGRectMake. And at a lower level on the drawing side, we have these like CG functions and stuff. So this will return us a rectangle object, basically. And so our points are going to be, and this is going to be basically the dimensions of the circle. 110, comma, and these are sizes fitting to an iPhone screen. 175, 100, 100.
Okay.
And because of the nature of a Bezier path, this will, well, you'll see what happens. So then we'll block this off, and then we'll say, so here's what's weird. What we're going to do is we're going to call left bracket circle space fill right bracket. So we're going to call the fill method on circle.
Okay, circle fill.
Yep. And then close the brackets, and that's it. So what this will actually do is this will realize that it's in an extended view. It will realize that it's instantiated inside of this view and that it's inside of the drawRect method, and it will draw this by calling fill in its declaration, in its creation, to the view, which is kind of a strange concept to get used to. So that's all we're going to do. We just want to basically just draw the circle to the view.
Okay.
And it seems like you would want to say, self.draw on, pass it the circle or something like that, but it doesn't work that way. It's kind of backwards from what you may be used to. So we'll click on our view controller zip file, and we'll select this view, and we'll bring up our inspector.
Okay.
So we'll just kind of click on the background and then go to our inspector.
Fella.
Nope, that's the source code tire together.
I knew that.
Yep, there we go. So we click on the view, so we know that the view is selected, and then we go to our properties here. Okay, so now we're in our view controller with our view and our interface builder nib file, and what we're going to do is you can see the default class that this is coming from is the UI view class. So if we click on the drop down, we can now go to my custom view. Whoops, whoa, a little scroll crazy, all the way at the top. My custom view.
Mm-hmm.
So now, because we extended the UI view, we didn't really do much to it. The only thing we really changed, it seems like it's empty, but it's everything that the UI view has. In addition, we've overloaded the drawRect method, right? So that's our custom view. So now we're saying that this view in the interface builder is coming from, is extending from, is inheriting my custom view now. Is that good?
Yeah.
So that's what it takes to draw on the screen. So now if we run this, and we could put a label on this view if you want, just to kind of show that it's still perfectly fine. So we'll put a label on there and say wibbit.net.
Okay. Wibbit.net.
Yep. Okay.
And then run this?
And now it works. Now the center thing works. Okay, yeah, run that. It builds, it's successful, the thing launches, it comes up, and what do you know? We got a circle on there.
Huh, interesting.
Isn't that strange?
That's very strange.
So it didn't think it was going to work, did you?
No. That's weird.
I know.
That's really weird.
So by instantiating the object inside of the extended class of the UI, and this is why in the lectures we spent so much time talking about, class inheritance and that as like a fundamental concept of like the app universe and app building. So we extended the UI view class, and we created my custom view, as we see, and now that did not have a nib file with it. Like, we didn't create a view controller class.
Right.
We only extended the UI view class, and then we tied that into the interface builder on our view controller, which usually just uses the view of UI view, but in this case, it uses our custom view.
Okay.
So if we go back and we change the parameters, it'll change the size of the circle, where we can make crazy paths, we can make little spark lines or graphs or graphing calculators, whatever we want to do. So, in a nutshell, if you need to draw on a view, you can do that. Also keep in mind that things like a UI text field or a UI button are subclasses of a UI view as well. So just as like a little hint, you can also overload stuff on those in a very similar sort of a way.
Right.
Thanks for watching.
Hey, Brian.
Yeah, but I was just talking. I was just talking to Wibbit the frog.
I like how Brian's always he's like half burnt, but I start talking to what, Kevin? What was that? We're about to do something incredibly amazing.
Yeah,
and this is how we're going to start it. I know that we've been kind of looking at Xcode and the fun, sexy things that you can do with this language and with the Apple development. But what are we going to do with this one?
We're not going to use any of those things.
At least in the beginning, right?
Yeah.
Because what we want to do is we want to gradually move you up into developing an application that integrates with the controller code, right? The controller code?
Yeah, the view controller. So, so what we want to do is developing an iPhone app, especially for somebody who hasn't done it before, really kind of sucks.
Yeah.
And like there's a lot of weird obstacles. The documentation is very convoluted, makes assumptions that you know certain things.
And people are kind of assholes.
Yeah.
Yep.
So what we want to do is we really just want to like march you through from text editor and we're going to build our model class, make sure it works on a command line, We're going to then build it for the OSX so that you can see what that environment is like and how you can make a Mac app. And then from there, we'll make it again on the iPhone, so you can kind of see the difference between Coca and the OSX versus iOS.
Right, but at the same time, you're still interacting with the base code.
Exactly. So the base code we write here will stay the same. So we thought, well, what's like a simple example that will kind of use a lot of these concepts, but won't kind of overwhelm you as like a lab.
Right.
So what we're going to implement is Wibbit.net TicTacToe.
Yes!
The most awesome edition of TicTacToe you could ever possibly imagine.
But before we actually add the Wibbit.net component, we're actually just going to be going over a basic tic-tac-toe algorithm.
Right.
And if you think about how the tic-tac-toe game works, it's fairly simple. And there's tons of ways that you can do it. This is just how Brian and I conceived the idea, and it works very well. It isn't the greatest, but it's the best because we did it. So, as we would always do, we're going to be starting with 3 code files, which is going to be our H file. So the first file we're going to work with is we'll go to the Wibbit.net drive, and we'll make a folder called TicTacToe. Is that right?
I couldn't have said it better myself.
And you didn't. So inside of the TicTacToe folder, we'll have
TicTacToe.h.
.h.
Uh-huh.
And then this little guy here.
This will be the implementation file.
So in the drive, TicTacToe, TicTacToe.m, save.
Cool. And then last but not least is the driver.
Yeah. Save as.
Don't call me baby driver, want on a better wheels. I hit the road and I'm gone. No.
TicTacToe driver. I have no idea what you're talking about.
Paul Simon?
No clue.
All right.
No. Inside of here, we're going to import the
TicTacToe.m.
TicTacToe.m. That's how you spell it, right?
Yeah.
Okay. And we'll just kind of like devise the board in a little while, but right now, it's all about the logic, baby. So let's define the header file, Brian.
Okie dokie.
So let's define the header file, Brian.
Okie dokie. First things first. Import foundation.
Yes.
Foundation.
Foundation.
Foundation.h.
Nice, Brian.
What is this, like a French?
This is a French tutorial.
This is a foundation.
Foundation.
You start of this, Mr. Mime.
Mr. Mime. Where did that come from? Didn't you just like bust that out one day? Interface declaration, Brian.
So we're going to make a class, naturally. An interface, TicTacToe.
Yeah.
That's why we called it TicTacToe.h.
Yeah, right. Yeah, it makes sense.
This is going to extend as all things Objective-C and NSObjects.
Beautiful. And
we've got our curlies. Okay, and more importantly, we have our end.
Yes.
Yeah? Right?
Yes.
Cool. Awesome. Sweet. Private. So we're going to have a couple privates.
Right.
We're going to have a TicTacToe grid. We're going to have a counter of how many moves have happened. And we're going to have like an identifier of who won.
Right. Now the grid, Brian, when you start thinking about when you play the game of tic-tac-toe, it's just a pound symbol. There's 3, 3, and 3. Right? So we're going to have a 2-dimensional array of rows, columns 3 and rows 3.
Correct.
Beautiful.
Total of 9 cells.
And we're also going to be using an integer, an NS integer, and this is just going to increment every time that a move has occurred. And the benefit of keeping track of this is if it's mod 2, we know that it's, either X or O that's running. So we can keep track of whose turn it currently is just by keeping track of this number.
Right. So in that case, we'll call it move count. Yeah?
Yes. And lastly, we're going to have a global variable that's going to store a character value of who the winner is. And it's either going to be X, O, or blank if it's nobody, or a D if the game is over and it's been a draw.
Right. Precisely. Okay, so what do we want to implement here? We want probably override init.
Why not? That sounds like fun.
Okay, and then after that?
How about a reset button?
Sounds good.
So it's like it's the 80s arcade game. So it's like the NES.
Nice.
You hit the reset button and it falls in that infinite loop. You know how it like... You never had that happen?
Yeah. How about this?
All right. Yeah, blow on cartridge. Blow on cartridge true. Yes. So what if we want to have a method here, Brian, that returns whose turn it currently is?
Perfect.
That sounds good.
And what's next?
Is that correct? Is it who or is it whose?
Probably whose.
Yeah. Now we want to get the value at a position. So the position is going to be a column in a row. So get value at column, NS integer, col or column, whatever, and row, same thing.
The second label, NS, and you guys know what's going on here. We don't have to tell you.
I hope so.
You're experts by this point. And if not, what the hell were you doing the whole time? We were explaining this to you.
How about make move, Brian?
Make move at column.
So if you could imagine so far what we have, the get value at column is going to return to you the character that is sitting at that particular index.
Right.
Within that two-dimensional grid.
Yeah.
Then the make move is basically, you can almost think of it like I've pointed or I've clicked or I've touched something, and that specific row and column is where I want to make my move.
Right, so if you're player 1 and you click the top left,
you get an X.
You would make move at column 0, row 0.
Right. And we'll also have a condition where if you do that and then the following player does the same thing, we have to handle that because they can't make a move that you've already made.
I also want to put in a who is winner.
Yes, why not?
Okay.
There's the header file.
That's that.
So on the
right.
implementation, in the implementation, Brian, let's do our if define end if. So that way, in case somebody else in the world makes a TicTacToe class, it doesn't interfere with ours.
Those bastards.
Alright, so we've protected our class from being instantiated multiple times. Now let's declare, well, first let's import the TicTacToe.h that we just wrote.
Cool, I like it.
And then let's do it at implementation TicTacToe.
A what? An implementation?
Implementation.
TicTacToe, bitches.
Yeah, and then do an end after that. So we can just copy the declarations from the .h file over there.
Absolutely.
We can be lazy, sexy programmers.
Hell yeah. Call that shit.
Yeah, it's a waste of my time.
And my mind. Okay, init.
Right.
Let's just kick it.
So what we're going to do in init first is we're going to set self equal to super init, but we can also encase this inside of an if statement.
Ah. Oh, because it evaluates.
Yeah. So let's do if.
Okay.
And then if not.
Not something else.
If not self equals super init.
Okay, so we're going to evaluate some other condition in here. I'll just make a little space for it.
Yeah, so
we'll say self
equals super init.
Equals super init.
Right. And then
cool.
If we do that, and we could either return nil. Let's just return nil. So if it fails, return nil. So we return nil. Now, if the super init was successful, then we're going to just kind of reset the board. So we'll do that later. So we can just call self reset.
And we have the method reset down below, you see.
Yeah. Right. Awesome. And then return self, and there's your init method. Cool.
Okay, so now that we called reset, let's implement the bastard.
Nice. Now reset should be easy, Brian. We were going to set the move count to 0 because if we've restarted the game...
There's been no moves.
There's been no moves.
Easy enough.
And the winner is going to equal blank, which is going to be just...
Because there's no winner
There's
anymore.
no winner. So, exactly. Perfect.
Okay, cool.
And now we're going to go through a two-dimensional grid here, and then just kind of set each element equal to 32, which is the same thing as a space. Right.
Awesome. Okay. So we want NS integer.
Yeah. I, comma, j. Awesome.
Okay, so we got an I and a j since it's going to be a nested for loop. Yep. So for I, 0, I... Whoa!
Whoa!
2 alligators just tried to have sex. I plus plus.
Are you gonna move that guy? Wait.
Whoa.
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 Okay.
A little Joey Lawrence action for you.
J is 0, while J is less than 3.
Yeah.
J what? Minus minus? No.
Oh.
All right. Plus plus.
Now, since we declared this grid as an NS integer, Brian, let's just set each element equal to 32.
TTT grid.
I think so.
You know what TTT reminds me of?
What?
Total Recall. When he walked into the bar.
I don't remember that. What? TTT?
There's an alien that had 3 boobs.
Oh, okay, I got you.
I don't know. Okay, whatever. Shut up. Okay, cool. So
nice.
that effectively resets the board.
So we have reset the move count, we have removed if there was a winner, which when we first instantiate there's not, and we have set the grid equal to the integer of 32 in every single space.
Yep. Okay, so now let's determine whose turn it is.
This is going to be a really tough one, Brian. You may want to.
Aren't they always?
You may want to go a little slow here.
Okay.
If move counts.
Okay, so if the number of times we've done an action.
Right, mod 2.
Okay, so if it's an even number.
Right.
Return.
Oh!
Okay, so that's character 0 for the second
That's
player.
O, not 0.
I mean, character O for the
capital
second,
O,
yeah,
right.
for the second player.
Right.
Otherwise, if it's an odd number, like the first move or whatever, we'll just return X.
Right. So
Awesome.
the reason why this works, Brian, is because we set move count equal to 0 in the beginning, which is mod 2, right?
Yes.
Right? Yeah.
Oh, yeah.
So if mod 2, the first time that we run this, mod 2 is going to be 0, that's going to evaluate that false, which means that it will be returned X. And then when it's 1, mod 2 will then evaluate to 1, which is true. So then it will return O.
So it's a little like a double negative because returning 0 is even, but that's false, so it's sort of flipped. But anyway, you get the idea.
Yeah.
Okay, so now let's get value at column. So now let's get value at column.
Now, get value at column is just basically going to first check to see if the number column and the number row that we sent is inside the bounds of our list.
Oh, yeah, because that would suck.
Right, and if it's not, we're going to throw an exception. And then if it is, what we're going to do is we're going to switch on that value and then just basically return what it is. So the first thing we'll do, Brian, is if the column is greater than 2, which means it's outside the bounds of our array.
Okay.
Or if column is less than 0, which means that it's outside, going the other direction.
Right.
Or, and then this is going to be one evaluation, so parenthesis out that one. I don't know if you have to, but, or if, row is greater, actually, it's fine. Actually, that evaluates cleanly. Because if any of those are true, we want this to bail. Or if the same thing is true for row.
It would be like this.
Wow. That's a lot of, Brian likes parentheses. Row is greater than 2, or row is less than 0.
And we'll see what we can get rid of after this.
We can get rid of the outer ones, because each one of these can be treated unique.
Okay.
So you can either get rid of the outer ones, actually, you know what? No, put it back. It'll be less expensive for us to remove the innards. Remove the innards. That'll work. Not that one. The one that's up to gets the call 0. Go over one left. Remove that one. And the first one there. And
because or has a different operation than less than, greater than. Has different
priority. Those will still be evaluated separately.
Cool.
We'll do the same thing for row.
I like it.
So this first condition is if we are not inside of our little fun, sexy array. Then what we're going to do, Brian, is we're going to raise an exception. No, you can put that back.
No. Yeah. Okay.
You're good.
Awesome. All right.
So, and you don't have to block this off because we're going to have one expression. It's going to be an NS exception, and we're going to call the class level access or static method called raise. And we're going to raise the exception, and we're going to call the exception, and this is our choice. It's going to be an NS string. It's going to be TicTacToe out of range exception. It's my exception. I do what I want. And then we're going to call the label format. Let me bring this down to the next line so it's not so scary and weird looking.
Format?
And the format's just going to be an NS string that says cell is out of range. And we're not going to put any format characters, Brian, so we don't have to put the comma delimited list, so we can just end it right there.
Nice.
So if you give us something that's out of range, your program's going to crash unless you catch the exception. Now what do we do, Brian?
All right, so now let's see. This is get value at column. So we basically want to get the number that's at that position and basically interpret it into a character and return some shit. So
okay,
let's do a switch on the index that we're referring to. So that's our total recall grid.
Nice.
And that's going to be because this is we're going to have to just
you don't have to do that.
Yep. Column row. So we're going to switch on. So the column and row that we pass in, what is the value at that location? And we're going to switch on it. So in the case that it's, what's the X? 88?
Yeah.
We're going to return X.
And look at your ASCII chart if you don't know what we're doing here.
In case of ASCII character 79, we're going to return a big O.
Yeah.
Remember Big O and Duke?
I do, yeah.
And then the default...
Dukes is still on the radio. He does.
Really?
But he does sports talk for the Washington Redskins.
That's too bad.
What? It's entertaining. I listen to it.
You would.
He does it. LeVar Arrington does it too with him.
So if it's any other value in that grid position, we're just going to return nobody's turn.
Right.
Okay. So that's that. So let's now
let's make a move.
Okay.
Let's make a move.
Okay. Cool. Let's make a move.
I'm gonna make a move on your mom. Yeah.
Yeah. Okay. You're right.
What's up, Mrs. Bryan? How are you? You look delicious this evening. So let's do a condition, Brian. Let's check to see who is winner. Now, we have not defined that method yet, but we will next.
Right.
So
let's down below.
Right. Let's evaluate self. So self is going to be the receiver, and we're going to pass the message who is winner. So we're calling that method. And if the winner is not equal to blank,
then we got a problem.
Then we have a problem.
Well, we're just going to throw an exception.
Because you've made a move after the game is over.
Yeah.
Right. So the exception, we're going to do an NS exception. Call the raise method.
Raise it.
And we'll call it a TicTacToe set exception. And the format that we're going to send is going to be an NS string that just simply says game over.
Game over.
I feel like I'm in an arcade.
Yeah, I know, right?
Don't you? Yeah. So game over.
Okay, cool.
Now let's do an else if. Now let's check to see that if we're fine, the game is still going on, but you've selected something that somebody else, including yourself, you or the other player, have previously set. So else if, and we'll just do the self, we'll evaluate against self, the get value at column, which we defined above.
I like it.
And we're going to pass it call and row. And if that does not equal
blank.
Yeah.
Sweet. Awesome.
Yeah, and we'll do the same thing. You can probably just copy the code in NS exception. And this is also going to be a TicTacToe NS set exception, but we'll have a different message to send. And the message is going to be a cell is already valued. And now I don't know what to do. I'm lost.
Oh.
So maybe Brian.
Okay. Well, let's see. So if the winner exists, then it's game over, and that's the exception. Otherwise, if the position is not blank, then we already valued
okay, we've made our checks, right?
Yeah,
so now we can actually do the movement.
We're looking to make the move. So we want to set the position we're referring to be equal to the numerical ASCII value of the character of whose turn it is.
Sure, that sounds good.
Cool.
That sounds great.
Okay, so the grid in position, XY column. Okay, so column row is equal to, and all we're gonna do is say self whose turn. Remember when we implemented that one?
Nice, awesome.
And because that's a NS integer type, it's just gonna jam it in there as an integer, basically. Okay, so because that's a character it returns. Move count ++.
Nice.
We made a move, so we increment it.
And now the next player's move is next. I like it. I like it.
Yes. And so
let's evaluate the self who is winner. Because what that's going to do is that we'll set that winner flag if a winner has been if this move that you made is the winning move, we're going to set that winner flag.
Okay. Okay. So now let's go implement that so that we make sure that happens.
Because remember now, Brian, we did set that winner flag. Now what this is going to do is this is a multi-purpose method.
Right.
The first execution is we can actually run this return nothing, but just kind of determine who the winner is and set that flag. But somebody can call this on their own will and invoke this. So you don't have, this is gonna work in a couple of ways. We're gonna have to check to see if that winner flag is equal to nothing, right?
So if the winner flag is not equal to blank,
right,
then we'll just return what the winner is.
Right.
Because we know that there is a winner, let's just return it.
Now, Brian, if there is no winner, let's check to see if there is a winner. So we're gonna scan the grid for the pattern, which, as you know, Brian, in TicTacToe, you basically have the whole top row, the middle row, the bottom row, the left column, the middle column, the right column, and then diagonal left to right, diagonal right to left.
Right.
Those are all the combinations for a winner in TicTacToe.
Okay, so let's say step 1, check diagonals. And then step 2 will be check
the rest. Check rows and columns.
Check castle moves.
Okay. So a simple way to check diagonals, now you could actually craftily write a for loop to do this, but since we're dealing with such a small data set, there's really no point of putting ourselves through that. So let's just have a conditional if statement that will evaluate this.
Okay.
So we'll just
kind of like manually do it basically.
Right. Because if we had if this was the game of life, I would argue for a better algorithm.
Or any other game, but TicTacToe.
TicTacToe is just such a simple, why make it more complicated?
Right.
So let's do,
we don't want to lose you in that detail.
Let's check the upper left corner of the grid, which is going to be the 0, 0.
Okay. So if that's equal to.
All right. If that is equal to 1, 1, which is the center cell, so that's going down 1.
Okay.
Going over 1 column, going down 1 row, which is the center cell. So if the upper left is equal to the center and the upper left is equal to the bottom right, then what we've done, Brian, is we've checked, we know at this point that every single value from the upper left, middle, and right is the same. So if we can evaluate that...
Sorry for having the thing fly off the screen.
Yeah, just move that down, make it look nice. Take that whole condition down,
gotcha.
yeah. So and
we'll
then bring that down.
And then this.
Mm-hmm.
Okay.
So if those are all equal, and it is not equal to blank.
Right.
So that means they're all the same and they're all equal to an X or equal to an O.
Okay.
So and grid 0, 0 does not equal blank.
So let me just think about these parentheses here. We probably
got it. Well,
probably
okay.
don't need this one and this one just to keep it clean because these parentheses are going to get out of hand.
Yeah, that's true.
Okay. So it's basically like this or this.
And you could put this other condition inside of this too if you want.
And then we say or.
No. You got one other to do. You want to do another and.
Oh, I understand. Okay.
So and this is going to be the grid 0, 0 does not equal space.
Right. Because otherwise,
and we can just
stretch that out a little bit.
Yeah, stretch it out just a little more like your mom. Sorry.
Okay.
Nice.
So if because if the top left is blank, then obviously the whole thing's flawed. So
right, but at least we know they're all equal. So let's say, Brian, this condition fails. Now let's do an or statement, and let's do the exact same thing, going from the upper right to the bottom left.
Okay. So we should be able to take this from here to here.
Absolutely.
And we're just going to evaluate the opposite diagonal, essentially.
Yep.
And then close the parenthesis.
Absolutely.
So in this case, it's going to be 2, 0. The 1, 1, which is the center.
Which is the center.
And the upper right box
Yep.
to the lower left, which is 0, 2.
Right. Exactly.
Yep. So long as 2, 0 is not blank in this case.
Perfect.
Okay.
So we've done, if either one of these conditions are true, we have a winner. And the winner is the person in the center, because in both conditions, that value is going to be in the middle.
Oh yeah, good point.
Yeah.
That works out well.
Yep.
Okay, so so that's going to be TTT grid 1, 1.
Yep. That's not bad.
No.
I kind of like that. It's really simple.
That's okay. I like it. Now we'll just return the winner and we're done.
The wiener.
Okay.
Now, Brian,
Step 2.
Now we have to go scan for the straight line. So we're going to look left and right, and we're going to look up and down.
Okay.
Now, Brian,
Step 2.
Now we have to go scan for the straight line. So we're going to look left and right, and we're going to look up and down.
Okay.
Now, you could write a more sophisticated algorithm that does sub-nesting for, like, the for loops, but again, we're dealing with such a small data set, why do that?
Okay.
So ours is going to be a little simpler. So we're going to do an NS integer I and j, and you can set that to 0, but you don't have to.
Yeah. Okay, so so we want to iterate basically like once going down, and we'll check everything over every time.
But here's what we're also going to do, Brian. We're going to go down, and we're going to check. We're going to take that upper corner cell, and first we're going to check across and then down from that cell. So then when we go to the second one, we're going to go to the second row. We're going to check the second row and the second column.
Right.
Then the third one, we got to check the third
So
row
we're basically
and
going to
the third
evaluate
column.
up, down, and left, right for diagonally upper left to bottom right.
Yes.
Right.
Right.
Okay. So
for that, Brian, all we have to do is iterate through one for loop that goes
Right.
the length of the array.
nice. It's cool. It's classy.
Yeah, it's not bad. You stay classy, San Diego. So, Brian, let's check the first condition, which is going to be checking from... Which one is that?
So that'll be our current position
Right.
sub 0. If that's equal to the current position sub 1. Right. So if it's this is equal to basically grid sub I 2 now, and we check that.
Right.
And obviously we don't want the grid I sub 0 to be blank.
Right.
Okay, cool.
Cool, and if that happens, we have a wiener. And we set the wiener equal to the upper left corner, which is going to be I0.
TTT grid sub I sub 0.
And then return the wiener.
Is that a sweaty wiener?
Of course, it's a fetchy wiener. All right, else if, Brian. So now that we've gone through and we've checked to make sure that the current row is or is not the wiener, let's check the column for that position.
Okay. So it's going to be kind of like a sideways view of what we just did.
Yep. It's the opposite of what we did, really.
Right.
So instead of I0, it's 0I.
So it's kind of flipping it on its side, so to speak.
One eye. Sleep with one eye open. No? Metallica? No? Alright. Sorry. Gripping your pillow tight. Enter Sandman, dude.
Yeah, I know what it is. I'm just acting like I don't. Because Metallica's freaking.
Hey! You're stupid.
Okay. So that flips it sideways.
Yep. So now we can set the wiener, in this case, equal to the grid 0 sub I, or sub 0 sub I, whatever you want to, however your brain functions, we don't really care. Nice. So we're setting that equal to the current cell the first cell that we evaluated.
Cool. Okay.
Now, if we make it through this, Brian, and we don't have a winner, we can also have one other condition.
A draw or a tie.
Correct.
Okay, so let's just do basically, if any cell is not blank, we got a problem.
Right.
So we can just iterate through, see if one's blank, that means that we'll just return who the winner is. Like
Right, and the winner should be nothing.
Exactly.
If you get down this far, the winner's going to be blank.
So for I is 0, so long as I is less than 3, I plus plus, and then inside here for J is 0, so long as J is less than 3, J plus plus. Can you have like a 4-column tic-tac-toe? Is that?
I suppose you can expand
or like
the
a
algorithm.
20-column tic-tac-toe?
Sure, why not?
How boring of a game would that be?
That would be horribly boring.
I guess that's basically Connect 4.
Hey, I like Connect 4. Hey, you're right, it is Connect 4. Yeah.
Isn't that weird?
Except for in the tic-tac-toe version, you have to go all the way across, not just have 4 in a row.
Yeah.
Yeah.
Interesting. Because it would be too much to have to go all the way across. You'd always get blocked.
Yeah.
Okay, so we iterate through. If we ever find a case where there's a blank, we just return the winner, which is blank. Right. Otherwise, if we never made it down here, it's a draw. And that concludes the implementation. So now let's drive this fucker and test it out.
All right, Brian, if I'm going to implement this, I'm going to have some part of my code that shows me the data, because this class is not designed to show you the data. It's just the logic for the game.
Exactly, just like it should be.
Right. Now, actually, before we get involved in any of that mess, let's make sure that we have a compilation that's going to work here.
Okay.
So I think we saved this on the Wibbit.net drive, which is going to be in our volumes.
Wibbit.net.
It should just, oh yeah, you're right. Wibbit.net/TicTacToe.
Right.
We should do a GCC.
GCC, motherfucker.
Dash Objective-C.
Objective-C.
And then we'll do the input file, which should be what it's TicTacToe driver.m dash o TicTacToe driver. All right. Let's see what we got error-wise. Awesome.
Hey, we got some problems.
I wonder if hold on, Brian. Let me put that framework switch in there. See what that does.
Foundation. Framework. Foundation.
All right. Well, that did it.
Hey, cool.
So now we have. Oh my goodness, we typed that without a single syntax error.
Whoa! Do you believe that?
All right. TicTacToe driver. Hey, not bad. All right. So when we go to Text Wrangler, Brian, the first thing that I'm going to do, the very first thing, is I'm going to extend using a category, the TicTacToe class, because, like we were saying a second ago, it just contains the logic.
Yeah. Now
our program is going to implement that.
Right.
And we're going to do that by extending it using a category.
And one of the things that we really want to know is, what are we looking at?
Yep. So let's make an interface called TicTacToe, which is the exact same name as the interface that we're putting a category on. And the category is going to be called printGrid.
Nice. And that's the category, not like a method name or anything.
Right, right.
And if you don't remember, go back to categories.
And this is going to have a void method called printGrid.
Cool. So that's the extended category extension.
Yep. So now inside of here, we'll also just do an implementation. Implementation of TicTacToe.
And then category printGrid.
PrintGrid.
Cool.
All right. And then all we're going to do, Brian, is we're going to define what a printGrid method would do in our console-based application.
Nice. Okay, so I say we clear it, and then just do it old school with the little for loops.
We can do that. So let's do a system clear.
This goes back to this is like first programs in C++ kind of thing when you're like.
So we're going to go on the command line, and we're going to call the clear command, which is just going to clear the screen. And now let's do a for I equals 0.
Okay.
While I is less than 3, which is going to be the size of the grid, I++.
Cool. Okay, and then inside that,
we'll
do another for, yep. So we got a nested, so we're kind of going through every cell.
Mm-hmm. But in this case, it's going to be J.
Yeah. Okay, and then for every one of these, we'll just kind of print some stuff. Print out the cell value.
So I'm going to do a printf here.
Okay. And
inside of this printf, we're going to do a left bracket and a,
nice. I like
%C for that character.
Yeah, character representation.
And then like 3 spaces or something.
Nice.
And what we're going to do is, inside, or the parameter that we're going to pass is we're going to go inside of self, because remember, Brian, we're working inside of the instance of TicTacToe.
Right, because it's a category. We're extending.
We want to get the value. And the value method that we designed is, if you go back to the H file, we have a get value at column and row. So then if we go back to the driver code, we can just kind of put this in here, and let's make it not look so scary. So we'll get the column, and we'll get the row. So the column is going to be, actually I can just pull this up here. The column is going to be what? I?
Yep. And the row is J?
And the row is going to be...
Absolutely.
J. And we should have successfully evaluated that with a parenthesis here to end that off.
And then after this, let's do a new line.
Okay.
Because that will end every outer for loop.
Right.
And then we'll do another new line after this for loop to end the entire little block.
Wow. That's crazy.
Nice.
Printf \n. All right. Is that all we're gonna do?
That's it. Let's do it. Let's print it out and see what the deal is.
Let's do a compilation first, just to make sure. Oh my goodness, are
man.
we on fire? Are we on fire? All right, Brian. So let's go down to the main function and let's actually start to put this code together.
How about auto release pool for funsies?
Okay, we can do that. So we'll do an NS auto release pool.
Yep. I always thought release should be capitalized.
Yeah, if you're gonna, it's kind of stupid.
Whatever. It's consistently inconsistent.
Yeah, the Apple framework is very consistently inconsistent. So we're going to call new, which just calls alloc init automatically, and then we're going to flush the toilet. So we're going to call new, which just calls alloc init automatically, and then we're going to flush the toilet. We're going to drain the poo.
That's more like cherry bomb in the toilet, I guess.
Nice.
Anyway.
Now what?
Okay, let's, well, we have our TicTacToe class, so let's create an instance.
Oh, nice. Cool. TicTacToe.
We'll do TTT.
TTT equals. And we can call alloc init, but I'm going to just do the same thing as before because it's, to me, I like using new. If you're just going to call alloc init, save yourself some time.
So then TTT will print grid, and we'll just see what we're looking at.
Yeah, and that's also, for good memory management, we'll release TTT. Or we can call auto-release, but whatever. We'll just do that. Alright, so now that we have that, Brian.
Okay.
You want to call TTT print grid.
Yeah, I want to see if that category works. Does it even do anything?
Which, remember, folks, it's a category, so it's not part of the class that we wrote, but we extended that using a category.
That we wrote.
That we wrote. So if we run the program...
Yes!
Hey!
There's a TicTacToe board.
Holy crap, that's awesome!
All right.
Now we have to put some more logic in here so that you and I can actually play the game.
So let's do an old school game loop.
A game loop, exactly. So TicTacToe, while TicTacToe who is winner,
who dis,
who dat equals blank.
Right. Means there's no winner.
Right. So while there is no winner, the game shall go on.
The game must go on.
All right, Brian. Now what do we do?
All right, so let's define a column and a row.
Okay.
Because we're gonna be using that.
Nice column and row.
Okay, and let's use a good old-fashioned label.
Okay. What do you want to call the label?
Restart turn.
Okay. So this label can be used in the event that somebody inputs incorrect data, like the cell that they're trying to value is outside the range, or the cell that they're trying to value has already previously been valued.
Right.
Right. Awesome. Now what do I do?
Let's print out whose turn it is.
Okay. And I guess a printf would suffice.
Oh, yeah.
So the printf, we could do a little format. So C''S, which is going to be the return value, the character value.
Right. So that'll be like X's turn.
Right. And then we'll do row space column to kind of guide the user's input.
Yeah, cool.
And then the value that we're going to pass the printf is going to be TTT, whose turn. Whose turn. Okay, I can probably do that.
Perfect.
Like this?
Yep.
Like that?
Yeah.
All right. So then we're gonna grab input from the user using scanf, right?
Yeah, it's easy.
And then scanf is going to be taking in 2%D, %D, and this is going to be the memory location of row and the memory location of column.
Yeah.
And hopefully we don't have an issue with the NS integer, but we'll see. Actually, we can just test this right now.
So just switch the little modulus with an ampersand.
Yeah. Who do you think you is, Brianna? All right, compile.
Oh.
Yeah, see the warnings. Let's see if we have a problem. So it's like 10.
So it'll take whatever we give it.
Right. So that's fine. Even though we get those warnings, I'm going to try to keep it that way because it's Objective-C, so sort of. So Control C to break out.
Okay.
Now what?
Let's see. So how about this? If the column is -1 or the row is -1, then we'll break.
Oh, so that's like somebody quitting the game.
Yeah.
Right. So if the column equals -1 or the row equals -1.
Hey, it's a console game, people.
Right.
Screw off.
What do you think this is, huh?
Do you want to be here for 5 hours while we implement like every little cool menu feature?
Right.
Probably not. Okay, so since we're dealing with the exception handling,
remember like screen development, like back in the DOS days when you would make programs with
I'd
like
spend
screens?
forever with like menu ASCII art and crap.
Oh man, and like a lot of like you can get those APIs where you could like import like the text files.
I remember that.
Those were good times.
Yeah.
And you could also, some of them had like the macros where you would specify a file and it would like compile that in the code, and they were crazy stuff back in the day.
Okay, so let's do a little try catch in case an exception happens when we make a move.
What's funny is we're not very old, but we reminisce about programming back in the 1980s as if we were there.
Well, because
we weren't there, but we remember.
I'd say probably around like early 90s. I was definitely like starting on the 80s stuff.
Maybe.
You know what I mean?
Well, maybe because you and I just chose to go back that far. We didn't start with
because we were kids. We obviously weren't like cutting edge.
Right. Yeah.
So we had like all the hand-me-down books, which had like a 5-year tech lag, you know?
Oh yeah, 5 year if you're lucky.
Yeah. Yeah, right.
Anyway, I'm sorry, you said a try catch, right?
Well, and also, like, what computer were we able to play on?
Yeah.
Like the shitty old computer that Dad got from work, you know?
Yeah, like
they were going to throw away.
Like the Tandy or the Commodore with like...
the dumpster dive Tandy.
Right, like, they were going to throw it away at work, and your dad was like, I'll take it.
Yeah, and then we tried to, like, open it up, and I remember... whatever, I digress. Okay, so try catch.
We had some fun childhoods with computers, no question. Anyways, try catch.
So let's try to make a move.
All right, so we're going to make a move on Brian's mom, and we're going to see if she rejects us,
so
which is not bloody likely. Make move
at points.
It's going to be at column, right?
Yep.
Let's go back to the H file.
So it's column and row.
Make COLUMN.
Okay.
Make move at column. Yep. The column is going to be COL.
Yeah.
And row, and that's going to be row.
Colon.
Your mom.
It's colon.
I know. Your mom I'm making a move on your mom's colon.
Okay, and then, so we'll throw an exception, and we'll just use, like, the normal, plain old NS exception.
Yeah, so we'll do, like, the printf. Oh, yeah, you're right. Like, right here it'll be NS.
Yeah.
Exception, like, EX, and that's going to be a pointer, right?
Absolutely.
All right.
It's funny, like, we put the pointers in different places, and we also use brackets differently. Did you notice that?
There's a lot of things we do differently.
Yeah.
I only do this when I'm in like Unix for some reason. I always use the like when I'm in Windows. I don't do this.
Right.
But for some reason, when I'm writing an Objective-C, sometimes Perl, TCL, of course, syntactically forces you to do that. In Java, I like to use these. Although it's not I like to. I feel like I'm obligated to.
There's a lot of ways to do stuff. Like you know, I like tight brackets. You like loose brackets. I like girls.
I like gorillas.
Alright, printf.
But I like girl gorillas.
How about error? Let's just throw error.
Come on, Eminem. Error. And then how about like a little percent
S, yeah, new line. Awesome.
And the error is going to be what?
The exception reason.
Okay. EX reason, which is an NS string, and we're just going to go ahead and pull out the C string.
The depreciated C string.
The depreciated, which it can go suck
I appreciate.
Yeah, I appreciate
the C string. Okay, so if that's caught after we print it, let's just go to restart turn and try this again.
Wow.
Yeah.
I knew he put that label there for a reason. Do you mind if I just compile this to see? I like catching errors a little earlier on. So, it looks good.
It's depreciated.
Let's do a -W.
There's actually another. We can actually do like a UTF string instead of C string that's not depreciated, but I don't really care about that.
Yeah, I don't care either. If you don't care about it, why'd you bring it up? Obviously,
I'm just noting it. Well, because in later labs we'll use it.
Then we'll learn that later labs.
Okay,
Brian.
so let's just print the grid out after every.
See, I like this C string because when we wrote the Whippet string, we used that same method name, so it makes me look. It makes me happy, like knowing where we came from.
Yeah,
exactly.
And all of this. Yeah, I can see
makes
that.
Me so happy. All right, so now, Brian,
we'll print the grid.
Holy monkey! And this is the print grid that we extended.
And now, don't forget, once we break out of this while loop.
Right.
That means we have a winner.
We have a winner, or the person quit the program.
Well, true.
So maybe instead of break here, we should do a return.
There you go.
Yeah,
good point.
So now, once we've gotten here,
that's true.
We have a winner.
All right, so let's just we'll just like print that we have a winner.
All right, we have a wiener. All right, we're gonna use print fart,
and then once we do this, we're gonna have a Kevin versus Brian showdown. Just like Grandmaster Flash, the Furious 5 versus the Sugar Hill Gang.
Who won that one?
Grandmaster Flash, the Furious 5.
Yeah, I would imagine.
Yeah.
And
so we got two little ditties in there. Perfect.
Hop.
Wop.
All right. You think we can give this a try?
Yeah. Let's try playing it.
All right.
So long as there's no errors.
Yeah, let's do that. Let's do that. Let's do the error check real quick. All right, I got the -W to remove warnings. Okay, now let's just do a practice run before we actually do the showdown. Okay, so X's turn, row column. Brian, pick a row column.
I'm going to start in the middle.
All right, you always start in the middle. Okay, great. Why do I got to be O? I mean, that's so like demasculating to be O. All right, I'm going to go to the left upper corner.
Okay.
All right.
I'm going to go to the bottom corner.
Okay.
No, that's not the bottom corner. No, that was the bottom corner.
Yeah, because we reversed it for the user.
Oh, it's upper right.
Yeah.
Okay, anyway.
We gave it the user's benefit.
That's
now,
right.
Brian, what I'm going to do now is I'm going to go to the middle, where you are.
Okay.
Cell is already valued. Okay, now I'm going to go
spot.
100 and -5 billion trillion. Cell is out of range.
Nice.
Awesome. So now I'm going to go to row, let's go to row 1, and I'm going to go to column 0, so that should be...
Bad move, buddy.
Oh.
Bad move. Ready for this? I am the champion, my friends.
All right, that game was a practice. Let's do it again. I'm X this time. And I'm going to do middle.
Oh, bastard. Let's see here. Okay.
All right, so row...
All right, so you're up.
Is that backwards? Because you put in 2-0.
Yeah. Row 2, column 0. No, actually it is backwards.
It is backwards.
Yeah. We found a defect.
Yeah, so that's a logic error, and it's Brian's logic.
Oh.
Let's see what we did.
How about just say call row on whose turn?
But we're passing what the person sent as row column.
Ooh.
Right? The person said I want row this, column this, and we're passing column and we're passing row. Do we have the code in the back end mixed up maybe?
Maybe. Let's check it out.
Let's go look. Let's go look at the make move at index. We're passing column and row.
Where is that row column? Okay, so let's look at our make move at column.
Yeah. I think we have a little bit of a backwards thing here. So what Brian and I did is this row column. So we're looking at that switch statement first at the get value at column. We're going to call it row column instead of column row. And then we're going to do the same thing down here.
Right.
To row column.
Yep.
And that should be good.
And even though a two-dimensional array is all in how you implement it, we'll just try to keep it aligned to be the textbook.
Right.
You know.
Because I row, J column.
Right,
so
right,
now
right.
this should be functional. Row, column, at column, and row. Okay. Now
let's try that.
Let's try it again. So this should be more consistent and behave more like we would want it to. So Brian, let's see if you can catch that
so
upper right.
I want 0, 1 is going to be top left.
No, that's going to be middle, top middle. So you want 0, 2 is going to be upper right.
Oh, yeah.
If
Okay,
if
0,
this is,
2. Nice.
So what we just got is we got column 0, row 2. So what's backwards
We just
now?
turned it like 90 degrees.
Column 0, row 0.
I think we only wanted to change one of the...
Well, we only changed it one. We changed the 2 references in the backend code. So this is it the printing? What do we have? What is backwards? Why is this backwards? Row, column, whose turn? And even though this is backwards, if we come up here, row, column, that's consistent.
Yeah.
And then here,
column and row.
oh, look, we have this backwards. Look, this has to be J, because we said column and row.
Oh, yeah.
J and I.
Right.
Now, Brian, try to hit that upper right corner.
Okay.
So it's all in how we're, well.
Yeah, it always goes back to how you want to be consistent with how you want to implement it.
All right, now hit that upper right.
Oh, 2.
Yeah!
All right.
So I'm going to do row 1 and then column 2, which will be right below you.
Okay. And then I'm going to do 0, 1.
All right, and then I'm going to do 0, 0 because I'm not going to let it go that easy this time.
And I'm going to say 0, 2. Oh!
Oh, you've already got
How
it.
about
Value.
2, 0?
All right, Brian. So then I'm going to do 1 and 1.
Okay. And I'm going to do...
So I definitely blocked you.
0 and 1?
Oh, boo.
How about...
It's going to be 1, 0, I think.
Yeah, I'll try 1, 0. Okay.
All right. So, I mean, this is going to end in a draw.
Oh.
So what I'm going to do is...
So let's say you do 2, 1.
Yeah. So I'm going to go down 2, and then I'm going to hit 1. So I'm going to hit that.
Okay, and I'll do 2, 2.
All right. Now the game ended in a draw. Now our code is a little bit jacked up because it says D is the winner.
Well, it's not jacked. It's just...
Yeah. It should check if the winner is D, the game is a draw.
Right. But we just want to make sure that our model class is functioning properly. And
so
it is.
What we've done, Brian, is we proved that we can get a winner. Before we walk out of here, let's check all the different conditions. So if we do 0, which we can do this rather quickly. If we do 0, 0, right, and then we'll do, what is this? Row 1, 0 for O, and then 1, 1, 1, 1, and then 2, 2. No, I don't want 2, 2.
1, 2, 0.
2, 0, and then 2, 2. We
So
have
our diagonal works.
right. The one diagonal works, and then we do row 0, 2, and then 0, 0, and then 1, 1, and then
0, 1.
0, 1, and then
2, 0.
2, 0.
Cool.
The 2 diagonals work.
What about along the bottom? Because I think we already tested the top row.
Did we?
Yep.
Along the bottom is going to be 0, 2,
That's okay. You can just have O in.
1. Okay. And that's going to
So
be
2,
what?
0.
2, 0,
And
0,
then-
0.
Yep. And then,
And then 2,
2,
1. And then 0, 1. And then
2, 2. Oh! Well, it still tested it.
You know what,
cool.
Brian? Let's just trust the fact that this works
it's
because we'll have more opportunities to test it in the graphical application
Absolutely.
anyway.
So thanks for watching.
Yep.
I know you can't wait. Next up, we're going to use the same
Did
model
you say
class.
next up?
So we're going to use the same model class that we just wrote here, but we're going to kind of consume it with a controller and a view in a Mac OSX application.
Nice.
Yep.
All right, Brian. Let's make history here. You guys remember that in the no? All right.
That was a little epic. Let's make history. It's going to be the first time somebody's ever done a video tutorial of Xcode.
Well, the history is this is the first time someone's done a Mac OS app tutorial while drinking out of a Whippet.net coffee mug, like I am right now.
I need to order.
So I am making history. As you guys recall, in our last video, what we did was we built a tic-tac-toe algorithm. So inside of the Whippet.net drive that we've been kind of building these projects in, there's a folder called tic-tac-toe, and you guys remember us building this. So here's the logic that we're going to implement now inside of a Mac OS X application.
Awesome. And if you've watched the previous labs, we went through like a simple OSX interface. This is going to use a lot of those concepts and then extend on them.
Right.
So let's just kind of orient ourselves and then jump right in.
All right. The first thing to look at, Brian, is you made us some nice little pictures here for the app.
Yeah.
So, just real quick, Brian, what are these pictures and what are we going to use them for?
Okay, so the grid on the bottom left is like the stage. So that's where you would like play tic-tac-toe. Like if you play with your friends, you take a piece of paper, you draw this grid on a paper, and then you start mixing like X,
like a pound,
O,
the
X,
pound symbol. Yeah.
So that's like the grid, which is going to be kind of the background.
I like how it looks like you drew it. Like someone drew it with a marker or something.
And then we have an X and an O for player 1 and player 2, and it's going to be the frog versus the fly. So when the player whose turn it is will be awake, and the players whose turn it is not will be asleep.
Ah, nice.
There's also this blank PNG. When neither the X or the O has been selected, I'm going to put that view to just be a blank image.
Right.
So we'll just clear it out.
Right.
And the reason they're PNGs is because they support alpha layer transparency. So, like a CompuServe GIF file, when you have transparencies, it's actually like some freaky color you choose not to use.
Right, yeah.
And you identify which color that is, and that's your transparent color. So your transparency either on or off.
Mm-hmm.
But because there's an alpha channel in a PNG file, it's not just on or off, it's how on is this pixel and how off is that pixel. So you can have like really smooth transparencies in the background. PNGs are a really nice file format.
Pretty awesome. One of my favorites.
Yep.
So you guys obviously don't have to make these images. We'll provide these images for you. And the first thing we're going to do is get started with Xcode and start building our project.
All right.
All right. So we'll just make a new project.
Yep. And as you could imagine, this is going to be a Mac OSX application, Cocoa application.
I can imagine a circumstance you build.
Okay, let's call it TicTacToe App.
Okay. TicTacToe App. In one word.
Perfect.
Like that?
Beautiful. Look at that. And the App Store category, we'll call it like...
Puzzle game?
Puzzle game. There you go.
Awesome.
And we're not document-based, no core data, no unit tests.
All right, so just next.
Nope. And we also don't need a local Git repository for this project, so we can uncheck that.
This guy here?
Yep, there you go.
All right, so we're on the Wibbit.net drive that we've been working out of, and we'll just create.
Beautiful. Nice.
Beautiful. Very, very attractive, Brian. Now let's run our program, and we'll call it a day. Well, one thing, Brian, when I first look at this app, and I start to look at my dock, I notice that there is a standard Coca application icon.
Ooh.
But I know for us, we want to do something cool, like Xcode has it, you know, this system, whatever, iTunes. We want to have our own little icon here.
Yeah.
And with
like transparent and stuff.
With Xcode or with Mac programming, there's a separate application that we're going to use to do that.
Yeah. So let's add. Actually, let's just go make the icon right now.
Yeah, why not?
Cool. So let's minimize this.
All right.
And we're going to go to our developer folder on our root drive.
All right. So we'll go to Mac, which is my root partition.
Right. So that might be like internal HD or Macintosh HD or whatever and then the developer folder, and then applications, and this is where Xcode like natively sits.
Right.
You know, we have a shortcut, but this is naturally where Xcode is. And then under utilities folder, there's app icon creator.
The icon composer.
The icon composer.
Yeah, you were kind of close.
Yes. The app icon creator.
Oh, I thought it was a baby bottle, but it's glue.
Oh, yeah. That's kind of hokey.
All right, so now that we have the composer up, Brian, on this side of the screen, we're going to put this up, and then we're going to pull up our icons over here.
Yeah, look at the clipboard view app icon. How crappy is that? Go back to this icons. The developer utilities.
Yeah.
Look at that clipboard view icon. What is this, like Windows 95?
Oh, wow.
Yeah, what the hell is that? It's got like a little dark gradient back
like
there.
A genie.
Yeah, it is it's terrible. It's horrible. The application loader icon's nice looking. But look at that clipboard viewer, though. Good God. Scroll down a little bit. Is there any other ones? Yeah, those are all
The rest of them are right.
Yeah, but man, that's a bad one. Apple, you should update your clipboard viewer icon. That thing's just sad.
So let's just pick, since we didn't design an app icon, Brian, for this project.
We'll just grab one of the characters.
Yeah, so let's just grab the frog.
Okay.
And he'll be the icon.
And so we're going to drag it. If you notice on this icon composer application, we can just drag it into these squares. So you have the 512 pixel square, which is more for like, you know, big format, retina display, app store. And then you have 256 for like other devices, the iPad icon. And then you have 128, which is a more standard size, 32 and 16-bit. So it's just like different.
Or 16 pixels,
16
width.
Pixel, yeah, thank you. So it's just kind of like different circumstances that you would have the different sizes. And it packages all of those separate scaled image files into a package And on Mac, I think it's ICNS is the file format, something like that. And that will create like your Mac icon file format type.
Mm-hmm.
And once this is loaded, you'll notice on the bottom left, there's images, masks, and preview. And one of the things that you can do is you can inspect your mask layer to make sure that your transparencies are working okay. And then we can preview it.
All right,
So we'll select masks, and you can see that the frog is the black is opaque, and the not black is transparent. So we can see that our alpha channel is perfectly fine. And if we preview this, we can see him over a checkerboard, and he's not like slightly transparent, like it's all perfectly fine. We can also scrub the size up and down. It doesn't really matter. Anyway, so we'll just...
I'm shrinking! No, wait, he just jumped. Goodbye, world!
Whoa. It's like the end of Die Hard.
Yeah. The end of Die Hard. Anyway, sorry, I had to do it.
All right, so we'll just say File, Save As, and we'll save it as App Icon.
Okay. File.
Save As.
Save as.
And we'll save it in our image. We'll just save it on the desktop.
Here, let's pull this down.
Okay, so we'll go to images, and then we'll just call it App Icon.
Okay. Like that.
There we go.
All right.
And save. That's it.
Now
Done.
watch, ladies and gentlemen. App Icon is now in this directory.
Yeah, if we double click it, you'll see it open in preview.
All right, but let's close out of here.
Yeah, we don't need that anymore. And preview has like all the different sizes all packaged together on the right.
Nice.
So anyway, we'll quit preview, and then we'll switch back to Xcode. Anyway, we'll quit preview, and then we'll switch back to Xcode.
Mm-hmm.
And actually, now that the project is created, let's go to the project folder and add the images folder from the desktop to it.
So now we want to go back to Xcode.
Yep. And we'll add that images directory now to our project. So we'll right-click on the TicTacToe App group, or folder, whichever you want to call it, and add files to TicTacToe App. And then we'll go to the desktop, and then click once on images, and then you'll see on the bottom it says copy items into destination groups folder if needed, and create groups for any added folders. Mm-hmm. So that'll create basically a subfolder inside of our project called images as well.
Right, so add that?
Yep, add that. And voila, we have our images.
All right.
Okay, so expand...
Before we do that,
yep.
If you go to the TicTacToe app, TicTacToe, there's now an images folder.
Right, so it copied it in here for us.
Right, all the images that we were working with.
Yep. Okay, so now let's expand that, and then we'll click on the TicTacToe app project on the left, and then so you see on the right under the application target summary, there's an app icon, no image specified. We can just drag our new ICNS file into there, and it will add, and we can just say yes. It's basically going to just, okay, and then hit finish. We'll basically just copy the file into like the root so that it's kind of properly accessible in the package. No big deal.
So now we run the program, and we go down here.
Look at that.
And we have our little frog.
Nice.
Not bad.
So the hard part's over. I don't know.
The hard part's over?
Whatever. Okay, so now let's go to our nib file, and we'll start building out our interface. Okay, so let's switch over to the interface builder. Now, in Xcode 4, if you guys are used to an earlier version, the interface builder is no longer like its own separated thing.
Yeah, thank goodness for that, because that was a pain.
I thought so.
Yeah.
So let's go to our zip file, and you'll notice our interface builder kind of loads like in this panel.
Yeah.
So the default view is our main menu view, and we'll click on the window view right below it. Okie dokie. So now we have our window, and we'll expose the right panel and start, building our application.
Awesome. All right. So what objects do we want in our program?
All right.
Brian?
Well, the first thing we want is like a label.
Okay. So we can go find a label.
Yep.
So
and just as like a forewarning, we're not going to make this application look as nice as we will make the iPhone app look. We're going to take the iPhone application to the App Store. We're probably not going to take this one.
Mm-hmm.
So we just want to get the idea across with this one and then move on to the iPhone. And that's probably what you're more interested in anyway. So let's put a label top dead center.
All right.
And we'll call this player 1, and then in parentheses, Wibbit the Frog. And this will switch back and forth between whose turn it is.
Okay.
So let's center this so that when we change it, it will stay centered.
Okay.
So if you select it and we go to our attributes panel, which is the next one over, it's like the little slider indicator.
Right.
Yep. Then we'll click on the center alignment
Right here?
option. Yep. And then we'll click on our font T to spawn off the font dialog window. And then for this, let's see, do they have like a Helvetica? It's like a pretty...
H-I-J-K-H-I... Yeah, they do.
Okay, let's do Helvetica.
Okay.
Helvetica bold. And then we'll do like, I don't know, 22 point, 24 point.
24? Okay, that's good.
All right, bigger, smaller, doesn't matter.
I think that's good.
Okay.
Yeah.
And now let's stretch this to be the entire width of the window. There.
Yeah. All right, so we got that centered.
Okay. So, and this is going to switch back and forth between saying player 1, wave at the frog, and then player 2, buzz the fly.
Right, yeah.
Okay, so the next thing is to, so do you see on the bottom area where we have our object library, there's like a little film strip on the right tab above the list.
This guy here.
Yeah, so that is like our media library. Now, hit the drop down for the media library and switch to workspace.
Workspace?
Yeah, and workspace will restrict to any media that's in our project.
Okay, nice.
Convenient.
Very convenient.
So we'll scroll down to the grid, and we will drag said grid onto said window.
So just take a dice and move a dice.
Exactly.
Okay.
And then we'll center that. And we will drag said grid onto said window.
So just take a dice and move a dice.
Exactly.
Okay.
And then we'll center that.
Okay. You want it to be bigger, or does it look good like that?
Let's expand the window.
Okay.
So we need a little space for like the frog and the fly to be like to the sides. So you can either, it's up to you, you could either have them directly on the sides or kind of down to the sides.
Right.
Let's just say they're going to be directly to the sides. So, yep. We'll center that, and then maybe just maybe let's make it a little wider.
A little wider?
A little wider and not as tall.
Okay, so pull this out to about here.
And then make
take
it
this up to about here.
Yep.
Okay.
All right, now we'll center those things one more time.
All right.
Sometimes you just kind of have to like stick it on there, get a feel for it, maybe move that down a little bit. We can just use the arrow keys.
I'm glad it lets you at least do that. Yeah.
Okay. Nice. All right, so let's take the awake frog and put him on the left.
Okay, so over here, the frog awake PNG.
Yep. We'll stick him over there. Okay, so now we'll just shrink him down. And when we shrink him, we want to keep his aspect ratio proportionate.
Right.
So we'll shift drag, I think. Does that work? Yeah. Go memory. Go.
Let's see here.
Yep, and then we'll drag that
a little more?
a little bit. Yeah, right about there.
Oh, right there?
Yeah, that's good.
Right there.
Perfect. Look
Perfect,
at that.
yeah.
Maybe
All right.
You could even move him down like a hair if you wanted to. But
if I want to?
If you want to.
I desperately want to.
Okay. All right.
Like that?
Perfect.
Okay.
Look at that. Okay, now we'll make the awake fly on the right side.
Okay, so fly
awake.
Awake.
Okay.
All right.
And he's smaller than the frog, so he doesn't really need to be scaled.
Yeah.
Okay, and he has a little shadow because he floats.
Yeah.
The frog's a vampire. Just shut up. Okay. So now we're going to put the fly asleep on top of the fly awake. So instead of like switching out the image and worrying about scaling and stuff, we're just going to like show hide.
Okay. So we'll pull this little fella out here.
And then we'll shrink him down real tiny like.
All right, so we'll try to make him the general size of...
Or even tinier.
Oh, that's right, because his... Okay.
Because we want the focus like not to be on him, you know?
Right, so like that maybe?
Yeah, maybe a hair smaller and have him sitting on the floor.
A little smaller, like that?
Yep, and then have him sit on the floor.
Then put him down here?
And not quite that, like on the shadow, in the center of the shadow.
So here...
Down maybe like 2 pixels.
Yeah, like about right there.
Yeah, exactly.
All right.
Yep, perfect. Okay, and then we're going to do the same thing with the frog.
All right, so we'll go to the frog asleep.
Yep.
All right, so we got to scale down the froggy here.
Yep, and we'll shrink down the sleeper frog.
Whoa, I lost him.
Frog down, frog down, frog down. Okay, we'll drag down that little, yeah. I hope you like a little bit bigger than a fly. Just like that. Perfect.
Maybe a little bigger.
Little
like,
bigger?
Like that big.
Okay, there you go. Cool.
Because he still has to be proportionate to the frog.
Yeah, and still has to be smaller than the fly when he's awake.
Yeah, and he's sticking. All right, like right there.
Cool. I like it.
Nice, not bad.
What do you guys think?
Yeah.
Nice, good. All right.
We like it very much. All right, Brian. Let's take a look at our app now.
All right.
Now that we got all this settled in.
This is called Wibbit.net Orgy.
Yeah, yeah, that's
Doggy style.
This is Froggy style, actually. All right, so now that we have this set up, what's the next thing to do?
So the next thing to do is we'll stop at that. And then we'll hide the sleeping frog and we'll hide the awake fly.
Okay, how do we do this?
And then we'll hide the sleeping frog and we'll hide the awake fly.
Okay, how do we do this?
So we click on the sleeping frog.
All right, he looks like he's sleeping to me.
And we click hidden, which you just think you have to scroll down a little bit to see.
Let's see if we can scroll down a little bit to see it.
Drawing is hidden. And then we'll click on the fly.
Who's awake?
Hide that one too.
He's a hidden.
And essentially all we're going to do is switch back and forth
Right.
between who's awake and who's hidden.
Yeah, so if we
Player
run
one and player two.
we run the program now, you don't see
Right.
the opposite. So the frog's turn is now, and the fly is not doing its
It
thing.
takes so long for the frog to take his turn, the fly just passes out. He's like, all right, f*** it, man, just
I'm out.
wake me-
Screw this.
Yeah, wake me up when you're done.
All right.
Okay, so, and then the last thing we're going to do for, like, just putting stuff on the user interface is let's use, like, the X icon, because the X icon's boundaries are bigger than the 0 is, and that will give us an indicator of, like, how big or small. Now, because this is supposed to look all hand-drawn, we don't actually want all of the X buttons to be the same size and location. We don't want, like, a perfect grid.
Right. Yeah.
So some of these spaces on the grid are bigger than others. So
Right.
we'll kind of like randomize a little bit to get the X's to fit in there, and then we'll switch them all to blank, and then we'll use them.
All right.
Create our outlets.
So you just want to drag over a bunch of X's?
Yep. So we could probably just drag an X in the top left and copy and paste them into all the rest of the positions.
All right.
So we actually don't want to drag it like that because, and I'll tell you why. This is an important thing. If we have one selected, let's go to our information, our summary sheet on here. The identity inspector.
Go to the identity inspector.
Yeah, and click on an image on the window.
Okay.
Okay. Now, if you notice, the class that it's extending is an NS image cell.
Right.
So an NS image cell doesn't. I'll just say it effectively does not have the ability to bind an action like a click action to
Right.
it. So they're kind of weird. So we actually need to use a button and use an image on the button.
Okay.
So easy enough.
Right.
So let's go to our objects panel on the bottom and switch to the object view, which is a little cube. And then there's one called a square button. This one seems to kind of like serve itself well for images.
Square button.
Yep, and we're going to just drag that on over.
Right here.
Right there.
Okay.
Okay, and you could probably make it a little bigger.
All right. I can do
Kind
that.
of like fill that space out a little bit there.
Yeah. A little more, or is that good?
Maybe undo that and then do it proportionately.
Maybe you should shut your damn mouth.
Maybe you just want a warm glass of shut the hell
Shut
up.
the up. Yeah.
Ben Stiller.
My favorite one was why don't you go outside and play hide and go yourself? That's one of my favorites.
Okay, so now let's go to our attributes, and we'll see here there's an image drop down. So click on the image drop down and drop it down to X all the way at the bottom. Or it's probably faster, you can just type the letter X. Yeah, that's cool.
All right. So X.
Yep. Hey, we got an X.
All right. Cool. That was pretty
so
easy.
now it's like bordered, and it's gonna actually just push play, and we'll see what happens.
Right. Okay.
I'll show you what we gotta get rid of. So first problem is that we got this white background, a little border, and when you click on it, it flashes at us.
Oh, boo.
So yeah, I know that's really lame. That doesn't even look like it's not natural looking.
Yeah.
All right, so let's quit this program, and then
I actually had a comp sci professor that called them programs.
Oh yeah,
Yeah.
Nice. Pilgrim.
And I also had a business professor that said process instead of process.
Oh.
That really got on my nerves.
I had a boss that said database.
That is so stupid.
Well, I think if we investigate the data,
I would have probably thrown a hot
Yeah.
coffee in his face.
I'm pretty sure he did it intentionally just to sound cool. I
Yeah.
think he probably read it in a book somewhere. Okay, so select the button.
I can do that.
And then, let's see, we want to say it's not bordered, and that's at the top. So let's uncheck that.
Bordered?
Yeah.
Gone. All right, Brian, so now...
Cool.
Now that we have selected remove the border, now what do we do?
All right, so now let's just copy and paste it a bunch of times.
Oh my god, we can do that in
Yeah,
Xcode?
I know, not by right-clicking it,
Yeah,
though.
I know. Let's do it the visual way.
Copy.
Yeah.
Paste. We can actually also do duplicate, too, which is the Apple key D. So...
All right, so should I shrink this?
Yep.
Just like a D's? Like a little bit like a D's?
Yeah.
Like a...
You can probably make it a little bigger.
A little bigger?
Yeah. From the bottom left down.
Bottom left. If I can catch that corner. Like that?
Yep, there you go. And then
right.
just do Control D. Oh, actually, select it first.
All right.
There we go. I'll drag it over there. Maybe make it a little bigger. Just a hair bigger. There we go. Beautiful. Okay.
All right. Then, so they're nice and uneven, which is good.
So let's just keep on copying and pasting the rest of the 6 of them.
All right.
And...
Look at you and your hand snapping, Brian. You snapped, and Xcode did what you wanted.
I know.
What an intuitive operating system Mac has put together.
I'm kind of a programming genie.
So now if we run the program,
you just have to rub me the right way. I don't know. That's
all right, Christina Aguilera.
Yeah, that was uncalled for.
Here we go. Here's all of the X's on the grid. Kind of cool looking, huh?
Okay. So now what we want to do.
All right.
That application icon's kind of cool.
Yeah.
It's fun. Okay, so now we need to bind some outlets and some actions.
Okay.
So let's hide our right panel view.
So we're going to take this and make it go away.
And then we're going to go into tuxedo mode.
Tuxedo mode.
You know, I don't even know what the proper term for that is. It's kind of sad, but...
Yeah, whatever. Show assistant editor.
Oh, no, like, it's a tuxedo, like it's your servant or something?
Wow.
No, that's dumb. I like tuxedo mode.
Yeah, tuxedo's better.
It doesn't make any sense, but... whatever. Okay, that's just...
All right, so now we want to bind these to the code, right?
Yeah. So we actually want to bind the player images to show and hide them first. So
right.
So let's start with we'll do the label, and then we'll do the players, and then we'll do the X's.
All right, so we're going to click on that, right-click, drag, inserting the outlet.
There we go. And then we'll call this text title.
TXT, PCP, text title.
Yep.
So that will insert the NS field here.
Yep.
And
now let's do it for the
our
players.
property. So now we'll do Wibbit the frog. So I'm going to click on the awake frog and drag this little guy over here.
Yep. And we'll call this IMG frog awake.
Okay, and that's an NS image view. All right, connect. So now we've made that little outlet.
Now we'll do the frog asleep.
Yep, we'll get the sleepy dude. So this is going to be IMG frog asleep, right?
Yep.
All right.
Now we'll scroll to the right,
Dun, 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 dun. All right.
And then we'll do the same thing with the fly. Mr. Fly!
I'm pretty fly. All right, and this is going to be IMG fly awake. And the last image for the character is going to be IMG fly asleep.
And for all you haters out there saying, like, why in the hell are they doing this? There's a way better way to do this. Well, sometimes repetition is a good way to learn. And it keeps the project simple. And you will remember how to build outlets and actions by the time you're done with this.
Of course.
So...
that's what Wibbit.net does.
Exactly.
We don't take shortcuts.
So screw off, freaky people inside of the canyons of my mind.
Actually, yes, just make sure that you blow up on the forums because we want to read your little snarky comments very badly. All right, so now that we have those done, Brian, we still have these.
Oh, and if you're enjoying this, anytime you see one of our labs, like, make it really badass and post it.
Yeah, right.
People would love to see that.
Yeah.
It helps others learn. Okay, so now we're going to make to clear the board... for resetting the board, we're going to have an outlet for every one of the tiles.
Mm-hmm.
So let's maybe make a space in our tuxedo code view.
All right.
And then we'll just do an outlet for every one of the cells.
Okay, so we'll drag this guy, and this will be what? Button? How do you want to name this?
Yeah, we'll call this TTTA1.
TicTacToe A1.
And we're going to do it Excel style.
Nice. All right, TTTA1.
And then that'll be TTTA2 is the next one down. That'll be B1. Yep, so that's A2.
TTTA2.
And then we'll cut from here to C3. And the TTT-C3.
Nice, Brian.
Okie dokie. All right, so that's all of our outlets. So now we want a action for when we click on the button. Now, obviously, we don't want to have like a custom action for every single thing that we click on because that would just suck.
Yeah.
So what we're going to do is we're going to create an action for all of these and bind them all to the same action.
Okay.
Okay, also, if you right-click on C3, you'll get our little outlet connector, and you'll see that by creating that outlet, it adds it to the referencing outlet section and says our TicTacToe blah, 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 blah is now tied to TTT-C3.
Right.
So that's kind of cool. Not bad. And you can remove that outlet connection by hitting that X in that view. Let's right drag the first cell over underneath the outlets, and we will now instead set an action.
All right, so we'll stick this down here.
Yep. Right drag the first cell over underneath the outlets, and we will now instead set an action.
All right, so we'll stick this down here.
Yep. And then on the connection drop down, we'll select action.
Okay, dokie.
And we'll call this click action.
All right.
And then connect. Okay, so that passes the sender. So now what we can do is let's go to A2 and drag A2 onto that click action. So instead of making a new one, we're going to connect this to click action as well.
Like that?
Yep, and then this is connect action. Yep, and then we're going to do that for all of these.
So drag that to this one.
Yep.
Wow, Brian, this is awesome.
Yeah.
Yay! It's like when I lost my virginity. I was really scared and confused for a while, but then I got the hang of it, and then I finished prematurely. Anyways,
And then I gave the goat back.
Yeah. But your mom didn't seem to mind. All right, so that was the last action there.
Okay, the last action hero.
Yeah.
Okay, so let's hide the tuxedo view, and we'll go back to this, and we'll reveal our right panel, because how do we know which button we just clicked? Unfortunately, in the Apple world, they don't find it useful to keep like the name of the image file in the image view.
But I can't imagine a circumstance, Brian, where you would need to know that.
They also don't have like textual fields that you can like give as attributes to keep track of stuff. Oops. So what they do give you is the ability to use a integer tag.
Yes.
So,
which is still kind of lame because in other languages, that's any data type you want, you can stick in there.
Right.
Yeah.
So, what we're going to do is, to identify which one, we could do like 1, 2, 3 from letter to 9.
Yeah.
The way the grid is laid out, it's kind of like position 0, 0 to position 2, 2, or you could say position 1, 1 to 3, 3. Now, because we can't really store like a 0, 1 that easily, and for the sake of our algorithm, we're going to do position 1, 1 to 3, 3. So we're going to represent that like an integer.
All right.
So the upper left tag is going to be actually 11.
Okay, 11.
And then the next one down is going to be 1, 2.
All right.
Or 12.
12.
And then 1, 3 or 13.
13.
And then B1 is going to be 2, 1.
Mm-hmm. 21.
And then 22, 23.
22.
And this will allow us to easily identify the row in the column.
23.
And then C is going to be 3, 1, 3, 2, and 3,
31. 32. And
33.
33.
So we have access to that tag value in our click action by pulling it from the sender. So that basically concludes our building of the interface. Now we just need to jump in and implement it.
Yeah, but I want to look at it again before...
Okay. Yeah, I want to see the little icon again.
Yeah. Yeah. Ooh, little X's. Cool. All right, guys. So like Brian said, we're going to come back and we're going to implement this.
Yep. Cool. So that's what our app looks like.
Yeah.
So because we're not really going to go back into the interface builder, let's just select all of the X's and set them to blank.
All right.
So we'll just kind of shift select all of them.
All right. So we'll do a hold shift and
select all these.
I like these.
And because they're all of the same like class type and the same image, you can see the image to all these is set to X. Let's replace that with blank.
All right.
Because we have that blank.png file.
Right.
Yep, exactly.
Blank.
There we go.
Very nice.
So we'll just click off of that, save it, and then we probably won't be dealing with the...
Of course I can't save it there. That would make too much sense. All right. Save it.
Yep. Okay, so that's that. So we probably won't be coming back to that, but we'll see.
All right. Now what?
So now let's go to our TicTacToe App Delegate. Actually, you know what we're missing?
We have to import the
our
class
model
code
class.
file.
Yeah.
All right. So in the TicTacToe app, Brian, we're going to add files. And from here, we're going to go to our
Wibbit.net.
Yeah, the Wibbit.net hard drive. And then we're going to go to the TicTacToe.
Yep.
And then we're going to pull in M and H, right?
Yep, that's it. And we don't need the driver, obviously.
Right, yeah. So .m. All right, so .m and .h.
Then we're going to copy items into the destination.
Yep.
Cool, awesome, add.
Yep, add. And these have added.
Awesome.
And what I'm going to do is I'm going to just, so for me, I'm going to move that up so we have all of our code files together.
I like it.
All right, so you guys remember this code, and if you don't, please go back to the previous tutorial and go ahead and do it. All right. So we've already created our properties and outlets here in the header file.
Right.
So in the implementation file, Brian, we have some work to do.
Right. Actually, in the header file first, it's all right.
Excuse me.
Yes. Let's just add TicTacToe.
Oh, make an instance.
Object. Yeah, we'll make an instance.
Gotcha. So in
and that
here,
can be private, no big deal. So we'll import that in the
.m file.
Yes. Above the import .h.
Yep. So in the .m file, right above the TicTacToe app delegate, we're going to do an import of. We're going to pull in the TicTacToe.h
because it's Xcode and it's counterintuitive.
Right. So let me just for my own comfort make sure that builds.
Yeah.
And it
builds.
Does. All right. So back in the .h file, we're going to come here and we're going to do TicTacToe pointer,
and we'll call it TTT.
Here, I'll be like Brian. TicTacToe.
I like that way better.
I don't, but whatever. I'm better than you, and you know.
Because then it's like saying the thing is a pointer, not the thing is. I don't know. Shut up.
But hold on a second, Brian.
Okay.
If I was going to set that equal to something, would I do this?
No.
Right? So doesn't it make more sense?
Well, who's dumb?
Brian, U.S.
Who
dumb?
can't even spell dumb?
Wouldn't it be like this?
Yeah.
So to me, I view that as
fair enough. I can see that.
Object is a pointer, and the pointer label is.
Actually, you know it's probably
that's what makes more sense to me.
Space on both sides of the pointer.
No, but then it looks like an asshole.
Yeah, it does look like an asshole.
Come on.
Just put a couple parentheses there, and you have a Vonnegut style asshole.
there's our language.
Kurt Vonnegut. Here's to you. All right.
I love it. That's awesome. Woo! All right, kids.
That totally looks like a butthole.
That is an asshole.
Like, put a space between the. Put a
like
space
that
in there, yeah.
No, that is a fat. That's a
fat
ass. Oh my god.
Anyway.
Can we get like
some legs? Yeah. There you go.
All right, I swear I'm done. I swear there's the X-rated ASCII art portion of our tutorial. Woo, boy! All right.
Anyway.
Okay, so we made an instance of TicTacToe and called it Triple T.
Yes. There's also going to be a method that we're going to add.
Okay.
Aside from the click action, we're going to do like a reset board.
Great. A void?
Yep, void.
Okay.
Void the noid. Reset board.
Reset board, and that's going to take nothing.
Yep, that's it. Okay, cool. So now let's on to the implementation. Okay, cool. So now let's on to the implementation.
I'm going to go ahead and while you speak about what we're doing, I'll get a few things set up here.
Okay, so we want to add the that reset board.
Oh, that's what you were going to say.
Yeah.
Reset board. Okay.
And it doesn't return anything, so no big.
Right. Yeah.
Okay.
All right. So the launching code, right? So this is what executes when our program successfully displays itself, right?
Yes.
And when we do this, Brian, we're going to want to alloc init our TicTacToe object along with a few other things, right?
Exactly. Yeah, that's actually all we have to do there.
Okay, so we're going to do the TTT without a star. Thank you very much.
That's true.
Equals TicTacToe alloc, and then we'll run the init method on that because that's going to be initializing a few things inside.
And then we own it, so we want to...
Yeah, so do we need a dealloc method?
Probably,
I think we do. Even though we don't have to do it,
I'll just add it. I wouldn't worry about that.
I'm worried about it. I'm very worried about it. So we'll make a dealloc method here in the H file and go back to the M file. Void.
Dealloc.
Right, so in dealloc, what we're going to do is we're going to select all, delete that. TTT release, and then we're going to call self dealloc.
Yep.
All right.
Super dealloc?
Nope. Super dealloc. Sorry. Super dealloc. Self dealloc would just probably cause an infinite loop.
Okie dokie. Okay, so let's reset the board first, and then we'll do the click element, the click action to call our model class stuff.
Okie dokie.
So for reset board, we're going to keep this pretty simple and pretty straightforward. So we want this code to be like as straight shooter as possible. So the first thing we want to do, we created an outlet for the title text, right?
Right, which was txt title text.
Yeah, so we're going to do txt title, and then it's all going to be in brackets because we're going to be calling a method on that.
Okay, so txt title.
And then the method's going to be called set string value.
Set string value, okay.
And then we'll say like at NSString player1, and then in parentheses, Wibbit the frog. So this is like the same thing that we have on the interface builder, that we put on the interface builder. Wibbit the frog. And then maybe a lowercase t, I'm not sure. Not that it matters.
All right, Mr. Picky Pants. Wibbit the frog, like that, right?
Yep.
Okay. Why does it not do what I tell it to do? All right, like that?
Yep.
Okay.
Okay, cool. And then the other thing, too, is we want to make sure that the hidden values are like that the frog is awake and the fly is asleep.
Right.
So we'll say frog awake, set hidden no.
So it's img
frog
awake, set hidden to... No!
Ow.
Sorry, I didn't do it. The program did it.
And then frog asleep, set hidden yes.
Okay. img frog asleep, set
hidden yes.
Hidden yes.
Okay, and then the same thing but opposite for the fly.
Okay, so img fly awake,
set hidden yes.
Set hidden to yes.
Image fly asleep, set hidden no.
Image fly asleep, set hidden yet.
So that way, whatever turn that we end on, when we call reset board, it'll just reset it.
Right, bring it back to how we initially started it.
So we could have on a init called reset board and not worried about like hiding the stuff in the interface builder and just left it all visible, but whatever, we'll just do it here.
This is Brian you're dealing with, okay? Yeah. He has a very particular way of how he likes to do things.
And that's only right for me. Okay, so the next thing that we want to do is we want to take the we want to blank out all of the
all of
tiles.
the cells, right?
Yeah.
Mm-hmm.
So the first thing that we're gonna do is because this is kind of long, we're gonna kind of like break it into little bits. So we're gonna say we want an NS string.
Okay.
And we'll call it like a blank file name.
Okay. NS string, blank file name.
Yep. And that's going to be, okay, and then blank file name is equal to...
Oh, sorry. You're making it equal to something?
Yeah.
Okay.
Yep. And then we'll say, okay, 2 square brackets, NS bundle, main bundle. Now the main bundle, as I think we discussed before, but I'm not sure, and then end the bracket.
Yeah, we did talk about that.
Okay, so I'm not even worried about it.
Right.
Path for resource.
Path for resource.
And then at quote blank quote.
Like that?
Yep.
Okay.
Sorry, the word blank.
Oh.
Yeah, because it's blank.png.
Right.
And then of type PNG NS string.
PNG?
Yep.
Do I have to put a dot?
Nope, that's it. So that's like the file and file type, you know?
Right, so go to our resources, find a file that's named blank that is of type PNG.
Right.
Is what that basically says.
Exactly. Let's see what it's warning about.
It's probably saying it's unused.
Yeah. Oh, yeah, that's fine. We know that. It should like give you a little bit of time before it says that. Like, chill out, man. We know, we just wrote the line. Okay, so now we're going to make an NSURL object.
NSURL. Okay.
Yep. And we'll call it like blank image URL.
Okay.
And that's going to be equal to.
All right.
in brackets NSURL space
URL space
NSURL, and then file URL with path.
File URL with path,
and then blank file name.
Okay, blank file name.
That's it. Okay, so that makes an NSURL object. The NSURL object is then used to create a new NS image.
Of course. How intuitive.
So now, NS image, blank image.
NS image, blank image, okay,
is equal to, and then NS image alloc and init with
NS image alloc init
with contents of URL.
With contents of URL, and then blank image URL?
Yep. Now, there is another way to do it. This is like a init with contents of file, but this way we can like refer to the main bundle, whatever. There's a lot of different ways to do it. So we want to make sure that we release this image later. So let's just like add a few lines in there, and we'll just say blank image release, just so we don't forget it. It's always best to do it like as soon as you create it. Otherwise, you'll forget. Or I'll forget, because I have no short-term memory.
Now, we probably do not have to release the blank image, but do we have to release the NS string? We can just do that anyways. It wouldn't hurt to release it.
No, it wouldn't. We can release it if you want.
Yeah. Even if it is auto-release.
We'll just double release it.
Yeah.
Okay.
And then the other one we don't have to. At least
so
we should
just say safe. Okay. So now that we have that, between the releases and the the blank image, we're gonna say in brackets
TTT-A1,
which is the A1 outlet that we created earlier.
Right.
Set image.
Right. Set the image
to blank image.
To.
And that's gonna like clear out that tile.
Right.
So we'll copy and paste that 8 other times.
All right. So we got there's 1, 2, 3, 4, 5, 6, 7, 8 times, and then this is going to be A2, A3, B1, B2, B3, C1, C2, C3.
Yep.
PO. Sorry.
And then last but not least, after this...
Star Wars joke.
And then after this, we're going to call... if you remember in our model class, we have a reset method on our TicTacToe instance.
To reset the backend class.
Yep,
right.
So let's reset that backend class.
Reset, right?
That'll do it. Cool.
Wow.
So that's all we have to do to reset the board. Can you guys think of anything else?
If you do...
No?
Well,
okay. I don't hear it, so...
Yep.
All right, moving on.
You didn't speak loud enough.
So now all we have to do is implement the click action. And then we're good to go, bud.
All right, Brian. You said that we now have to implement the click action method.
I said that?
Somebody said that. Let me do a quick build just to make sure that you didn't f anything up. You didn't do it. All right, cool.
So we want to. Okay, so when we click something, we want something to happen.
We do.
Right?
Okay. All right, that makes sense.
So one thing we could do if you wanted to is we could just write NSLog the tag.
Okay. So that way we can just kind of like write out.
Yeah, you can just kind of like see how the tag works.
Right.
You know?
So you want to do a format string and then sender.
And so sender tag.
Tag.
That's all it is.
Okay.
And then in the format string, we'll just say like you clicked on image with tag %d.
Okay. With tag %d, and we don't have to do a new line.
So let's just run the program. That. Yeah, we'll just run that, and we'll oh, it's LD.
Oh yeah, it's
I forget. It's D in iPhone and LD in OS X.
It's LD, or if you want,
there you go.
You can do that. Yeah, it's what?
Oh, semicolon. Whoops.
Like we've said before, the Apple development is consistently what, Brian?
Inconsistent.
Yes. That's the only thing that it can be is not the same. All right, so we need to get our console up, so I guess we'll come back over here to... Here we have our little console window.
All right, so let's switch back over, and we should be able to...
All right, so we click on that, and we get that one. So there's 1, 1,
1, 1, 2, 1, 3, 2, 1, should be 2, 2, 2, 3, 3, 1, 3, 2, 3. Beautiful. Awesome.
Not bad, huh?
Very cool, okay.
And, like, the kind of neat thing that this demonstrates is, since we set that action for all the buttons to come here, we have the ID, so any object on that in our program that we want to come to this, it could be of any type.
Yeah.
And then we can handle it, and we can use
I really
things
like that ID data type.
We can use like the reflection if you really want to find out what type it is. If there's like some specific things to do,
with it,
you can do perform selector. But in this case, we're just going to be taking in the object, and since we know for a fact they're all going to be buttons, we're just going to treat them that way.
Yeah.
There we go, baby. Let's do it.
Awesome. Okay, so what do we need? We need to know a couple of things.
All right.
The first thing is, what image should we use to set the tile to?
All right.
So we'll make like an NS string, and we'll call it like TTT image file name.
Image file name.
Yep.
Okay.
And we can probably comment out that NSLog too.
All right.
But we'll leave it there. Just
all right.
so you can see it. I mean, we could just comment it out, but
I'm leaving it there.
Okay.
I don't care what you say. You're stupid.
Whatever.
Nobody likes you.
Okay. So NS integer, a row and a column.
Okay.
So we want to convert. Basically, we want to convert the tag to a row and a column.
Right.
And we want to say like if it's X's turn.
Right. So
if
TTT. I'm sorry. We have to evaluate this. If TTT, whose turn?
Right.
Whose turn
is X
is equal to X.
Then we're going to set the image file name.
Okay, so that's going to be sender, right?
So the TTT.
Oh, I'm sorry.
Yeah, that's all right. So the TTT image file name without a bracket is going to be equal to something.
TTT image file name. Okay,
it's going to be equal to, and this is going to be the NS bundle main bundle path for resource.
NS
bundle.
Main bundle.
Path for resource, and the resource NS string is just going to be the letter X.
So
because it's x.png.
Lowercase x, right?
And then PNG is the type. Exactly.
Okay.
Exactamundo.
PNG.
Yep. And we can probably copy this line, and it's going to be like else, and then
right. So we don't need these brackets, do we? Because we're just doing one statement here. So I'm going to pull these out. All right. So then you also have an else condition here, and we could just steal this code, and we could just make it an O, right?
Yep.
Like oh. Video kill the radio star.
That was the first song ever played on MTV.
Yeah, that was the first music video on MTV.
Okay, so now let's convert the sender tag to the row and the column. Okay, so now let's convert the sender tag to the row and the column.
Okay, let's do it.
So column is going to be equal to
column equals,
and then in parentheses the sender tag.
Sender tag. Okay.
Yep. So that mod 10.
Okay.
So that's going to say like it's basically going to strip off the first character, and we'll say -1 because we don't want a 1.
Okay.
So if this is 21, it'll return 1, and then -1 will be 0.
Okay.
Make sense?
That makes sense to me.
Okay, so then a row.
Although you don't need those parentheses, but I see why you put them there.
Yeah.
Order of operations would do the mod before the subtraction.
I like to.
Yeah, I got you.
I like doing that.
I know you're a parentheses hound.
So we're gonna actually typecast this. Well, we'll just do it and then we'll typecast it. Sender tag divided by 10.
Divided by 10.
-1.
Okay.
But now in this case, we just want to make sure we typecast to an integer
as an integer,
because otherwise it'll do like rounded, whatever.
Well, it probably won't matter because. Actually,
anyway.
Yeah, it's gonna.
I typecast to just int, like literally to just int.
Yeah, that you don't have to do that though, because I mean the typecast will just remove its decimal point.
But yeah, that's all we want to do.
Yeah, but you're storing it as an NS integer, which means the decimals won't be there anyway.
Okay.
Yeah.
Right. So, so what we could do after this is we can make another NSLog entry and just say like the column is and the row is.
All right. So we'll do col equals %d, row equals %d, and then I'm going to do that, col, int, row, and you want to just try this out real quick and see how it goes?
Yeah, let's see that.
All right, so we'll play it, and let me pull this up just a tad.
And obviously we won't see anything happening because the images are all blank.
Right, but we'll see the log reflecting hopefully properly. So if we do this, row 0, 0, and that's column 1, okay, well this is backwards. Because that should be row 1, column 0.
Okay, so let's fix that.
Yeah.
So let's just call column row and row column there.
Okay. So this will be row, and this will be col.
We always have grid dyslexia.
Yeah.
Let's try it again.
Yeah. But I think it's a perfectly reasonable thing to have. 0, 0, and we got a crash. Bad access.
Bad access. Well, this path to resource may be like the same every time. Do you know what I'm saying?
Well, I'm gonna see if that's ever nil. Because when it says bad memory, it's either pointing at something that's been deallocated or it's pointing at nil.
Or maybe because it tried to unload the image twice. never happens on the first click.
All right, well...
It should clean it up for us.
All right, well, we'll give it a shot.
All right, we'll just kind of...
Maybe it's an auto-release object. All right, so now that we pulled out that release, that seemed to fix the problem, and perhaps this is my fault that we were trying to release an auto-release object, and it caused the problem.
All right, whatever.
So
cool.
All right, so we're able to successfully get every single cell to respond.
Okay, so now we want to make our move.
Make your move, fool.
And because of the way we have the exceptions come back, we want to try to make a move.
Right.
If you remember from when we did the console app.
Right. And then we'll do a try, and then we'll set up our catch. So the try goes here, and then the catch.
And then we'll catch an NS exception.
Mm-hmm. Because that's what we throw.
Yeah.
An NS exception. And the NS except tune.
EX?
Exception.
Cool.
NS exception. Why is that not... Whatever. Okay. So this
Put
is
a
going to
space
be...
between catch and Bren. Whatever.
So this is going to be TTT, right?
Yep. Make move at
Make
column,
move at column.
call, and row.
And row. Row.
Awesome.
Nice.
That's all we're going to try to do. And then for our catch, at least for right now, let's just log it to NSLog and say like error.
Okay. Error.
Error colon and then %string, %s.
Are we doing it? Is that an NS string? Yeah.
It's actually neither.
What is it? EX? Reason?
I don't know if you can actually...
Yeah.
No, it is an NS string.
All right. We'll just make sure that works, but that should work.
Okay. So that should be fine. So let's click on the same image twice real quick.
All right. Just see how it works.
That should produce an error.
All right. So we'll keep it on the log here. So when we click here, it's fine. We click here, it's fine. I click here again, we get an error cell is already valued.
Awesome, perfect. Okay.
I click here again, I get an error cell is already valued. Nice.
Beautiful. Okay. So we quit the application. All right, so that's all we're going to do for right now in the error. Okay, so we want to send a message saying that, there is an error, say what the error is, or maybe not say an error, but we want to throw the message up as a pop-up.
Right.
And then do the turnover.
Okay.
We want to send a message saying that, there is an error, say what the error is, or maybe not say an error, but we want to throw the message up as a pop-up.
Right.
And then do the turnover.
Okay.
So we won't actually be changing the screen. We won't be doing anything else. We're just going to say, we're going to call the function NSRunAlertPanel.
NSRun alert panel.
And this is only available on the OSX, actually. And we'll just say, like Wibbit.net for the title.
Okay.
And then the message is going to be the EX reason.
Okay, so it's going to be EX reason.
Exception reason. REA. Yep.
And then the default button.
We'll call it try again. We'll put that for the string.
Try again?
Yep.
Alternate button, Brian?
Nil. And then the other items just niet.
Niet.
And then after this, we'll just return. So like no harm, no foul. Just get out of here.
Okay. Like that?
Yep.
Let's see. Is that going to work?
Yep.
See what it does. So we have this. Oh! Try again! I like it. And we got the little frog back on there.
Awesome.
That's cool. Nice.
Okay.
Good work.
We'll quit out of here. And, okay. So the next thing we want to do is we want to create an image URL for the image that we selected on earlier.
Okay.
We can just do it after the cache because otherwise we'll unnecessarily be building all this crap. Actually, it may make sense to move let's see if we can do this. Let's move the row column NSLog and the try and catch all above the whose turn if else. Or actually just move the if else blah 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 below the catch.
Okay.
Because we don't really need to be doing that up there.
All right.
And we'll just move that down there. Yeah, I like that better.
Okie dokie.
Yep. Very nice. Okay.
Right.
So now after this, we're going to make a NS URL.
All right.
After the else.
I'm going to define it up here, Brian, just to have it equal to nil. That way we keep our
that's fine.
variables up here. NS URL. And what is this going to be called?
We'll call it the TTT image URL.
Image URL. And so we have no harm. It's just going to be equal to null.
Okay.
So we just define a label that points to nothing.
And then at that point, we're also going to make an NS image called the TTT image.
Right. MS image, TTT image equals nil. Still, we'll never get used to nil. All right.
Okay. So now we want to set our image URL.
Okay.
And that's going to be equal to evaluated NSURL. It's a class level method called file URL with path. File
URL with path.
TTT
string.
Image file name is going to be the object we pass.
Like this?
Yep.
All right.
Okay, and then the next one is going to be we're going to set our...
Okay, and the TTT image file name was set here.
Yes. And then the next one is going to be, we're going to set the NS image, so TTT image is equal to alloc init with contents of URL. NS image, yep. Alloc. And then init with contents of URL, image URL. Or TTT image URL.
Right, sorry.
And we got to change that on the line prior to this as well.
Yep. Okay. And now since that's alloc.
Capital I.
Damn it, Brian, why I gotta be all like, I'm Brian. Hello. I'm the greatest man in the entire galaxy.
I am the greatest man that ever lived. Release you.
Alright. Release you into the wild. Alright, now what?
Okay. So now let's set the image of the sender button to be this image, because that's the one we just clicked on. So it's sender image. Yep. And then surrounding that, so we'll finish the evaluation of that.
Like that?
Yep. And then surrounding this, we'll say set image. We'll call set image on the result of that, basically.
The result of that memory space, we'll say set image. Okay.
Why isn't that? Oh, it's the button. Sorry.
No.
Undo that. It's just going to be sender set image. So we're going to call set image on the sender, which is whatever, NS button thing.
An NS button thing, like the record routed
TTT image.
Thing. Yeah. Okay.
Golden. Okay. And that's that for that. So all we want to say is, like, if we have a winner, we want to just have a message pop up that says we have a winner and reset the board.
So Brian, if what I think is going to happen here is those images are going to populate now, right?
Yeah, they will.
So before we get into the rest of the logic, I want to see some shit. Hey! Although I think it's backwards.
Oh, yeah, it is. Okay, no biggie. We can fix that.
Game over!
All right. So we'll just say if it's not equal to X.
Right.
I think we made the same mistake on the console app the other day, too. Because we're crazy.
Crazy.
There we go. Okay, cool. Awesome. And next up. So that throws an exception, but when we catch who the winner is, we won't get an exception that way.
All right.
So let's do that now. So after we set the image.
Okay. Right.
Yep. We're going to say if the winner is X. So if TTT who is winner.
Who is winner.
Is X.
Equals X. Okay.
Yep. Then we want to maybe write to the log, like NSLog, the winner is Wibbit the Frog.
Okay. The winner is Wibbit the Frog. Okay.
And then we want to call the NS run alert panel function again to have like a nice little alert pop-up fly up there.
All right, so we'll...
And the only difference is instead of try again, we want to say play again.
Right. And then the reason.
Right, so instead of the reason, it's going to be that string. Which we could put in a string, but whatever.
Who cares?
Okay, so now we're just going to call self reset board and call the reset board method we implemented earlier.
Reset board?
Yep.
All right.
And then return.
All right. We don't want to return.
We do, because if we don't have a condition happen where this person's the winner or the other person's the winner, we have to set up for the next player. So we do want to return here. We want to release the TTT image and return.
All right. Well, then let me pull this up.
Hold on a second. Maybe we can change this.
And we can probably just put that
no,
right
it's okay.
Here.
I got a different way to do it. No problem. Just leave it.
All
okay,
right.
we'll just... Okay, and then we're going to say else if the winner is O.
Right.
Because we could not have a winner, you know.
Right. Else if the winner equals O, same thing.
Right, same thing, just different message.
Yeah, and then
we probably could have made it a little more efficient, but...
We're not.
We're not. It's okay.
The winner is...
Buzz the Fly.
Buzz the Fly. Winner is...
Like Buzz Aldrin.
Buzz.
Buzz Aldrin's in the new Transformers movie.
Is he really?
Yeah.
That's awesome. And then we also have another condition where it's a draw, right?
Right. So we're actually going to say else whatever other condition.
Are we looking for D?
We're looking for anything that's not the winner.
Okay.
Oh, I understand.
We have to look for a draw.
Yeah. Right. Fair enough.
All right. So then we have to do a draw.
There are no winners, only losers.
Yeah. Draw. Okay.
Awesome. Okay, and then we'll say else.
Now we have an
and
else.
the else means there's no winner.
Right.
And if there's no winner, then we want to set up for the next player.
Right. Right.
So inside of this, if whose turn is X.
If TTT
whose turn
equals X. Okay.
Then we just want to set the text of the title and then change all of the hidden values. So we can actually copy that out of our reset board down below.
What are we doing?
So we'll grab that text title set string value to that.
Okay.
So we want that in there.
All right.
Because it's player one.
Right, yeah.
You know? And then after that, we want the set hidden block.
Right. So the you want to take both of these, right?
All four of them, yep. Exactly. So that just kind of resets it for player one. And then we say else, and then we copy and paste that same block that we did for X, but make it the opposite and make it for Buzz the Fly.
Okay. So copy that, and we'll paste that.
And that's what's going to kind of switch the stage between player moves.
Right.
Back and forth, back and forth.
Buzz the Fly. Okay, so set hidden for a frog awake, yes.
So the frog will be awake this time.
And
the frog will be hidden. The frog asleep will be visible. Yep.
Wait,
No, that's right.
Okay.
Because you're setting the hidden, not the visible. It would make more sense to say visible, not hidden. You know, it makes it all backwards.
Yes.
But think different.
Yeah.
So, okay. So, do we have anything else we want to release? I think that's probably
I think that should be good.
Right. So, in theory, we finished the program.
All right. Well, let's see how this runs.
Yeah. So, in theory, we finished the program.
All right. Well, let's see how this runs.
Yeah.
So, we'll do this. The fly didn't come awake.
Oh, so something I want to miss.
Yeah.
Oh, that's why. Check that out.
What?
Here, quit this. Fly awake, fly awake. So this should be image fly awake, image fly asleep. So in all three of our blocks, this should be fly sleep.
Oh, so we have a typo down here.
Whoops.
Fly
It's the danger of type ahead.
Yeah. Sometimes you hit A, and it looks like what you want, but it's not really what you want.
I know what I want.
I know what I want. You don't tell me what I want. All right, let's try that again. All right, so we hit that, and the fly is awake.
Cool.
And we hit that, and the frog is awake,
now
and this is player one.
Player two.
All right, and now we're going to make the fly win this game. All right, now it didn't... Oh, yeah, it did print it. All right.
It's a little confusing because the icon is always the frog.
Right. So the winner... Yeah.
Now, you know what we could probably do, but it's probably not worth it? We could switch the app icon with every move, too.
Yeah, you could. Yes.
We could do that.
Yeah, we're not going to do it, though.
No.
That's your homework assignment.
Yeah, that's definitely your homework assignment.
We've gotten people on the forum saying, hey, are you guys going to do homework assignments? That's the first f***ing homework assignment. Swap it.
Yeah. Fair enough.
All right.
Make up your own homework assignments.
Now, the program did crash at the end.
Oh, really? That's fine.
So let's figure out what that's... I mean, at least it closes for you.
Yeah, what the deal is. You mean just when we hit play again? All right, win another game, and let's see what's happening.
Let's see what's going on. Maybe we don't release this image.
Really? What does it look like when we instantiate the image?
It's an Alec.
Yeah, we should be releasing that then. Yeah, I'm thinking we want to release that.
Yeah?
Yeah. I don't know.
Well, let's see what happens. Let's have a winner again. So we have that, we have that, we have that. A winner, play again, crash. All right.
All right, so it may be something with our resetting the board.
All right, you may be right. So let's go down to the reset board method.
Actually, comment out reset board and see if it still crashes.
That's a good idea. So, all right, comment that out.
And there's one more.
There is? Yeah. Why would there be another
X,
one?
X0 and D.
Oh.
Or X O and D.
Oh. All right, let's try it. On.
Cool,
right.
So that didn't crash it.
All right, so we definitely know where the problem is. So let's uncomment these and let's go figure out
what the deal is.
What the deal is, yo. All right, so let's kind of scrutinize this code a little bit. So we're setting the text value.
I'm saying we shouldn't release the blank file name.
Oh, you're right.
You're
Whoops.
right. Yeah. Bad memory.
Manual memory management is a little,
stupid.
It's one of those things.
All right, let's have the frog win again. Frog won.
Nice.
The frog. Now,
there we go.
Let's have the fly win. Oh,
Whoops. Let's make him win diagonally or something. Well, whatever.
All right.
Cool.
Buzzy the fly.
Let's do a diagonal win. Nice. Awesome. Let's do a draw, if we can figure one out. Yep, center for O. O in the center.
Draw.
Nice. Awesome.
Hey, not too bad. Not too bad. Just real quick, I haven't looked at the top. So, okay, player 2 Buzz. Nice. That's pretty cool, huh?
Not bad.
Yeah. Cool. So there you go, folks. There's a TicTacToe program written in Mac OS X. So there's a couple other things that you guys can do to improve on this. You could maybe make it look a little bit pretty, but there's also other options that Brian and I discussed before in the zip file, where you can do stuff like, where do you want this to start when you execute the program? Do you want it to be in the center?
Screen? Do you want to click here to start?
Right.
Do you want this somewhere else? Do you want to not have the players like that? Do you want to do whatever you want?
Yeah, this is for you to play with. Enjoy it, folks, because the next time that you see us, we'll be doing the same thing on the iPhone.
Right. Hey everybody, welcome back. Hey. Now we're going to make tic-tac-toe on the iPhone.
Holy monkey, Brian. Yeah. This is the greatest day of my entire life.
So what we hope to show you by doing this is all these weird little odds and ends and quirks and like getting used to the NSObject ecosystem of Apple stuff.
Yep.
It's tough to just like march through every single one of those concepts. It would take forever.
Yeah.
And then you'd end up with like the Apple developer documentation. So what we want to do is we just want to like walk you through, and that's exactly why we chose TicTacToe, is because it allows us to kind of like touch on a lot of different concepts. We want to, now you're familiar with it, we're not going to get bogged into like the how or the why. And you have the general concept of how we're going to like make the actions on the images on the screen.
Absolutely.
So you're perfectly oriented. Now we're just going to be able to, now that you know that stuff, it'll wash all that away and we can just focus on the iPhone stuff.
Very cool.
Yeah.
Very exciting. Now, when we first get started, guys, you'll notice a couple of familiar things on the desktop, the images, but Brian is also including a font for us.
Right. So this is a font that you can get freely, and we'll include this in the attachments. It's called Alti Haas Grotesque, and Haas is the person who worked in the Swiss foundry that made Helvetica. And this font is like a tribute to that guy, and they kind of like did some rounding on the corners and stuff, whatever. And
it's a kind of like in Flight of the Conchords, the Light of the Conchords.
Yeah, exactly. Yep, exactly.
So the number 2 folk duo, number 1 was their tribute band.
So this is kind of like and he made a lot of like really cool grotesque fonts. And so this is kind of like a alternate of a grotesque hostile font in bold.
Yeah, cool. So we're going to actually...
Nobody really cares about that.
We're going to be installing this in the OS, and we're also going to be bringing this along with our application.
Right.
So it's going to be pretty awesome. So that's like a little extra, little extra new nugget for you to learn.
Because the thing is if you have a font on the system, it might not be available for the iPhone.
Yeah, that's
true. So it's a kind of a weird little thing to get your fonts into your programs on the iPhone. So that's why we want to show you this.
Nice, cool. So let's create a new project.
Yeah, let's.
And unlike last time where we made a Mac OS X project, we're going to do iOS, and it's going to be an application, and it's going to be a view-based application.
Yes.
And the name of the project is going to be
TicTacToe
iPhone app. Okay? And the device family is going to be iPhone, and we're not going to include the unit tests.
Yes.
And on the Whippet.net hard drive, we'll just save it right there.
Awesome.
Brian, I've been waiting my whole life for this moment. I just want to say that right now.
I've been waiting. Moment. Okay, so we're not going to support landscape right and left. We had a lot of deliberation about this issue because we do want to show you how to like rotate the device, but we think that may be better served just kind of like in its own lab somewhere. So we may or may not get to this. We're not going to get to it for this project. We really just want to boil this down to just these like certain kind of like funny oddities that you need to kind of get accustomed to be able to program in the Apple environment.
Right.
So we want to keep this simple. We're not going to do anything too fancy, but we want to get you, just accustomed to the environment. Anyway, that said, let's go to our if we stretch this out, we can kind of see the file names a little better. You'll notice we have TicTacToe iPhone app delegate and the main window zip file. So the main window zip is kind of like if you click on it, you'll even see it's really just like the housing for the application. And within this, a view is loaded from TicTacToe iPhone app view controller.
Mm-hmm.
And if you remember in the model view controller kind of structure, the .h and the .m on the app view controller files are the controller side.
Mm-hmm.
And then the zip file contains the view. And then we're also going to add the model, which is our model TicTacToe class.
Right, exactly.
So let's add that class now.
Okay, so we'll go to TicTacToe iPhone app, and we'll add files. So on the Wibbit.net hard drive, we're going to go down to the TicTacToe code that we wrote before.
And then we're going to take that .h and .m.
Right.
So that way we have the TicTacToe class, or the TicTacToe interface.
Which we've written already, and we've already used that in the other
So
project.
This you could actually kind of call the TicTacToe model. So that's the model. This is the view.
Mm-hmm.
And I'm sorry, this is the
This is the
controller, and this is the
the
view.
view.
Yep.
Mm-hmm.
So that's our MVC setup.
Right.
And let's add the images and the fonts while we're at it. Just kinda,
we can
so
absolutely
we have them in
do
the project.
that.
We'll just get those out of the way.
So we'll add files again, and this time we're going to go jumping on the desktop where we have those image files, the same ones that we used in the Mac OS program.
And then we'll shift select the font as well.
And why not? So we'll hold down Shift and we'll grab the font. Can we do that?
I don't know.
Actually, it won't let us do that.
Oh,
it will let us do that. Okay.
Okay, so now you see a couple options. There's the checkbox that says copy items into destination groups folder if needed. So that's great. It'll copy into our project folder. Also, create groups for any folders added.
Yeah.
So that
that's what we want to do.
Exactly.
Right.
So let's add those.
Yep.
And we'll see the font and the images folder.
Nice.
Perfect. Awesome.
Very, very
Flawless.
nice. Very,
Beautiful.
Very nice.
Just because we've been playing tonsil hockey doesn't mean you get to score a goal in my
jockeys. Yeah.
All right.
We have we have everything, and now Brian, let's go ahead and install this font, right? So we could run this from the desktop, but since you guys are probably not going to have this on your desktop, when you guys get this package, you're going to have a folder like this. So we're going to pretend like we're you, and here's the TIFF file, right? Or the TTF file.
Uh-huh.
We'll double click on that.
True type.
Right? And then we'll do the install font.
Yep.
Okay? And that installed the font onto our system.
Look at that.
So we can close out,
It was that easy.
and then come back to Xcode.
Okay. So
I called it Xcode.
now we have the font installed on our system. So now let's go to our app view controller zip file.
Let's do that, right, Dar?
And let's reveal the right panel.
I can do that.
It's like a game show.
What's behind the right panel?
So now we want to go to our object library,
Yes, object library.
which is a little cube.
Yeah, sorry. So we're going to add a label.
Yeah.
All right. So we put the label just like we did in the Mac OS app. We put the label here. We're going to stretch it to the size of the device and
the reason we want to
align center.
The reason we want to stretch it to the size of the device is because this label text is subject to change. And so it being centered is also subject to change with the size being different, you know?
Mm-hmm.
And so if we just put it to the side, so we know that it's going to be centered and it can we can have as much text fill out on here. So if instead it was not player 2, Buzz the Fly, if it was Snuffleupagus, the Snuffleupagus,
right,
it might fit on, so we want to maximize our text space.
Makes sense.
Anyhow,
Anywho.
So let's change the label to be player 1.
Let's
Wibbit
do
the
it.
Frog.
All right.
So let's change the label to be player 1. Wibbit the Frog.
All right.
Player 1.
Player 1.
Also known as Wibbit the Frog.
Wibbit the Frog.
Cool,
All right.
Awesome. All right. Now this looks like
stupid.
Let me see this thing. This looks
this
looks like ass.
This looks like butt, Brian.
Yeah.
It's got to be something that you made.
Nobody wants to play a game that looks like that. We'll just lighten it up here and add just a little bit of yellow here. Maybe like that. How about a little?
That's about as perfect as you can get it. Ugh.
Cool. And then this I don't know if let's change the font here. We'll switch this to be the Alti Has Grotesque. And we'll make this 22. Now what's interesting is you can see that the font in the font preview, which is click here and hide and show preview. This font clearly is not the same as this font.
I wonder why.
And we installed this on the system, so the system understands. But as far as the interface builder is concerned, this is not a font that's naturally available on the iPhone.
iPhone doesn't understand.
So, just keep that in mind as we go along with this, and we will resolve this issue later.
Okay, nice.
Yeah.
Exciting, Brian.
It is exciting.
Yes.
So custom fonts in an iPhone app is definitely something that's fun.
Yeah, and it's worth exploring.
Yeah.
So the next thing we're going to do, I guess, Brian, is we're going to start to add stuff.
Yeah,
right?
let's put like the grid on there.
Right, so we go here to our workspace.
Yeah.
We can then scroll down here to the grid.
Yep. Do it.
Yep, and we can stick the grid on here.
So unlike the other one, let's get this like as high as possible.
Like right there?
Yeah, like a 4-foot bong, just
nice.
high as possible. Let's go left a little bit. It looks a little yeah.
Huh?
Oh yeah. Right
Good.
there.
Perfect.
Oh yeah.
So now we want to get the awake frog.
Yeah, absolutely. Let's
So
just drop them on there.
Awake
Nice.
frog in there, and we'll see if we can capture that little corner.
Okay, and as you notice, an image view doesn't by default like stretch to the view of the view that it's contained in. So in our view inspector, we can switch the mode from center to scale to fit.
This guy right here?
Yep, scale to fill.
This guy right here.
Yeah, there we go.
Nice. That's
not too bad.
Not too scary.
Nope. And we'll just move him down to that bottom left.
Like around here?
Oh, perfect. Yeah, just like that.
All right.
Cool.
All right, now we want to bring his sleepy counterpart over.
Yeah, let's do that.
And
his sleepy counterpart will be like a little, also scale to fit. And then he'll be like a little smaller, if you remember.
Oh, I remember. Remember, I was here last time.
Oh, yeah.
I was sitting right here, right next to you.
In the same spot.
Is that small enough, do you think?
Yeah, and we'll just line him up like he's a clone of himself. It's cool, whatever.
Wow, that is creepy looking, dude. Wow. All right.
Okay.
So now we're going to do the fly.
Yep.
And
fly awake.
Fly awake.
Where are you, Mr. Fly?
Oh.
I don't know. I always think he's French.
Well, because you like to make French parodies. I don't know. Could you do a good Frenchman accent? Oh, I want some French bread and some crumpets. Oh.
And a hairy Pete.
Yes, I like to have smelly, hairy women. All right. A little smaller because he's a fly.
Yeah, a little bigger.
Bigger?
You think so? No, okay. All right. Well,
he's a fly.
All right, cool.
He's supposed to be small.
All right, there you go.
He's inadequate.
He's inadequate. Nice. Okay.
At least that's what his girlfriends tell him. So
all
now
right,
we gotta
fly asleep.
We gotta bring his little sleepy counterpart over.
Oh, siesta.
Yeah. All right, perfect, right? Just like that.
Yep. It's just the eye. It's like the eye of a fly.
Well, it is an iPhone device, so
okay, that's good.
I think a little bigger than that. Oop, 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 oop.
Hi-oh.
Hey-oh. I wanted it to be a little bigger, like a these.
There you go.
Did that?
Yeah, you're
right?
good.
All right, and then we're gonna put him right on the little shadow, like we did on the Mac OS program.
He could probably drop down a couple more pixels.
Brian's always got to be precise with his pixels.
One more, one to the left. Oh yeah,
all right, cool.
Sweet. Done deal. Okay, so now let's hide the sleeping frog and hide the awake fly.
All right, so to hide the frog again, remember guys, there's a little hidden option here.
Yep.
So we're going to put that guy out, and we're going to take our awake fly, and we're going to take him out.
All right, so let's see what this app looks like.
All right, so let's run it.
Yep. And here comes our iPhone simulator, our trusty iPhone simulator.
Hey!
Not bad, eh? That's kind of cool.
Cool, we got little stuff here. And yeah. Awesome. I like it. Now, how much do you think this will go for in the open market? $20, $30 billion?
Yeah.
Yeah? Awesome. All right. Anyways.
Whatever people are willing to donate, basically.
like I said, $20, $30 billion.
Exactly.
Okay, guys. We got that done. I'm gonna hide the.
That's fine.
Console thing.
Awesome.
All right. Now what?
Okay, so now we want to throw the X's in there.
All right.
So as you recall, binding a click event or a touch up event to an image is like not so much. So we want an image to be inside of a button. Right. That's what a button's for. You know?
And now which kind of button do we want?
Well, actually, I'll show you the cool little trick. On the bottom, just type in button.
Stick down here.
Yeah. button.
A button. All right.
Okay, so now we got bar button, blah, 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 round rectangle button.
Which
Done.
one do we want?
Top.
Top one?
Round rect button.
I could have picked that one from the list, Brian.
I know, but...
All right.
Yeah, it's cool.
All right.
Okay, so now let's make it like, you know, like a little taller, so it's kind of... See the little height width thing on the side? Like when you're dragging it?
Yeah. I did.
Drag the...
Don't we want to...
Drag this again?
Yeah.
And so make it like 80 by 80.
Is there somewhere we can define that?
Probably, but this is more fun.
Well, for you.
Up.
It's not going to let me go any higher.
Oh, let's see if we can define it somewhere then. So scroll down in our attributes.
That's all right. I can get it. It's trying to snap.
Yeah. Hey!
Oh! Maybe this should be the iPhone app. Oh, got it. Okay.
Nice, okay. Scroll down here. And if we scroll down on our attributes, keep scrolling, keep scrolling, keep going, keep going, keep going. Okay, so we want to, we want to set the image to be X.
Okay.
So just like we did before, we'll click on image.
Right.
And just type X and that'll jump us to the bottom of the list and
right.
tab off and...
Do we want the PNG this time?
Mm-hmm.
Okay.
It's a little different. It's consistently inconsistent, if you remember.
Yes. The only thing you should ever know about Apple development. All right, what do we got now?
So now we got some problems here.
We have a serious problem,
Yeah,
Brian. It looks weird.
Yeah, that just sucks. Okay,
It looks
so
stupid.
go to type,
Okay.
and we're going to just say, like, custom.
All right.
Ooh.
Ooh, it's all see-through and stuff. Nice.
Okay, so that's all.
So we just have to copy this a bunch of times, right?
Yeah, exactly.
All right.
So, bum, bum, ba-da-bum. Okay, so now we have all of our X's placed in place, and then the next step we're going to do...
The next step? You always say... During the Objective-C series, you said that a million times.
...is to create our outlets and our actions.
Sexy! Welcome back, Wibbiters. As you guys recall, as you can see here, we've developed the view, and I think the next thing that we want to do is try to get that font functioning. So we can get a... No?
Yeah. Well, first let's build our outlets and actions.
Oh, that's...
Or do you want to do the font first?
I want to do the font first. The reason why is because I want to just get it...
Yeah, okay.
Get the view done, and then we can start focusing on the code.
I'm with you on
visual...
Well, why don't we just do at least the outlet for the title, and then we'll get it set up.
Oh, okay, that makes sense.
Because
you are the smart one.
So let's go to let's hide the right panel and go to tuxedo mode.
Go away.
Because what I would have done is I would have just had a switcher on the right panel to switch the right panel to tuxedo mode.
Yeah,
but because now click the right panel.
Like, oh, this is perfect. I like this.
Oh,
Brian.
I'd use this all the time. This is awesome.
Let's see if we can get everything.
Yeah, like it's great.
I love it. This is flawless. All right.
Sorry.
All right. So you want me to take this little guy, right click on him, and drag him in here,
exactly,
right?
Yeah. And now that we've done it for the OSX app like 1,000 times, you're like, oh yeah, I know that.
Right.
Whatever.
So we're now defining the outlet for this UI label, and we're going to call this
like
text title.
Yeah, player title, whatever, doesn't matter.
Well, the way I like to name it is the type that it is first. So it's TXT
and
everything.
Player title.
Or should we call it label, like LBL or label?
Sure.
So we'll do like label like that.
For LBL.
LBL.
Player title.
Player title.
Beautiful.
I like that. And this is of type outlet, so we'll make the connection.
The connection is outlet. The type is a UI label.
Yes.
Perfect.
So now we can.
Nice. Yeah. So let's save this.
Right. Now we can get the font working. So if we save this guy,
and now we go to our app view controller.
All right. So if we go to the .m file,
yep, the implementation, and now we go to view did load. Okay. So now we go. So this is all kind of comes with the view controller, and we will uncomment the view did load comments.
All right, so we're going to use that. Right, and these are just basically instructions that will execute when your file fires up.
Or the zip file, yeah. So as soon as the view is done loading, this is the first thing that does. Right. And as you can see in the comment, it says implement view did load to do additional setup after loading the view, typically from a nib.
Right.
Okay, so what we want to do here is we want to evaluate that LBL player title.
Okay.
And call on the method setFont.
Set font.
Yep. Okay. And so we're going to call a class level method on the UI font class.
Okay. So it's going to be UI fonts, right?
And then the method is called font with name.
Font. Whoa. With name.
Yep. Okay. And then and it's an NS string, and it's going to be exactly like it says in the file name.
Okay. So this file name here.
Yep. So Alti Has Grotesque Bold. So copy that. And go back to the implementation file,
right.
And we'll just paste that little bastard in there.
All right, like that. Do we need the file extension or no? Okay, great.
And then the next parameter is size.
Okay.
And we'll make the size, let's make the size 24. Let's make it 22. I think that's what we set it to.
Okay, like that?
Yeah, and then we'll just close these brackets off.
All right.
And then end line. And that's it.
That's it?
That's it.
All right. So let me ask you this question, Brian. This is only going to show up after we execute
exactly.
it. Right, so it's not going to reflect our development environment.
Right.
So let's see how it looks.
So it looks okay, it's just a little small. So let's quit this and make it like 24 or 26 points instead.
All right.
Every font kind of has their own, stuff.
All right, so this will be 26.
Yeah,
I think 26.
Let's try 26. And if it's too big, we'll shrink it down.
Yeah.
So I'll do what I want.
Do what I want. You don't know me. I'm an iPhone developer now, fool. You can't tell me what to do. That didn't work.
It's still tiny.
I don't think that actually worked. The font still looks the same to me.
I think the name is wrong.
Yeah, I think you're right. The font doesn't look right.
In order for Alti Has Grotesque Bold as that term, we'll kind of we're going to copy this, and we need the application to understand what that font with name is.
Okay.
So what we're going to do is we're going to go to our supporting files.
All right. So that's going to be down here.
Yeah. And there's a file called infoplist.strings.
This guy here.
That's not the file we want to be looking at.
Okay.
There's another file called TicTacToe iPhone app info.plist.
Nice.
Sorry. Okay, so now we're going to add a new key to this list.
Okay, and how do we do this, Brian?
By adding
right-click,
a row.
Add a new row?
Exactly, right. Okay, so now this is going to be called UI, uppercase UI, app fonts.
Like this?
Yep.
Okay.
It's plural.
Oh.
Yeah, and then hit enter.
I can do that.
Okay. So now it understands what that is and now says fonts provided by application. So now we'll hit the little drop down thingy.
Which is this guy here.
Right, because it's a collection.
Mm-hmm.
And we're going to add a value to this. We're going to add an item. Okay, so now we're just going to double click on there. And we're going to type the exact file name. So we're going to hit paste .ttf.
Okay.
Okay, and hit enter. So that kind of like loads a font into the key list for the application to understand.
Okay.
So now let's run the application and see the modified font.
All right, so it looks like, Brian, the font did not load. So this is usually a symptom that we did not properly identify the name of this font.
So this is a very common issue, right?
Right. So how can we solve this? What's a simple way for us to get this name?
What else does it want? We have the string identified in our plist, and we've referred to it, and we put it in the interface builder. Like, what else do you want? Okay, so let's find out like how does the zip file try to reference it?
Okay.
That's usually like a pretty clear way to determine like the proper name of the true type file by the reference of like how the system refers to a particular, because a font is not, if you see like italics and bold and stuff like that, those aren't all one font. That's a font family.
Right.
So we're only specifically referring to one of them, and in this particular case, a bold one.
Right. Okay. So in this case, so we're going to go to the iPhone app project directory for Xcode. We'll go to the app. We'll go to the en.lproj. And then in here we have the zip files.
Right. Now the zip file is really just an XML file.
Right. So we can open this with, and we could do other and
TextMangler.
TextMangler. So we can open this with TextWrangler. And you'll see that this is nothing more than an XML file, right?
Right.
So when we cruise through here, we should be able to see.
Because if you remember, when we built the interface, we did select this font.
Right. Yes, we did. And here it is right here. So what if we took
look at that.
This text.
So if you notice, it's a little different. There's an underscore bold.
Right. So let's try that. Let's go to Xcode. And let's paste
and our file name
that.
didn't have that underscore in it. And it doesn't have to.
Right. So let's see if that helps. And it did. Very cool. Now, to prevent some weird file locking issue, I'm going to take TextMangler out of this. All right.
Cool.
So the font has been set.
So it's a little weird. So just to kind of recap, we first set it in the interface builder.
All right. So we came here and we went to here and
even with all that, we still can't preview that font in the interface builder.
Yeah, I know, it's crazy.
Okay, so then we went to supporting files. So we set it in here.
Right.
Then we went to supporting files to our app info plist.
Yeah.
And we added to fonts provided by the application.
Yeah.
And we referred to the file name.
Right.
And then
we came here, and at first we had the wrong value, but once we put the correct name, this functioned like a champ. Yeah. All right, so now we have to define the outlets for the rest of the objects.
Yes, okay, let's do that.
All right, Brian, so now what's the next move?
So now let's make the outlets for the player images, and then we'll make the outlets for the cells.
Right.
The tiles, and then we'll make the click event for all of them.
Okay, so we have our little tuxedo man here. Tuxedo man! So I'm going to bring in the frog awake, and this is going to be an IMG frog
awake. Just like it was on the OSX app.
It'll be exactly the same.
So that way you don't have to worry about these concepts so much because you're already used to this. Yeah? You see?
Yeah, you see? How do I make this?
Just drag
that's right.
Yeah.
It poofs away. I forgot about that. So next we're going to do the sleeping frog. We'll drag his little sleeping behind over here. So IMG frog asleep. Right?
Yep.
And that looks good. I'm going to make some room for myself to work here. Okay, so now that we got those two guys, let's get the fly. So we'll do a IMG fly awake.
Cool.
And see if I can get this little guy. We'll do an IMG fly asleep.
Awesome.
Very nice.
All right, cool. So let's we can kind of like shrink the spaces up if you want a little bit.
You mean like this?
Yep.
Oh,
beautiful.
All right, Mr. Picky Pants boy, you.
All right, so now we will create outlets for each one of the tiles so that when we clear the board, we can blank them all out.
All right, so we'll pull this little fella out here. So this will be
TTT-A1.
TTT-A1.
Or you can just say BTN-A1 if you'd rather. Keep it consistent.
Yeah, I'd like to do that.
Oh, yeah?
It's done, okay? It's over. It's done, okay? Just get off my back. Jeez.
Right. So now let's create our
God. All right. Action Jackson. All right. Now, Brian, remind us again how we can make these actions.
The same way we made the outlet.
Right.
It's just like a little drop-down thingy.
So we're going to take this guy.
Down in there.
Down here.
Yeah.
And then instead of the
outlet, it'll be an action.
We go to
Yeah. So now, this is a little different. So we're going to call this like our click action or whatever you want to call it.
What did we call it in the other one?
Click tile. Let's call it that.
But what did we call it in the other app?
Tile has been selected. let's call it that.
Are you serious?
Yeah, tile.
You're an ass.
Tile was selected.
Tile is currently...
No, it's not currently. It's past tense.
Okay.
Tile has been selected.
Been selected by the user of the
That's way too
location,
much.
and he is
Pissed.
wearing...
And he is waiting.
He is waiting for this method to execute in order to do what he needs to do ASAP. I mean, we can't just keep
the guy
waiting.
Or her, I don't want to discriminate.
He has a
life,
lot to do today. Serious.
Okay. And more importantly, the event is going to be touch up inside. We have a couple different events we can use.
As much as I want to call it that, and as much as the Apple people want it to be called that, I'm not going to do it.
How about just tile has been selected? I don't like this any more than you do.
Okay. Woo! All right, you were saying.
So click on the event thing and let's see the other events.
All right.
That's nice.
Wow.
Let's do touch up inside.
I'm sorry, what?
Touch up inside.
Okay, all right, okay.
Just get up inside there and just touch around.
And the arguments
are that simple. It seems like it's really mysterious. It seems like, how am I going to approach this thing? I don't know. I've never you just get up inside there and just touch around. That's it. It's that simple.
It's that simple.
It's way less complicated than it seems like it would be.
And the great thing is, Brian, once you master that technique, you can apply it to every single other object you come in contact with for the rest of your life.
Yes.
So we'll just kind of
So just like, we did on the OSX one, we're just going to keep on reconnecting the action to each one of these little button objects.
Yep. The same exact action. And if you don't know what we're doing, go back to the Mac OS app.
Yeah.
Because if you skip that, we don't like you.
Yeah, we did it in order for a reason, people.
Yeah. Come on in. 40 years.
Get with the program.
Yeah, the program. There you go.
Okay.
Cool, huh? Now, can we build this?
Yeah. Yeah, we can build it.
Are you sure?
Yeah. Oh, let's put like an NSLog in there and see if we can get a click action going.
Oh, we can do that. No problem.
Oh, let's put like an NSLog in there and see if we can get a click action going.
Oh, we can do that. No problem. Okay, so the NSLog would have to go in the implementation
of
code.
The controller.
So we'll hide that for now.
We're basically done with the interface. But so let's go to down below here. Keep going. Nope. After this, tile has been selected.
Yes.
And we'll just throw something to the NSLog like you have clicked, and then we'll display the tag like we did before. How about that?
We didn't set the tags.
Right. So we'll say we'll display the tag. We'll go back and set the tag and blank out the images. How's that?
So we'll do you have clicked, and then we'll add the parameter
Okay, that works.
Right. So that way we can at least show the
semicolon in there.
No, I don't know why they got to be all picky. I mean,
I can't imagine
a circumstance. All right. So now that this fires up, NSLog shows you have clicked.
Nice,
and
awesome.
I think all of them are responding. Okay.
Oh yeah. What was the? Didn't you come across like a brethren Apple developer in the forums the other day?
Oh yeah. I emailed that to you. Pull up.
Yeah.
Get the link.
I think it was on Stack Overflow, which is a great site, by the way. So we'll just search Google for Stack Overflow. Great website. And then making UI alert view. Wait for user input.
Input.
There we go. Okay, so this guy asked a perfectly legitimate question. So this guy says, okay, here's what I got going. A perfectly fair question. I've got a UI alert view set up, but he wants something to happen as a result of clicking it. Because the way the UI alert view object works is it'll just kind of show release fire and then it threads off and you can't, whatever.
Mm-hmm.
So he wants to do something. He wants to kind of wait for the response and then do something as a result of the response, And so here's the answer, and I don't even know why it was an accepted answer.
And I don't know why you would waste your time answering if this is your answer.
Unless you're just getting off by being an asshole. I don't know. So here, like, it's just the condescending tone that drives me crazy. You can't do that. Show, message, and UI alert view won't stop for user input. Associated delegates will need to handle the code you are planning to put in. Second set of code section. Having said that, let me give you some advice. Like, seriously, I know he probably didn't mean it quite that badly, but it always comes off this way. Add text field with value message is an undocumented API user feature. Do not in bold. Like, the guy's taking the time to bold this shit, you know? Like, what a face. Do not use it. It has been used a long time ago. That approval process from Apple for you APP would let you pass even if your application used add text field with value. Oh my god, I'm so sorry. I forgot it's depreciated. Like, whoa, kill me. But nowadays, like this month, that doesn't happen anymore. Your application will be automatically rejected if it is using that undocumented feature. Here is a blog entry on the topic. Hope it helps.
Now, this did not actually answer the guy's question.
No, not at all. I don't even know why there's a checkbox on it. Like, what the fuck, dick?
But
like,
now,
here's a blog entry on why you can't do what you just tried to do. Go f*** yourself, you know? Like, it's probably not actually going to get rejected for that, you know?
So now, if we go down here's one of our friends.
And like this guy, like this, you know, this weird demon, like, he's obviously a nice guy. Like, he's just a guy trying to learn some shit, you know?
Right.
He's like, good to know. Thanks for the info.
But then here's the guy that I like.
Yeah. And then this guy's like, don't you just love it when people say, don't do it that way and never give you any good or correct way you should be doing it? Thanks. like this person's, you know, like.
He gets it.
Yeah,
this guy gets it.
It's like,
yeah.
What the f***? You just wasted the thread. Like, I'm glad now we have a place where we didn't answer the question. It's still a perfectly valid answer. And there is a way to get the UI alert view to wait for user input. And surprise, surprise, we'll show you how to do it in this project.
Yes.
It's awesome.
Yes, you will know. And then
who you, buddy?
And the first person that watches this tutorial, here's the race. Here's your homework assignment. Go to this thread and answer this guy's question.
Yeah, exactly.
We're not going to do it.
Right.
This is your assignment.
Yes.
Answer this guy's question. And the 25 other threads that have the same question, answer the f***ing question.
Yeah, so we can fight back against these f***ers on these forums that are ruining Apple development.
Well, they're ruining, yes, they give development in general a bad name.
They're beautiful devices. It's not a bad language. The object structure is strange, but once you get used to it and don't mind its inconsistencies, it's not bad. But these f***ers are ruining it for everybody.
Yeah, Wibbit.net, revolt!
Anyway, we digress significantly.
Alrighty. Alright, anyways.
So, I don't even know what the hell we were doing anymore.
We were doing we were gonna put the tags or something?
Yeah, let's go put the tags in there.
Because we already tested this thing.
Yeah. Let's put the tags in there.
Alright.
Display the tag.
We were gonna put the tags or something?
Yeah, let's go put the tags in there.
Because we already tested this thing.
Yeah. Let's put the tags in there.
Alright.
Display the tag. It'll be good.
Alright, now we're gonna be using the same algorithm that we did in the Mac OS app.
Right.
And the tags that we're gonna set,
will be like 1, 1, 1, 2, 1, 3,
and the tag is down here. So it's gonna be 1, 1, right?
Yep.
And then this one's gonna be 1, 2.
Yeah, And again, these are integers, and like, there isn't really any other way to identify the objects other than this tag integer. One of the things that threw me for a loop, let me just kind of like digress here for a sec. I'll just wait.
Yeah, let's get through this first.
I'm just getting excited.
I know, I'm getting fired up as well. Because once we get this done, I mean, the app's gonna write itself.
Yeah,
you know?
Basically.
3-1,
3-2,
32, and 30. Alright, so now we have set the tags for these.
Yeah.
And now we can actually retrieve those values.
Yes, we can.
So let's go back to the M file, Brian.
Right.
And let's start writing.
Oh, yeah, let's put, you have click tag.
Right, we can do that. You have clicked %D. And this one we don't have to typecast.
Yeah, because we're in iPhone land. An NS number is not a long.
iPhone land. All right, cool. So,
and we probably want that. Oh, it popped up anyway.
11,
okay, cool. So you have clicked 11, 12, 13. Awesome. Oh, this is great. So we're already cruising and kicking and rolling.
Rocking and rolling.
So in our header, let's make a reference to our model class.
Let's do that. So
actually, in our, I'm wrong. I apologize.
The implementation.
Yeah.
So we're gonna go in the implementation right before the TicTacToe iPhone app view controller header file. We'll do a little import action here, Brian.
Yep. And we'll import TicTacToe.h.
TicTacToe.h.
And that way we got our model class.
Nice.
Okay. In our header file,
yes,
we will create a little instance in here.
All right, so
TicTacToe. And we'll call it TTT just like we did before.
Nice.
Awesome.
So now we're going to add a dealloc overload here, or method here. Yeah, and even though we don't really have to do it, Brian and I like to do this.
Actually, I don't like to do it. Well, Kevin likes to do it.
Well, I don't care. I'm just the most badass person ever.
I can see its merits.
Yeah, so
I'd probably start doing it.
In the dealloc method, we'll go ahead and before we run super dealloc, we'll do TTT release. And we need to then instantiate, Brian, on the view did load method.
Yes, view did load. So
okay.
I was going to view did unload. Yep, exactly.
All right, so in the view did load, we're going to do the TTT equals an instance of TicTacToe alloc, and we'll call init.
Perfect. Look at that.
And there's that.
Cool. And then actually that's pretty awesome.
Yeah.
So now we'll start on our the tile has been selected by user method.
Okay, great. Awesome. Here we go.
So now we'll start on our the tile has been selected by user method.
Okay, great. Awesome. Here we go. So now in the tile has been selected method,
okay,
we're going to do some ridiculous craziness.
Yeah, this is where it gets fun. Okay, so now we want to do something. Now we have our outlets all set, so we can always go back and access things in our view from our controller.
Yep.
And we want to have the logic come from our model class.
Right.
So you're kind of seeing how this starts to come together. It's kind of cool. If you remember, we need to know a row and a column from the tag.
Yes.
So let's set up exactly.
Okay.
Yep, perfect. And we also are going to want a...
Does it not like this, or is it just saying it's unused?
It's just saying it's unused.
Okay.
It's just bitchy. For the moment, we're just going to create an NS string called string message. And the string message is going to be like the... Actually, we can call it like player title message if you want. Actually, let's just call it message because it's going to go to...
Call it message?
Because we're going to like log it and some other stuff. You know what I mean?
I don't give a crap. Message is fine.
Cool.
I'm easy.
All right. So then we're going to say the column is going to be equal to...
Okay.
The... I'm going to do this backwards because I think our whole, like, everything is backwards. You know what I mean? So we got a 50-50 shot, so I'm going to switch it.
All right. Worst case scenario, we fix it.
Yep. Okay, so this is going to be the sender tag divided by 10 minus 1, typecast to an integer.
Okay, so we're going to do sender
tag, and that's an integer.
Right.
And that's going to be divided by 10.
Right.
And then minus 1.
Okay.
So that, and then typecast that to an integer.
You tried to pull the same crap on me in the other app. That's going to be fine.
Okay.
I promise.
All right. Row?
It's already typecast.
All right, so then this is going to be mod 10 instead.
Right.
And so that way, like, 10 would be 0, and then 21 would be whatever.
Cool.
1, and
nice.
so on.
So let's go ahead and
select all, delete that.
Select all, delete that. I'm going to move this little fella down here, and
we don't actually really need that. We can just...
Well, I'm going to do it just because...
That's cool. Okay, so after...
Hold on a second. Clicked row D, column D, and we'll do...
oh, yeah, good idea.
Row, column... Let's see if this is functioning as
cool.
expected before we get too far into this.
Perfect.
Because we did have a little snafu in the other app. What is this? Expected star before... What is this?
Try importing it above UI
no.
instead. That doesn't make any sense.
No, because you've already got it imported ahead of content.
Yeah,
It's already imported.
unless it's like
here.
freaky, because
Yeah.
in my code I have it in the header.
I mean, we could try, but that's not
Yeah.
that's not going to do anything.
It shouldn't.
It won't. It shall not. And it did. That is the dumbest thing.
Is the lamest thing I have ever seen.
All right. So what is that? What consistently inconsistent?
Cool.
I hope that we're also making some Apple people a little embarrassed at this.
Yeah.
Because those types of things are just insane.
One of the things we want to kind of show you with these screw ups, other than the fact that like we're not perfect, nobody's perfect, and you don't have to like you're fine. Like chill out, don't beat yourself up, you're fine. One of the things we want to show is with a programmer's programmer mindset, what does it look like to approach Apple realistically?
Yeah.
Do you know what I mean? Because if we're a programmer, and we are, like take Kevin theoretically, for example, you learn Objective-C.
Mm-hmm.
Like not Apple, you learn C, you learn Objective-C. You know Objective-C.
Right. Very well.
So knowing Objective-C, why are the rules consistently violated?
Right.
This is Objective-C, it's an Objective-C compiler.
Right.
So it's an interesting thing to see. It's just like the English language. Like a lot of other languages have a system and they have a structure and they have rules.
Right.
Well, with English, there's always these exceptions. Well, because we're in the South, we're going to say this. Or, well, because, this, we're just not going to pronounce the E. Whatever. It's like all these crazy things. Like, you have to constantly memorize all these weird exceptions to speak English.
Right. So we got row 0, row 1.
Yes, column 0.
Row 2, row 0, row 1, row 2, row 0, row 1, row 2.
I'm an old man now. Okay, whatever.
Whatever.
So we were right all along. Okay, so now, if you remember, we have like an exception that gets thrown up if anything happens in certain circumstances and stuff. So let's make a big fat try-catch block.
Let's do it.
Ooh.
Thank you for filling all of this out for me. I appreciate it.
Yeah, nice. That. Okay, cool. Awesome. So,
I get to delete all this crap too.
Thanks. That's cool.
Thanks, buddy.
All right, so in the catch, let's do like an NSLog.
Okay. All right.
Error.
Like that?
Yeah, and then we'll just
like do the percent at.
Yeah, exactly. And it's the X reason.
EX reason.
That'd be funny if we just released it.
You want to throw me an error? There you go.
Throw you an error.
I'll show you what you can do with your error.
Okay, so let's just kind of do some stuff and see if it works. So first thing we want to do in the try block is to make a move.
All right.
So we clicked a button. We want to tell the. Excuse me. We clicked a button.
The button.
I get a little nervous being recorded. There's a guy that I work with that every time we're in a meeting, he like somebody will go speak and it's like, okay, person, maybe you can explain this. And, okay, and he never talks like this otherwise, and he's just like, the thing is with the. And he's like always like trying to swallow throw up. It's like he's constantly vomiting in his mouth.
Oh, it sucks.
Yeah,
Poor guy.
Suck. I know, poor guy.
Poor guy.
He's a great guy. He just,
so we're making a move with the column, which we've done this
column,
before.
yeah, and row, whatever. So we make a move.
Come on. This is chicken shit right here.
Now this is the thing that will probably get the error thrown up from it.
Ever.
Anyway. Okay, so let's say that if it's not X's turn, we're gonna set an image to X.
Right. Oh my God, this process looks weirdly
so familiar. I know. It's
so
strange.
TTT.
We could probably have. Well, it's different enough to not be able to copy and paste .osx.
Yeah.
Because it gets different. See, like
we did change it around, so yeah.
We had to.
Yeah.
Otherwise, we would have left it the same.
All right.
You got some.
All right. I got.
You got some freak nasty shit with the.
All right. Okay. All right. Okay.
Guys. All right.
Okay, all right, cool. All right, so if it is not X's turn.
So then we're going to say, on the sender,
okay,
which is the button, UI
sender,
button.
Hello, sender, how are
We're
you?
going to set image.
Sender, I would like to set your image to something.
Now, this is a UI image, so it's a little different. So what we're going to do is we're going to call a static class method on UI image.
UI image, okay.
And the method is called image named.
Image?
So it's basically going to be like, give me an image named.
Right.
And it's an NS string, and we're just going to say x.png.
Okay.
Now that is sexy. That's way
better.
sexier than like the whole making the NS URL bullshit. Like that just sucked. Now, this is depreciated, unfortunately, so we can't do this. We actually have to also add for state, UI controller state normal. I know. Why not just make it, it's outside of that.
Oh.
It's actually part of the set image.
Yeah. So
set image by itself is depreciated, right?
Right. Okay. For state.
For state. And the state's going to be UI controller state normal. Now, were it me, I wouldn't have depreciated set image. I would have just defaulted to UI control state normal. But what do I know? I'm not an asshole. Okay, so else.
All right, but we can copy this, right? Because we're going to use this verbatim.
Yeah, absolutely. So else, we're just going to set it to 0. Or O, sorry, not 0.
Else, we're going to set, instead of X, we're going to set it equal to O.
Yep.
Which we've already imported, right?
Exactly.
The image is over here, right?
Yep. So, in theory, if we make a move, we should see the image swatch.
All right.
Before we test that out, let's go to our zip file, select all of the X's, and make them blank.
Yeah, you're right. We do have to do that.
We could do that when the app initializes, but
we're not going to do that. So we hold down the Shift key, and we're going to just walk through.
Not the Control key. You'd think so, but no.
That's Winders. All right, so now that with them all selected, the image is going to be blank, which is it in the list?
Yep. Scroll up and blank.png.
All right, we did the exact.
There we go. Cool.
We did the exact same thing in the Mac OS app.
The only difference is iPhone has the .png extension in the name.
Right. So let's fire this baby up and see what it does. So when we
click one of them, it should set the image to whatever player's turn it is.
Okay, so that's an X.
Cool. And we click another one.
Move this over here so we can see the log.
Beautiful.
You're beautiful. It's true.
O-X-O-X. Nice. Awesome. All right. And the game's
over. Oh, that's right. There was a win. I unintentionally won.
So it's just like, it's catching error. Yeah,
because the logic is correct. We're just not displaying it correctly. Right.
And we're not switching out like who the player is and stuff.
Right.
Anyways, so far so good, right?
Yeah, very good.
You guys following along? Everything's cool so far?
Yes.
So, if the winner at this point in time is the character D.
Okay, so if TTT, who is winner, equals a draw, right?
Yeah.
Then what?
Then we're going to set the message.
Oh, so we're going to set massage
equal to it's a draw.
Like a D's?
Yeah.
Nice.
Maybe one more explanation. No, that's good enough.
I'm going to put another one, just because.
Okay, cool.
It doesn't look correct.
Yay!
Hey! Else if, right?
Else if, yep. The winner is X.
If TicTacToe, who is winner, equals X, okie dokie.
Then we want to set the message to be, the winner is Wibbit the Frog.
Alright, so message equals, the wiener is Wibbit the Frog.
Yay!
2 exclamation points.
Alright, and...
wait, no, this one it's a winner. This one gets all 3.
Okay, cool. You could probably copy the else if too, if you felt so inclined. But
okay.
Whatever.
I'm doing it.
Because we're going to say else if... Oh. And the reason we don't put an else, because it could be a blank space too.
Right.
Cool. So the winner is Buzz the Fly, because he flies.
Yeah, as evident by his little shadow.
Yep.
Nice.
Cool. All right. Now, if we get past this point, right, and the message is not null,
right,
that means that there's nothing else to do. We've kind of hit like a terminal condition in the logic of the game, right?
So if it does not equal nil?
Yeah, so if it does not equal nil, we now have a message.
Right.
So so we want to basically like throw an alert, reset the board.
Now this is going to be a tangent.
Yes.
Because we have to kind of describe how this happens. Now, there are, just to be clear about this, there are many ways to accomplish what we're about to show you. We're going to show it to you the way that Brian and I feel makes the most sense.
Yes.
It is not necessarily the way that you'll see other people do it.
Now, to prevent confusion, should we just put a comment in there and log it and come back to that?
I think we should. So we'll do a pop-up.
Pop-up alert.
Like, you know when you're using your phone, you get a text message, you get like that little pop-up alert?
Yeah, we want to do that.
That's exactly what we're going to do.
And then upon hitting OK, we want to clear the board.
Right.
So the question the guy asked in the Stack Overflow forum, where like you want to
Right.
do something as a result of somebody clicking something.
Right.
That's what we'll show you how to do. And we may have to kind of like describe the concept first. But anyway.
Right, we will.
We'll get there.
Really, once you get the concept
No
down,
big
it's
deal.
very,
Yeah.
very easy.
So long
Very
as you watched
easy.
Intro to Object-Oriented Programming.
Yes, yeah.
Okay, so we'll just write...
And you paid attention during the delegate lesson and...
Yeah, so
all
we'll
that
just
stuff.
write to the log the message. Like, just the message.
Right, so
Nothing
we'll
else.
just do message. Okay.
Yep. I think we have to give it a format string or else it'll get pissy.
Nah, you don't have to. Anyways, what's next?
It's gonna get pissy
It
because
does?
we didn't give a format string.
That's not
Yeah, click on the little warning thingy.
Objective-C.
I mean, it'll be... Yeah, see?
I've used this a
Yeah,
billion
yeah,
times
yeah.
without having this issue.
Well, you can just say, like, F the warning, but still.
So in the iPhone,
So we'll
is
just
it that?
At. That's at.
Okay, so it's going to be percent
%at,
Okay,
yeah.
I didn't know if the iPhone was
Yeah.
different.
You would think it's consistently inconsistent.
Yeah, right.
That would be consistently...
And you know what sucks about this framework is you consistently have to stop and think about that kind of
Yeah,
stuff.
so
you know?
that's why I would kind of recommend, if you work in a group, have one person become the expert on OSX,
yeah,
and
right,
have one person become the expert on iPhone. Like, draw straws or something, you know?
right,
Because, like, switching back and forth kind of blows.
yeah,
It's like switching back and forth between VB and VB script. At which point, if you're using either of them,
yeah.
just, like, jump out of the building.
No, don't do
Not
that.
like a really tall one, just enough to kind of, like, be like, ow, that hurt. Not enough to go splat.
Yeah, well, and don't do that, but just find a better job.
Okay, fair enough. I'm suing him because he told me to do it. I believed him. I believe I can fly.
There it is.
Okay,
I knew
yeah.
that was coming. I knew that was coming.
All right. So, anyway, so that's the case
And
for that condition.
we want to clear the board, don't we?
Um,
Oh no, I'm sorry. That
Yeah.
happens somewhere
right.
else.
So we do. So
Forget
maybe you
about
add
it.
a comment in there and we'll say clear the board.
Actually, we don't
Because-
need to do that. We don't need to do that.
Well, we'll
Because-
just put a comment to say that logically that will happen. Yeah, pop-up alert and clear the board. Now, if you remember in OSX, we had like the reset board method. Now, we
Right.
didn't put that in here. We'll get to that.
We're gonna put that somewhere else.
Anyway, so just know, blah, 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 blah.
blah blah blah.
After this
Okay.
if condition,
Okay, dokie.
we'll say like, if whose turn is X and the winner is still blank.
If TTT, whose turn equals X.
Yeah.
Okay.
And the winner is blank.
TTT, who is winner equals space.
Yep.
Okay.
So we have no winner, and it's X's turn. Then in a if block,
Mhm.
we will set the player title text. Now this gets interesting. In iPhone land, a lot of these objects have properties.
Right.
So what we can actually do is say the label player title dot text is equal to some NS string.
That's weird.
I know, isn't that awesome?
Huh.
It's much better. I wish they would just update the
Yeah.
API for OSX
Right,
to
and then-
like reflect it. I mean,
And then
just-
depreciate everything else.
exactly.
Yeah.
I mean, it's not like they don't depreciate shit all the time. So we'll say player Wibbit the Frog.
Isn't it player one?
Player
with
one.
The frog?
Yep.
Okay. Nice.
Cool. Okay, so now we want to do the same thing we did in OSX land where we set hidden, and this hasn't
Right.
changed.
Right.
So even though this is like not an NS image, but instead a UI image,
So it's going to be the frog awake.
right?
Set hidden.
To know.
Set hidden to no.
So there are still some similarities between the UI image view and the NS image,
Yeah,
but whatever.
it's rarely consistent.
It's inconsistently consistent.
And so how many of these? We're going to have four of
Four,
these,
yep.
right? Because there's going to be the image frog awake,
Image frog
image
asleep.
frog asleep, and the image frog asleep is going to be yes, right?
No. Yes. Because it's hidden.
Right.
And then fly awake
image
will be
fly
hidden.
fly awake.
That will
Set
be hidden.
to yes.
And then
Asleep.
fly asleep will be sleep.
Yes. No.
Perfect. Okay.
All right.
And then we'll say else if the turn is O and the right. So just grab that whole
Yep.
kit and caboodle. And we'll just say else if.
Else if the turn is O and the winner is blank.
Yep. So in this case, the text title is going to be Player 2, Buzz the Fly.
Buzz Aldrin.
And then we're going to switch the logic.
So this is going to be yes. This is going to be no. This is going to be no. This is going to be yes. All right.
Okay, so apart from implementing the alert view, we are functionally done.
Right.
We just have to implement the alert view and how to reset the board.
Okay, so let's take a look at what we have here. So now we should see stuff swapping around. So right now it's Wibbit's turn. When Wibbit's no longer up, he's asleep, the fly is up. So now it's O's turn.
Yeah.
So now the frog, it's there, and then the fly, and then the frog. And now he actually won. You see down here, the winner is it. Winner is what that's supposed to say. But the winner is Wibbit the frog. So the logic is in place to capture this.
Yeah.
The winner
is.
The winner is.
Okay, cool. Awesome.
So now, Brian, let's have a conversation about the delegate.
Actually, we could just do the UI alert view, but it won't be based on an action. Just to show what it looks like. You know what I mean?
Okay.
How's that?
That sounds good.
Okay, so we're just going to show you... so we'll get into the UI alert view, and then we'll do the resetting the board. Okay, so let's put in the UI alert view, and that way you can kind of see what this thing's all about.
Right, okay, nice.
Okay, so let's make a UI alert view, and we'll just call it alert view.
Okay, alert view.
And this is the pop-up that you're used to seeing. Yeah, you got it?
I'm getting there.
And,
you speak, I code. That's how it works here.
So we'll alloc and init with title.
What? UI alert view, alloc. And then we're going to, I'll just pop this on the next line. Init with title. All right, and the title is?
Wibbit.net TicTacToe.
Okay.
Yep.
And the message is?
Nil.
Oh. Well, very anticlimactic here.
And the delegate?
The delegate is?
We'll say self.
Okay, you gotta be all boring again.
Yeah.
Stupid Brian, I hate him so much. And the cancel button is?
We need a colon after the delegate, I think.
Stupid. Why do you always have to be all like...
Because you're stupid.
Self-righteous.
And you smell.
Alright, and the cancel button is?
Close.
Actually, that's not that bad. I'm actually kind of excited about that. Oop,
and then let's get rid of all that other crap, and we'll just make the other button titles nil.
All right, so I'm going to take these down here, and this is going to say nil, correct?
Correct.
Correct.
And no comma. And just get rid of
no
the other
comma.
One. We don't need that. Shit.
Comma's
get that out of here.
Like this.
Yep.
All right.
All right. Cool.
Real quick. I don't know if I trust you, Brian. They didn't give us a chance to use it. No init. What is this?
Init with title.
Delegate. Oh wait, look at this.
Yeah. Whoops.
That's my fault. But it didn't error. I mean, it would have still tried to do that.
That's funny. Okay. Cool.
Yeah.
So build succeeded. So we're going to create a UI alert view object.
Done.
We're going to initialize it with the title, Wibbit.net TicTacToe. We won't have a message.
Nope.
And the delegate we're just going to pass ourselves. And the cancel button title is just going to say close.
Sounds good.
Okay. And no other buttons and stuff. Because it's alloc init, and finally, after we try or catch, we want to release the alert view object.
Right.
So that's kind of a cool thing about finally. No matter if we catch, if we fail, if we try and succeed, after either condition, we'll properly release the alert view.
Finally.
I know, I like it. Finally, it's happened to me right in front of my face, and I just can't hide it. Okay. So, if the string message is not null.
Oh my god, I know that song. Jeez. I'm gonna pour my drink over your head. That
was a good pull, huh?
That was a good, I mean, I'm embarrassed for you, but yeah, that was a great pull.
You knew it.
I did, yes.
I couldn't tell you who sang it or when it, I don't know. It's just somewhere in like the canyons of my mind.
That's your next homework assignment, Wibbit viewer. Who sings that song?
The Wibbit.net soundtrack, and people will be like, what the
and then
did you put together all the songs?
when you find out who does that song, go to some random Apple forum where somebody asks a legitimate question and then post that as the answer. Like, not even relevant.
Okie doke.
Woo, baby. All right, rock and roll. Let's do it.
The answer to your question is found at 2 minutes and 43 seconds in a song. Finally, it's anyway. Okay, so where we have the little comment that says pop-up alert and clear board, let's just pop up the pop-up alert. Actually, we will show our alert view.
Nice.
Okay, so
Is that it?
Well, it would be otherwise, but we don't have a message. So before we show that, let's set a message.
Okay.
And that's really crazy. We say set message.
Oh, interesting.
I know. See, the iPhone SDK is really kind of not that bad. You know, it's way better once you get used to it than the OSX BS. All right. So we're going to set the message to, we actually just have it in message.
Oh.
So you can just get rid of that little doodad and. Oh,
like a Dece?
Perfect.
Can we run that?
We can run that. So if we have a winner, it will pop up and say we have a winner.
Right.
So let's check it out.
Right, but there is a catch here.
Yeah, and we'll show you this catch here right now.
Yeah.
And that will lead us to the final question.
And helping out that poor unfortunate soul on that forum.
Exactly.
We should probably just post on the forum, go to whippet.net to answer your question. All right, so here, right? We hit this. All right, good. We hit this. Boom.
Hey, look at that.
The winner is
So that is the UI alert view.
Right.
Kind of cool, huh? And then we have the button that says close. See where it says the NSLog message?
Yep.
That happens after we show the alert view.
Right. Watch this. Yeah. Okay. Great point, Brian. Watch the log output or the terminal output here.
Now, I think if you click on that X again, it will show an error.
What?
Click on a space that's already been clicked.
Well, hold on. First,
Okay,
first
sorry.
let's demonstrate this.
Right.
So watch this. When I click this, watch this. So you see that this text right here executed, even though this window popped up. So this window is not waiting for a user interaction to continue with the code. It actually spawns a separate thread.
Right. So if you say, like, while alert view is displayed, like, that's not going to help you.
Right.
It won't do anything. It doesn't work that way, unfortunately.
Yeah, yeah.
So,
if you do that, actually, it pops up with no text and just sits there and does nothing.
Right.
Yeah. What it wants...
it's not like it waits and then continues, you know what I mean?
Right.
So if we hit close or don't hit close, it doesn't really care. It's just going to complete this.
Mm-hmm.
And so that's okay. So, there is no, like, alert view wait, you know what I mean? Or, like, wait for completion. The way that this will work is by, in the top, when we instantiated this, we said delegate self. We can actually, there's a certain method that's called when the cancel button or when a button is hit.
And we will discuss that right after these messages.
Yes. Good point.
All right, so let's kind of explain how this alert view thing's going to work. Just to kind of start off, we're dealing with objects, right? And object-oriented programming. So we'll take a look here. This is our little UI alert view. So we'll call this UI alert view, right? So the UI alert view is just kind of chilling over here. So this is the guy that actually makes that little window to pop up, right? Now, this little guy has a assumption, right? There are things inside of him that are designed to execute during certain situations. So you could look at that like it's a method, right?
Right.
And there are multiple methods here. Now, these come actually from a protocol that defines these methods. So an abstract class, although you don't really have to, well, we won't even really get into that, but that's kind of like where these come from. Now, let's take a look at an example of one. There's a method called clicked button at index, and magically our method and object got larger. I wonder how that happened. So anyways, we have this object with this method. Now, right off the start, this method is not activated.
Right.
It's just kind of sitting there
It has
doing
the
nothing.
potential to exist.
Right. But it does not exist initially. Right. So now let's take this object
But
here
it's not really implemented initially.
and let's make this as our code. So when we look at what's the name of our controller class?
Our controller class is it TicTacToe iPhone controller view? TicTacToe iPhone view controller.
Something like that. We
Yeah.
may be off by a little bit, but whatever.
You get the point.
Right. So here is our controller. Now this is our iPhone application. Now inside of our iPhone application, we are making an instance of one of these little fellas in here, right? So this is just an instance of this type. And when we evoke this, so when we call the method inside of here to show, it's going to check to see, do I respond to a responder? Is this responder or is this method available? And if it is not available, which is a circumstance that we have in our code, it just flies by and does nothing.
Right.
But if it is available, then what we're going to do is we're going to process something and we're going to be retrieving the index of whichever button, like it'll be a numerical index. So if we had 2 buttons, you'll have 0, you'll have 1. And our program will actually wait for that action before it continues on. So the thread will run, the thread will stay running, and then once that's done, it will exit out. Now, how do we do this? I mean, there's a few ways that we can do this. We could actually probably subclass the alert view, but we're not going to do that. Another way that we can do this is inside of our class, we could make a method that's called clicked button at index.
Right.
And then we would pass ourself
as the delegate. And
then this method here will then be defined, and it would then, in turn, run that code back here.
Right. So one of the disadvantages of doing that is that any time that we then create a UI alert view,
right,
it would only be doing that action that one time.
Right.
So that's not very flexible necessarily.
Right. Yes.
In our particular case, we could get away with that.
Right.
But we want to show you maybe like what we think is a better programming practice.
Yeah. And it's kind of stuff that you already know because it's things that we've already discussed. So what Brian and I are going to do is we're going to take
the UI alert view and
we're basically going to make an instance of a class to use as a delegate, Brian, and we call it something like reset game delegate.
And this is just going to be an NSObject.
And you guys are familiar with this type because when we talked about delegates before, this is kind of what we did.
Right.
So in this case, we're going to be defining a class that has a method here, and the method is going to be called click button at index.
Right. Now in proper Appley world, this reset game delegate class would not only be from an NSObject, but it would protocol.
Yeah, you would implement a protocol.
UI alert view controller delegate.
Right. You can do that. Now, really, when you define a protocol, what exactly are you doing? You're just basically taking in a design for a class, and you're making your class fit to that format.
Right.
Now, in Objective-C, since the language is so f***ing flexible, you don't have to do that. As long as you have a class of any kind that has a method that's called clicked button at index or whatever the method is called,
try to fire it, right.
It will check, does this delegate class respond to this method?
Right, and that's using that reflection concept.
Right, and if it does, you're right, exactly. And if it does, then execute it. So, in our case, we're going to make this class here, and we're going to instantiate it inside of our controller class.
And that way, so if we wanted to, we can have a normal UI alert view. We could have a reset game delegate one. We could have a different type of one. We could have a different type of one. Mm-hmm. Each implementing. So the action to reset the game will actually be defined inside of the click button at index. That will call then our reset functionality.
Right. So when we get to the section of code that activates this instance, what we're going to be doing is we're going to be taking this little fella here, and we're going to pass this guy here. And this is going to come in as a delegate. So instead of passing self, which would be him, we're passing this guy. And this guy, if you look at the template over here, contains this method.
Right. Then we're going to create a reset board method on our TicTacToe iPhone view controller that gets called as a delegate call from click button at index back to that.
Right. So one thing that we're also going to be doing, and we're going to be taking this.
Right.
Yeah.
Yes.
It's going to be backwards, but we're going to be passing the instance of our iPhone game or our whatever to him.
Or at least a reference to it.
Right. So inside of here, we're going to have a reference to this object.
Right.
And inside of this object, we're going to have a method. And this method is going to actually define what needs to do to reset the game.
Right.
So that's what this method is going to be doing.
And that reset game delegate class will be specifically designed to call that reset game method. Are you confused yet?
Yeah, so this will call this. And aesthetically, this may look kind of complicated, but the reason why Brian and I like this method is because we can use the same alert view instance to run so every time we can call this instance to send it a different delegate each time.
Right.
Every single time it can be, and that way we can use the same instance to do multiple things.
So let's review this one more time.
Well, just to kind of finish up.
I'm sorry.
When we initiate this click, so now that we've set this guy is going to have the reference to this guy, which it's going to run this method, so it's encapsulated here. We're going to pass this to the UI alert instance as a delegate. And then once we have this, the button gets clicked. The method here, since it's been activated, will then fire. And when we fire this, we're actually coming down and executing this code right here from this context. Right? So we click on the OK button, we fire this code, this fires this code, and then the whole picture is complete.
Right. So, long story short, when you click the button, it resets the game.
Right. But the reason why we like this method is because it can reset the game, it could change
do whatever you want it to do.
The character's color, it can...
And we can swap out the delegate on the alert view whenever we want.
Yeah, it could format your iPhone, it could send text messages to your... Horrible.
Of your wiener to all your constituencies.
Yeah. Whatever. Hopefully that kind of describes it, and we're going to code that right now. Even though that explanation may have sounded a little bit confusing, when you actually see this in action, with the information that you know from the tutorials that you have followed, this is going to be really simple.
Yeah.
Really.
So, this, in effect, answers the guy's question on Stack Overflow. And this also, let me just take a little side road. This is a perfect example, now that you're walking through this with us, this is a perfect example of why I think people become condescending. Because they don't feel like explaining all this stuff. It's kind of like, we had to draw pictures and
Right, yeah.
That's the only way that we could figure out how to explain it to you. I mean, not because you're stupid, but just because it's a weird thing, Mm-hmm.
Yeah.
So I can understand why, maybe if the message boards would allow you to, upload images. I don't know. Who knows?
Well, I mean, you can...
they probably do, so...
You can type the descriptions. I mean,
yeah,
it's not...
yeah, that's true. Good point.
I mean, it may not be perfectly clear, but at least you'll get someone thinking, and then they may be able to figure it out for themselves from that point on.
So, what we want to do is we want to implement that blue... not the blue one, but the orange one.
No, it was the blue one. Yeah,
it was the blue one. Yeah. The blue one is the reset game delegate.
Okay, so we're going to make a new file. We're going to make a CocoaTouch Objective-C class, and this is going to be a subclass of NSObject,
Yep.
And we're going to call this...
Reset Game Delegate class.
Like that?
Yeah.
Reset Game Delegate class.
I like that.
All right?
Because it's not actually a delegate, it's the delegate class. Nice.
All right, now, and I'm going to just bring this... It's a supporting class, so I'm just going to, throw this up
that's
here.
Cool.
All right, so, Brian, talk to me.
So, we want, privately, the board controller view. And we'll just say that it's an ID. We don't actually, care about the object type necessarily.
All right, so what is this? We're going to have an ID.
And this is going to be underscore.
Oh, it's right.
Yeah,
We're using the right format. Okay.
Board controller view. Now, and what this is going to be is, the TicTacToe iPhone app view controller?
It's going to be the instance of this.
Exactly.
The instance of what we've been coding in.
Right, and we'll just call that the board, basically.
Yeah.
So that'll be the board's controller view.
Right.
The view controller or whatever you want, whatever.
Mm-hmm.
It's fine. And then just take the parentheses out around the ID.
Oh, man, I'm stupid.
It's cool.
You know what?
That's a return. Yeah, I know.
Yeah.
It's fine.
I do that all the time.
Okay, so then, also, we want a selector. And if you remember the reflection stuff, so we'll call it underscore reset board. And that's going to be of selector type.
Like that?
Yeah.
All right.
Okay, we want a couple methods.
So these are the only fields that we're going to have,
Yeah, that's all we got.
Okay, great.
So we want init with view. Init's like a failsafe, basically.
Right. Mm-hmm.
Init with view is the one we'll probably want to use. And then we'll pass in as a parameter a UI view controller.
Okay.
Pointer. And then we'll call this the board controller view. That's the parameter name.
Okay.
And selector.
Okay.
And then selector type. Not necessarily a pointer, because it's whatever.
Right.
Reset board. And based on the naming convention of our private fields and stuff, you could probably gather what this is going to do. Anyway, and then we're going to have a couple other ones. The next one is going to be This is basically the one that we referred to about the clicked button at index, but it's not actually going to... It's a little longer of a method name than that.
Right.
So here's how this goes. And this is the method that's... The shell is implemented or it's expected in the UI alert view class.
Yep.
And so it must exactly be this name.
Yep.
Because the UI alert view class has a selector that has this name in it, and it's going to try it on this delegate class.
Absolutely. Absolutely.
All right. So it's called exactly this. I'm going to read it because we have to do it exactly like they want it. Alert view, with a capital V, colon, and we're going to pass a parameter UI alert view pointer, action sheet with a capital S,
okay,
space, clicked button at index. There you go. NS integer button in. Oh wow, awesome! It just filled it in for you. I got to know what you're getting at, so that's fine. And then we'll just put a semicolon.
All right.
All right, and then last but not least, the dealloc. So that has to be exactly that method name.
All right, so let's copy this class declaration stuff, and let's go to the implementation, and let's start implementing.
Okay, so in init...
No, nothing?
Okay, so in init, we can just say self equals super init.
Okay. Super init, done it.
And then we'll say if self. We did explain that, right?
Yeah.
In previous, okay, cool.
And if we didn't, this is just saying if it's not equal to nil.
But it's also the hierarchy waterfall of initialization and
we explained that.
Yeah, we explained that.
We may not have used the if self, but I mean, it's like if
self is nil, it's going to translate to being false.
It's typically standard that if there's like some screw up in initialization, you return a nil.
Right.
So like you'll know that if it's screwed up somewhere above, then don't bother working on it.
Just stop the whole chain. So we can just say else return nil.
Right.
Yeah. Because that means it failed to init, super init.
Mm-hmm.
Okay, so we're going to say underscore board view controller is equal to nil. And this isn't what we would prefer to do, but this is just like in case somebody inits it incorrectly. Because it's an NSObject, you can always init it. All right, and then underscore reset board is going to be set to nil, and then we're going to return ourself.
Yeah, because the init method is not designed to be functional. The init method is just like designed for you to init with the view.
Right.
I mean, it's this is just kind of a fail-safe.
So, and then we're going to return self.
Oh.
After we reset the board to nil. Turn self. Perfect. Okay. Now we're going to init with view.
Okay.
And then self equals init.
Hang on 1 second. Let me just block these out so we could remove like errors and warnings and stuff.
Good call.
Okay.
Okay.
Self super init, right? Same stuff right here?
Actually, we can say self equals self init so that it kind of does the rest of it.
Oh, yeah. So self equals self init. So we got a little daisy chain thing going on
and now
here.
we'll go up and do that stuff.
Yeah, why not?
And then we'll say if self. So just so nothing catastrophic happened. Else return nil. Same dealie.
Mm-hmm.
Okay. So we're going to first release the board controller view.
Just in case there is one.
Internal board controller view.
Right, just in case there is one.
Right. Release. And then release the board... I don't know. Bad Mr. Burns impersonation.
Yeah.
Underscore board controller view is going to be equal to... And then we're just going to retain the board controller view that we took in as a parameter.
Right.
And retain will return, the pointer to itself.
Right.
And then the underscore reset board, it's the selector, if you remember, is going to be equal to reset board.
Mm-hmm.
Yep. And then return self.
Okay.
And that's all we do to tie everything together.
Right, exactly.
So no big deal.
And then dealloc, we're going to release underscore
board controller view. Yep. And then super dealloc, obviously.
Right. Obviously. Okay, now, Brian, this is where it's at right here.
So this means that we've clicked that close button.
Give me a snap, Brian.
All right. Or at least we clicked some button. We don't know which.
Right, yeah.
So
whatever we passed this as a delegate to, we clicked that.
Right. So this is really simple. This is no big deal. If the board controller view is not nil.
Okay, if it does not equal to nil.
Yeah. And.
Oh! Hold on a second. Hold on.
And the board controller view.
Hold on a second there, Sparky. Board controller view.
Responds to selector.
Respond. This is crazy.
Yeah. Reset board, underscore reset board.
Holy junk.
Right?
Very nice.
So if it responds to that selector, you can probably guess what we're going to do. We're going to perform that selector.
Hmm.
So if So if the controller view that we got a reference to has the method that we defined in the NSelector, which we'll pass in from the calling class with our proper name, has the method that we told it it's going to have, then perform that method.
Right. So we're going to be then resetting the board after the button was clicked. So the guy clicks OK or whatever the button is, and then this code runs right after that.
So really, what we could do with this, if you wanted to, instead of calling this the reset game, we just kind of name that for the sake of this explanation. But what we could just as easily do is not call it the board controller view. We could just call it the view, the sum view, and we can call the selector the sum selector.
Yeah.
Do you know what I mean?
Which is a standard delegate class.
And we could just make this just a normal plain old delegate class and tie it back to some other selector that we passed.
The difference is this class needs to implement that method. Or it has to have that protocol.
Right. Well, this class would just be for clicking a button on a UI alert view.
Yeah, but that method has to be defined.
But it doesn't have to be reset board.
I know, but that method still has to be defined.
Yes, it does. Yeah. Exactly. So I'm just saying we could abstract it out from the idea that it's to reset the game, but no big deal. So for the sake of this, we just wanted to keep the names of everything very clear. Okay, so now let's jump to our implementation. And what we're going to do is we're going to tie this together. Okay, so now let's jump to our implementation. And what we're going to do is we're going to tie this together, and then we'll just write to the log. So that if you remember before, it wrote to the log right away. Mm-hmm. We wanted to write the log after it's complete.
So just one last time. Just one last time. That little blue pop-up window comes up. This code does not immediately execute.
Right.
It's sitting here. But what it protects is it protects from the code below that in your implementation from executing. So it halts the execution. When you press the button, the index number. So if you have one button, it'll be 0. If you have two buttons, it'll be 0 or 1.
So
3 buttons, 0, 1, 2, 3.
We're just doing it any button because we only have one button.
Exactly.
You could choose.
We're not even using that property or that parameter.
That potential, yeah.
So when any button is clicked, we run this code right here, just so that you're 100% clear, and that when you go answer that guy's, thing on the forum, you can explain it as articulately as Brian and I can. Hopefully, I guess. I don't know.
Yeah. Cool.
Okay, now let's go back here to the M file, right?
Now let's go back to when we allocated it.
Okay, so let's scroll down here to the show message.
Right. So
right here. I'm sorry.
Yeah. So we need to create. So it says delegate self.
Do we want to create the instance?
Yeah, we need to create a delegate instance.
All right. So we'll in the .h file.
Yeah. It's gonna be a reset game delegate instance.
Yes.
Yeah, we need to import reset game delegate.h.
Imports reset game delegate.h, and then we're gonna make an instance of that. Reset game delegate class. What do you want to call it, Brian?
_ reset delegate.
Reset delegate.
Cool.
Very nice. And then
also let's implement a method that we're going to be using as a selector on this.
Okay.
So let's go down and we'll implement the reset board.
Okay, so we'll scroll down here to.
Or we can call it game has been no. We'll just call it reset board to have the board reset by the user. Okay, by the pop-up window. It's going to be awesome. How about we just call it like reset the board? I swear. And I swear.
By the moon and the stars. Alright, let's get Wibbit.net again, not Appley.
Reset board. That works. Okay. And we'll go implement that.
Okie dokie. So we go into the M file of the controller, and we'll scroll down here to the end. My only friend. The end. Actually, we'll do it here where the dialog is.
Okay, cool.
Right.
And we'll just say like NSLog, the board has been reset.
What? Select all. Delete that. NSLog.
That was such an infamous event.
What's that?
Select all, delete that with Windows Vista?
Yeah. Yeah. Select all. Delete that.
No. I said select all. Select, delete that. Oh.
So I have to do this then?
Yep.
What am I doing? The board?
Yep.
Is that it?
Okay, almost. So, now we have that. Now let's go to when the view did load.
Okay.
And we will initialize the reset delegate.
Okay, so in the view did load, just like we had the TicTacToe, we'll do _ reset delegate equals a Delegate, what was it? What
reset game delegate.
Reset game delegate, Alec, init
with view.
With view.
And that's going to be self.
Self.
And the selector is going to be @selector.
Uh-huh.
Reset board is the name of the method we just defined.
Right.
I mean, we could make it like, the board will be reset when the user requested it, but whatever. That can be anything that you want, long story short.
Exactly. So, and I'll just kind of pull that there for readability
Looks
purposes. Nice. And, Brian, since we own it, we have to clean it up. So in our dealloc method up here, which is just a little stroll up north in the code, we will then release that instance.
So now let's go back to where we instantiate the UI alert view. So now let's go back to where we instantiate the UI alert view.
Okay, now that's going to be down here in the tile has been selected, the alert view.
Right. So now this was pointing to self, which obviously doesn't have that crazy one that we typed and read. The button was clicked or OK was clicked.
Right, but if you wanted to simplify this, you could just define that method in your class.
Yeah, but
it's not really dynamic.
Right, exactly. Mm-hmm. That would be the cheater's shortcut way.
Yeah.
Okay, so instead, we're going to pass that delegate. So it's _ reset delegate.
Okay.
Yep. And that's the one we just allocated and initialized.
Instead of close, I want to put OK.
Okay,
the more generic. That's been bugging me the whole time.
No problem. Okay, so now it's going to pass to the reset delegate. The reset delegate has the method that the UI alert view is expecting that we implement as a result of clicking on the button that then calls the selector that we passed it reset board here, which is there, and that's going to fire NSLog. So what should happen is in our log, that won't say anything until after we click the button.
Let's test your theory, Brian.
Okay. Whew. I hope we didn't lose you guys. I feel lost.
I don't. It makes sense to me.
It's not that bad.
And yet, if it doesn't make sense to you and you didn't watch the other tutorials, then shame on you. We've taught all these concepts already. So now, Brian, if we hit this guy, you clicked. And now the fly's up. Now that, and then him, and then that, and then now we have a winner. Now notice that this did not say the board has been reset.
Right, it says the winner is Wibbit the Frog.
Right, so when we hit OK, watch that screen, the bottom right terminal, the board has been reset. Nice. It waited for us to then interact with it, and then it did what it had to do. It's so f***ing awesome. I love it. Ooh. Sorry.
All right.
Sometimes I get a little high on this shit.
So you've been a Red Bull?
I've been drinking apple juice. Maybe just too much sugar in my apple juice. All right, now we actually have to make reset board do something.
Exactly. Okay. So one of the things that we want to do is we want to blank out all the images. So let's go. Yeah. Let's add a UI just because we're gonna have to be recreating this all the time. Let's add a UI image and we'll call it image blank as just generically our blank image in the header.
Inside the header file.
Yep.
All right. So inside the header file, we will come here to the delegate. And we'll do a UI image. Okay.
And we'll just call that image blank. Because we're going to use this a bunch.
Now, we didn't use underscores for the rest of these. We probably should have, but...
Yeah, we'll keep that consistent. Consistently inconsistent.
Yeah,
at least we failed you.
We'll follow the Mac model here. Okay. So, and then I'm assuming that we'll initialize that
so we want
view did load, right?
Yep. So we want to initialize that.
Okay.
So it's going to be image blank is equal to UI image with contents of file. Contents of file. These are so long. You guys are gonna if you don't know C# and Java and you've just been going through our videos, your mind is gonna be blown when we go to C# and Java. And if you know Java and C#, you'll know why we're laughing right now. Anyway, so blank.png.
Nice.
All right. And then we don't actually have to dealloc that.
Because we're using an instance level, so we should be good.
So we should be good to go.
And we'll run this in the memory testing tool after we're done just to see.
Check it out. So now we go to our reset board.
The reset board method, which is the one that we just set up right here.
Yep.
Okay.
So the first thing we want to do is set the player title text,
which we called. What did we call that?
TXT label.
LBL.
LBL player title.
Right.
Dot text is equal to player1 Wibbit the Frog.
Right.
And then we want to hide we want to like hide and show the correct player. So let's just go up where we did that for player 1 before.
Okay, that's going to be down here in this code
right there.
here.
And we'll just grab those 4 to save some time.
Yeah, actually, I'm just going to take all of it because if I have a typo I don't want it to look all stupid. Especially since you're going to be paying $37 billion for this app.
Do you remember when the iPhone first came out? Or maybe not first came out, but like when the App Store first came out? Somebody made an app called like I Am Rich.
Yeah.
And it was $99.
Yeah.
It was $99.99.
And all it said was like, I am rich. Or
yeah,
something
it didn't do anything. It just said, I am rich. And like, for some weird reason, all these people like downloaded it. I don't know why. It's really weird.
Anyways.
Whatever.
So we've then set the frog awake. He's not hidden. He's viewable. Yep. And then the frog is, other one's asleep.
All right, so now what we want to do is we want to set the image blank for all these things. So we want to set like A1, which, was it image A1 or TT? I think it was IMG. IMG A1?
I don't know. Let's go back to the
header class. Button. BTN. That's right, because they're buttons, not images.
Yeah. So we got BTN A1. Yep. A1 sauce.
So we're going to call on that the set image.
Oh, that's okay. I got you.
That's cool.
We're going to be interfacing
it's a method.
with it.
Yeah, it's a method on the UI button class.
All right. Set an interface, and we're going to do image blank.
Yep. For state, UI control state normal.
Okay. No big deal.
Yep.
So this will be UI control state normal, and then we'll just copy this for all buttons.
Exactly.
So copy A1. This will be A2, A3, B2, 3, C2, 3. All right, so we'll do C3,
PO.
C2, C1, B3, B2, B1. Oh, whoa, excuse me.
It like freaks out.
A3,
that's A1.
A2.
There we go.
B1.
Okay, and then the last thing we want to do is we want to call reset on our TTT object.
Oh, right. So TTT, reset, hit the reset button on TTT.
Right. And unless I'm forgetting something...
This is it?
This is it.
All right, well, let's run it.
This is the final countdown.
The final dude. All right, anyways, all right.
I'm so excited.
All right, here we go. You ready? You ready?
Okay.
All right. So X, O, X, O, X. Oh, we have a winner. Now let's make the fly win. O, X, O, X, O.
Nice.
The fly win. Now let's have a draw. Help me out here.
Okay.
O, and then
X down there, over there, X over there,
O there, X there.
Oh, no, you won.
Oh, shit.
You had to switch the bottom too. Nope, that's going to win.
No.
Yeah,
the
you're
fly.
right. Yeah.
So then the X goes here.
Yep.
And then O goes here.
There. Yep.
So now nobody. No. X goes here.
There.
Now nobody can win.
Yeah.
No matter
O goes
what
in the middle.
It doesn't matter.
Oh yeah, that's true.
Doesn't matter. It's a draw. Not bad. Not bad. Now I do think that we didn't take care of this. Ready? So.
Oh yeah.
So it just says the cell is
already valued. Yeah, that's right.
So there's going to be another. We have to do.
That's in our catch.
Yeah.
So we need an alert view to pop up on our catch.
Yep.
So we need an alert view to pop up on our catch.
Yep.
So here's where it gets interesting. When we catch this error, we don't actually want to reset the board.
Mm-hmm.
We're just saying like, hey, you can't do that. Right? Like it's out of bounds or you clicked on a cell that's already valued or whatever.
Mm-hmm.
So, what we want to do is we want to set that message value.
Okay, so what we're doing, alert view?
Just message, the string message. The one that we were passing around, like a cheap, dirty whore.
Right.
We're going to set that bit to equal to X reason.
Okay, so let me just pull this up one then. Because if we're going to NSLog it too.
Oh, yeah, good point. Fair enough.
EX reason. Okie dokie, smoky jokey.
Okay.
Message.
And then.
I did.
Okay, so now we're going to say alert view, and we're going to set the delegate to nil because we don't want to reset the board. We don't actually want to do anything. Now we could set it to self, but we'll just set it to nil. I mean,
so how do we do that?
So it's just a set delegate method on alert view. Set delegate. Yep.
Set delegate to nil. Okay.
That's it. Exactly. Perfect. Beautiful.
Nice.
Okay, and then after that, we want to update the message. So we're going to say alert view set message to be message.
Okay. Message, which comes from the back-end code.
And then alert view show.
Oh, nice. Wow.
So because we don't actually go do anything as a result of it,
we don't have to wait for the user to respond.
Because after this is done, we'll go to finally release it and just kick back and we're back to making another move.
So let's see that. Let's fire it up.
So there's that. And, oh, cell is already valued.
Perfect. Nice. We can continue on our merry way. Cell's already valued. Okay, so now we want to just do a little more polishing. So we want to finish this application off.
Right. There's a couple things right off the bat, Brian. When we look at our home screen here, the name looks ugly, and there's no thing. And Brian, it would be kind of cool if we could have like a splash screen too. So like when we open the app, we'll have like a little splash screen and then all that kind of crazy stuff. So what we have here on the left is a couple of images that we have prepared for this app. So we have our app icon that we're going to use.
It's like the frog, like in Tron, where he's like, holding the...
And he's got the little grid behind him, which may or may not be viewable, but whatever. Here's our splash screen for the 3G and 3GS iPhone devices, and then here is a splash screen for the Retina. So as you can see, the quality is much higher and it's going to look a lot nicer.
Yeah.
So those are the images that we're going to then add to our application, and we have them on the desktop. So in Xcode,
add them to the project.
So we're going to add them to the images folder here, or the images, whatever. Add files to this. Go to the desktop, and we want these three suckers right here.
Awesome.
And they are now ours. So Brian, when we go to the project, we have an option here. App icon.
Now, the app icon we probably want to make of the proper icon type so that it displays properly, but we can probably throw the launch images in there.
All right, let's see what happens.
So we got the non-retina one.
So it's this one should go here.
Yep.
Yes.
Okay, that's fine. Sure.
Yep.
Yeah, we know it's already in there, and you're going to stick it in there, and that's fine.
And this one should go here.
Yep. Yep. Now, add that.
Let's launch it.
And if you notice, the name of the files changed to the files that added, and this is kind of important. If you didn't do this, this is the way that you would implement the splash screen. So it's just default at 2 times,
Nice.
It's kind of dumb, but whatever. Ooh. Very nice. Okay.
So now we can play the game and do all kinds of
stuff. So some people argue that the splash screen should be the default loaded condition of your application to make it appear that your application launched faster. I don't know. I think that's crap.
Yeah, it's kind of stupid.
There's no easy access delay for how long the splash screen will launch for. So it seems like what people generally do is they actually create another view, push that, and then whatever. It's done. So
this is just a simple way to have a splash screen.
So just so you know that, but anyway.
All right. So now Brian, for the app icon, it's going to be a little bit different. Now, Brian, for the app icon, it's going to be a little bit different. Okay. Because there are specific sizes that they have to be, and they have to be a PNG.
So, the ttt.icon.png that we have in our images folder is 512 by 512 or something. It's huge.
Yeah.
So, what happens if you try to drag that image into one of those app icon buckets?
Let's find out. Okay. It needs to be 114 by 114, and then the other one here needs to be 57 by 57.
Now, generally, we try to stay away from graphic design how-to stuff, but sometimes somebody may give you a big icon, and that should be able to be usable on other things. So we're going to show you. Okay, that's cool. We're going to show you how to resize this to the sizes that you need, just by using the built-in Apple tools. So we open it in Preview, and then we're going to say Tools, Adjust Size. And this is going to be 114.
117.
117.
Right? It was 117?
That was 114. That was 57 and 114. There you go. 114.
All right, good catch.
I am the champion, my friend.
So it's 114. 4.
So that's for the retina size. And then we'll just save this as
ttt.117.
We're going to do that retina or something. Or dash retina.
I'll just do 117.
Okay.
All right. So there's that one.
We'll do Tools, Adjust Size, and then 57. I think it was 57. And then we'll save that. Save
as dots. 57.
Oh, you called it 117. You were stuck on that 117 for some reason.
That's all right. I'll fix that.
We'll rename that.
We'll quit that and enter 114.
Cool. Right. Okay, so now let's add those 2 files to our project.
Yeah. All right, let's do that. So in Xcode,
We're gonna do some crazy stuff here. Add to project. We want these two.
Yep. Beautiful.
All right, so then the 114 is gonna go
to the retina
here.
one. Yes, we do want to continue because it has to kind of like do a similar thing it did with the splash thing.
And now
And then we'll drag the 57 one.
The 57 one is gonna go here.
Yep. And then yes, we will also like re-add it.
So
We probably
now
don't have to do that, but we're going to do that anyway.
if we run the app, all right.
Splash screen.
First of all, when we it has there, and if we were to look at our processes, it has an icon. All right. Now, how do we fix that name, Brian?
All right. So let's quit the simulator. Okay. So now we want to change the name, and now we'll go to our info plist.
All right. Now that's going to be in the support files, right?
Mm-hmm. Info plist.strangs. Let's go to the plist for our app info.
This one here.
Yeah.
And the bundled display name, we have it as product name, but we're going to change this to what?
TicTacToe.
See what that looks like?
All right, we'll save that. Cool. Yep. Now, we should have not only a splash screen and a crazy cool icon, but it should also be called just TicTacToe.
Not bad, huh?
Not at all.
All right, Brian, as I look at our tic-tac-toe game, I see something that I don't like.
Oh.
Look at the fly.
I know.
He looks like shit.
Yeah.
He did not scale well. He looks like a little... You can't even see those little Z's.
It's not even... It's pixelated, but it's not like Atari pixelated. It's just crap pixelated. And even there...
Even the frog looks like
when we put these images on
Look
here...
at this.
If you remember... When we first put these images on there, they were not huge, but they were much bigger.
Right.
We scaled them down.
At least in comparison to the device that they're on.
Right. So Apple, in their infinite wisdom, decided, if we're going to do image scaling, who needs interpolation? Let's just not bother, you know? So it's in there. It's in the NS image, or the CG image underneath. It's just not used.
That sucks.
For the UI image implementation.
That's really stupid.
Yeah, so when you scale an image down, and you say like scale to fit, or the aspect ratio is going to, fill the aspect or fill the width or whatever, it's going to look like crap.
That sucks.
It's a common problem.
All right, but you know how to fix this.
Yes.
Hold on, let me beat the fly real quick.
And unfortunately, there isn't like we'll just put the setting on the UI image. It doesn't really work that way.
Like all things Apple. I mean, it's just...
Yeah, so we're basically...
Why?
So basically, we're going to be fixing the UI image class.
Okay. Now, how would we do something this crazy?
We're going to use a category.
No way.
If you remember about categories, a category is like a bolt-on method to an existing interface.
So we're going to make a new file.
Yep, a new file, and it's going to be a category file.
All right, so a...
Objective-C category.
That guy?
Yeah. And the category is going to be on a UI image.
Like that?
Yep.
Okay.
Okay. Let's see. And then we're going to save this as UI image plus resize image smooth. Yeah.
Like that?
Yeah. Right.
Like smooth jazz? No? Not like smooth? All right, screw you. I hate
like
you. You're stupid.
Jazz. So this is our interface.
Mm-hmm.
It imports foundation. And the category name is UI image. I don't like that. Let's just call it resize image smooth. We don't need all that.
It's kind of dumb how it added that there.
Yeah. Okay, so we're going to do two methods.
Okay.
Very simple. We want to keep this as clean as possible. Now, we could have made this cleaner, and I'll explain why, and we're not going to just because.
Mm-hmm.
So one is going to be a class method, and one's going to be a static method. So this is going to return an UI. They're both going to return UI image pointers.
Okay.
The first one is image with image.
Image with image.
And then the parameter is going to be a type UI image pointer.
UI image, okay.
And we'll just call the parameter image.
Okay.
And then the second half is going to be, the label is going to be scale to size.
Okay.
And then it's going to take in a CG size object.
Okay, CG size, which is not a pointer, right?
Right, which is not a pointer.
CG size
and
is...
new size.
Like a D's.
Right.
Nice, okay.
And then we're going to return a UI image pointer. And this is going to be scale image to size. So
scale image to size.
So one will be a class level that creates an image, creates a UI image, and the other one will send back a copy of an image scaled to a certain size. And
okay. And this is going to be this, right?
Yep.
All right.
So on the instance, I want to scale the instance to a certain size, and we're going to pass in the size.
Okay. So that's all for the header file?
That's it.
Okay, now let's go to the...
Okay. Creepy.
All right, so the static method, Brian, what do we got going on
All right,
here?
so the first thing is we're gonna call a function called UI graphics begin image context. Totally intuitive, right?
Yes, sure, why not?
And then we're gonna pass it in the new size.
Okay.
And then we're gonna call on the image instance that we passed in as a parameter.
Mm-hmm.
We're gonna call the UI image method draw in rect.
Of course.
And then the first parameter is going to be, CG rect, so CG rect make function.
Oh, I'm sorry. So CG
rect make.
Make?
Yep.
Okay.
And then we're going to pass it 0 and a 0.
Okay.
For positions, and then new size dot width, and then new size dot height.
Okay.
And then block that off, bracket that off, and end it.
All right.
Okay. So we're gonna just kind of make it. We're gonna block out that size, and then we're gonna say a new UI image pointer. We'll call it new image.
Okay.
And it's a pointer.
Of course. Of course.
Of course, it's a horse. Of course. Never the famous talking horse. I don't think that's the right words. All right, and so we're gonna call another UI function called UI graphics get image from current image context. It's like a fucking paragraph.
Yeah, I know.
And then we're going to call another UI function called UI graphics and image context. Yeah, totally useful, right?
Yeah, whatever.
And I'm glad that we passed our size into the draw and rect, make rec, because that wasn't useless at all, if we're going to call the context. Anyway, and then we're going to return a new image. So it's basically just like it's whatever. You got it.
Like that?
Yep.
Boy, that's a mouthful right there.
Yeah.
So why do we have to do the whole begin image context and then the draw and
rect? We'll draw it into the context. And then we take that context, pull the image out, put it into the new image, and then end the context and return it.
All right, then why not just have a resize method?
It's like Fox News, you just don't think about it, just stare at it. I don't know.
All right, scale to size. What is this all
Okay, so this is just going to call image with image.
Okay.
So we're going to return.
Oh.
And then we're going to call the static method we just categorized.
UI image.
Image with image.
With image. Okay.
And then we'll pass it self, since that's what we're dealing with.
Right.
And then scaled to size.
Scaled to size.
New size. Not too bad, right?
I guess
sense?
that's not so bad.
So we probably could just call image with image and never have to bother and just pass whatever we want, but at least it kind of puts it on the instance level.
Okay.
No big thing. This
will work?
This will work.
All right, so how do we implement this, Brian?
Pretty easily. So we go to the view controller.
View controller.
Yeah.
Okay, Brian.
So now that we have our category code, let's import it into our app view controller.
Let's do that. So that's going to be UI resize by each. Okay.
Okay, and now the only images that this seems to have an effect on is going to be like the players, like the frog and the fly, especially when the fly's asleep or like the frog's asleep. Those are the most egregious ones where you see the pixelization.
Egregious!
So, General Grievous, I don't know. So, those images, we're not like reinstantiating every time we use them. We're only like showing them and hiding them. So what we can do is we can call this like resize image on each of those 4 images on view did load.
Perfect.
And that will smooth them out.
Perfect. Let's do that.
Still not ideal, but maybe in a more ideal world, I would actually look through, if we had more time and motivation, I would probably look into the actual implementation code of the UI image and actually override the method and then use the new UI image view class that we make that's smoother in the interface builder. Obviously, that would be the smoothest, but whatever.
All right, so now, Brian, what we want to do is we're going to do image
fly asleep
dot image.
Yep. So we're going to set that equal to the result of the copy from our instance level method.
Image, that.
Which is called scale image
to size.
Yep. Now the size is going to be the size of the view. So to get that size,
image fly asleep.
Yep.
Dot
frame
dot
size.
Nice.
And we probably don't need that in brackets.
You're probably correct. Now, Brian, we could actually see what this looks like right now before we even do the other ones.
Yep.
So let's run this and let's see this fly looking all smooth and sexy. Hey, look at that!
Nice, awesome.
The Z's are nice. He doesn't have like jagged edges. And now let's do the frog awake.
Yep. Okay. Well, let's just do all 4 of them.
Oh man. Okay.
We can just copy and paste that little bastard.
Face. Copy and paste your face. Okay. So IMG fly awake, and then I'll just go ahead and do a little copy action, a little paste action.
Also, a good source of information on looking at fixing this problem is Trevor's Bike Shed's website. And he had a blog post in like late 2009 called "Resize a UI Image the Right Way." So if you're interested about another way to solve this problem, maybe a little more full, complete way to solve this problem, solving the problem of like maintaining EXIF data, fixing a couple bugs in the resized image with an alpha channel problem, and a rounded corner issue that gets fixed, and just like a number of problems with the UI image and his solutions for it using categories. Definitely check out Resize a UI Image the Right Way by Trevor's Bike Shed.
So now that we have all those updated, right?
Yep.
We can play it. Come on, iPhone app. Here it comes. Here it comes, Brian. Are you excited? Come on.
I'm thrilled.
Look. Now if I do this, the frog's Z's are nice and smooth.
Hey, nice. Awesome. Much better. Yeah. Oh, I feel better now. Okay, cool. All right, so now that we got that problem solved, what's the next thing we should do?
We have one more problem left in this game, Brian. Okay? Let's just say I don't want to play against myself all the time.
Or somebody else.
Let's say I'm on the bus, and I want to play TicTacToe.
And
we're going to solve that problem next. All right, Brian. Now, Wibbit.net is not on record as being a very great tic-tac-toe computerized AI group.
No.
So
that's not our thing.
That's not our thing. We're not tic-tac-toe analysts. But what we are fantastic software developers. And we did not want you to walk away with this app without having the ability to at least try playing against the C pseudo-random number generator in your spare time. So the chances of
human versus C pseudo-random number generator. Who will win?
Test your skills. Or you can swap this out with the twister that we did before if you really wanted to.
Or an actual like tic-tac-toe algorithm.
Yeah.
But the thing is, we just want to show you like some app pitfalls. We don't really want to get into like CPU intelligence on playing tic-tac-toe. Like it's way out of scope. You know?
Mm-hmm. Yeah. So there's a few things, Brian. The first thing that we're going to have to know is how many players, because we're going to have to make a decision at some point on what to do. If we have 2 players, we do this. If we have 1 player, we do this. And I think that the most effective way that we can do that is have another one of those alert views come up with 2 buttons. So not only do we get to learn, not only do we get to implement this and also see a different way to send that delegate. You know how we wrote our own reset game delegate before? Now we're going to show you why we did it this way by having that method in our own class. Because had we put that other delegate in here, we would have had to write something else to have this one work. So it's all kind of weird stuff. And all that it's going to do is just going to ask you how many players you want, and then we're going to store... You're right there.
Yeah, so I just totally spaced out. I was like, stop it.
You guys are going to also have exposure to now having another pop-up window that has 2 buttons instead of 1.
Nice.
Yeah. So
and what to do based on which click.
Precisely.
Which one was clicked. And that's what we want to show you. That's what matters.
So in the header file, Brian, we want to store something, right?
Yeah, like how many players.
Correct. NS integer.
How many squirrels out there just trying to get a nut?
What?
I don't know. Like players?
Wow.
No.
No, that was horrible, Brian.
Anyway,
that was horrible.
We also want to add a method in our method declarations down below for when the computer makes a move.
Okay. And this is
so
going to be...
computer will make a move.
Computer will make move.
Once there is no more yogurt.
You want to call... I don't like that name.
I know.
How about CPU make move?
Okay.
CPU make move.
Awesome.
I like that, but much better. So this will be the CPU's make move.
And I don't think that needs any parameters passed, I don't think.
We'll make sure it doesn't. So if we go down to where we have our where is it? The tile has been selected method. We'll just kind of throw this right below it. and we'll implement this down here.
Okay, and before we get into that, do you want to add the UI alert view?
I would love to, Brian. Now, where do you think the most effective place to put this would be?
Well, probably in 2 places.
All right, lay it on me.
The first place is probably going to be in view did load.
Okay.
And the second place is going to be at the end of reset board.
Okay. You know, one thing you could do, Brian, is you could just put it in reset board and call reset board on view did load if you wanted to.
Oh, yeah, good point.
Yeah.
All right, let's do that.
Yeah, so on view did load, after we get all of our stuff situated, why don't we just call self reset board, right?
Yep.
And that's what that delegate would call when we have the other situation set up. So in the reset board method, which is up here somewhere.
There we go. So let's go down to the end of it.
Right here?
Yep, the very end.
Fantastic. What are we doing?
And so here's how it's going to go. We have a new UI alert view, just like we did before.
Alert view, okay.
Yep. And we're going to call it alert view.
All right.
We're going to release it as soon as we're done with it. So
alert view equals.
Yep. Yeah, we're going to alloc init with title.
UI alert view alloc init with title, and the title's going to be
Wibbit.net TicTacToe.
Awesome. Wibbit.net TicTacToe.
And the message is going to be how many players?
How many players? Okay, great.
How many players trying to get some nut? How many players trying to get? No.
What the f*** are you talking about, man? The
delegate is self.
Self. We're going to show you guys another way to implement this too. I'm excited about that.
Cancel.
Cancel?
Oh yeah. Well, cancel could just be like 1, and other button will be 2.
Okay, so this can be.
I'm glad
1.
they called it cancel button. Like
yeah,
to force
I know.
You to,
I'm glad they called it that.
They didn't just say primary, tertiary. You know? Anyway.
Okay, and then the other button is going to be 2.
So it'll be a 1 player 2.
And then we have to put a nil here.
Yep.
Yeah.
Okay, and then we'll show it and release it.
Okay, so we'll do a alert view show, and then we'll do a alert view release.
Yep.
Okay, now let's see how this runs real quick.
Right. Well,
just because.
All right, that's cool.
Just because we're awesome. All right, so here comes the loading of the app, and we should see it pop up any time now. Hey, cool. So we have a selection here. But of course, if we do this, it does nothing. But we can, since we're passing the delegate as self, all that we have to do, guys, is if we go back to our little reset game, all we have to do is have a method that looks just like this.
Right, because if you remember, that's the one that the selector from the UI alert view is going to attempt.
Yeah.
On the delegate. Right.
And no matter what class instant you pass it doesn't matter what the instance is. If it has this method defined, it will run this on after click.
Yep.
Nice stuff. All right, so if we go back to the M file, we'll kind of put this right below here. Awesome.
And this goes to show you that you can kind of put it where you're putting it, or you can have it off in its own class. Either way.
Yeah.
So all this is really going to do is set the number of players.
Okay.
To be, well, in this case, it could be, the button index plus 1?
Mm-hmm. Yep, button index plus 1.
Because the button index will be 0, 1.
Right.
And we'll just bump it up 1, so it's going to be number of players, 1 or 2.
So let's do an NSLog that says number of players.
Now set to.
And then we'll do a %dibby, and then num players.
There you go.
So let's see how this executes. If we run the application. So we have, Brian, how many players?
1.
If I do 1,
move it up.
Number of players 1.
All right, so then play the game real quick. And it should call reset board. And no, just go back.
Oh, that's right. I can play a game.
Yep. Hey.
Okay. Number of players, 2.
Hey, it's set to 2.
All right.
Okay,
so
cool.
now that we're capturing this information, Brian, we have to find a spot in this code to make a decision where we can then take the logic of the code in a different direction if we're playing with just 1 player.
Okay.
We have to find a spot in this code to make a decision where we can then take the logic of the code in a different direction if we're playing with just 1 player.
Okay.
Where's a good spot to put this?
Let's put it at the end of, well, we're going to click a button.
Right.
And that clicking of the button is going to complete our turn and send the turn off to the next person. So how about right at the end of tile has been selected?
Okay.
We'll do an if statement, and if the condition is right for the CPU to do something,
okay,
then we'll pass it on to CPU make.
Okay, now what is the condition that we're going to look for?
Well, I guess if there's only 1 player.
Mm-hmm. So if num players equals 1, I gotcha.
And then if it's O's turn,
right?
So X is always player 1.
Right. So if TicTacToe, whose turn if that equals O, which means that X just had his turn, and now O is about to have his turn. Okay.
And there is no winner.
Oh, great.
Because that means the game's not done.
TicTacToe, who is winner? If that does equal O as well.
Or if that's blank.
I'm sorry, blank. I'm being dumb. Okay, so there's the condition.
So then we'll call CPU make move.
That is insane. Self, CPU make move.
Make your move, computer.
Make the move.
Mr. Fly.
So now, Brian, we are not, like I said, and those of you hardcore Wibbiters can go ahead and write your own crazy, logical, nasty, awesome, smart algorithm.
And post it in the forum.
Yes, do that. But Brian and I are going to use kind of a cheater's way out of this with absolutely no logic. We're just going to allow the pseudo-random number generator to do its thing.
Yeah.
All right. Maybe you can talk us through this, Brian. What do we do?
So, we're going to make some NS integers.
All right.
A row, a column, and a tag.
All right, so let's do a time, no.
Okay, so we're going to make an NS integer called CPU row, CPU call, and CPU tag.
CPU row.
Yep.
Okay, CPU column.
Yep.
And what?
CPU tag.
CPU. Oh, we're going to calculate the tag from the... Oh, I see what's going on here.
So let's set right away the CPU row and column to be equal to rand mod 3.
Okay, so rand...
Since it's a 3x3.
Right, 0, 1, or 2.
Yep, and then the same thing with CPU column.
CPU call equals the rand function, the crand function, mod 3. Okay, so we've selected 2 coordinates on this grid.
And we need to, and we can print out like the value at that location if we choose to. It doesn't really matter. Okay, so we want to keep trying to put this value into the grid so long as it's valid, so long it's empty.
We're just going to randomly find an empty spot.
Right.
Mm-hmm.
Thank you.
So the way we can do this is have a while loop.
Yep.
And all the while loop has to check for is what, Brian?
So if the 2 random numbers we just generated, the row and column, are at a position on the grid that gives us a blank value back, then we're okay.
Okay. So if this column and this row, right?
Yep.
If that
is not blank.
So if it's
not equal to blank,
then
we'll continue in the while loop.
Good call. Okay. Nice.
Otherwise, we'll break out of there.
Awesome.
Now we'll have never entered into this method if there's a winner, so we know that there's at least one that's blank. So this won't be an infinite loop.
Right. Mm-hmm.
So yeah, exactly. So we'll set that again, we'll randomize it again, and we'll just keep moving through the loop until we get one.
Okay, so we'll just
not the most efficient loop, but it's cool.
It's fine. It's only 9 squares.
Yeah, I know,
mean,
right?
if we had 5 trillion squares, I would fight you on this one, but
so
not for 9.
So now let's set the CPU tag.
Oh, okay. So like we're basically simulating the button tag, because you know how we set those buttons
to 11, 12, 13, 21, 22, 23, 31, 32.
We're going to use the 2 random numbers that we selected in that empty cell to then calculate what number that would be, so we know which button to simulate was clicked.
And because it's mod 3, the numbers of row and column are either going to be 0, 1, or 2.
Correct.
So keep that in mind. So the CPU tag is going to be equal to...
Okay, CPU tag equals what?
The CPU column plus 1.
CPU call plus 1, okay.
Times 10.
Times 10.
And then that whole thing plus CPU row plus 1.
CPU row plus 1. Okay, so that will get us either that...
we do the 1 times 10 and the other one just added on to it.
Okay, so now that we know which cell, we can then switch on that.
Yep, good call.
So we can switch on the CPU tag, and we can simulate, Brian, the button being pressed. So we have a few cases that are known. Let's start with let me just kind of break this out here. Let it break this out here. So you know we're going to have 11, 12,
13, 21,
13,
22, 23, 31, 32, 33.
All right, so we got 11, we got 12, we got 13, we got 21, we got 22, 23, 31, 32, and
45.
40 billion trillion. 33. All right.
So all we're going to do in any of these cases is just act like we are the computer and that we clicked it. So we're just going to select the tile, A1, A2, A3, depending on the tag.
Okay. So we're going to evaluate myself, and I'm going to call the method
tile has been selected. Earl of Yorkshire.
And the sender, Brian, is going to be what?
Button A1 in this case.
Oh, so we're literally going to be passing the button as a parameter.
Yeah.
That's kind of cool.
Yeah,
I like that.
Not bad, because that's what sender is.
Yeah. So we'll copy that, and we'll kind of do a little paste action here and here and here, 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 here.
And where?
Huh?
No.
Huh?
No, no,
Oh,
Woody.
Jeez. God. It tastes like warm milk.
Ew.
Yeah. Man, this is a lot harder than it looks. Good golly. Okay, alright. Okay.
Right. And then maybe we'll just tab all that back. Oh!
Or I'll just tab this one over. I like that. That's less work.
That's cool.
Okay, so is this it?
Yeah, that's it. That's it. We're done.
it? Alright, so if we run the program, if we run the program, we should be able to play against the C pseudo-random number generator if I select 1. So now it's our turn, Wibbit's turn.
Whoa, that's a fast fly.
Wow, that guy is quick.
Yeah,
we run
he's
this.
not joking.
Oh!
Hey.
Look at that. He's
Don't
even
let
got
him win.
me.
Don't let him win.
Oh, okay. Well, he just cockblocked me.
Oh
My God, the C pseudo-random.
Oh, wait. Go for broke. Go for broke. Bottom left.
Should I give him a chance to win?
No.
Okay, we're going to draw this.
Woohoo!
Oh.
We are the champions over the pseudo-random number generator.
But then if I go back to players 2, I can hit this, and then my friend or myself, if I want to kind of like do a little mind on myself. Yeah.
Nice. Cool. Awesome.
Yeah. And then just, I guess, home to exit.
Yeah. Cool. Awesome.
Yeah, not bad. So there's our Mac or our iPhone. So there's our iPhone application.
Vicious. Okay, so that's all well and good, but when you click on one of those tiles, that fly makes us move awfully fast.
Pretty f***ing fast.
Yeah. So we want to show a possible tactic of how you can thread something, have it sleep, lock the process you're at so you're not to confuse the application, kind of take manual control over it, but also put a delay in there, which is not as easy as it seems at first glance.
Okay. So I guess the first thing to do, Brian, in order to pull something like this off, is if we go to the view controller header file, we can come up here to the fields, and we can make a Boolean data type, and we can just call this isLocked.
Okay.
Because what we're thinking about doing, since this wasn't really designed into the code, this is more like an afterthought. Which, when you get into the field, I mean, guess what? When you're picking up projects someone else wrote,
yes, exactly.
You're going to have to jam in there just like we're doing here.
Right.
And you got to be creative. So what we're going to do, Brian, we'll have that little global Boolean data type.
Yep.
That Boolean data type is going to store yes or no if we want the user to be able to touch the buttons.
Right.
Right? So we need to then set something that will kick off, lock the phone, sit for a second, make the move, unlock it, come back.
Right. So, right off the bat, we know that reset board is called on view did load.
Yeah.
So at the end of reset board, let's say that isLocked is not locked.
You are a smart motherfucker.
I know. Son of a bitch. We change lives here, people.
Yeah.
We're changing lives.
So we'll do isLocked equal to no.
And then when we enter into the button has been selected, or tile has been selected, or whatever the hell it's called.
Yeah. All right. So then we'll make a decision right when we first get in here. If isLocked, then what are we going to do, Brian?
Return.
Right.
So if the CPU, basically, if the CPU is thinking.
Right.
Or waiting, or thinking, simulated thinking.
Simulated, because the decision's already been
made. It has to act like it's thinking, you know?
So
it's kind of like when a kid asks their parents for something ridiculous, like, can I have a pet sloth? You know, the parent's like, let me think about that. Otherwise,
let me ask a father.
Yeah. No. Okay, so if the CPU is in its thinking process,
right,
we don't want to be like taking turns at the same time,
right.
So we want to lock this out.
But if you do press a button, it will accept that click.
Right.
It just won't act on that click.
Right.
So here we go, Brian. As we come in here, we lock it. We reinstantiate the random number generator. We sleep for 1 second. During the time that this is sleeping, we're locked. Right? Then and I think that we kind of misplaced this, right?
Right.
Let's move this into a position up here. Now, this should happen so quick that the other user shouldn't really have time to react.
Right.
So we'll unlock it. The other O will get to make its move. That's that.
Okay, let's try it out.
Well, that's not going to work because we have to thread this off.
Oh, yeah.
So instead of calling this...
I knew that.
Instead of doing CPU make move, this has to be threaded.
Right.
This has to be threaded.
Right.
And we could do that in a couple of ways.
Right. So we can do it in a perform selector and background.
Okay. Let's talk.
All right. So instead of self CPU make move,
right,
it's just going to be self perform selector and background.
Perform selector in background.
And then we're going to say at selector, and then the name of our method.
Oh, I see where I got screwed up. I got to remove this.
Yeah, we got it. Yeah, just get rid of that. Or just cut it. Oh, whatever.
All right, so okay, I got you. At selector, and the selector is going to be CPU
make move.
Make move.
Exactly.
With object
self. Yep.
Okay.
There we go.
And that should thread this thing off?
In theory, yep.
Let's see what happens. So if we run the game... Well, just so that you guys know we're winging this.
Yeah.
All right, player 1. X flies up. Oh! Yeah! Nice! Holy shit, that's awesome. I love it. Should we make it like a random 1 to 2 second or something?
No, that's fine. I'm good.
You think 1 second's fine?
Yeah, 1 second's fine.
It's a draw. Oh my god, Brian.
That's cool.
I'm going to play this all the time now. I want him to win a game. Oh, he beat me! I'll let him beat me.
The fly's kind of stupid.
Oh my god, Brian!
It's awesome.
This is fucking awesome!
Yeah.
We just made a full-scale iPhone game!
So, if you want, I recommend you go to the App Store, download it, donate $1.
Buy the game!
And have it on your phone. It'll be fun. You'll be like, hey, look, it's the game. I saw how to make it. Hey, it's
yeah, cool. And I made it for myself because I'm awesome.
Okay, so there's some... It's definitely a little getting used to. And obviously, like, this isn't the ideal program.
Yes, it is.
But it's the ideal program for getting used to some of the hurdles and just getting, like, I mean, we built this thing in a couple hours.
Yeah, really, yeah.
I mean, for shit's sake. Like, that's pretty awesome. So we obviously are not going to walk you through, like, 2 weeks of, like, painstaking detail to every possible thing that can go wrong and accommodating every circumstance and turning the fly into a robot in CPU mode and stuff like that, which I'm not saying you should do or anything, but it would be cool. Like a robot fly version.
Robot fly.
I am now the computer. Put sound effects and stuff in there. Like, we could do all sorts of fun stuff. But what we do want to show you is, like, the UI alert views, how to click an image, how to do a button, setting the outlets, setting the actions, kind of getting used to the flow, some of the problems you're going to run to, how to solve some types of problems like this. So enjoy it, have fun with it, mess around with it, make it better, improve the process, and we'll see you in the next lesson.
After I beat... Yeah! There we go.